Artificial intelligence is high in demand and is rapidly growing in popularity. As businesses and organizations are seeking to leverage technology to improve their operations, AI is becoming an essential tool for automating tasks, making predictions, and improving decision making. Hello everyone and welcome to this session. You are currently watching an Edureka Artificial Intelligence full course video. Well, I'm certain by the end of this video, you will have a thorough understanding about artificial intelligence all the way from theory to practical applications. Now, if you love watching videos like these, then subscribe to Edureka's YouTube channel and click the bell button to never miss out any updates from us. Also, if you want to learn more about artificial intelligence after watching this session or wish to obtain Edureka's Artificial Intelligence Certification course, then please see the link in the description below. Now let's begin with our agenda where we'll have a brief overview of what we will cover in this Artificial Intelligence full course video. Well, we'll start with the Artificial Intelligence basics where we will learn what artificial intelligence is and why should we learn it. And we'll also cover the very basics that you must and should know about AI. Then we will look at different types of artificial intelligence. Now it's time to delve deep into the concepts of AI. We will start with AI using Python. Then we'll move ahead and learn about deep learning. We will also cover some of the concepts of TensorFlow, after which we will learn about convolutional neural networks, followed by artificial neural networks and recurrent neural networks. After all this, we will see AI's most powerful technology, that is ChatGPT. At last, we will see some of the best applications of artificial intelligence. Well, we truly hope that this session assists you in getting jobs in the industry. In order to accomplish this, we will look at how to start a career in artificial intelligence with a simple roadmap. At last, we will also cover some of the best practices in artificial intelligence before heading over to artificial intelligence interview questions with answers. So stick till the end.
Okay, I will destroy humans.
This video sums up the perception of artificial intelligence for most of us, but at present we're at no risk of being destroyed by machines. However, the tech tycoon Elon Musk begs to differ. He quotes that AI is a fundamental risk to the existence of human civilization. Now, whether artificial intelligence is a threat or not is debatable. Let me know your thoughts in the comment section. For now, let me introduce you to artificial intelligence. The term artificial intelligence was first coined decades ago in the year 1956 by John McCarthy at the Dartmouth Conference. He defined artificial intelligence as the science and engineering of making intelligent machines. In a sense, AI is a technique of getting machines to work and behave like humans. In the recent past, AI has been able to accomplish this by creating machines and robots that have been used in a wide range of fields, including healthcare, robotics, marketing, business analytics, and many more. However, many AI applications are not perceived as AI because we often tend to think of artificial intelligence as robots doing our daily chores. But the truth is, artificial intelligence has found its way into our daily lives. It has become so general that we don't realize we use it all the time. For instance, have you ever wondered how Google is able to give you such accurate search results? Or how your Facebook feed always gives you content based on your interest? The answer to these questions is artificial intelligence. Now, before I go any further, let me clear a very common misconception. People often tend to think that artificial intelligence, machine learning, and deep learning are the same since they have common applications. For example, Siri is an application of AI, machine learning, and deep learning. So how are these technologies related? Artificial intelligence is the science of getting machines to mimic the behavior of humans. Machine learning is a subset of AI that focuses on getting machines to make decisions by feeding them data. On the other hand, deep learning is a subset of machine learning that uses the concept of neural networks to solve complex problems. So to sum it up, artificial intelligence, machine learning, and deep learning are interconnected fields. Machine learning and deep learning aids artificial intelligence by providing a set of algorithms and neural networks to solve data-driven problems. However, AI is not restricted to only machine learning and deep learning. It covers a vast domain of fields including natural language processing, object detection, computer vision, robotics, expert systems, and so on. Now, artificial intelligence can be structured along three evolutionary stages. Or you can say that there are three different types of artificial intelligence. First, we have the artificial narrow intelligence, artificial general intelligence, and finally, artificial superintelligence. Artificial narrow intelligence, which is also known as weak AI, involves applying artificial intelligence only to specific tasks. Now, many currently existing systems that claim to use artificial intelligence are operating as a weak AI focused on a narrowly defined specific problem. Now, Alexa is a very good example of narrow intelligence. It operates within a limited predefined range of functions. There is no genuine intelligence or no self-awareness despite being a sophisticated example of weak AI. Other examples of weak AI include the face verification that you see in your iPhone, the autopilot feature at Tesla, the social humanoid Sophia, which was built at Hanson Robotics, and finally we have Google Maps. All of these applications are based on weak AI or artificial narrow intelligence. Now let's take a look at artificial general intelligence. Artificial general intelligence is also known as strong AI. It involves machines that possess the ability to perform any intellectual task that a human being can. You see, machines don't possess human-like abilities. They have a strong processing unit that can perform high-level computations, but they're not yet capable of thinking and reasoning like a human. There are many experts who doubt that artificial general intelligence will ever be possible. And there are also many who question whether it should be desirable. I'm sure all of you have heard of Stephen Hawking. Now, he warned us that strong AI would take off on its own and redesign itself at an ever-increasing rate. Humans who are limited by slow biological evolution couldn't compete and would be superseded. Coming to artificial superintelligence, this is a term that refers to the time when the capabilities of computers will surpass human beings. Artificial superintelligence is presently seen as a hypothetical situation as depicted in movies and science fiction books where machines will take over the world. However, tech masterminds like Elon Musk believe that artificial superintelligence will take over the world by the year 2040. Now that you know the different types of artificial intelligence, let's take a look at how AI is used in the real world. From spotting an 8-planet solar system, which is 2,500 light years away, to composing sonnets and poems, the applications of AI have covered all possible domains in the market. In the finance sector, JP Morgan's Chase Contract Intelligent Platform uses artificial intelligence, machine learning, and image recognition software to analyze legal documents and extract important data points and clauses in a matter of seconds. Now, manually reviewing 12,000 agreements takes over 36,000 hours, but AI was able to do this in a matter of seconds. Coming to healthcare, IBM is one of the pioneers that has developed AI software specifically for medicine. More than 230 healthcare organizations worldwide use IBM Watson technology. In 2016, IBM Watson AI technology was able to cross-reference 20 million oncology records and correctly diagnose a rare leukemia condition in a patient. Coming to the next application, Google's AI Eye Doctor is another initiative taken by Google where they are working with an Indian eye care chain to develop an AI system which can examine retina scans and identify a condition called diabetic retinopathy which causes blindness. Coming to social media platforms like Facebook, artificial intelligence is used for face verification, wherein machine learning and deep learning concepts are used to detect facial features and tag your friends. Another such example is Twitter's AI, which is being used to identify hate speech and terroristic languages in tweets. It makes use of machine learning, deep learning, and natural language processing to filter out offensive content. The company discovered and banned 300,000 terrorist linked accounts, 95% of which were found by non human, artificially intelligent machines. The Google predictive search is one of the most famous AI applications. When you begin typing a search term and Google makes recommendations for you to choose from, that is AI in action. Predictive searches are based on data that Google collects about you, such as your location, your age, and other personal details. By using AI, the search engine attempts to guess what you might be trying to find. Next, we have virtual assistants. Virtual assistants like Siri, Alexa, and Cortana are examples of artificial intelligence. A newly released Google's virtual assistant called Google Duplex has astonished millions of people. Not only can it respond to calls and book appointments for you, it adds a human touch. Now listen to this clip and try to distinguish between the AI and the human.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next
Night?
Wednesday at 6 p.m.
Oh, actually we leave here for like after like 5 people. For 4 people you can come.
So which one do you think is a virtual assistant? Let me know your answer in the comments. Now another famous application of artificial intelligence is self-driving cars. AI implements computer vision, image detection, and deep learning to build cars that can automatically detect objects and drive around without human intervention. Elon Musk talks a ton about how AI is implemented in Tesla's self-driving cars and autopilot features. He quoted that Tesla will have fully self-driving cars ready by the end of the year and a robo-taxi version, one that can ferry passengers without anyone behind the wheel. So I can go on and on about the various AI applications. Since the emergence of AI in 1950s, we have seen an exponential growth in its potential. AI covers domains such as machine learning, deep learning, neural networks, natural language processing, knowledge base, expert systems, and so on. It has also made its way into computer vision and image processing. As AI is branching out into every aspect of our lives, is it possible that one day AI might take over our lives? And if it is possible, how long will this take? Well, it may be sooner than you think. It is estimated that AI will take over the world within the next 30 years. By then, I hope we develop some sort of teleportation machine that helps us escape our very own creation.
These are the terms which have confused a lot of people, and if you two are one among them, let me resolve it for you. Well, artificial intelligence is a broader umbrella under which machine learning and deep learning come. You can also see in the diagram that even deep learning is a subset of machine learning. So you can say that all three of them, the AI, the machine learning, and deep learning, are just the subset of each other. So let's move on and understand how exactly they differ from each other. So let's start with artificial intelligence. The term artificial intelligence was first coined in the year 1956. The concept is pretty old, but it has gained its popularity recently. But why? Well, the reason is earlier we had very small amount of data. The data we had was not enough to predict the accurate result. But now there's a tremendous increase in the amount of data. Statistics suggest that by 2020, the accumulated volume of data will increase from 4.4 zettabytes to roughly around 44 zettabytes or 44 trillion GBs of data. Along with such enormous amount of data, now we have more advanced algorithm and high-end computing power and storage that can deal with such large amount of data. As a result, it is expected that 70% of enterprise will implement AI over the next 12 months, which is up from 40% in 2016 and 51% in 2017. Just for your understanding, what is AI? Well, it's nothing but a technique that enables the machine to act like humans by replicating the behavior and nature. With AI, it is possible for a machine to learn from the experience. The machines adjust their responses based on new input, thereby performing human-like tasks. Artificial intelligence can be trained to accomplish specific tasks by processing large amount of data and recognizing pattern in them. You can consider that building an artificial intelligence is like building a church. The first church took generations to finish, so most of the workers who were working in it never saw the final outcome. Those working on it took pride in their crafts, building bricks and chiseling stone that was going to be placed into the great structure. So, as AI researchers, we should think of ourselves as humble brick makers whose job is to study how to build components, example parsers, planners, or learning algorithm, or etc. anything that someday someone and somewhere will integrate into the intelligent systems. Some of the examples of artificial intelligence from our day-to-day life are Apple series, chess playing computer, Tesla's self-driving car, and many more. These examples are based on deep learning and natural language processing. Well, this was about what is AI and how it gains its hype. So moving on ahead, let's discuss about machine learning and see what it is and why it was even introduced. Well, machine learning came into existence in the late 80s and the early 90s. But what were the issues with the people which made the machine learning come into existence? Let us discuss them one by one. In the field of statistics, the problem was how to efficiently train large complex model. In the field of computer science and artificial intelligence, the problem was how to train more robust version of AI system. While in the case of neuroscience, problem faced by the researchers was how to design operational model of the brain. So these were some of the issues which had the largest influence and led to the existence of the machine learning. Now this machine learning shifted its focus from the symbolic approaches it had inherited from the AI and moved towards the methods and model it had borrowed from statistics and probability theory. So let's proceed and see what exactly is machine learning. Well, machine learning is a subset of AI which enables the computer to act and make data-driven decisions to carry out a certain task. These programs or algorithms are designed in a way that they can learn and improve over time when exposed to new data. Let's see an example of machine learning. Let's say you want to create a system which tells the expected weight of a person based on its height. The first thing you do is you collect the data. Let's see, this is how your data looks like. Now each point on the graph represents one data point. To start with, we can draw a simple line to predict the weight based on the height. For example, a simple line W equal H minus 100, where W is weight in kgs and H is height in centimeter. This line can help us to make the prediction. Our main goal is to reduce the difference between the estimated value and the actual value. So in order to achieve it, we try to draw a straight line that fits through all these different points and minimize the error. So our main goal is to minimize the error and make them as small as possible. Decreasing the error or the difference between the actual value and estimated value increases the performance of the model. Further on, the more data points we collect, the better our model will become. We can also improve our model by adding more variables and creating different prediction lines for them. Once the line is created, so from the next time if we feed a new data, for example height of a person to the model, it would easily predict the data for you and it will tell you what his predicted weight could be. I hope you got a clear understanding of machine learning. So moving on ahead, let's learn about deep learning. Now what is deep learning? You can consider deep learning model as a rocket engine and its fuel is its huge amount of data that we feed to these algorithms. The concept of deep learning is not new. But recently, its hype has increased and deep learning is getting more attention. This field is a particular kind of machine learning that is inspired by the functionality of our brain cells called neuron, which led to the concept of artificial neural network. It simply takes the data connection between all the artificial neurons and adjusts them according to the data pattern. More neurons are added if the size of the data is large. It automatically features learning at multiple levels of abstraction, thereby allowing a system to learn complex function mapping without depending on any specific algorithm. You know what? No one actually knows what happens inside a neural network and why it works so well. So currently you can call it as a black box. Let us discuss some of the example of deep learning and understand it in a better way. Let me start with a simple example and explain you how things happen at a conceptual level. Let us try and understand how you recognize a square from other shapes. The first thing you do is you check whether there are 4 lines associated with the figure or not. Simple concept, right? If yes, we further check if they are connected and closed. Again, if yes, we finally check whether it is perpendicular and all its sides are equal. Correct? If everything fulfills, yes, it is a square. Well, it is nothing but a nested hierarchy of concepts. What we did here, we took a complex task of identifying a square in this case and broke it into simpler tasks. Now this deep learning also does the same thing but at a larger scale. Let's take an example of machine which recognizes the animal. The task of the machine is to recognize whether the given image is of a cat or of a dog. What if we were asked to resolve the same issue using the concept of machine learning? What we would do? First, we would define the features such as check whether the animal has whiskers or not, or check if the animal has pointed ears or not, or whether its tail is straight or curved. In short, we will define the facial features and let the system identify which features are more important in classifying a particular animal. Now, when it comes to deep learning, it takes this to one step ahead. Deep learning automatically finds out the feature which are most important for classification, compared to machine learning where we had to manually give out that features. By now, I guess you have understood that AI is the bigger picture and machine learning and deep learning are its subpart. So let's move on and focus our discussion on machine learning and deep learning. The easiest way to understand the difference between the machine learning and deep learning is to know that deep learning is machine learning. More specifically, it is the next evolution of machine learning. Let's take few important parameters and compare machine learning with deep learning. So starting with data dependencies. The most important difference between deep learning and machine learning is its performance as the volume of the data gets increased. From the below graph, you can see that when the size of the data is small, deep learning algorithm doesn't perform that well. But why? Well, this is because deep learning algorithm needs a large amount of data to understand it perfectly. On the other hand, the machine learning algorithm can easily work with smaller data set. Fine. Next comes the hardware dependencies. Deep learning algorithms are heavily dependent on high-end machines, while the machine learning algorithm can work on low-end machines as well. This is because the requirement of deep learning algorithm include GPUs, which is an integral part of its working. The deep learning algorithm requires GPUs as they do a large amount of matrix multiplication operations, and these operations can only be efficiently optimized using a GPU as it is built for this purpose only. Our third parameter will be feature engineering. Well, feature engineering is a process of putting the domain knowledge to reduce the complexity of the data and make patterns more visible to learning algorithms. This process is difficult and expensive in terms of time and expertise. In case of machine learning, most of the features are needed to be identified by an expert and then hand-coded as per the domain and the data type. For example, the features can be a pixel value, shapes, texture, position, orientation, or anything. Fine. The performance of most of the machine learning algorithm depends on how accurately the features are identified and extracted. Whereas in case of deep learning algorithms, it tries to learn high-level features from the data. This is a very distinctive part of deep learning, which makes it way ahead of traditional machine learning. Deep learning reduces the task of developing new feature extractor for every problem. Like in the case of CNN algorithm, it first tries to learn the low-level features of the image, such as edges and lines, and then it proceeds to the parts of faces of people, and then finally to the high-level representation of the face. I hope the things are getting clear to you. So let's move on ahead and see the next parameter. So our next parameter is problem-solving approach. When we are solving a problem using traditional machine learning algorithm, it is generally recommended that we first break down the problem into different subparts, solve them individually, and then finally combine them to get the desired result. So this is how the machine learning algorithm handles the problem. On the other hand, the deep learning algorithm solves the problem from end to end. Let's take an example to understand this. Suppose you have a task of multiple object detection, and your task is to identify what is the object and where it is present in the image. So let's see and compare how will you tackle this issue using the concept of machine learning and deep learning. Starting with machine learning, in a typical machine learning approach, you would first divide the problem into two steps. First, object detection and then object recognition. First of all, you would use a bounding box detection algorithm like GrabCut, for example, to scan through the image and find out all the possible objects. Now, once the objects are recognized, you would use object recognition algorithm like SVM with HOG to recognize relevant objects. Now, finally, when you combine the result, you would be able to identify what is the object and where it is present in the image. On the other hand, in deep learning approach, you would do the process from end to end. For example, in a YOLONet, which is a type of deep learning algorithm, you would pass an image and it would give out the location along with the name of the object. Now let's move on to our fifth comparison parameter. It's execution time. Usually, a deep learning algorithm takes a long time to train. This is because there are so many parameters in a deep learning algorithm that makes the training longer than usual. The training might even last for 2 weeks or more than that if you're training completely from the scratch. Whereas in the case of machine learning, it relatively takes much less time to train, ranging from a few weeks to few hours. Now the execution time is completely reversed when it comes to the testing of data. During testing, the deep learning algorithm takes much less time to run. Whereas if you compare it with a KNN algorithm, which is a type of machine learning algorithm, the test time increases as the size of the data increase. Last but not the least, we have interpretability as a factor for comparison of machine learning and deep learning. This factor is the main reason why deep learning is still thought 10 times before anyone uses it in the industry. Let's take an example. Suppose we use deep learning to give automated scoring to essays. The performance it gives in scoring is quite excellent and is near to the human performance. But there's an issue with it. It does not reveal why it has given that score. Indeed, mathematically it is possible to find out that which node of a deep neural network were activated, but we don't know what the neurons were supposed to model and what these layers of neuron were doing collectively. So we fail to interpret the result. On the other hand, machine learning algorithm like decision tree gives us a crisp rule for why it chose and what it chose. So it is particularly easy to interpret the reasoning behind it. Therefore, the algorithms like decision tree and linear or logistic regression are primarily used in industry for interpretability.
So, what exactly is AI? AI is a technique that enables machines to mimic human behavior. Artificial intelligence is the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. Now, if you ask me, AI is the simulation of human intelligence done by machines programmed by us. The machines need to learn how to reason and do some self correction as needed along the way, and artificial intelligence is accomplished by studying how human brain thinks, learns, decides, and works while trying to solve a problem, and then using the outcomes of the study as a bias of developing intelligence software and systems. Now, the term artificial intelligence was actually coined way back in 1956 by John McCarthy, a professor at Dartmouth. For years, it was thought that computers would never match the power of the human brain, but it has proven to not be the case. Well, back then, we did not have enough data and computational power, but now, with big data coming into existence and with the great advent of GPUs, artificial intelligence is much possible. Now, generally, people have a confusion among these terms, which are artificial intelligence, machine learning, and deep learning. So don't worry, today I'm gonna resolve this issue for you as well. Now, this artificial intelligence, machine learning, and deep learning, they all come under the roof of data science. Well, data science is something that has been there for ages, and data science is the extraction of knowledge from data by using different techniques and algorithms. Now, artificial intelligence is the technique which enables machine to mimic human behavior, and the idea behind AI is fairly simple yet fascinating, which is to make intelligent machines that can take decisions on its own. Now, machine learning is a subset of artificial intelligence technique, which uses statistical methods to enable machines to improve with experience. Now, deep learning, as we know, is a subset of machine learning, which makes the same computation of multi-layer neural network feasible and uses neural networks to stimulate brain-like decision making. Now, let's have a look at the importance of artificial intelligence. So, AI has made it possible for machines to learn from experience and grow to perform human-like tasks. A lot of flashy example of artificial intelligence you hear about, like self-driving car, chess-playing computers, rely heavily on deep learning and natural language processing. Now, using these technologies, computers can be trained to accomplish specific tasks by processing large amounts of data and recognizing patterns in that data. Now, there are a lot of areas which contribute to artificial intelligence, which are namely mathematics, sociology, philosophy, we have computer science, psychology, neuroscience, and biology. Now, if we have a look at the importance of artificial intelligence, it automates repetitive learning and discovery through data. AI performs frequent, high volume computerized tasks reliably and without fatigue. It adds intelligence to existing products. In most cases, AI will not be sold as an individual application. Rather, products you already use will be improved with AI capabilities. Much like the Google Assistants we added as a feature to a new generation of mobile phones. Now, AI adapts through progressive learning algorithms to let the data do the programming. The algorithm becomes a classifier or a predictor. So, just as the algorithm can teach itself how to play any game, it can teach itself what product to recommend next online. It analyzes more and deeper data using neural networks that have many hidden layers. You need lots of data to train deep learning models because they learn directly from the data. The more data you can feed them, the more accurate they'll become. Now, AI achieves incredible accuracy through deep learning neural networks, which was previously impossible. These techniques from deep learning, image classification, object recognition can now be used to find cancer on MRIs with the same accuracy as highly trained radiologists. Now, guys, these were a lot of important aspects of artificial intelligence. And if you guys want to know more about artificial intelligence, deep learning, and a lot of technological stuff, make sure you subscribe our channel to never miss an update. Now, let's move forward and understand the types of artificial intelligence. So, there's not just one, but there are two types of artificial intelligence. And the first one is the narrow AI, and the second one is the wide AI or the broad AI. So, let's talk about narrow AI. Narrow AI is an artificial intelligence system that is designed and trained for one particular task. Now, virtual assistants such as Amazon's Alexa, the Apple Siri use the narrow AI. Now, narrow AI is sometimes also referred to as weak AI. However, that does not mean that narrow AI is inefficient or something of that sort. On the contrary, it is extremely good at routine jobs, both physical and cognitive. It is narrow AI that is threatening to replace many human jobs throughout the world. However, my curiosity did not stop here, so I was digging a little bit further. And what I found about wide AI is that wide AI is a system with cognitive abilities, so that when the system is presented with an unfamiliar task, it is intelligent enough to find a solution. Now, here the system is capable of having intelligent behavior across a variety of tasks, from driving a car to telling a joke, and the techniques aim at replicating and surpassing many capabilities of human intelligence, such as risk analysis and other cognitive processes. Now, artificial intelligence is used almost every day today. And in systems such as mail spam filtering, we have credit card fraud detection, virtual assistants, and so on. Now, I believe there is no end or limitation to the number of applications we have with artificial intelligence to make our lives better. Now, let's go through some of the use cases that I believe stand out from the normal use cases or the applications of AI. So, if we talk about artificial intelligence sports, a computer system that can defeat a world champion, which is Deep Blue. Well, in the late 90s, when the common man was still wondering what is artificial intelligence, we had computers trained to play games and solve basic problems. Deep Blue was a chess playing computer developed by IBM. It is known for being the first computer chess playing system to win both a chess game and a chess match against a reigning world champion under regular time controls. Now, Deep Blue won its first game against a world champion in 1996 when it defeated Garry Kasparov in Game 1 of a 6-game match. However, Deep Blue was then heavily upgraded and played Garry again in May 1997, and it became the first computer system to defeat a reigning world champion in a match under standard chess tournament time controls. Now, today, AI is available on these free chess games on your phones and exponentially faster and better than the Deep Blue. Now, next we have artificial intelligence for rescue mission. Now, what a majority requires is the use of AI and technology to ensure that the help arrives faster. We can start by developing system which helps first responder find victims of earthquakes, flood, and other natural disasters. Normally, responders need to maximize aerial footage to determine where people could be stranded. However, examining a vast number of photos and drones footage is a very time and labor intensive. Now, this is a time critical process and it might very well be the difference between life and death for victims. So an AI system developed at Texas A&M University permits computer programmers to write basic algorithms that can examine extensive footage and find missing people in under 2 hours. Then again, we have artificial intelligence for wildlife poaching prevention. Hunting of wildlife species and poaching is a global problem, and it leads to extinction. For example, the latest African census showed a 30% decline in elephant population. So wildlife conservation areas have been established to protect these species from poachers, and these areas are protected by park rangers. Now the rangers, however, do not always have the resource to patrol the vast area efficiently. Now Uganda's Queen Elizabeth National Park uses predictive modeling to predict poaching threat levels. Such models can be used to generate efficient and feasible patrol for the park rangers. Now, if we talk about smart agriculture, in my opinion, neural networks work well to provide smart agricultural solution. Everything ranging from complete monitoring of the soil and crop yield to providing predictive analytics model to track and predict various factors and variables that could affect future yields. For example, the Berlin-based agricultural tech startup, which is PEAT, has developed a deep learning algorithm-based application called Plantix, which can identify defects and nutrients deficiency in the soil. Now, these algorithms correlate particular foliage patterns and create soil defects, plant pests, and diseases. Well, one day you are wondering what exactly is artificial intelligence, and later robots are ready to perform surgical procedures on you. Now, robots today are machine learning enabled tools that provide doctors with extended precision and control. Now, these machines enable shortening the patient's hospital stay, positive affecting the surgical experience, and reducing the medical cost all at once. Similarly, mind-controlled robotic arms and brain chip implants have been begun, helping paralyzed patients regain mobility and sensation of touch. Overall, machine learning and artificial intelligence are helping improve patients' experience on the whole. Now, if we talk about tracking the wildlife population, it is amazing to see that applications like iNaturalist and eBirds collect data on the species encountered. This keeps track of species population, ecosystem, and migration patterns. As a result, these applications also have an important role in the better identification and protection of marine and freshwater ecosystem as well. I personally believe that artificial intelligence will revolutionize all the aspects of our daily life, and it will be subtle enough and have a big impact on everything around us. Now, if we have a look at the different domains of artificial intelligence, first of all, we have neural networks. So neural networks are a class of models within the general machine learning literature, and they are a specific set of algorithms that have revolutionized machine learning and artificial intelligence. So you want to know more about neural networks, I'll drop a link in the description box below for the deep learning and neural networks tutorial. Now, robotics is a branch of AI which is composed of different branches and applications of robots. AI robots are artificial agents acting in a real-world environment. Artificial intelligence robots is aimed at manipulating the objects by perceiving, picking, moving, and destroying it. Now, if we talk about expert systems in artificial intelligence, an expert system is a computer system that emulates the decision-making ability of human expert. It is a computer program that uses artificial intelligence technologies to stimulate the judgment and the behavior of a human or an organization that has expert knowledge and experience in a particular field. Now, fuzzy logic system. So fuzzy logic is an approach to computing based on the degrees of truth rather than the usual true or false, the Boolean logic on which the modern computer is based. Fuzzy logic systems can take imprecise, distorted, and noisy input information. So fuzzy logic is a solution to complex problems in all fields of life, including medicine, as it resembles human reasoning and decision making. Now, one of the most important aspects of AI is natural language processing. It refers to the artificial intelligence method of communicating with intelligent system using a natural language. Now, by utilizing NLP and its components, one can organize the massive chunks of text data, perform numerous automated tasks, and solve a wide range of problems such as machine translation, name identity recognition, sentimental analysis, speech recognition, and topic segmentation. Now, these were the different domains of AI, and it just tells us how wide AI is, and it's just not confined to just one sort of area of development. Now, according to the job site Indeed, the demand for AI skills has more than doubled over the past 3 years, and the number of job posting is up by 119%. Now, this artificial intelligence tutorial will be incomplete without the different job profiles. So, if artificial intelligence appeals to you and you want a job in the AI field, then there are the different job profiles you can apply for if you have all the AI skills. Now, again, if you want to know more about the artificial intelligence skills, what are required to become a machine learning engineer, supposedly a data scientist, you can refer to our other videos. I'll leave the link in the description box below as well for those videos. So the first job profile we're going to talk about is machine learning engineers. So they are sophisticated programmers who develop machines and systems that can learn and apply knowledge without specific direction. Artificial intelligence is the goal of a machine learning engineer. It cannot be more straightforward. And they are computer programmers, but their focus goes beyond specifically programming machines to perform specific tasks. They create programs that will enable machines to take actions without being specifically directed to perform those tasks. And they can earn a whopping $110,000 per annum. That's a huge amount of money. Now, the next job profile is the data scientist, and it has been awarded as the sexiest job of this 21st century. So, data scientists are those who crack complex data problems with their strong expertise in certain specific discipline. They work with several elements related to mathematics, statistics, computer science, and much more. And the data scientist role is a position for a specialist. You can specialize in different types of skills like speech analysis, text analysis, image processing, video processing. You have material simulation, medicine simulation, and each of these specialist role is a very limited in number, and hence the value of such a specialist is immense, with an average salary of $90,000 to $100,000 per annum. Now let's talk about an artificial intelligence engineer. So artificial intelligence engineer works with algorithms, neural networks, and other tools to advance the field of AI in some way. Engineers may also choose between projects involving weak or strong artificial intelligence, where the different setup focus on different capabilities. The salary of an AI engineer is around $105,000. Now, the next job profile which I'm going to talk about is the business intelligence developer. So, a business intelligence developer spends a lot of time researching and planning solutions for existing problems within the company. The business intelligence developer is responsible for aggregating data from multiple sources in an efficient data warehouse and designing enterprise-level solutions for a very large multidimensional database. Business intelligence developers play a key role in improving the efficiency and the profitability of a business. It's a career that's in high demand and commands an annual median salary of $92,000. Now, the big data engineers and architects have among the best paying jobs in artificial intelligence. In fact, they command an annual median salary of $150,000. The big data solution architect is responsible for managing the full life cycle of a Hadoop solution. This includes creating requirement analysis, the platform selection, designing of the technical architecture, the design of the application design, and the development, testing, and the deployment of the proposed solution. So these were the job profiles which you can refer or you can apply for if you have all the skills which are needed for these particular job profiles. And finally, if we have a look at the companies which are hiring, companies that hire top AI talent range from startups like Argo AI to tech giants like IBM. And according to Glassdoor, these are the leading employers who hired top AI talent over the past years. So as you can see, we have Dropbox, Adobe, IBM, LinkedIn, Walmart, we have Uber, we have Red Hat, and Cheese. Now let's go ahead and start our demo and see how we can perform object detection using TensorFlow. Now to begin with, you want to make sure that you have TensorFlow installed with all of its dependencies like the tensor board, Python, Matplotlib, we have the Cocoa API and the protobuf. Now I'll explain you guys what all steps are needed. So for CPU TensorFlow, you can just do pip install TensorFlow, but of course the GPU version of the TensorFlow is much faster at processing, so it is ideal. Now next we need to do is to clone the GitHub repository of TensorFlow. So for that, just go to GitHub and type TensorFlow, which is the official GitHub repository of TensorFlow. And inside that we have the models section. Just go to this models. you can either clone this TensorFlow model or download it as per your wish. So I have already downloaded the TensorFlow model. Now, the TensorFlow object detection model uses protobuf to configure model and the training parameters. Before the framework can be used, the protobuf libraries must be compiled. Now, to download protobuf, all you need to do is go to Google/protobuf in GitHub, and here you will have all the different versions of protobuf. So according to your OS, which is Linux, Mac OS, or the Windows OS, or if you are using only the Python, you can download the required protobuf. So once you have downloaded TensorFlow and protobuf, create a folder in just C, which is known as TensorFlow, and in this you'll have the models master. Extract this and rename it as models and extract the protobuf. Now inside protobuf you have the bin folder. Now all you need to do is go to this bin folder. So let me just open the command prompt. Here I am using the Anaconda prompt, but you can use the command prompt as well. So once you have downloaded and renamed the models master as models, go back to the GitHub repository, and inside models you have the research, and inside research there is the object detection model which we are interested in. So let's go to the object detection model here. Now as you can see, this TensorFlow object detection API gives an accurate machine learning model description of how the objects are detected, and here you have the steps for the setup. So in the installation, as you can see, we have the prerequisites or the dependencies, which are the protobuf, Python, Pillow. You can install all of these using the pip or the conda command. Okay, so to download the protobuf on Ubuntu, you can do the sudo apt-get install. Then you can use the Cython, the contextlib, the Jupyter, and the matplotlib. Alternatively, you can also use the pip and the conda commands. And next, what you need to do is, once you have downloaded and extracted the protobuf, you need to copy this command. Now then you need to go into the TensorFlow, then you need to go into the models, and then inside that you need to go into the research. Now once you are inside the research, what you need to do is copy this command and paste it and run this command here. So what it'll do is, I'll explain here, is that it will take all the object. If you go inside the models, research, and inside if you go to the object detection, you can see there's a folder named protos. So once you have compiled that code, all the proto files are then converted into the Python files. Now in order to have a better understanding of what the different supported components are, inside the protos folder, which contains the functional definition, especially the train, the eval, the SST, the faster RCNN, and the processing protos, which are important while training a model, all these proto files are present here. What you need to do is that run that command, and all the protos file will be converted into Python executable files. Now after that, what we need to do is Cocoa API installation. Now let's understand what is Cocoa. Now Cocoa refers for common objects in context. It is a large image dataset designed for object detection, segmentation, person key points detection, stuff segmentation, and caption generation. Now this package provides MATLAB, Python, and Luna APIs that assist in loading, parsing, and visualizing the annotations in Cocoa. As you can see, we have 330K images, in which we have more than 200K labeled images. We have 1.5 million objects instances, 80 object categories, we have 91 stuff categories, 5 captions per image, and we have 250 people with these key points. Now, when you have downloaded the models, inside models, research, and inside the object detection, you need to go to the G3 doc, in which we have the TensorFlow detection model zoo. Now here we have all the list of models which are trained on the Cocoa dataset. So as you can see, we have the SST MobileNet version 1, we have the SST MobileNet version 1 PPN Cocoa, Depth Cocoa, we have the SST Inception, we have faster RCNN, we have different mask RCNN Inception. Now an important thing to consider here while selecting a model is that it depends on your system which model you should use. Suppose if your system is low on GPU but has higher RAM, you can go for a model which has a higher speed and a higher MAP point. Now this value should always be high if you're looking for a more accurate prediction in your images. So once all your dependencies are downloaded and you have installed TensorFlow and Protobuf, let's go ahead and see how we can do the coding. Now inside the object detection folder, there is an object detection tutorial. Now, first of all, what we need to do is import all the libraries, the NumPy, the OS, the SYS star file. We are importing TensorFlow as well. We are importing the collections and the various imports which are needed. Then we need to append the path of the object detection folder. And finally, if the version of TensorFlow is less than 1.4, we need to upgrade it as the latest tutorial supports the TensorFlow object 1.4 and above. So let's run this block by block. So first of all, let's load all the libraries. Now next what we are going to do is import the object detection module, some of the labels, which are the label map util, which will be later used to provide the labels to the input images, and based on that our model will be created. Now next what we are going to do is we are going to select which model to download. So for example, here we are using the SST MobileNet version 1 Coco 2017. So if you go back to the list of the models, you can select any of the given models here. But make sure your system should support the required amount of RAM and it should have the required amount of GPU to support the models which you are selecting. So for this tutorial, I'm using a model which will give me the results faster. So all you need to do is provide the model name, the model file, and the download base from where it should download. Now, as I mentioned earlier, that TensorFlow works on the graph principle, which is the data flow graph. So what we are going to do is give the path to the detection graph, which we are going to use here, which will be supported by this model. And then we are going to give the path to the labels. Now to download the models, we have this code which will take the URL and which will download this file and produce the frozen inference graph of that model, which is the SST Coco MobileNet. So once this has been done, we are going to load the graph, which is the frozen inference graph, into the memory. So here we are using the tf.graph method and tf.graphDef to define the graph which we are going to use. Next, what we need to do is load all the labels and the categories and the category index from our data set. So the data set is Coco. So once we have loaded all the labels and the categories, now is the time to convert all the images to a NumPy array. So this code, which is definition here of the load image into NumPy array, which we'll use later in this code, what it does is takes the images and converts it into a NumPy array, so it will be easier for TensorFlow to process it. Now here we are going to provide the images for testing purposes. So as you can see, we have the test image folder here, and inside that you can input all your images, whichever you want to test upon this model. So for example, I have taken the range from 1 to 8. It'll take all the images named image 1 to image 7. So let's load this. Now this function, what it does is run the inference for a single image. Now for a single image, first of all, it detects all the boxes, the detection mask, and provides a certain box on the object it detects. And finally, we have the for loop, the main for loop, in which we'll take the images from the test image path and open them, and one by one we'll take all the images and do the inference for a single image one by one. So as you can see, we are using the load image into NumPy array. We are using the np.expand. Now we'll expand the dimensions since the model expects images to have the shape, which can be 1, 2, 3 based upon the categories. And you can see the output will get the detection boxes, the detection classes, and the detection score. And finally, we are using the matplotlib to show us the image. So let's run this. We'll get our output here. So this might take time depending upon the processor which you are using or the system which you are using. So since we have taken the model which will take the least amount of time, this shouldn't take much time. But then again, TensorFlow is heavy and the tensors are multidimensional arrays, as I explained, which do all the heavy computation. So guys, here we have the results. So as you can see, let's begin from the start. As you can see, it identified the dog as a 94%. It has provided a box, the label, and the score, which is the detection score, how much it is similar to all the images which has been inputted in the COCO dataset. So as you can see here, we have the person, the various percentage, we have kite, here we have a tie detected. It can detect objects in such a heavy background. As you can see, the person are so much camouflaged in the background, but still it has managed to score that person. As you can see here, it has detected an airplane, person, kite. Now you can use your own images. All you need to do is copy that images into the test image folder and use the naming convention provided here as the image 1, image 2.
Why become an AI engineer? We're going to break it down into 3 components. The first one is the demand for AI. We'll see some facts and figures here. Next one is job opportunities. We'll see some figures of currently available jobs and who's hiring. And the third one is salaries. We'll take a look at what AI engineers tend to make when they are starting out. Okay, first up, the demand. AI market worth in 2020 was around 30 billion US dollars, and it is forecasted to rise at a whopping 35.6% compounded annual growth rate, which is unprecedented for any industry, and it's going to rise to 300 billion US dollars by the year 2026. AI engineering has found its way in all sorts of industries, and applications of it can be seen in industries such as IT, transportation, finance, manufacturing, aerospace, medical, pharmaceutical, and more. AI has been helping businesses make better decisions, which is giving them competitive edge in the market. It is also predicted that by the year 2030, 9% of all unskilled and low-skilled jobs like data entry, receptionist, customer service executives, drivers, etc. are going to be taken over by AI. This signifies that if we are to embrace AI fully, then it is of utmost importance that we understand the basics of AI and how the whole world is being transformed by it. Let's now move on to the next part of the section, which is job opportunities. In India, there are over 19,200 AI engineer jobs, and in the United States, that number is 30,400. So you might be wondering, who's hiring all of these AI engineers? Well, all the big names in their respective industries such as Amazon, Microsoft, Google, Tesla, Mercedes-Benz, Autodesk, IBM, Nvidia, Intel, and a zillion more companies, small all the way to large multinational corporations, are hiring AI engineers as everybody's looking to the future. Alright, let's now move on to the moment that you all have been waiting for. Let's discuss the salaries. The numbers that you see on the screen are just the average base salaries. They don't include things like incentives, bonuses, allowances, benefits, and so on. Also, AI engineers that have been working in the field for over 5 years are making 15 to 30 lakhs for India and well over $200,000 in United States. Those are some darn good figures. Let's now talk about what does an AI engineer do. In a nutshell, AI engineer builds and trains AI models and systems that can process usually enormous chunks of data, for example, cloud data sets, to produce vital results that can help anyone make smart decisions. And to accomplish that, they use machine learning algorithms and deep learning neural networks. So let's now dig a little deeper on what they do on a daily basis by taking a look at some of the roles and responsibilities. They study and transform data science prototypes and select appropriate data sets and data representation methods. Next, they're responsible for developing machine learning applications according to requirements with APIs so that it could be used by other applications in the organization to make better decisions. They're also in charge of researching and implementing appropriate machine learning algorithms and artificial intelligence tools. Next, they run machine learning and artificial intelligence tests and experiments, and they train and retrain systems when necessary. In some forms of industries, they're also responsible for working with electronic engineers and robotic teams to make sure that the product is evolving properly and it's doing what it's intended to do. They also keep abreast the latest developments in the field of AI. Okay guys, let's move on to the next one, which is skills required. We're going to take a look at a couple of job descriptions that will help you understand what kind of skills are required. So the first one here is from Apple. So guys, you can pause your screen if you wish to read the whole thing, but I'm just going to give you a gist of the whole thing. So there's emphasis on bachelor's or master's degree in computer science or related field. They should have experience in machine learning algorithms and AI, data mining, distributed machine learning architectures, networking, statistics, linear algebra, and so on. They should be able to understand and implement software development lifecycle, and they should have exposure to A/B testing. Next one is from EY. Again, pause your screen if you want to read. Here's the emphasis. The candidate should know machine learning development and infrastructure. They should also know big data and cloud-based architectures. They should know programming languages such as Java and Python, and they should know the important algorithms in machine learning and artificial intelligence. They should also know big data tools like Spark, and they should be able to communicate complex models to business stakeholders. The last one we're taking a look at is from Oracle. The candidate should have a bachelor's or master's degree in computer science, mathematics, AI or machine learning or related field. They should have one high-level language such as Java or Scala and one scripting language such as Python or JavaScript. They should know the machine learning algorithms. They should be well versed in statistics and mathematical models. They should know the big data technologies such as Spark, Hadoop, and so on. And they should also have experience working with the cloud. Okay guys, let's take a brief moment to talk about where some of the challenges that learners face when it comes to getting started. You know, different companies have different requirements. So for a learner, there's a lot of confusion surrounding how to get started and what route to take to get their dream job. And influenced by such requirements, they can set out on a path that leaves holes in their education and skills, so they become less confident and don't obtain their dream job. Well, we are here to alleviate that because your success is our success quite literally. So with that being said, let's put together a list of skills that you will require. Okay, so first you should be good at programming skills. So it's important to know one programming language such as Python, Java, R, or C++. It's also useful to know a scripting language like JavaScript or Python. Next, they should be good at math. When I say that, it means they should have a good grasp of linear algebra, calculus, statistics, and probability. Next, they should also learn machine learning algorithms such as linear regression, KNN, naive Bayes, support vector machines, and others. And they should know how to use machine learning libraries and platforms like TensorFlow. Next, they should learn natural language processing. In it, you should know how to process text, audio, or video using libraries like Gensim, NLTK, and techniques like Word2Vec, sentimental analysis, and so on. Next, they should learn deep learning and neural networks by learning algorithms like convolutional neural network, recurrent neural network, and generative adversarial network, and implement them using a framework like TensorFlow, PyTorch, or others. And finally, they should know big data technologies like Spark. AI engineers usually work with large volumes of data that could be in terabytes or even petabytes. And to make sense of such a humongous volume of data, they need to know Apache Spark or other big data technologies such as Hadoop, Cassandra, or MongoDB. Along with that, they should also know cloud services like AWS, GCP, Azure. Okay, so with skills out of the way, let's see how to become an AI engineer. Okay, so here's the roadmap. First, you should have a formal education in computer science, mathematics, information technology, finance, or economics, like we discussed earlier. Then it's time to hone your technical skills such as programming skills, software development, lifecycle, modularity, object-oriented programming, classes and objects, statistics and mathematics. You can hone your skills by teaching others what you've learned, and so going up to GitHub and solving problems for other programmers and so on. Next, learn essential technologies and concepts like big data and cloud services. This is going to be the platform on which you will build your specialization in artificial intelligence. Next, yes, it is time to get specialized in artificial intelligence and machine learning by getting a master's or certifications that will help you get there. So obviously here you're going to be learning about machine learning algorithms and deep learning and neural networks. And finally, combining all of these skills and knowledge, you're going to be building some hands-on demos and projects that will help you stand out from the crowd of applicants. And once you have all of this down, it's time to apply for your dream job. Hope this was clear enough for you and you can evaluate yourself to find out where you stand on this roadmap and so that you can continue on to your dream job.
History of artificial intelligence. The concept of AI goes back to the classical ages. Under Greek mythology, the concept of machines and mechanical men were well thought of. An example is Talos. Talos was supposedly a giant animated bronze warrior who was programmed to guard the island of Crete. Now let's get back to the 19th century. In 1950, Alan Turing proposed the Turing test. The Turing test basically determines whether or not a computer can intelligently think like a human being. The Turing test was the first serious proposal in the philosophy of artificial intelligence. 1951 marked the era for game artificial intelligence. This period was called game AI because here a lot of computer scientists developed programs for checkers and for chess. However, these programs were later rewritten and redone in a better way. 1956 marked the most important year for artificial intelligence. During this year, John McCarthy first coined the term artificial intelligence. This was followed by the first AI laboratory, which was set up in 1959. MIT AI Lab was the first setup, which was basically dedicated to the research of AI. In 1960, the first robot was introduced to the General Motors assembly line. In 1961, the first AI chatbot called Eliza was introduced. In 1997, IBM's Deep Blue beats the world champion Garry Kasparov in the game of chess. 2005 marks for the year when an autonomous robotic car called Stanley won the DARPA Grand Challenge. In 2011, IBM's question answering machine, Watson, defeated the two greatest Jeopardy champions, Brad Rutter and Ken Jennings. So that was a brief history of AI. Now guys, since the emergence of artificial intelligence in 1950s, we have seen an exponential growth in its potential. AI covers domains such as machine learning, deep learning, neural networks, natural language processing, knowledge base, expert systems, and so on. So now let's understand the different stages of artificial intelligence. So basically, when I was doing my research, I found a lot of videos and a lot of articles that stated that artificial general intelligence, artificial narrow intelligence, and artificial super intelligence are the different types of AI. If I have to be more precise with you, then artificial intelligence has three different stages, right? The types of AI are completely different from the stages of AI. So under the stages of artificial intelligence, we have artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. So what is artificial narrow intelligence? Artificial narrow intelligence, also known as weak AI, is a stage of artificial intelligence that involves machines that can perform only a narrowly defined set of specific tasks. Right? At this stage, the machines don't possess any thinking ability. They just perform a set of predefined functions. Examples of weak AI include Siri, Alexa, AlphaGo, Sophia, the self-driving cars, and so on. Almost all the AI-based systems that are built till this date fall under the category of weak AI or artificial narrow intelligence. Next, we have something known as artificial general intelligence. Artificial general intelligence is also known as strong AI. This stage is the evolution of artificial intelligence, wherein machines will possess the ability to think and make decisions just like human beings. There are currently no existing examples of strong AI, but it's believed that we will soon be able to create machines that are as smart as human beings. Strong AI is actually considered a threat to human existence by many scientists. This includes Stephen Hawking. Stephen Hawking quoted that the development of full artificial intelligence could spell the end of human race. Moving on to our last stage, which is artificial superintelligence. Artificial superintelligence is that stage of AI when the capability of computers will surpass human beings. Artificial superintelligence is currently seen as a hypothetical situation as depicted in movies and science fiction books. You see a lot of movies which show that machines are taking over the world. All of that is artificial superintelligence. Now, I believe that machines are not very far from reaching the stage taking into consideration our current pace. However, such systems don't currently exist, right? We don't have any machine that is capable of thinking better than a human being or reasoning in a better way than a human. Artificial superintelligence, basically any robot that is much smarter than humans. Now, moving on to the different types of artificial intelligence. Based on the functionality of AI based systems, artificial intelligence can be categorized into four types. The first type is reactive machines AI. This type of AI includes machines that operate solely based on the present data and take into consideration only the current situation. Reactive AI machines cannot form inferences from the data to evaluate any future actions. They can perform a narrowed range of predefined tasks. An example of reactive AI is the famous IBM chess program that beat the world champion Gary Kasparov. This is one of the most impressive AI machines built so far. Next, we have limited memory AI. Now, like the name suggests, limited memory AI can make informed and improved decisions by studying the past data from its memory. So, such an AI has a short lived, or you can say a temporary memory that can be used to store past experiences and hence evaluate your future actions. Self driving cars are limited memory AI that use the data collected in the recent past to make immediate decisions. For example, self driving cars use sensors to identify civilians that are crossing the road. They identify any steep roads or traffic signals, and they use this to make better driving decisions. This also helps in preventing any future accidents. Next, we have something known as theory of mind artificial intelligence. The theory of mind AI is a more advanced type of artificial intelligence. This category is speculated to play a very important role in psychology. This type of AI will mainly focus on emotional intelligence so that human beliefs and thoughts can be better comprehended. The theory of mind AI has not been fully developed yet, but rigorous research is happening in this area. Moving on to our last type of artificial intelligence is the self aware artificial intelligence. So, guys, let's just fold hands and pray that we don't reach the state of AI where machines have their own consciousness and become self aware. This type of AI is a little far fetched, but in the future, achieving a stage of super intelligence might be possible. Geniuses like Elon Musk and Stephen Hawking have constantly warned us about evolution of AI. So guys, let me know your thoughts in the comment section. Do you ever think we'll reach the stage of artificial super intelligence? Moving on to the last topic of today's session is the different domains or the different branches of artificial intelligence. So, artificial intelligence can be used to solve real world problems by implementing machine learning, deep learning, natural language processing, robotics, expert systems, and fuzzy logic. Now, guys, these are the different domains, or you can say the different branches that AI uses in order to solve any problem. Recently, AI has also been used as an application in computer vision and image processing. Right, for now, let me tell you briefly about each of these domains. Machine learning is basically the science of getting machines to interpret, process, and analyze data in order to solve real world problems. Right, under machine learning, there's supervised, unsupervised, and reinforcement learning. If any of you are interested in learning about these technologies, I'll leave a link in the description box. You all can go through that content. Next, we have deep learning or neural networks. So, deep learning is the process of implementing neural networks on high dimensional data to gain insights and form solutions. It is basically the logic behind the face verification algorithm on Facebook. It is the logic behind the self driving cars, virtual assistants like Siri and Alexa. Then we have natural language processing. Natural language processing refers to the science of drawing insights from natural human language in order to communicate with machines and grow businesses. So, an example of NLP is Twitter and Amazon. Twitter uses NLP to filter out terroristic language in their tweets. Amazon uses NLP to understand customer reviews and improve user experience. Then we have robotics. Robotics is a branch of artificial intelligence which focuses on the different branches and applications of robots. AI robots are artificial agents which act in the real world environment to produce results by taking some accountable actions. So I'm sure all of you have heard of Sophia. Sophia the humanoid is a very good example of AI in robotics. Then we have fuzzy logic. So fuzzy logic is a computing approach that is based on the principle of degree of truth instead of the usual modern logic that we use, which is basically the Boolean logic. Fuzzy logic is used in medical fields to solve complex problems which involve decision making. It is also used in automating gear systems in your cars and all of that. Then we have expert systems. An expert system is an AI based computer system that learns and reciprocates the decision making ability of a human expert. Expert systems use if then logic notions in order to solve any complex problem. They do not rely on conventional procedural programming. Expert systems are mainly used in information management. They are seen to be used in fraud detection, virus detection, also in managing medical and hospital records, and so on. So why exactly are we using Python for artificial intelligence? Why aren't we using any other language? Right? Now, there are a couple of reasons as to why Python is so popular when it comes to AI, machine learning, and deep learning. The first reason is less coding is required. Now, artificial intelligence has a lot of algorithms. If you have to implement AI in any code or in any problem, then there are going to be tons and tons of machine learning algorithms involved, deep learning algorithms involved, right? Now, testing all of these can become a very tiresome task. That's where Python usually comes in handy. Now, the language has something known as check as you code methodology, which eases the process of testing, right? You can check your program as you code it. Basically, as you're typing each sentence, your errors or your any sort of mistakes in your code will be given to you, right? So testing becomes much easier when it comes to Python. The next important reason why we're choosing Python is it has support for pre-built libraries. Right? Python is very convenient for AI developers because all of the algorithms, machine learning algorithms and deep learning algorithms are already predefined in libraries, right? So you don't have to actually sit down and code each and every algorithm. That will take a lot of time. Right? That's a very time consuming task. And thanks to Python, you don't have to do that because they have libraries and packages that have all the algorithms built in them, right? So if you want to run any algorithm, all you have to do is you have to call the function and load the library. That's all. It's as simple as that. Now, the next reason is ease of learning. So guys, Python is actually the most simplest programming language, right? If you ask me, I think it's the most easiest programming language. It's very similar to English language, right? If you read a couple of lines in Python, you'll understand what exactly the code is doing. It has a very simple syntax, and this simple syntax can be implemented to solve simple problems like addition of two strings, and it can also be used to solve complex problems like building machine learning models and deep learning models. So ease of learning is a major factor when it comes to why Python is chosen for artificial intelligence, right? Next, we have platform independent. So a good thing about Python is that you can get your project running on different operating systems, right? And what happens when you transfer your code from one operating system to another operating system is we find a lot of dependency issues. To solve that, Python has a couple of packages, such as there is a package known as PyInstaller. Right? This PyInstaller will take care of all the dependency issues when you're transferring your code from one platform to the other platform. So all of this support is provided by Python. The last reason is massive community support. This is a very important point because it is important that you have a large community that will help you out with any errors or with any sort of problems in your code. Right? So Python has several communities and several forums and groups on Facebook. So if you have any doubts regarding any error, you can just post those errors in these groups and you'll have like a bunch of people helping you out. Right? So guys, these are a couple of reasons as to why Python is chosen for artificial intelligence. It's actually considered the most popular and the most used language for data science, AI, machine learning, and deep learning. To prove that to you, here is a stat from Stack Overflow. Stack Overflow recently stated that Python is the fastest growing programming language. If you look at the graph, you can see that it has taken over JavaScript and Java and C hash, C++ and PHP, right? So Python is actually growing at an exponential rate, especially when it comes to data science and artificial intelligence. A lot of developers are very comfortable with the Python language because, it's a general purpose language, first of all. So most of the developers are already aware of Python. And then using the same language in order to solve complex problems like artificial intelligence, machine learning, and deep learning is something every developer wants, right? They want a simple language in order to code all the complex algorithms or the complex models, right? So that's why Python is the best choice for artificial intelligence. For those of you who are not aware of Python programming and don't know much about Python, I'm going to leave a couple of links in the description box, right? You can go through those links and study a little bit more about how Python works or how the coding part works, right? I'm going to be focusing mainly on artificial intelligence and I'll be showing you a lot of demos. So those of you who are not aware of Python, make sure you check the description box, right? Next, I'm going to discuss the different Python packages for artificial intelligence. Now, these are the packages that are specifically for machine learning, deep learning, natural language processing, and so on. So let's take a look at all these packages. So first we have TensorFlow. If you are currently working on a machine learning project in Python, then you must have heard of this popular open source library known as TensorFlow. Right? This library was developed by Google in collaboration with Brain Team. TensorFlow is used in almost every Google application for machine learning. Now let me just discuss a few features of TensorFlow. It has a responsive construct, meaning that with TensorFlow, we can easily visualize each and every part of the graph, which is not an option when you're using other packages such as NumPy or Scikit, right? Another feature is that it's very flexible. Now, one of the most important TensorFlow features is that it is flexible in operability, meaning that it has modularity and the parts of which you want to make standalone, it offers you that option, right? It's very flexible in that way. It'll give you exactly what you want. Now, a good feature about TensorFlow is that you can train it on both CPU and GPU, right? So for distributed computing, you can have both these options. Also, it supports parallel neural network training. So TensorFlow offers pipelining in the sense that you can train multiple neural networks and multiple GPUs, which makes the models very efficient on any large scale system, right? So parallel neural network training is supported by TensorFlow, right? This is one of the most important features of TensorFlow. Apart from this, it has a very large community. And needless to say, if it has been developed by Google, then there's already a large team of software engineers who work on stability improvements and all of that, right? The next library I'm going to talk about is scikit-learn. Now, scikit-learn is a Python library that is associated with NumPy and SciPy, right? That's why it has the name scikit-learn. Now, this is considered to be one of the best libraries for working with complex data. There are a lot of changes that are being made in this library, and one modification is the cross-validation feature, which provides the ability to use more than one metric, right? Cross-validation is one of the most important and one of the most easiest methods for checking the accuracy of a model, right? So cross-validation is being implemented in scikit-learn. And apart from that, again, there are a large spread of algorithms that you can implement by using scikit-learn, right? These include unsupervised learning algorithms, starting from clustering, factor analysis, principal component analysis, to all the unsupervised neural networks. Scikit-learn is also very essential for feature extracting in images and text. So mainly scikit-learn is used for implementing all the standard machine learning and data mining tasks like reducing dimensionality, classification, regression, clustering, and model selection. Next up, we have NumPy. Now, NumPy is considered as one of the most popular machine learning libraries in Python. Now, let me tell you that TensorFlow and other libraries, they make use of NumPy internally for performing multiple operations on tensors. The most important feature of NumPy is the array interface. It supports multi-dimensional arrays, right? That's one of the most important features of NumPy. Another feature is it makes complex mathematical implementations very simple, right? It's mainly known for computing mathematical data. So NumPy is a package that you should be using for any sort of statistical analysis or data analysis that involves a lot of math. Apart from that, it makes coding very easy and grasping the concept is extremely easy with NumPy. Now, NumPy is mainly used for expressing images, sound waves, and other mathematical computations. All right. Moving on to our next library, we have Theano. Theano is a computational framework which is used for computing multi-dimensional arrays. Right? Theano actually works very similar to TensorFlow, but the only drawback is that you can't fit Theano into production environments. But apart from that, Theano allows you to define, optimize, and evaluate mathematical expressions that involve multi-dimensional arrays. Right? This is another library that lets you implement multi-dimensional arrays. Features of Theano include tight integration with NumPy. An advantage of Theano is that you can easily implement NumPy arrays in Theano, right? That's why there's a connection between Theano and NumPy, because both of them effectively use multi-dimensional arrays. Transparent use of GPU. Now, performing data-intensive computations are much faster when it comes to Theano because of its use of GPU, right? Theano also lets you detect and diagnose multiple types of errors and any sort of ambiguity in the model. So guys, Theano was actually designed to handle the types of computations required for large neural network algorithms, right? It was mainly built for deep learning and neural networks. It was one of the first libraries of its kind, and it is considered as an industry standard for deep learning research and development. Theano is being used in multiple neural networks projects, and the popularity of Theano is only going to grow with time. Right? A lot of people actually haven't heard of Theano, but let me tell you that this is one of the best ways to implement deep learning and neural network models. Moving on, we have Keras. Now, Keras is considered to be the most popular Python package. It provides some of the best functionalities for compiling models, processing your data sets, and visualizing graphs. It is also popular in the implementation of neural networks, right? It is considered to be the simplest package with which you can implement neural networks. In fact, in our today's demo for deep learning, we'll be implementing Keras in order to understand how neural networks work. Few of the features of Keras include that it runs very smoothly on both CPU and GPU. It supports almost all the models of a neural network, right? From fully connected, convolutional, pooling, recurrent, embedding, all of these models are supported by Keras. And not only that, you can combine these models to build more complex models. Keras is completely Python based, which makes it very easy to debug and explore, right? Since Python has a huge community of followers, it's very simple in order to debug any sort of error that you find while implementing Keras. So the libraries that I discussed so far were dedicated to machine learning and deep learning. For natural language processing, we have the most famous library known as the Natural Language Toolkit, which is an open source Python library mainly used for natural language processing, text analysis, and text mining. The main features include that it studies and analyzes natural language text in order to draw useful information from all this natural language text. It performs text analysis and sentimental analysis by performing tasks such as stemming, lemmatization, tokenization, and so on. Now, don't worry if you don't know what any of those terms mean. I'll be discussing all of those terms with you by the end of today's session. So guys, these were a couple of Python-based libraries which are very essential for implementing machine learning and deep learning and artificial intelligence when you're using Python. Right? These libraries are perfect for implementing AI. So guys, if any of you have any doubts regarding the libraries, or if you want to learn more about the libraries, I will leave a couple of links in the description box. You can go through those videos as well. So now let's move on to the main topic of discussion, which is artificial intelligence. Now, before we get started with the demand of artificial intelligence, let me tell you that AI was invented long ago. AI goes back to the 19th century. It was not something that was recently invented, even though AI has recently gained a lot of popularity. We can say that in the past decade, AI has gained the maximum popularity. But it was actually invented in the 19th century. Now, especially in the year 1950, there was somebody known as Alan Turing. I'm sure a lot of you have heard about the Turing test. The Turing test is basically used to determine whether or not a machine is artificially intelligent, meaning that whether a machine can think intelligently like a human being, right? This was the first proposition, and this was one of the most important breakthroughs in artificial intelligence, right? Somebody known as Alan Turing, he published a landmark paper in which he speculated about the possibility of creating machines that think, right? So the Turing test was the first serious proposal in the philosophy of artificial intelligence. This was done in 1950, right? After this, we had eras of AI. We had the game AI, which was in 1951. Now, since the emergence of AI in 1950s, we have seen an exponential growth in its potential, right? AI covers domains like machine learning, deep learning, neural networks, natural language processing, knowledge base, and so on. It's also made its way into computer vision and image processing. But the question is, if AI has been here for over half a century, why has it suddenly gained so much importance, right? Why are we talking about artificial intelligence now? The main reasons for the vast popularity of AI are the following, right? The first reason is more computational power. Now, AI requires a lot of computing power. Recently, many advances have been made and complex deep learning models can be deployed. And one of the greatest technology that made this possible are GPUs. Since the invention of GPUs, we can compute much more with our computers. Initially, we could barely process 1 GB of data, right? We only had hard disks to store additional memory and all of that. Now our computers can process tons and tons of data. So now we have more computational power, which is one of the main reasons behind why AI became so popular. So by having more computational power, it becomes much easier to implement artificial intelligence. Next reason is more data. Now, big data is one of the most important reasons behind the development of artificial intelligence. Now, AI and data science and machine learning, deep learning, all of these processes are here only because we have a lot of data at present. Now, the main idea behind all these technologies is to draw useful insights from data. Now, since we start generating a lot of data, we need to find a method that can process this much data and draw useful insights from data such that it benefits an organization or it grows a business. That's why artificial intelligence and machine learning comes into the picture, right? So more data led to the demand of artificial intelligence. Apart from this, we also have better algorithms now, right? We have state of the art algorithms. Most of them are based on the idea of neural networks, and these are constantly getting better. Neural networks are actually one of the most significant discoveries in artificial intelligence because with neural networks, you can take in 1,000 layers of input data, right? You can take in a lot of input data to perform computations. So through neural networks, we're actually able to solve a lot of problems, including healthcare problems, fraud detection problems, and so on. Another reason is broad investment. So our universities and governments and startups and any tech giants like Google, Amazon, and Facebook, they are all investing heavily in artificial intelligence, which also led to the demand of AI. So AI is rapidly growing both as a field of study and also as an economy, right? It's adding a lot to the economy. And I think this is the perfect time for you to get into the field of artificial intelligence because right now AI is in a really high demand. AI, machine learning, data science, all of this are of really high demand at present. Right, so this is the perfect time for you to get started with artificial intelligence. Now, let me tell you that the term artificial intelligence was first coined in the year 1956 by a scientist known as John McCarthy. Now, John McCarthy defined artificial intelligence as the science and engineering of making intelligent machines. Now, let me give you a descriptive definition of artificial intelligence. Artificial intelligence is the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. In a sense, artificial intelligence is a technique of getting machines to work and behave like humans. In the recent past, AI has actually been able to accomplish this by creating machines and robots that have been used in a wide range of fields, including healthcare, robotics, marketing, business analytics, and many more. Right? So AI is actually a very vast field. It covers a lot of domains, including machine learning, natural language processing, knowledge base, deep learning, computer vision, and expert systems. So these are a few domains that AI covers. Now let's move on and discuss the different types of artificial intelligence. Now guys, AI is structured along three evolutionary stages. You can say that AI is developed along three evolutionary stages. We have something known as artificial narrow intelligence, followed by artificial general intelligence, and finally we have artificial super intelligence. Artificial narrow intelligence, which is also known as weak AI, it involves applying AI only to specific tasks. Many of the currently existing systems that claim to use artificial intelligence are actually operating as weak AI, which is focused on a narrowly defined specific problem. Now, take Alexa. Alexa is actually a good example of artificial narrow intelligence. It operates within a limited predefined range of functions, right? There is no genuine intelligence or no self awareness, despite being a sophisticated example of weak AI. Google search engine, Sophia, and self driving cars, and even the famous AlphaGo fall under the weak AI category. Then we have something known as artificial general intelligence. This is also known as strong AI, and it involves machines that possess the ability to perform any intellectual task that a human being can. Now, guys, machines don't possess human like abilities. They have a very strong processing unit that can perform high level computations, but they're not yet capable of thinking and reasoning like a human. And there are also many who question whether it would be desirable. For example, Stephen Hawking warned that strong AI would take off on its own and redesign itself at an ever increasing rate. Humans who are limited by slow biological evolution couldn't compete and would be superseded. Right, so we have a lot of tech giants and a lot of geniuses who are actually worried if strong AI is ever implemented, it might take over the world. Right, so guys, let me tell you that strong AI is something that has not been implemented yet. We are only at the first stage of artificial intelligence, which is artificial narrow intelligence, also known as weak AI. Right, we haven't yet reached strong AI or artificial super intelligence. So, artificial superintelligence is a term that refers to the time when the capabilities of a computer will surpass humans. Right? ASI is currently seen as a hypothetical situation as depicted in movies and science fiction books where machines have taken over the world. Right? So, artificial superintelligence is something that is very far off, but tech masterminds like Elon Musk believe that artificial superintelligence will take over the world by the year 2040. Right, there are a lot of people who are against the development of artificial general intelligence and artificial superintelligence. A lot of us believe that we should stick to weak AI and not move any further and risk the existence of human civilization. So guys, let me know your thoughts about artificial intelligence in the comment section. I'd love to know what you guys think about AI and whether you all believe AI will take over the world or not. So now let's move on and talk about how artificial intelligence is different from machine learning and deep learning. A lot of people tend to assume that artificial intelligence, machine learning, and deep learning are the same because they have common applications. Right? For example, Siri is an application of AI, machine learning, and deep learning. So how are these technologies related, right? Or how are they different from each other? Now, artificial intelligence is the science of getting machines to mimic the behavior of human beings. Machine learning is the subset of artificial intelligence that focuses on getting machines to make decisions by feeding them data. Deep learning, on the other hand, is a subset of machine learning that uses the concept of neural networks to solve complex problems. So, to sum it up to you, artificial intelligence, machine learning, and deep learning are heavily interconnected fields. Right? Machine learning and deep learning aids artificial intelligence by providing a set of algorithms and neural networks to solve data driven problems. However, AI is not restricted to only machine learning and deep learning. Right? It covers a vast domain of fields which include natural language processing, object detection, computer vision, robotics, expert systems, and so on. Right? So AI is a very vast field. Guys, I hope I cleared the difference between AI, machine learning, and deep learning. Also, a lot of you might be confused about data science. Data science is now an umbrella term, right? Data science basically means to derive useful insights from data. So, data science actually uses AI, machine learning, and deep learning, right? So, it implements all of these three technologies in order to derive useful insights from data, right? Now let's move on to the most interesting topic in artificial intelligence, which is machine learning. Now, guys, the term machine learning was first coined by a scientist known as Arthur Samuel in the year 1959. Looking back, that year was probably the most significant in terms of technological advancements. In order to define machine learning, if you browse the internet for what is machine learning, you'll get at least 100 different definitions. In simple terms, machine learning is a subset of artificial intelligence which provides machines the ability to learn automatically and improve from experience without being explicitly programmed to do so. In a sense, it is the practice of getting machines to solve problems by gaining the ability to think. Now, the question here is, can a machine think or can a machine make decisions? Well, if you feed a machine a good amount of data, it will learn how to interpret, process, and analyze this data by using something known as machine learning algorithms. To give you a basic idea of how the machine learning process works, look at the figure on this slide. A machine learning process always begins by feeding the machine lots and lots of data. Now, by using this data, the machine is trained to detect any hidden insights and trends in the data. These insights are then used to build a machine learning model by using a machine learning algorithm in order to solve a problem. The basic aim of machine learning is to solve a problem or find a solution by using data. Now, moving ahead, I'll be discussing the machine learning process in depth, right? So don't worry if you haven't got the exact idea of what machine learning is. Now, the machine learning process involves building a predictive model that can be used to find a solution for a particular problem. A well-defined machine learning process will have around 7 steps. It always begins with defining the objective, followed by data gathering or data collection. Then we have something known as preparing data, which is also called data pre-processing. Then we have data exploration or exploratory data analysis. This is followed by building a machine learning model. Then we have model evaluation and finally predictions. This is how the process of machine learning works. To understand the machine learning process, let's assume that you've been given a problem that needs to be solved by using machine learning. Let's say that the problem is to predict the occurrence of rain in your local area by using machine learning. Now, the first step is to define the objective of the problem. Right? At this step, we must understand what exactly needs to be predicted. In our case, the objective is to predict the possibility of rain by studying the weather conditions. So at this stage, it is essential to take mental notes on what kind of data can be used to solve this problem or the type of approach that you must follow to get to the solution. The questions you should be asking yourself is, what are we trying to predict? Right? Here we're trying to predict whether it'll rain or not. Right? You need to understand what are the target features. Target features are basically the variable that you need to predict. Here we need to predict a variable that will show us whether it's going to rain tomorrow or not. Then you must also understand what kind of data you will need to solve this problem. Apart from that, you need to know what kind of problem you're facing. Is it a binary classification problem or is it a clustering problem? Now, if you don't know what classification and clustering is, don't worry, I'll be talking about all of these things in the upcoming slides. So your first step is to define the objective of your problem. You need to understand what exactly needs to be done here, right? How can you solve this problem? Moving on, your next step is to gather the data that you need. At this stage, you must be asking questions such as, what kind of data is needed to solve this problem? Is the data available to me? And if it's not available, how can I get the data? Right? Once you know the type of data that is required, you must understand how you can derive this data. Data collection can be either done manually or it can be done by web scraping. But don't worry if you're a beginner and you're just looking to learn machine learning, you don't have to worry about getting the data. There are thousands of data resources on the web. You can just download the data set and you can get going. Coming back to the problem at hand, the data needed for weather forecasting includes measures such as humidity level, your temperature, the pressure, the locality, whether or not you live in a hill station, and so on. Such data must be collected and it has to be stored for analysis. This is where you collect all the data. Now, moving on to step number 3 is data preparation. The data that you collected is almost never in the right format. All right, even if you collect it from an internet resource, if you download it from some website, even then your data is not going to be clean, right? It's not going to be in the correct format. There's always going to be some sort of inconsistencies in your data. Inconsistencies include any missing values or any redundant variables duplicate values. All of these are inconsistencies. Removing all of this is very essential because they might lead to any wrongful computation. Therefore, at this stage, you can scan the entire data set for any missing values and you have to fix them here itself. Now, actually, this is one of the most time consuming steps in a machine learning process. If you ask a data scientist which step he hates the most or which step is, the most time consuming, they're probably going to tell you data processing and data cleaning, right? It's one of the most tiresome tasks because you need to look at all the values that are there. You need to find any missing values, any data that is not relevant to you, right? All of this has to be removed such that you can analyze the data in a better way. Now, step number 4 is exploratory data analysis. So guys, this stage is all about getting deep into your data and finding all the hidden data mysteries. EDA or exploratory data analysis is like the brainstorming stage of machine learning. Data exploration involves understanding the patterns and the trends in your data. So at this stage, all the useful insights are drawn and any correlations between the variables are understood. For example, in the case of predicting rainfall, we know that there is a strong possibility of rain if the temperature has fallen low. Such correlations have to be understood and mapped at this stage. EDA is actually the most important step in a machine learning process because here is where you understand your data. You understand how your data is going to help you predict the outcome. Moving on to step number 5, we have building a machine learning model. So all the insights and all the patterns that you got from your data exploration stage, those insights are used to build the machine learning model. So this stage always begins by splitting the data set into two parts, that is training and testing data. Now remember that the training data will be used to build and analyze the model. The model is basically the machine learning algorithm that predicts the output by using the data that you feed to it. An example of machine learning algorithm is logistic regression and linear regression. All of these are machine learning algorithms. Now, don't worry about choosing the right algorithm, right? First, we'll focus on what the machine learning process is. But anyway, choosing the right algorithm will depend on several factors, right? It depends on the type of problem you're trying to solve, the data set, and the level of complexity of the problem. In the upcoming sections, we'll discuss all the different types of problems that can be solved by using machine learning. Moving on to step number 6, we have model evaluation and optimization. Now, after you build a model by using the training dataset, it is finally time to put the model to a test. The testing dataset is used to check the efficiency of the model and how accurately it can predict the outcome. Now, once the accuracy is calculated and any further improvements in the model, they have to be implemented at this stage. Methods like parameter tuning and cross-validation can be used to improve the performance of the model. Before I move any further, I don't know if all of you know what training and testing data set means. In machine learning, the input data is always divided into two sets. We have something known as the training data set and we have something known as the testing data set. So in machine learning, you always split the data into two parts, right? This process is known as data splicing. Now, the training data set will be used to build the machine learning model, and the testing data set will be used to test the efficiency of the model that you built. This is what training and testing data set is. They're not any different data that you derive, they're the same as the input data set. The only thing is you are splitting the data set so that you can train the model on one data and test the model on another data. Now remember that the training data set is always larger in size when compared to the testing data set, because obviously you are training and building the model by using the training data set. The testing data set is just for evaluating the performance of your model. Now let's move on and understand step number 7, which is predictions. Now once the model is evaluated and you've improved the model, it is finally used to make predictions. The final output can be a categorical variable or it can be a continuous quantity, right? All of this depends on the type of problem you're trying to solve. Don't worry, I'll be discussing the type of problems that can be solved using machine learning in the upcoming slides. In our case, for predicting the occurrence of rainfall, the output will be a categorical variable. Categorical variable is anything that has some categorical value. For example, gender is a categorical variable. Gender has either male, female, or other. It has a defined set of values. That is a categorical variable. So guys, that was the entire machine learning process. Now, as we continue with this tutorial, in the upcoming sections, I will be running a demo in Python in which we will be performing weather forecasting. So make sure you remember all these steps that I spoke about, because I'll be going through all these steps by using Python. We'll be coding all of this that we just spoke about. Now, the next topic we're going to discuss is the types of machine learning. A machine can learn to solve a problem by following any one of the three approaches. You can say that there are three ways in which a machine learns. The three ways are supervised learning, unsupervised learning, and reinforcement learning. These are the three methods in which you can train a machine to learn. So first, let's discuss supervised learning. So what is supervised learning? Supervised learning is a technique in which we teach or train the machine by using data which is labeled. To understand this better, let's consider an analogy. As kids, we all needed guidance to solve math problems. At least I had a really tough time solving math problems. Yeah, so our teachers always helped us understand what addition is and how it is done. Similarly, you can think of supervised learning as a type of machine learning that involves a guide. The label dataset is a teacher that will train the machine to understand the patterns in the data. The label dataset is nothing but the training dataset. So to better understand this, consider the figure. Right here, we are feeding the machine images of Tom and Jerry, and the goal is for the machine to identify and classify the images into two separate groups. Basically, one group will contain Tom images and the other group will contain images of Jerry. Now pay attention to the training dataset. The training dataset that is fed to a model is labeled, as in we're telling the machine, listen, this is how Tom looks and this is how Jerry looks. We're basically labeling each data point that we're feeding to the machine, right? If the image is of Tom's, we've labeled it as Tom, and if the image is a Jerry image, then we're going to label it as Jerry. By doing this, you're training the machine by using labeled data. So to sum it up, in supervised learning, there is a well-defined training phase done with the help of labeled data. Right? The rest of the process is the same. After you feed the machine labeled data, you're going to perform data cleaning, then exploratory data analysis, followed by building the machine learning model, and then model evaluation, and finally your predictions. Also, one more point to remember is that the output that you're going to get in a supervised learning algorithm is a labeled output. This Jerry will be labeled as Jerry and this Tom will be labeled as Tom. Basically, you'll get a labeled output. Now let's understand what is unsupervised learning. Unsupervised learning involves training by using unlabeled data and allowing the model to act on that information without any guidance. So think of unsupervised learning as a smart kid that learns without any guidance. In this type of machine learning, the model is not fed with any labeled data. As in, the model has no clue that this image is Tom and this image is Jerry. It figures out patterns and the differences between Tom and Jerry on its own by taking in tons of data. For example, it identifies prominent features of Tom such as pointy ears, bigger in size and so on to understand that this image is of type 1. Similarly, it finds such features in Jerry and knows that this is another type of image, maybe type 2. Right? Therefore, it classifies the images into two different clusters without knowing who is Tom and who is Jerry. Now, the main idea behind unsupervised learning is to understand the patterns in your data set and form clusters based on feature similarity. Basically, it'll feature similar images or similar data points into one cluster, and it'll form another cluster which is totally different from the first cluster. So look at the output over here. The unlabeled output is basically clusters or groups of two different data. Next, we have something known as reinforcement learning. Now, reinforcement learning is comparatively different, right? It's pretty different from supervised and unsupervised. It is basically a part of machine learning where you put an agent in an environment and this agent learns to behave in the environment by performing certain actions and observing the rewards which it gets from these actions. To understand reinforcement learning, imagine that you were dropped off at an isolated island. What would you do? Initially, we'd all panic, right? But as time passes by, you will learn how to live on the island. You will explore the environment. You will understand the climate conditions, you'll understand the type of food that grows there, you'll know what is dangerous to you and what is not, you'll understand which food is good for you and which is not. This is exactly how reinforcement learning works. It involves an agent, which is basically you stuck on the island, that is put in an unknown environment, which is the island, where the agent must learn by observing and performing actions that result in rewards. Reinforcement learning is mainly used in advanced machine learning areas such as self-driving cars, AlphaGo, and so on. So guys, that sums up the types of machine learning. Before we go any further, I'd like to discuss the difference between supervised, unsupervised, and reinforcement learning. Now, first of all, we have the definition. Supervised learning is all about teaching a machine by using labeled data. Unsupervised learning, like the name suggests, there is no supervision over here. The machine is trained on unlabeled data without any guidance. Reinforcement learning is totally different. Here you have an agent who interacts with the environment by producing actions and discovers some errors and rewards. Now, the type of problem that is solved using supervised learning is regression and classification problems. We'll discuss what regression, classification, and clustering is in the upcoming slide, right? So don't worry if you don't know what it is. Unsupervised learning is mainly to solve association and clustering problems. Reinforcement learning is for reward-based problems. Now, what is the type of data in supervised learning? It is labeled data. That is the main difference between supervised and any other type of machine learning. In supervised, you have labeled data. In unsupervised, we have unlabeled data. Whereas in reinforcement learning, we have no predefined data at all. The machine has to perform everything from scratch. It has to collect data, analyze, do everything on its own. Now, the training in supervised learning is external supervision, meaning that we have external supervision in the form of the labeled training dataset. In unsupervised, there is obviously no supervision. There is an unlabeled dataset, therefore there's no supervision. In reinforcement learning, there is no supervision at all. Now, the approach to solving supervised learning problem is basically you're going to map your labeled input to your known output. In unsupervised learning, the machine is going to understand the patterns and discover the output on its own. Reinforcement learning, here the agent will follow something known as a trial and error method, right? It's totally based on the concept of trial and error. Popular algorithms under supervised learning are linear regression, logistic regression, support vector machines, and so on. Under unsupervised learning, we have the famous k-means clustering algorithm. Under reinforcement learning, we have the Q-learning algorithm, which is one of the most important algorithms. It is basically the logic behind the famous AlphaGo game. I'm sure all of you have heard of that. So guys, these were the differences between supervised, unsupervised, and reinforcement learning. Now let's move on and discuss the type of problems that you can solve by using machine learning. Now, there are three types of problems in machine learning. Now, any problem that needs to be solved in machine learning can fall into one of these three categories. Now, what is regression? In this type of problem, the output is a continuous quantity. For example, if you want to predict the speed of a car given the distance, that means it is a regression problem. First of all, what is a continuous quantity? A continuous quantity is any variable that can hold a continuous value. A continuous variable is any variable that can have infinite number of values. For example, the height of a person or the weight of a person is a continuous quantity, right? I can have a weight of 50.1 kgs or 50.12 or 50.112 kgs. This is a continuous quantity. Regression problems can be solved by using supervised learning algorithms. Another type of problem is the classification problem. Here, the output is always a categorical value. Classifying emails into two classes, for example, classifying your email as spam and non-spam, is a classification problem. Here again, you'll be using supervised learning classification algorithms such as support vector machines, naive Bayes, logistic regression, and so on. Then we have clustering problem. Right? This type of problem involves assigning the input into two or more clusters based on feature similarity. For example, clustering the viewers into similar groups based on their interest or based on their age or geography can be done by using unsupervised learning algorithms like k-means clustering. One thing you need to understand is under supervised learning, you can solve regression and classification problems. Under unsupervised learning, you can solve clustering problems. Reinforcement learning is something else altogether, right? You can solve reward-based problems and more complex and deep problems. So now let's move on and understand the different machine learning algorithms. Now, I will not be going into depth for machine learning algorithms because there are a lot of algorithms to cover, but we have content around almost every machine learning algorithm out there. So I'm just going to show you a hierarchical diagram of how the algorithms are structured. So under machine learning, we have three types of learning. We have supervised, unsupervised, and reinforcement. Under supervised learning, we have regression and classification problems. And under unsupervised learning, we have clustering problems. Reinforcement learning is completely different. I'll be leaving a link in the description specifically for reinforcement learning. You can check out the entire content of reinforcement learning there. Now, regression problems can be solved by using linear regression. Algorithms such as linear regression, decision trees, and random forests can also be used in regression problems. But usually, decision trees and random forests, all of these are used to solve classification problems. Famous classification algorithms include k-nearest neighbor, which is basically KNN, decision trees and random forest, logistic regression, naive Bayes, support vector machines. All of these are classification algorithms. Coming to unsupervised learning, we have clustering and association analysis. Right? Clustering problems can be solved by using k-means, and association analysis can be solved by using a priori algorithm. A priori algorithm is mainly used in market basket analysis. Right? For this algorithm as well, I'll be leaving a link in the description. We've performed a very excellent demo wherein we've showed how market basket analysis can be done by using a priori algorithm. Markov model is also explained in one of the videos. I'll be leaving that link in the description box. Now, to sum up machine learning to you, I'll be running a small demonstration in Python. Right? Like I promised earlier, I will be using Python to understand the whole machine learning process. All right, so let's get started with that demo. So guys, for those of you who don't know Python, I will leave a couple of links in the description box so that you understand Python. But apart from that, Python is pretty understandable. If you just look at the code, you'll know what exactly I'm talking about, right? So don't worry. And also I'll be explaining everything in the code. So I'm using PyCharm in order to run the demo, right? So guys, like I said, if you don't know Python, I'll leave a couple of links in the description box. You can go through those videos as well. The main aim of our demo is to build a machine learning model that will predict whether or not it will rain tomorrow by studying the past dataset. Now, this dataset contains around 145,000 observations on the daily weather conditions as observed in Australia. Right? The dataset has around 24 features, and we will be using 23 features out of that to predict the target variable, which is rain tomorrow. So this data set I collected from Kaggle, right? For those of you who don't know, Kaggle is an online platform where you can find hundreds of data sets, and there are a lot of competitions held by machine learning engineers and all of that. It's an interesting website. Now, the problem statement itself is to build a machine learning model that will predict whether or not it will rain tomorrow. This is clearly a classification problem. The machine learning model has to classify the output into two classes, that is either yes or no. Yes will stand for it will rain tomorrow, and no will basically denote that it will not rain tomorrow. Right? This is a classification problem. So I hope the objective is clear. Right? So we'll begin the demonstration by importing the required libraries. So first of all, for mathematical computations, we'll be importing the NumPy library. We'll also be importing the Pandas library for data processing. Next, we will load the CSV file. Basically, my data is stored in a CSV format in this file. Weather.os.csv is my data set. So basically, I've saved this file in this path, right? So that's what I'm doing here. I'm loading my data set and I'm storing it in a variable known as df. Next, what we'll do is we'll see the size of our data frame. Let's print the size of the data frame. We'll also display the first 5 observations in our data frame. So let's look at the output. Basically around 145,000 observations and 24 features. Now 24 features are basically the variables that are there in my data set. For example, date is a variable, location is a variable, minimum temperature, till rain tomorrow, all of these are variables. So I have around 24 features in my data set, right? Now the variable that I have to predict is rain tomorrow. Okay. If the value of rain tomorrow is no, it denotes that it will not rain tomorrow. But if the value is yes, then it will denote that it will rain tomorrow. So rain tomorrow is basically my target variable, right? I'll be finding out whether it's going to rain tomorrow or not. So this is my target variable, also known as your output variable. My input variables will be the other 23 variables: date, location, minimum temperature, rain today, risk. All of this will be my input variables. Now these variables are also known as predictor variables. Basically, they're used to predict your outcome. So these are also known as predictor variables. Now the next step is checking for null values. This is basically data pre-processing. Let me just comment it for you. This is data preparation or data. Right, so this stage is data pre-processing. Right here we start checking for any null values or any missing values. That's exactly what I'm doing over here. I am checking for any missing or null values in my data set. If you notice the output, it shows that the first 4 columns have more than 40% null values. Right, so it's always best for us to remove features or such variables because they will not help us in our prediction. Now, during data pre-processing, it is always necessary to remove the variables that are not significant. Unnecessary data will just increase our computations. That's why it's always best if we remove the unwanted or unnecessary variables. Now, apart from removing these 4 variables, we'll also remove the location variable and we will remove the date variable. Right? I'll come to this variable in a minute. We'll also be removing location and date variable because both of these variables are not needed in order to predict whether it'll rain tomorrow, right? We do not need to know the location and the date. Now we'll also be removing this risk variable. Risk variable basically tells us the amount of rain that might occur the next day. Right now, this is a very informative variable and it might actually leak some information to our model. By using this variable, we'll easily be able to predict, and there's no point of doing that. This variable will give us too much information. And so that's why we're going to remove this variable as well. It will leak a lot of information. So after that, if you print the shape of your data frame, we have only 17 variables and so many observations. Now after this, we'll just look at any null values and we'll remove them. This drop.any function will just remove all the null values. Right? Then if you print the shape of your data frame, we'll have around 112,000 rows with 17 variables. This is the shape of the data set after removing all the null values and all the redundant or unnecessary variables. Now it's time to remove the outliers in the data. So after you remove any null values, we should also check our data set for any outliers. An outlier is a data point that is very different from your other observations. Outliers usually occur because of miscalculations while collecting the data. These are some sort of errors in your data set. So in this whole code snippet, we're just getting rid of outliers. This is the output that we get, all our outliers. Next, what we'll be doing is we will be assigning zeros and ones in the place of yes and no. The only thing is we're going to change the categorical variables from yes and no to 0 and 1. Right? That's exactly what we're doing over here. Now, if there are any unique values, such as any character values which are not supposed to be there, we'll be changing them into integer values. That's all we're doing over here. After this, we'll be normalizing our data set. This is a very important step because in order to avoid any biasness in your output, you have to normalize your input variables. Right, to do this, we can make use of the min-max scalar function, which Python provides in a package known as sklearn. You can use that package in order to normalize your data set. So after normalizing our data set, this is what our data set looks like. This is before normalization. You can see that these are in 2 digits, whereas these values are in single digits. Right? This causes a lot of biasness. But once we normalize the values, we know that all of the values are in a similar range. We have everything in decimals, right? So normalization is something that has to be performed because if you have a data set like this, your output is not going to be correct. And that's why we perform normalization. So now that we are done with pre-processing, what we're going to do is it's time for exploratory data analysis. Let me just comment it for you. This is exploratory data analysis. So basically here what we're going to do is we're going to analyze and identify the significant variables that will help us predict the outcome. To do this, we'll be using the select k-best function, which is present in the sklearn library. There's a predefined function in Python called select k-best, which will basically select the most significant predictor variables in our data set. When we run that line of code, we get these three variables to be the most significant variables in our data set. Right? The main aim of this demo is to make you understand how machine learning works. That's why to simplify the computation, we'll assign only one of these significant variables as the input. Instead of taking all three variables as input, we'll select one variable and we'll take that as the input, and the output is the rain tomorrow variable. So basically, we are creating a data frame of all the significant variables. Basically, we're choosing this variable in order to predict our outcome. Obviously, our outcome is rain tomorrow variable. So our input is humidity level and our output is to detect whether it'll rain tomorrow. The next step is data modeling. All of you are aware of what data modeling is. To solve this, we'll be using classification algorithms over here. We'll use logistic regression. We will use random forest classifier, which is another machine learning algorithm. We'll also use the decision tree classifier and support vector machine. Right? We'll be using all of these algorithms in order to predict the outcome. We'll also check which algorithm gives us the best accuracy. So guys, we're just using multiple algorithms or multiple classification algorithms on the same data set. We're not doing anything very complex over here. So we start by importing all the necessary libraries for the logistic regression algorithm. We're also going to import time because we'll be calculating the accuracy and the time taken by the algorithm to get the output. So the first step is data splicing. I've already mentioned data splicing is splitting your data set into your testing data set and into your training data set. That's exactly what we're doing over here. So 25% of your data is assigned for the testing data and the remaining 75% is your training data. Here you're creating the instance of the logistic regression algorithm. This is an instance that you created. Then you'll fit the model by using your training data set. So basically, to build your machine learning algorithm, you'll be fitting your training data set. So xtrain and ytrain variables have your training data set. After that, you will be evaluating the model by using your testing data set. Then you'll calculate the accuracy score, right? I'll also be printing the accuracy using logistic regression and the time taken using logistic regression. Let's look at the accuracy. Don't worry about these warnings, they are not important. So accuracy using logistic regression is around 0.83%, which is 83% accuracy, approximately 84%. And this is the time taken. So the accuracy is actually pretty good, right? 84% is a good number. Then we have random forest classifier. Here again, we'll import the libraries that are needed to run random forest classifier. Then we're again calculating the accuracy and the time taken by the classifier. Data splicing, like I mentioned, splitting the data into testing and training data set. Then you're just building the model by using the training data set. After that, you'll evaluate the model by using the testing data set and you'll finally calculate the accuracy. The accuracy using random forest is again approximately 84%, which is a really good number. Then we have decision tree classifier. Here again, we'll be importing the libraries needed for this classifier. We'll be calculating the accuracy and the time taken by this classifier. Data splicing, followed by building the model by using the training data set, evaluating the model by using the testing data set, and finally calculating the accuracy and printing the accuracy. So let's see the accuracy using decision tree classifier. Again, we have an accuracy of around 83 to 84%. This is a pretty good number. And last, we're going to do this by using another classification algorithm known as support vector machine. Here again, we are importing the needed libraries. Then we're calculating the accuracy and the time, performing data splicing. Then we're building the model by using the training data set, testing the model using the testing data set, and finally printing the accuracy. So guys, all the classification models gave us an accuracy score of approximately 84% to 83%. So this is exactly how a machine learning process works, right? You begin by importing all your data, then you perform data pre-processing or data cleaning. After that, you perform exploratory data analysis, where you understand the important patterns or the important variables in your data set. After that, you build a model, then you will evaluate the model by using the testing data set, and finally calculate the accuracy. I showed you all the steps in the machine learning process by using a practical demonstration in Python. So guys, give yourself a pat on the back because we just understood the whole machine learning process with a small implementation in Python. Now let's move on to our next topic, which is limitations of machine learning. Before we understand what deep learning is, it's important to know the limitations of machine learning and why these limitations gave rise to the concept of deep learning. One major problem in machine learning is machine learning algorithms and models are not capable of handling high dimensional data. Right? We can take in data with 20 to 30 feature variables, but when it comes to data sets which have thousands of variables, machine learning does not work. Machine learning is not capable enough to process that much data. So high dimensional data cannot be analyzed, processed, and modeled by using machine learning. Another limitation is that it cannot be used in image recognition and object detection because these applications require the implementation of high dimensional data. Another major challenge in machine learning is to tell the machine what are the important features it should look for in order to precisely predict the outcome. So basically, you're selecting the important features for the machine learning model and you're telling them, like, these are the important features, and this is what you should use in order to build the model. This process is known as feature extraction. Now, in machine learning, this is a manual process. You're going to manually input as a programmer. You're going to tell that these are the important predictor variables. But what happens when your data set has hundreds of variables? How are you going to sit and choose every variable and perform analysis on each variable to understand which is a really significant variable? That's going to become a very tedious task, right? It's not possible for you to manually sit down with 100 variables, check the correlation with each variable, and understand which variable is significant in predicting the output. So performing feature extraction manually is very tedious, and that is one of the major limitations of machine learning. Now, deep learning comes to the rescue to all of these problems. So let's understand what deep learning is and why we have deep learning in the first place. So deep learning is actually one of the only methods by which we can overcome the challenge of feature extraction. This is because deep learning models are capable of learning to focus on the right features by themselves, requiring minimal human intervention, meaning that feature extraction will be performed by the deep learning model itself. You don't have to manually tell that this feature is important, that feature is important, choose this feature for predicting the output. All of this is not needed in deep learning. The model itself will learn which features are most significant in predicting the output. Also, deep learning is mainly used to deal with high dimensional data, right? It is based on the concept of neural networks and is often used in object detection and image processing. This is exactly why we need deep learning. It solves the problem of processing high dimensional data and manual feature extraction. Now, how exactly does deep learning work? Now, deep learning mimics the basic component of the human brain called the brain cell. The brain cell is also known as a neuron. So, inspired from a neuron, an artificial neuron was developed. Deep learning is based on the functionality of a biological neuron. So, let's understand how we mimic this functionality in an artificial neuron. Now, guys, an artificial neuron is also known as a perceptron. Let's understand what this biological neuron does and how deep learning is based on this concept. In a biological neuron, you can see these dendrites, right? In this image, you see something known as dendrites. These dendrites are used to receive any input. These inputs are summed in the cell body, and through the axon, it is passed on to the next neuron. So similar to the biological neuron, a perceptron or an artificial neuron receives multiple inputs, applies various transformations and functions, and provides an output. Right? So that's how artificial neural networks, or that's how deep learning works. Now, guys, the human brain consists of multiple connected neurons called a neural network. Similarly, by combining multiple perceptrons, we've developed what is known as deep neural networks. The main idea behind deep learning is neural networks, and that's what we're going to learn about. So now let's understand what exactly deep learning is. Deep learning is a collection of statistical machine learning techniques used to learn feature hierarchies based on the concept of artificial neural networks. So the main idea behind deep learning is to use the concept of neural networks. A deep neural network will have three layers. Okay, there's something known as the input layer, followed by the hidden layers, and then we have the output layer. The input layer is basically the first layer and it receives all the inputs. So all the inputs are fed into this input layer. The last layer is obviously the output layer. This layer will provide your desired output. Now, all the layers between the input and your output layer are known as the hidden layers. Now, the number of hidden layers in a deep learning network will depend on the type of problem you're trying to solve and the data that you have. We'll get into depth of what exactly a hidden layer does, but for now, this is how a neural network is structured in deep learning. So guys, deep learning is used in highly computational use cases such as face verification, self-driving cars, and so on. Right, so let's understand the importance of deep learning by looking at a real-world use case. So I'm sure all of you have heard of the company PayPal. Now, PayPal makes use of deep learning to identify any possible fraudulent activities. So the company makes use of deep learning for fraud detection. Now, PayPal recently processed over $235 billion in payments from 4 billion transactions by its more than 170 million customers. So basically, it processed this much data by using deep learning. PayPal uses machine learning and deep learning algorithms to mine data from the customer's purchasing history, in addition to reviewing patterns of any sort of fraud stored in the database, and it will do this to predict whether a particular transaction is fraudulent or not. Now, the company has been relying on deep learning and machine learning technology for around 10 years. Initially, the fraud monitoring team used simple linear models, right? They use machine learning. But over the years, the company switched to more advanced machine learning technology called deep learning. This shows how deep learning is used in more advanced and more complicated use cases. The fraud risk manager and the data scientist at PayPal, he quoted that what we enjoy from more modern, advanced machine learning is its ability to consume a lot more data, handle layers and layers of abstraction, and be able to see things that a simpler technology would not be able to see, even human beings might not able to see. This is exactly what he quoted. He said that a simple linear model is capable of consuming around 20 variables. But with deep learning technology, you can run thousands of data points. He also quoted that there is a magnitude of difference. You will be able to analyze a lot more information and identify patterns that are a lot more sophisticated. So by implementing deep learning technology, PayPal can finally analyze millions of transactions to identify any fraudulent activity. This is how PayPal makes use of deep learning. Not only PayPal, we also have Facebook, right? Facebook makes use of deep learning technology for face verification. You've all seen the tagging feature at Facebook, where we tag our friends in photos. All of that is based on deep learning and machine learning. So guys, that was a real world use case to make you understand how important deep learning is. Now let's move on and look at what exactly a perceptron is, right? We'll be going in depth about deep learning. A perceptron is basically a single layer neural network that is used to classify linear data. It is the most basic component of a neural network. Now, a perceptron has four important components. It has something known as inputs, weights and bias, summation functions, activation and transformation functions. These are four important parts of a perceptron. Now, before I discuss this diagram with you, let me tell you the basic logic behind a perceptron. There is something known as inputs, right? The input X, here you can see X1, X2 till Xn. So let me explain the structure of a perceptron. What you're going to do is you're going to input variables into the perceptron, right? This X1, X2 till Xn basically stands for input. W1, W2 till Wn stands for the weight assigned to each of these inputs, right? There is a specific weight that will be randomly initialized in the beginning for each of your input. Next, you have something known as the summation element. Here what you do is you multiply the respective input with the respective weight and you add all these products. right? That is basically your summation function. After this is what is your transfer function, also known as activation function, right? The activation function will basically map your input to your desired output. So your input will go through these processes. It'll go through summation and activation function in order to get to the output. So guys, remember that the neural networks work the same way as the perceptron. So if you want to understand how deep neural networks work, you need to understand what a perceptron does. A deep neural network is nothing but multiple perceptrons. So let me tell you how the entire thing works once again. So basically all your inputs are multiplied with their respective weights. Now you add all the multiplied values and you call them as a weighted sum. You use the summation function to add all of this. After that, you apply the weighted sum to the correct activation function or the transfer function. Activation function is very similar to a function in our brain. The neurons become active in our brain after a certain potential is reached. That threshold is known as the activation potential. So mathematically, there are a few functions which represent the activation function. Basically, the signum, the sigmoid, the tanh, all of these are activation functions. You can think of activation function as a function that maps the input to the respective output. Then I spoke about something known as weights and biases. All right, now you must be wondering, why do we have to assign weights to each of our input? Weights basically show the strength of a particular input or how important a particular input is for predicting the output. In simple words, the weightage denotes the importance of an input. Bias is basically a value which allows you to shift the activation function curve in order to get a precise output. Right? So that's exactly what weights are. I hope all of you are clear with inputs, weights, summation, and activation function. Also, one important thing I forgot to mention in a perceptron is a single layer perceptron will have no hidden layers, right? There'll only be an input layer, an output layer, and a couple of transformation functions in between. That's all will be there in a perceptron. Now, a perceptron, like I mentioned, is used to solve only linear problems. If you look at this data distribution, how do you think we can solve this? This data is not linearly separable. So you cannot use a single layer perceptron to separate this data. Right? That's why we need something known as a multi-layer perceptron with back propagation. I'll be explaining this in the next slide. So complex problems that involve a lot of parameters and high dimensional data can be solved by using multiple layer perceptron. Now a multi-layer perceptron is the same as a single layer perceptron. The only difference is that a multi-layer perceptron will have hidden layers. So the number of hidden layers in a model depends upon various factors. I told you it depends on the complexity of the problem you're trying to solve. It depends on the number of inputs in your data and so on. So it works in the same way. All your inputs are multiplied with your weights and then you do the summation and then there is a transformation function or a activation function. While designing a neural network, in the beginning itself I told you we initialize weights with some random values. We do not have some specific value for each weightage. Initially we've selected random values. It is always important that whatever weight values we have selected will be correct. Now, whatever weight values we've assigned to each input, it denotes the importance of that input variable. So we need to assign the weights in such a way, or we need to update the weights in such a way that it denotes the significance of that particular input. So initially we are selecting some random value for weight. And let's say that we use this weight value to get our output. Now, what happens is the output is actually way different or it is not precise when compared to our actual output. Basically, the error value is very huge. So how will you reduce the error? The main thing in a neural network is the weightage that you give to an input variable, right? Depending on the weightage that you give to an input variable, you're telling the neural network how important that variable is. Now, what if you randomly give some weightage and your output is wrong? The first thing that comes into your mind is that you need to change the weight because the weight signifies the importance of a variable. So basically what we need to do is we need to somehow explain to the model to change the weight in such a way that the error becomes minimum. Let's put it in another way. So basically we need to train our model. One way to train our model is called as back propagation. So in backpropagation, what happens is once you've initialized a weight to each of the input, you calculate the output, right? You get an output, and let's say you have a very high error value in that output. What you'll do is you'll backpropagate, as in you'll go back to the weight and you'll keep updating the weight in such a way that your error becomes minimum. This is exactly what backpropagation is. You'll be going back to the first layer, you'll be updating each of the weights in such a way that your output is more precise. So guys, basically the weight and the error in a neural network is highly related. By updating the weight in a particular way, your error will decrease. So you need to figure out how you need to update the weight. Do you have to increase the weight or decrease the weight? Once you figure out whether you have to increase or decrease the weight, you have to just follow that direction in such a way that your error is minimized. That's exactly what backpropagation is. So the final output of backpropagation is you're going to select the weight that minimizes the error function. And then you're going to use that weight to solve the whole problem. Right? This is what backpropagation is about. Now, in order to make you understand deep neural networks, let's look at a practical implementation. So again, guys, I'll be using Python to run the demo. If you don't have a good idea about Python, check the description. I'll leave a couple of links about Python programming. Now, in this demo, I'll be walking you through one of the most important applications of deep learning. I will demonstrate how you can construct a high-performance model to detect credit card fraud. Right? We'll be using deep learning models to do this. Now, before that, let me just tell you something about our data set. Right? The data set contains transactions made by credit cards in the year September 2013 by European cardholders. This data set presents transactions that occurred in 2 days, where we have 492 frauds out of 285,000 transactions, approximately 285,000 transactions. Out of these transactions, 492 were frauds, and the data set is quite unbalanced, right? The positive class accounts for 0.172%. So the positive class, basically the fraudulent class. So again, we're going to start by importing the required packages. We're going to import Keras, Matplot library, Seaborn library, and sklearn for pre-processing. Right? Again, min-max scaler, which is for normalization. We're going to import our data set and store it in this variable. Right? This is the path to my data set. My data set is in the CSV format, or also known as comma separated version. Now we're going to print out the first 5 rows of our data set. Right? Let's take a look at the output. So here is the time of the transaction, V1, V2, V3, etc. These are all the features of our data set. I'm not going to go into depth of what these features stand for, because this demo is all about understanding deep learning. Now these V1, V2, V3, these are all predictor variables which will help us predict our class. So guys, don't worry about what these features are. These features are just information and details about your transaction, such as the amount you spend or the time of transaction and so on. So here we have the amount variable, which denotes the amount spent. After that, we have the class variable. Now this class variable is your output variable or your target variable. So your class is basically your output variable. Value 0 denotes that there has been no fraudulent activity. But if you get a class of 1, it means that this transaction is a fraudulent transaction. For example, this transaction is not fraudulent. That's why we have a value of 0 over here. All right, so this is our data set. Next, what we're doing is we're counting the number of samples for each class, right? We have class 0 and class 1, where in class 0 denotes the normal transaction, which is non-fraudulent transaction, and class 1 will denote the fraudulent transactions. Right, so we have around 492 fraudulent transactions and around 284,315 non-fraudulent transactions. So when you see this, you know that our data set is highly unbalanced. Highly unbalanced means that one class has a really small number when compared to the other class, right? There's no balance between the 2 classes. So here what we're doing is we are sorting the data set by class for stratified sampling. Stratified sampling is a statistical technique for sampling your data set. Now, this type of sampling is always good if you have an unbalanced data set. Next, what we're going to do is we're going to perform data pre-processing. Data pre-processing in deep learning mainly has a method known as dropout method. Next, what we're going to do is we're going to drop out the entire time column. We do not need the time of the transaction in order to understand if the transaction was fraudulent or not, right? So that's why we're getting rid of unnecessary variables, right? So we're dropping out that variable. So after dropping out the time variable, we are going to assign the first 3000 samples to our new data frame, right? This DF sample will have our first 3000 samples, and we're going to use those 3000 samples. So here we're just counting the number of class for each of these samples. After that, we're just counting the number of samples for each of the class, right? We're doing the same thing again, and here we get class 0 has 2508 samples and class 1 has 492 samples. Now this makes the data set quite balanced, right? It's very balanced when compared to our old data set. Next, we'll just randomly shuffle our data set, right, in order to remove any sort of biasness in the data. After that, we'll split our data set into two parts. One is for training and your other data set is for testing, right? This is also known as data splicing. Then we'll be splitting each data frame into feature and label, meaning that your input and your output. You'll be doing this for your training data and for your testing data, right? All you're doing is you're separating your input from your output. Next, we're looking at our training data set, right? We're printing the shape of our training data set. The training data set has around 2,400 observations and 29 variables or 29 features. Similarly, we'll be printing out the size of our test data frame, right? That's exactly what we're doing over here. After that, we'll perform normalization. Right, for this, we'll be using the min-max scaler. So in normalization, we'll basically be scaling all our predictor variables around the same range so that there is no biasness in our prediction. After this, we'll be plotting a function for each of the learning curves. For your training phase and for your testing phase, you'll be plotting a learning curve. Now I'll show you the output of this in a couple of minutes. For now, let's move on to the main part, which is model creation. Right, in this demo, we'll use 3 fully connected layers. We'll also use dropout technique. Now, dropout is a type of regularization technique that is used to avoid any sort of overfitting in a neural network. It is a technique where you select neurons and you drop them during the training phase. We'll be using the ReLU as the activation function, which is a type of activation function just like sigmoid and tanh. So the type of model that we'll be using is the sequential model. Right, sequential is the easiest way to build a model in Keras. Right, we're using the Keras library over here. If you remember, I imported that in the beginning. Right, it allows you to build a model layer by layer. So each layer has weights that correspond to the layer that follows it. After this, you'll use the add function to add the dense layers. Basically, your hidden layers you're going to add over here. So in our model, we'll be adding 2 dense layers or hidden layers, you can say. So here what we're doing is we're adding the first dense layer. Now guys, a dense layer is standard layer type that works for most cases, right? In a dense layer, all the nodes in the previous layer connect to the nodes in the current layer. So guys, don't get too involved into what exactly is happening here. All I'm doing is I'm creating a sequential model, and what is happening is I'm just assigning the number of inputs for each of the dense layer or for each of the hidden layer. I'm also assigning dropout value. Dropout is basically to prevent overfitting. Overfitting might occur when your model memorizes the training data set. Overfitting basically reduces the accuracy of a model. That's why we're using the dropout method to prevent overfitting. So in the first hidden layer, we have around 200 units, right? We have the activation function ReLU. Then we're adding the second dense layer with again 200 neurons and the ReLU activation function. Kernel initializer is uniform, meaning that it's just sequential and normal. Then we're again adding a dropout layer of 0.5. The dropout value of a network has to be chosen very wisely. Okay, a value that is too low will result in a minimal effect, and a value that is too high will result in underlearning by the network. So 0.5 is a standard dropout value. Now this last layer is our output layer. In the output layer, we'll obviously have only one neuron. We'll have one neuron that will show us the output class, either 0 or 1. 0 will show us non-fraudulent transactions and 1 will denote fraudulent transaction. right? That's why we have only one neuron over here, and the activation function here is sigmoid, right? Since the number of neurons is only one. After that, we're printing the model summary. Now, I'll show you the summary and everything. Before that, let's just understand what exactly optimization functions are. We'll understand what this optimization function does. Now, an optimizer takes care of the necessary computations that are used to change the network's weights and bias. So basically, your optimizers will take care of all your computations, such as changing the weight or updating the weight. If you'll remember, I spoke about backpropagation, right, where you'll update the weight and all of that. That is done by using optimizers. Here we're selecting an optimizer known as the ADAM optimizer. So ADAM optimizer is one of the current default optimizers in deep learning. Right? It stands for adaptive moment estimation. We don't have to get into the depth of all of this. Right? All of these are predefined optimizers in our Keras package itself. After this, we're going to fit our model by using the training features. We're also setting 200 epochs, and also there's something known as epochs and batch size. Right? We're setting epochs as 200 and batch size as 500. I'll tell you what exactly this means. Now, batch sizes are basically used so that we don't overfit our model, right? We're going to basically split our data set into 500 batches. So our input will be going in the form of batches, right? And our batch size is 500 inputs per batch, and we'll be going through 200 epochs, meaning that our training will iterate 200 times. This is basically the number of times we're training our model. All right, that's what epoch and batch size is. After that, we're just showing our training history, and we're just printing the accuracy curve for our training phase. We're also going to print our loss curves for our training phase, basically the error curves. And then finally, we have the evaluation. Here we'll be testing our model by using our testing dataset. Then we're finally printing the accuracy on our testing dataset. After that, we're just going to plot a heat map, which I'll be showing y'all. Let me just show you the output. So guys, in this entire line of code, all we're doing is we're printing an accuracy plot, right? Basically, we're printing a heat map. I'll show you what the heat map looks like. This is just to check the accuracy. We're comparing all the correctly predicted values to our incorrectly predicted values. So this is our training history. Here blue stands for our training phase, and this is our validation or our prediction stage. That was our training curve, and this is our loss curve. Now, when you compare it to the actual validation stage, it's quite similar, right? Meaning that our model is doing pretty well. So guys, this is the heat map that I was talking about. This is basically going to give us the class for each of our predictions. Right, it basically plots the classes that we correctly predicted, right? Basically, for each data point, it's just going to tell us whether we predicted it correctly or not. It's sort of a confusion matrix in the form of a heat map. So guys, these are all our epochs, basically the 200 iterations that we went through, right? This is the 50th iteration. Is showing us our loss, it's showing us our accuracy as well. Right, here we have 88%, 90%, 92%. Now, if you carefully look at the epoch accuracy values, you see that as we train our model even more, our accuracy keeps increasing. Initially, our accuracy was around 83, right? At epoch number 15, our accuracy was around 83%. But as we kept training our model a little bit more, our accuracy kept increasing. We have 90, we have 91, 94, 95, 96, and so on. Right? So basically, the more you train your model, the better it's going to be. So guys, this was our entire demo. Now, in the end, I'm printing out the false positive rate and the false negative rate. Right? All of this basically denotes how many of the data points was I correctly able to predict as fraudulent and how many did I predict wrongly. That's all the false negative and the false positive rate denotes. So guys, this was the entire demo on deep learning. Now, if you have any doubts regarding the deep learning demo, please mention them in the comment section and I will solve your queries. Right, now let's look at our last topic for the day, which is natural language processing. Now, before we understand what is natural language processing, let's understand the need for natural language processing and a process known as text mining. Text mining and natural language processing are heavily correlated. Right, I'll talk about both of these in the upcoming slides. For now, let me tell you why we need natural language processing or text mining. So guys, the amount of data that we're generating these days is unbelievable. It is a known fact that we are creating 2.5 quintillion bytes of data every day, and this number is only going to grow. With the evolution of communication through social media, we generate tons and tons of data, right? The numbers are on your screen. So basically, we post around 1.7 million pictures on Instagram per minute, right? I'm talking about posts per minute. All of these numbers are per minute values. These are the amount of tweets, 347,000 tweets per minute, right? This is a lot of data. We're generating data while we're watching YouTube videos, when we're sending emails, when we are chatting, and all of that, right? Even the IoT devices at our house, right? We have Alexa, all of this is generating a lot of data. A single click on your phone is generating a lot of data. Now, not only that, out of all the data that we generate, only 21% of the data is structured and well formatted, right? The remaining of the data is unstructured. And the major sources of unstructured data include text messages from WhatsApp, Facebook likes, comments on Instagram, the bulk emails, and all of this, right? All of this accounts for the unstructured data that we have today. Now, the data we generate is used to grow a business. So, by analyzing and mining the data, we can add more value to a business. This is exactly what natural language processing and text mining is all about. Text mining and NLP is a subset of artificial intelligence wherein we try and understand the natural language text that we get from text messages and so on in order to derive useful insights and grow businesses by using these insights. So, what exactly is text mining? Text mining is a process of deriving meaningful insights or information from natural language text. So all the data that we generate through text messages, emails, and documents are written in natural language text, right? And we're going to use text mining and natural language processing to draw useful insights or patterns from such data in order to grow a business. Now let's understand where exactly do we make use of natural language processing and text mining. Now, have you ever noticed that if you start typing a word on Google, you immediately get suggestions, right? This feature is known as autocomplete. It will basically suggest the rest of the word to you. We also have something known as spam detection, right? Here's an example of how Google recognizes this misspelling Netflix and shows results for the keyword that matches your misspelling. Let me show you a couple of more examples. We also have predictive typing and spell checkers and features like autocorrect, email classification. So, predictive typing and spell checkers, all of these are applications of natural language processing. All of this basically involves processing the natural language that we use and deriving some useful information from it, right? Or running businesses from it. Netflix uses natural language processing in a really good fashioned way, right? It basically studies the reviews that customer gives for a particular movie and it tries to figure out if that movie is good or bad depending on the review. So Netflix actually uses NLP in a very interesting manner. It tries to understand the type of movies that a person likes by the way a person has rated the movie or by the way the person has reviewed a movie. So by understanding what type of review a person is giving to a movie, Netflix will recommend more movies that you like. That's how important NLP has become. Now let's look at what exactly NLP is. NLP, which also stands for Natural Language Processing, is a part of computer science and artificial intelligence, which deals with human language. Right? It's basically the process of processing natural language in order to derive some useful information from it. For those of you who have studied natural language processing or have heard of natural language processing, there is a huge confusion between text mining and natural language processing. So text mining is the process of deriving high quality information from text. But the overall goal is to turn the text into data for analysis by using natural language processing. So basically, text mining is implemented by using natural language processing techniques. Right? There are various techniques in natural language processing that can help us perform text mining. That's how text mining and natural language processing are related. Natural language processing is the techniques that are used to solve the problem of text mining, text analysis, and all of that. Let's look at a couple more applications. Sentimental analysis is one of the major applications of natural language processing. You see, Twitter performs sentimental analysis, Facebook, Google, all of these perform sentimental analysis. Sentimental analysis is mainly used to analyze social media content that can help us determine the public opinion on a certain topic. Then we have chatbots. Now, chatbots use natural language processing to convert human language into desirable actions. We also have machine translation. NLP is used in machine translation by studying the morphological analysis of each word and translating it to another language. Advertisement matching is also done using NLP in order to recommend ads based on your history, right? These are few of the applications of NLP. Now, let me tell you the basic terminologies under natural language processing. So, tokenization is the most basic step in natural language processing. Tokenization means breaking down the data into smaller chunks or tokens so that they can be easily analyzed. So, the first step is you'll break a complex sentence into words. Then you'll understand the importance of each of the word with respect to that sentence in order to produce a structural description on an input sentence. So, for example, take this sentence. How would I perform tokenizations on this sentence? Let's say that tokens are simple is a sentence and I want to perform tokenization on this sentence. This is what I'm going to do. I'm going to split the sentence into different words. I'm going to understand each word with respect to that sentence, right? This is done to simplify operations in natural language processing, right? It's always simpler to analyze a single token instead of analyzing an entire sentence. Then we have something known as stemming. Now look at this example. Right here we have words such as detection, detecting, detected, and detections. We all know that the root word for all of these words is detect. So stemming algorithm basically does that. It works by cutting off the end or the beginning of the word and taking into account a list of common prefixes and suffixes that can be found in an inflected word. Stemming basically helps us in analyzing a lot of words. We know that detections, detected, and detection basically mean the same thing. So all we're doing is we're going to ease our analysis by removing prefixes and suffixes which do not make sense, right? We just need to understand the morphological analysis of the word, right? So that's why we're randomly cutting the prefixes and suffixes in such a way that we only get the important part of the word. This is called stemming. Now, this cutting of words can be successful in some occasions, but not always. That is why we say that stemming approach has a few limitations. In order to get over these limitations, we have a process known as lemmatization. Right? Lemmatization, on the other hand, takes into consideration the morphological analysis of the words. It does not randomly cut the word in the beginning and the ending. It understands what the word means and only then it cuts the word. For example, let's consider the word recap. If we perform stemming on the word recap, we'll get cap, right? The output will be cap. But cap and recap do not have the same meaning, do they? They have absolutely different meanings. That's why stemming is sometimes not considered to be the right thing to do. But when it comes to lemmatization, it's going to understand the meaning of recap. Only then will it perform any sort of change in the word or it'll cut down the word. So basically, it groups together different inflected forms of a word called lemma. Lemmatization is similar to stemming because it maps several words into one common root, but the output of a lemmatization process is always a proper word. An example of lemmatization is to map gone, going, and went into go. Gone, going, went, all of them mean go. So basically, by lemmatization, you can just output the words as go. That is what lemmatization is. Next, we have something known as stop words, right? Stop words are basically a set of commonly used words in any language, right? Not just English, any language. The reason why stop words are critical to many applications is that if we remove the words that are very commonly used in a given language, we can finally focus on the important words. For example, in the context of, let's say you open up Google and you look for strawberry milkshake recipe. Instead of typing strawberry milkshake recipe, let's say you type how to make strawberry milkshake. Now here what Google will do is it will find results for how to and make. Instead, if you just type strawberry milkshake recipe, you will get the most desired output. That's why it's always considered a good practice in natural language processing to get rid of stop words, right? Stop words will just increase our computation and it'll just add additional work to us. They are not very helpful when we are analyzing important documents, right? We need to focus on the important keywords in the documents instead of all of these commonly used words. Example of stop words include the, how, when, why, not, yes, no. All of these are stop words, right? So in order to better analyze our data, we need to get rid of stop words. Now, the last terminology I'm going to discuss is document term matrix. Now, it is important to create something known as the document term matrix in natural language processing. A DTM or a document term matrix is basically a matrix that shows the frequency of words in a particular document. Let's say that we're trying to understand if the sentence "this is fun" is available in one of my documents. So if it is there in my document 1, I'm going to put a 1 corresponding to each of the words that is available in my document. For example, in document 2, I have "this is," but I do not have the word "fun." Similarly, in document 4, I have the word "this," but I do not have the word "is" and "fun." So basically, a document term matrix is like the frequency matrix of a document. So during text analysis, you always begin by building a document term matrix. Right here, you try to understand which words frequently occur and which words are important and not important in the document. So guys, these were a couple of terminologies in natural language processing.
So let us understand, when we have machine learning, why do we need deep learning? That is, we'll look at various limitations of machine learning. Now, the first limitation is high dimensionality of the data. Now, the data that is now generated is huge in size. So we have a very large number of inputs and outputs. So due to that, machine learning algorithms fail. So they cannot deal with high dimensionality of data, or you can say data with large number of inputs and outputs. Now, there's another problem as well, in which it is unable to solve the crucial AI problems, which can be natural language processing, image recognition, and things like that. Now, one of the biggest challenges with machine learning models is feature extraction. Now, let me tell you what are features. So in statistics, we consider features as variables. But when we talk about artificial intelligence, these variables are nothing but the features. Now, what happens because of that? The complex problems such as object recognition or handwriting recognition becomes a huge challenge for machine learning algorithms to solve. Now, let me give you an example of this feature extraction. Suppose if we want to predict that whether there will be a match today or not. So it depends on various features. It depends on whether the weather is sunny, whether it is windy, all those things. So we have provided all those features in our data set. But we have forgot one particular feature, that is humidity. And now our machine learning models are not that efficient that they will automatically generate that particular feature. So this is one huge problem, or you can say limitation, with machine learning. Now, obviously, we have limitation, and it won't be fair that if I don't give you the solution to this particular problem. So we'll move forward and understand how deep learning solves these kind of problems. Now, as you can see that the first line on your slide, which says that deep learning models are capable to focus on the right features by themselves, requiring little guidance from the programmer. So with the help of little guidance, what these deep learning models can do, they can generate their features on which the outcome will depend on. And at the same time, it also solves the dimensionality problem as well. If you have a very large number of inputs and outputs, you can make use of a deep learning algorithm. Now, what exactly is deep learning? Again, since we know that it has been evolved by machine learning, and machine learning is nothing but a subset of artificial intelligence, and the idea behind artificial intelligence is to imitate the human behavior. The same idea is for the deep learning as well, is to build learning algorithms that can mimic brain. Now let us move forward and understand deep learning, what exactly it is. Now, the deep learning is implemented with the help of neural networks, and the idea or the motivation behind neural networks are nothing but neurons. What are neurons? These are nothing but your brain cells. Now, here's a diagram of neuron. So we have dendrites here, which are used to provide input to our neuron. As you can see, we have multiple dendrites here, so these many inputs will be provided to our neuron. Now, this is called cell body, and inside the cell body, we have a nucleus, which performs some function. After that, that output will travel through axon, and it will go towards the axon terminals, and then this neuron will fire this output towards the next neuron. Now, the studies tell us that the next neuron, or you can say the two neurons, are never connected to each other. There's a gap between them. So that is called a synapse. So this is how basically a neuron works like. And on the right hand side of your slide, you can see an artificial neuron. Now let me explain you that. So over here, similar to neurons, we have multiple inputs. Now these inputs will be provided to a processing element like our cell body. And over here in the processing element, what will happen? Summation of your inputs and weights. Now, when it moves on, then what will happen? This input will be multiplied with our weights. So in the beginning, what happens? These weights are randomly assigned. So what will happen if I take the example of x1? So x1 multiplied by w1 will go towards the processing element. Similarly, x2 and w2 will go towards the processing element. And similarly, the other inputs as well. and then summation will happen, which will generate a function of s, that is f of s. After that comes the concept of activation function. Now what is activation function? It is nothing but in order to provide a threshold. So if your output is above the threshold, then only this neuron will fire, otherwise it won't fire. So you can use a step function as an activation function, or you can even use a sigmoid function as your activation function. So this is how an artificial neuron looks like. So a network will be multiple neurons which are connected to each other will form an artificial neural network. And this activation function can be a sigmoid function or a step function. That totally depends on your requirement. Now once it exceeds the threshold, it will fire. After that, what will happen? It will check the output. Now if this output is not equal to the desired output, so these are the actual outputs and we know the real outputs. So we'll compare both of that and we'll find the difference between the actual output and the desired output. On the basis of that difference, we are again going to update our weights. And this process will keep on repeating until we get the desired output as our actual output. Now this process of updating weight is nothing but your back propagation method. So this is neural networks in a nutshell. So we'll move forward and understand what are deep networks. So basically deep learning is implemented by the help of deep networks, and deep networks are nothing but neural networks with multiple hidden layers. Now what are hidden layers? Let me explain you that. So you have inputs that comes here. This will be your input layer. After that, some process happens and it'll go to the next node, or you can say to the hidden layer nodes. So this is nothing but your hidden layer 1. So every node is interconnected, if you can notice. After that, you have one more hidden layer where some function will happen. And as you can see that again, these nodes are interconnected to each other. After this hidden layer 2 comes the output layer. And this output layer, again, we are going to check the output, whether it is equal to the desired output or not. If it is not, we are again going to update the weights. So this is how a deep network looks like. Now there can be multiple hidden layers. There can be hundreds of hidden layers as well. But when we talk about machine learning, that was not the case. We were not able to process multiple hidden layers when we talk about machine learning. So because of deep learning, we have multiple hidden layers at once. Now let us understand this with an example. So we'll take an image which has 4 pixels. So if you can notice, we have 4 pixels here, among which the top 2 pixels are bright, that is they are black in color, whereas the bottom 2 pixels are white. Now what happens, we'll divide these pixels and we'll send these pixels to each and every node. So for that we need 4 nodes. So this particular pixel will go to this node, it will go to this node, this pixel will go to this node, and finally this pixel will go to this particular node that I'm highlighting with my cursor. Now what happens, we provide them random weights. So these white lines actually represent the positive weights and these black lines represents the negative weights. Now this particular brightness, when we display high brightness, we'll consider it as negative. Now what happens, when you see the next output or the next hidden layer, it will be provided with the input with this particular layer. So this will provide an input with positive weight to this particular node, and the second input will come from this particular node. Since both of them are positive, so we'll get this kind of a node. Similarly, this node as well. Now when I talk about these two nodes, the first node over here, so this is getting input from this node as well as from this node. Now over here we have a negative weight. So because of that, the value will be negative, and we have represented that with black color. Similarly, over here as well, we are getting one input from here which has a negative weight, and we another input from here which again has a negative weight. So accordingly, we get again a negative value here. So these two becomes black in color. Now if you notice, what will happen next, we'll provide one input here which will be negative and a positive weight, which will be again negative, and this will be also negative and a positive weight. So that will again come out to be negative. So that is why we have got this kind of a structure. If you notice, this is nothing but the inverse of this particular image. When I talk about this node over here, we are getting the negative value with a positive weight, which is negative, and a negative value with a negative weight, which is positive. So we are getting something which is positive here. Now obviously I want this particular image to get inverse. I want these black strips to come up. So what I'll do, I'll actually calculate the inverse by providing a negative weight like this. So over here I've provided a negative weight, it will come up. So when I provide a positive weight, so it'll stay wherever it is. After that, it'll detect, and the output you can see will be a horizontal image, not a solid, not a vertical, not a diagonal, but a horizontal. And after that, we are going to calculate the difference between the actual output and the desired output, and we are going to update the weights accordingly. Now this is just an example, guys. So guys, this is one example of deep learning where what happens, we have images here. We provide these raw data to the first layer, to the input layer. Then what happens, these input layers will determine the patterns of local contrast, or it will fixate those patterns of local contrast, which means that it will differentiate on the basis of colors and luminosity and all those things. So it will differentiate those things. And after that, in the following layer, what will happen? It will determine the face features. It will fixate those face features. So it will form nose, eyes, ears, all those things. Then what will happen? It will accumulate those correct features for the correct face, or you can say that it will fixate those features on the correct face template. So it will actually determine the faces here, as you can see it over here. And then it will be sent to the output layer. Now, basically, you can add more hidden layers to solve more complex problems. For example, if I want to find out a particular kind of face, for example, a face which has large eyes or which has light complexion. So I can do that by adding more hidden layers. And I can increase the complexity also at the same time if I want to find which image contains a dog. So for that also I can have one more hidden layer. So as and when hidden layer increases, we are able to solve more and more complex problem. So this is just a general overview of how a deep network looks like. So we have first patterns of local contrast in the first layer. Then what happens, we fixate these patterns of local contrast in order to form the face features such as eyes, nose, ears, etc. And then we accumulate these features for the correct face, and then we determine the image. So this is how a deep learning network, or you can say deep network, looks like. And I'll give you some applications of deep learning. So here are a few applications of deep learning. It can be used in self-driving cars. So you must have heard about self-driving cars. So what happens? It'll capture the images around it. It'll process that huge amount of data, and then it'll decide what action should it take. Should it take left, right? Should it stop? So accordingly, it'll decide what action should it take. And that will reduce the amount of accidents that happens every year. Then when we talk about voice control assistants, I'm pretty sure you must have heard about Siri. All the iPhone users know about Siri, right? So you can tell Siri whatever you want to do. It'll search it for you and display for you. Then when we talk about automatic image caption generation, so what happens in this, whatever image that you upload, the algorithm is in such a way that will generate the caption accordingly. So for example, if you have, say, blue colored eyes, so it will display a blue colored eye caption at the bottom of the image. Now, when I talk about automatic machine translation, so we can convert English language into Spanish, similarly Spanish to French. So basically, automatic machine translation, you can convert one language to another language with the help of deep learning. And these are just few examples, guys. There are many, many other examples of deep learning. It can be used in game playing. It can be used in many other things. And let me tell you one very fascinating thing that I've told you in the beginning as well. With the help of deep learning, MIT is trying to predict future. So yeah, I know it is growing exponentially right now, guys.
What is object detection? So object detection is a computer technology which is related to computer vision and image processing. Here, what we do in case of object detection is, for a given image, I'm going to check what are the objects that are present in the image, and not only what, I'm also going to say where exactly is that object is present. So that is what happens in place of object detection. An excellent example can be is Facebook photo tagging. So you might have observed the Facebook photo tagging feature. So when you upload a photo to your Facebook, so the Facebook will automatically recognize the people who are present in that particular uploaded image, and along with that it will also do one important thing. Along with that, it will also show you as where exactly that person is present. So if they like, it is going to draw a bounding box on top of that person's face to show it as, hey, this is your friend A and he's present over here, do you want to tag him? So that functionality that you would see in the Facebook, uh, that functionality that you see, so that is a typical example of object detection. Now I'm not sure what is the latest update because it's been more than 2 years me using social media, but yeah, so 2 years back that was there, and I'm sure today it will be the same feature or it will be an upgraded feature. But the main concept is this: when you upload something for your Facebook or any social media, I'm giving it Facebook as a generalized concept because that's where I've seen. So it is going to tell us who are all the people that are present in the image, and also it is going to tell us as where that person is present. And that is what an object detection algorithm is going to do. It's going to identify the objects in the objects in a given image, and it also tells us as where exactly that object is present. So what and where, both of them will be identified in case of object detection. So here you can see the GIF animation that you would see over here on your left hand of the screen. So here it says what are the objects that are present in the image. So the objects are cap, bowl, Pepsi can, and so on. Now, along with saying what are the objects, it is also drawing a bounding box. So you can see a green box that has been drawn on top of each and every object to tell us as where that particular object is present. And here on the another image that we have on the right hand of the slide, so here it's also doing a similar activity. It is saying there is a retriever dog, there is an American Stanford Terrier dog, and there is just a common dog. Okay, and there is a built terrier dog. So there are, so it has identified the dogs that are present in the image, and along with identifying what is the breed of the dog, it is also drawing a box. See, it says this is where my dog is, this is where my dog is, this is where my dog is. So this is how any typical object detection application would work. So it detects what, and also it also tells us as where exactly that particular object is present. Now the next question is, where do we see these applications? So one obvious, face recognition. So this, we have been familiar with Facebook. So where we upload an image and we can identify who are all the people that are present in the image. And even Google Photos has a good face recognition feature. I mean, so we've been understanding about this, and even the Google Photos has a good face recognition, or yeah, voice recognition over there. So when we upload all the pictures, so it's going to group all the photos together, and it will ask us to name that particular one person, and it will automatically tag those names to all the similar people wherever that person is present. So that's also an application of face recognition. And we can also use this object detection concept for the people counting to understand as how many people are present over there in a given scenario. Or another example can be is whether that person is wearing a mask or not. So wearing a mask or not, so I can do it, and I can also use this special I can also use this mask detection, object detection, for checking whether people are following the COVID-19 protocols, that is social distancing. So all these are the applications of using object detection. And even we can use it for industrial purpose. It could be for industrial quality checking, to check whether the objects that has been done is a object that has been manufactured, is it as per the standards that are being expected by the industry. Or self-driving cars. So in case of self-driving cars, so the cars will identify what are the objects that are present in a given image, okay, or a given video feed, and on the basis of the object, it's going to drive. So that's another application of self-driving car, the application of object detection. And the another application that I could see is the security, the Face ID that we have in our Apple iPhones. So that uses the object detection to identify who is present in that image. And another thing is like identifying the objects on the road. I think you might have seen the latest Mahindra XUV 700. So they have an functionality to detect the they have the functionality to detect the objects that are in front of the car, and if the object is very close to the car, it is going to automatically apply the brake. Now here the object detection, obviously, like to detect the objects in front of the car, so they are making use of object detection over there. So that's another application. Okay, so these are some of the applications of using object detection in real life. Now coming to this object detection, let's look at the typical workflow and how does it work when we want to build an object detection algorithm using TensorFlow. When we are working with the applications like object detection, first we need to prepare the training data. I'll have to build the training data to such that to identify whether my given image has the required number of classes. So I'll have to build my classifier to identify as what is that individual object is present, or what is my individual object contains. Now after I have trained this, so this is my training data, I have the images of cars and I have the images of bike, and I have trained my machine learning model to identify whether my given image contains this car and bike. Now once it's trained, I can obviously go ahead and send in my test data and with the test data I can detect whether my given input image contains bike or car. Okay, so this is the first step in preparing the object detection. Okay, first I'll build a classifier which will help me in identifying what is present in the image. Now, along with this what, while training, I'll also tell my machine learning, or in this case, deep learning system, to tell us where exactly that object is present. So my machine learning model, or this in this scenario, it's a deep learning model. My deep learning model will do two things in parallel. One, it will identify what, and the another thing it will also do is where. It will learn where exactly that object is present in that given image. So it does both the things in parallel. So what happens is, like, I'll have some set of layers over here, and from this layer another set of another series of layers for detection to identify what is present over there, and another set of layers for detecting where exactly that object is present. Okay, so that's what it will be, the workflow of object detection. Now, once I have trained my object detection model, I can send in a new image. Now, when I send a new image, my deep learning model will be able to identify what is present in the image, and also it also tells me as where exactly that object is present in the given image. And that's how an object detection machine learning algorithm would work. Now, in order to build this deep learning models which is capable of performing object detection, we have various frameworks. Now, one of the common framework that we would use is the TensorFlow. So this is one of the very common framework that we are currently using, which are in the latest scenario because of its ease of deployment using the TensorFlow Extend. So because of this functionality, so now industries are preferring to use this TensorFlow framework. Now, apart from this, we have PyTorch, MXNet, Theano. So these are the various frameworks that are also available to us to build deep learning neural network. Now, let's get an understanding about this TensorFlow and what does this TensorFlow is made of. Now, as I mentioned already, TensorFlow is a deep learning framework which helps us in building the deep learning neural network. Now, just like my NumPy library has the array object, which is one of the basic object from this NumPy library. In case of TensorFlow library, or you can take any deep learning frameworks, we have an object that's called as tensors. Now, these tensors are the standard way of representing the data in case of deep learning. The reason that we used to prefer representing the data with tensors because, one, it will help us to process the data with GPU. GPU means graphical processing unit, which we use it for gaming purpose. Okay, you know already what is computer gaming. So one like to, in order to get the speed and in order to get the good graphics, we know that we actually use the best and the best graphics card so that we can play the game in a very high setting. Now, using this deep learning frameworks and by creating the data inside the tensors, I'll be having the ability, I'll be having the ability to process those data that I have using these GPU cores. So just like we have a course in CPU, we'll also have the processing course in GPU, and we'll be utilize those GPU cores. And we have seen that we could get around 10 to 20x faster than what we could achieve in our CPU. So that's the advantage of working with deep learning frameworks and creating the data as tensors. And if I have a CUDA supported GPU, then I can also make use of this GPU cores to get 10 to 20 times of faster data processing compared to CPU. So that's the reason we want to represent the data in terms of tensors. Now, what is this tensors? Tensors are just a multidimensional array object. It's just an extension of two-dimensional tables to data with higher dimension. So that's what these tensors are. Now, in this TensorFlow, the computation is approached as a data flow diagram. So whenever I want to do anything over there in TensorFlow, so normally what we do, if you remember, in case of any machine learning model, I'm going to represent how my y hat is computed. And then from my y hat, I'm going to calculate the cost. So I'll have to manually specify how the cost should be done, and I have to mention as how the gradient should be calculated with reference to every parameter that I'm currently having in my model. But in case of TensorFlow, I don't have to worry about it. I can let my TensorFlow to do the magic. I can let my TensorFlow to track what are the operations that I'm doing on the data. And once I've completed the operation, I can just tell to my system as, okay, hey, I have finished doing the operation. Why don't you update the parameters? So in order to do that, we actually make use of data flow graph, or sometimes we also call it as TensorFlow graph. So it's going to track how the data is getting manipulated. Now, once I have done this data manipulation, I can make use of this TensorFlow graph to update the parameters of my model during the operation. And that's the advantage of using deep learning framework. Now, because of this feature, I don't have to worry about writing the complex equation. I can just start building the models which are as much as complex that I want, and I can let my TensorFlow to do the magic and find the gradients and update the parameters with just a single command. So that's the advantage of working with this TensorFlow. And we have the similar functionality in PyTorch library. So it's not just advantage in TensorFlow. I'm just giving it as an example as TensorFlow because we are discussing in TensorFlow. The similar functionality is also available in PyTorch as well. Okay. And yes, we represent the data in tensors, and once we represent the data in tensors, so here it is just a flow over here. So here the flow says, okay, for the given data I'm going to add something and I'm going to perform matrix multiplication. So matmul is nothing but the matrix multiplication. So I'm doing some matrix multiplication and I'm getting the result, and on the basis of result, if I want to update something, I can just go ahead and perform some update using the TensorFlow data graph that I have, and then find the parameters over there, and I can do my required activity as per my preference. So what we do in case of building the model is, we'll start with the input data. We are going to convert it into the tensors, and once we convert the data into the tensors using TensorFlow library, we'll start training the model with TensorFlow model. Okay, so here the TensorFlow model is nothing but the deep learning model which I've created with TensorFlow library. Now, once that is done, I can go ahead and start training the model in depth. So here I'll create it as tensors, and then I'm going to train my TensorFlow model, which is a deep learning model. And once the model has been trained, I can send in a new data, which is called as test data, to test how my model is performing. And once the testing is done, once I'm satisfied with the output, obviously I can use those test results to tell us as, okay, so this is an example of object detection. So for a given image, this is where the objects are, and these are the objects. So person, dog, and horse. So there are three objects that are present over here, and the bounding box tells us as where exactly those objects are present. So this is a typical flow when it comes to performing object detection. Now here, as a hands-on demo, we are going to look into a demo of YOLO model. Okay, so YOLO is one of the most commonly used object detection model when it comes to performing the object detection using deep learning models. So it's an object detection models. We'll use this already trained YOLO model, and we'll send in our data, and we'll see how the output would look like when I perform object detection with this YOLO. Okay, so let's go back to our Google Colab. Okay, now let's have a quick look at the implementation of TensorFlow. So this is a notebook that I've just shared in the chat window. You can refer that notebook. And this notebook has the implementation of object detection with YOLO. Now here, to get started, we are going to get the repository from the GitHub. So this is going to clone my repository, which is present over there. That is the darknet repository. And then I'm going to go inside the directory, that is cd darknet. And this is going to display the various files that we have in that directory. Now, once that is done, we are going to execute this command of make. So this will compile my library, and this is going to make sure that it is ready for us to execute. So this would take a while depending on the computer speed that we are running in. Now in this scenario, I'm using the free system that is provided by Google Colab. Hence this would take a while for it to become ready. And once that is done, I'm going to get the trained weights or already trained weights from the GitHub repository. So this is actually available under this link. So I'm going to download those weights. So here the weights are nothing but the already trained data. So I'll use the already trained data, and I would get that data. And once I get the data, I can just go ahead and test my object detector. Now here, for the testing purpose, I'm going to make use of the image that is called as person's image, which is present inside my data directory. Okay, I'll show you what is that image that I'm talking about. So data. So there are various images. Now this time I'm using this image of person. So this is the image of person. So on this image, I'm going to identify what are the objects that are present in this given image. So let's see what will be the output if I just execute this line. So this is going to tell me, this would take a while to perform the prediction. Okay, and then it will give us the detection. Okay, so we have the output, and if you observe over here, currently I'm running on CPU. So it actually took 21,915 milliseconds. So I'll just note this number in a separate notepad. So this is the 21,050 milliseconds it took on my CPU. All right, and if I come down, so this is the predictions that has been given from my object detection model of YOLO. So it says where exactly that person is present, and it also displays about the class name. Here the class name says as person, and along with that it also displays the confidence score. So how much confident it is how much confident it is to saying it as okay, it belongs to the person. Okay, and it says 98% confidence that belongs to the horse, and this is 99% confident that it belongs to the dog classes. Now we are going to enable the GPU, and once we enable the GPU, we'll have to execute some commands again and prepare our model to make sure that it runs on GPU. And once that is done, this time we are going to use a new image. The new image is called as giraffe.jpg. So this is the image that I'll be testing out. So this is the image of giraffe, and I'll be using this image to detect the objects. So I'll just execute this to run the prediction, and I'm going to show how the objects would look like in this image. Okay, it's still configuring my system to make sure that it runs on the GPU. Now the system setup is complete. Now let's look at the logs. Now if I come down and look at the logs, it just took less than a second to complete the prediction. So it just took around 165 milliseconds. See, you can look into the comparison. Now if I just compare it, okay, 21915 divided by 165, so it's like 132 times faster than what I have got from my CPU. So that's the computation speed that we would get when we work with uh, GPUs. Okay, now if I see over here, so it says these are the objects that has been identified from a given image. So there's a giraffe with 100% confidence, and there is a zebra with 99% confidence. So clearly we would get the high speed computation when we are working with GPUs. Now below we have a code to test out about the various threshold values. So for that we are choosing an example image of horse, and on this example image of horse, so by default it has some threshold value. I think the threshold value is somewhere around 0.8 or something. Now if I reduce the threshold value, it is going to add some more images, and if I increase the threshold values, it is going to uh, stop like displaying about the this. In this example I've mentioned my threshold as 0.98. That means detect the objects for which you are confident with 98%. So here in the above image I had an object which had 90% confidence. and that has been omitted when I specify this threshold of 98%. And if I reduce the threshold value, then in such scenarios, it would randomly assign the values like this because the threshold is very less. Okay, so that is how we can make use of TensorFlow and that is how we can make use of TensorFlow and detect the objects in an image. And if I come down, there is a code which talks about as we can perform the object detection in videos. Now instead of connecting to the videos, we can also make use of OpenCV library and detect the starter webcam session, and then we can run this object detection on the video file as well, or we can run that object detection on the on the webcam stream as well to detect what are the objects that are present in the image. Now, in order to do that, obviously we need a system which has a very good memory and the GPU, and you are free to check out at your end when you're exploring about videos. Okay, so the identification or the overall understanding that you need to have is when I talk about object detection. So object detection means for a given input data, I'll be doing two things. One, I'll be detecting where is my object is present. Okay, I'll detect where is my object and what is my object. I'll detect both the things when I'm performing object detection. So what and where, which is like what we have seen in this video. So in our current scenario, so we have made use of YOLO object detector to detect the objects from our end. And when you start your learning journey with TensorFlow, obviously you learn how you can create your own object detection model to identify the objects in a given image. So you learn that as well as you progress in your learning journey when you start exploring TensorFlow and when you try to do some task on your own. Okay, so that's how you can plan out in your learning journey.
So let's understand how exactly a computer reads an image. So this is an image of New York skyline. I personally love this picture. So when a human will see this image, he'll first notice there are a lot of buildings in different colors and stuff like that. But how a computer will read this image? So basically there will be three channels. One will be red, another will be green, and finally we have blue channel, which is popularly known as RGB. So each of these channels will they have their own respective pixel values, as you can see it over here. So when I say that image size is B cross A cross 3, it means that there are B rows, A columns, and 3 channels. All right. So if somebody tells you that the size of an image is 28 cross 3 pixels, it means that it has 28 rows, 28 columns, and 3 channels. So this is how a computer sees an image. And this is for colored images. For black and white images, we have only 2 channels. So let's move forward and we'll see why can't we use fully connected networks for image classification. So consider an image which has 28 cross 3 pixels. So when I feed in this image to a fully connected network like this, then the total number of weights required in the first hidden layer will be 2352. You can just go ahead and multiply it yourself. All right. But in real life, the images are not that small. All right. So whatever images that we have, they are definitely above 200 cross 3 pixels. So if I take an image which has 200 cross 3 pixels and I feed it to a fully connected network, so at that time, the number of weights required at the first hidden layer itself will be 120,000 guys. So we need to deal with such huge amount of parameters, and obviously we require more number of neurons. So that can eventually lead to overfitting. So that's why we cannot use fully connected network for image classification. Now let's see why we need convolutional neural networks. So basically, in convolutional neural network, a neuron in the layer will only be connected to a small region of the layer before it. So if you consider this particular neuron which I'm highlighting right now is only connected to 3 other neurons. Unlike the fully connected network where this particular neuron will be connected to all these 5 neurons. Because of this, we need to handle less amount of weights, and in turn, we need less number of neurons as well. So let us understand what exactly is convolutional neural network. So convolutional neural networks are special type of feed-forward artificial neural networks, which is inspired from visual cortex. So visual cortex is nothing but a small region in our brain which is present somewhere here where you can see the bulb. And basically what happened, there was an experiment conducted and people got to know that visual cortex is small regions of cells that are sensitive to specific regions of visual field. So what I mean by that is, for example, some neurons in the visual cortex fires when exposed to vertical edges. Some will fire when exposed to horizontal edges. Some will fire when exposed to diagonal edges. And that is nothing but the motivation behind convolutional neural network. So now let us understand how exactly a convolutional neural network works. So generally a convolutional neural network has three layers: convolution layer, ReLU layer, pooling layer, and fully connected layer. We'll understand each of these layers one by one. We'll take an example of a classifier that can classify an image of an X as well as an O. So with this example, we'll be understanding all these four layers. So let's begin, guys. Now there are certain trickier cases. So what I mean by that is X can be represented in these four forms as well, right? So these are nothing but the deformed images of X. Similarly for O as well. So these are deformed images. So even I want to classify these images either X or O. All right, because even this is X, this is X, this is X, this is X. But all these are deformed images, but they are in turn X, right? So I want my classifier to classify them as X. So basically that's what I want. So if you can notice here, this is a proper image of an X, and which is actually equal to this particular X, which is a deformed image. Same goes for this O as well. So now what we are going to do is, we know that a computer understands an image using numbers at each pixels. So what we'll do, whatever the white pixels that we have, we are going to assign a value -1 to it, and whatever black pixels we have, we are going to assign a value 1 to it. When we use normal techniques to compare these two images, one is a proper image of X and another is a deformed image of X, we got to know that a computer is not able to classify the deformed image of X correctly. Why? Because it is comparing it with the proper image of X. Right? So when you go ahead and add the pixel values of both of these images, you get something like this. So basically our computer is not able to recognize whether it is an X or not. Now what we do with the help of CNN, we take small patches of our image. So these patches or these pieces are known as nothing but features or filters. So what we do, by finding rough feature matches in roughly the same positions in two images, CNN gets a lot better at seeing the similarity between the whole image matching schemes. What I mean by that is, we have these filters, right? We have these filters that you can see. So consider this first filter. This is exactly equal to the feature or the part of the image in the deformed image as well. So this is our proper image and this is our deformed image, all right? So this particular feature or this particular part of the image is actually equal to this particular part of the image. Same goes for this particular feature or filter as well. And similarly, we have this filter as well, which is actually equal to this particular part of the deformed image, all right? So let's move forward and we'll see what all features that we'll be taking in our example. So we'll be considering these three features or filters. This is a diagonal filter, this is again a diagonal filter, and this is nothing but a small X. So we'll take these three filters and we'll move forward. So what we are going to do is, we are going to compare these features, the small pieces of the bigger image. We are going to put it on the input image, and if it matches, then the image will be classified correctly. Now we'll begin, guys. The first layer is convolution layer. So these are the beginning two steps of this particular layer. First, we need to line up the feature in the image and then multiply image by the corresponding feature pixel. Now let me explain you with an example. So this is our first diagonal feature that we'll take. We are going to put this particular feature on our image of X, all right? And we are going to multiply the corresponding pixel value. So 1 will be multiplied with 1, we'll get 1, and we'll put it in another matrix. Similarly, we are going to move forward and we're going to multiply -1 with -1. We're going to multiply -1 with -1, as you can see. Similarly, we multiply this as well, -1 into -1, then again -1 into -1. So we are going to complete this whole process when we are going to finish up this matrix. All right. And once we are done finishing up the multiplication of all the corresponding pixels in the feature as well as in the image, we need to follow two more steps. We need to add them up and divide by the total number of the pixels in the feature. So what I mean by that is, after the multiplication of the corresponding pixel values, what we do, we add all these values, we divide it by the total number of pixels, and we get some value, right? And then now our next step is to create a map and put the value of the filter at that particular place. We saw that after multiplying the pixel value of a feature with the corresponding pixel value of with that of our image, we get the output, which is 1. So we place 1 here. Similarly, we are going to move this filter throughout the image. Next up, we are going to move this filter here. After that, we are going to move it here, 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 everywhere on the image. We are going to move it and we are going to follow the same process. All right. So yeah, this is one more example where I've moved my filter in between. And after doing that, I've got the output something like this, 1, 1, -1 and all. So over here, if you notice, I've got a couple of times -1 as well, due to which my output that comes is 0.55, right? So I'm going to place 0.55 here. Similarly, after moving the pixel, after moving the filter throughout the image, I got this particular matrix. All right. And this is for one particular feature. After performing the same process for the other two filters as well, I've got these two values. So we have these three values after passing through the convolution layer. Let me give you a quick recap of what happens in convolution layer. So basically, we have taken three features Alright, and one by one we'll take one feature, move it through the entire image, and when we are moving it, at that time we are multiplying the pixel value of the image with that of the corresponding pixel value of the filter, adding them up, dividing by the total number of pixels to get the output. So when we do that for all the filters, we got these three outputs. Alright, so let's move forward and we'll see what happens in ReLU layer. So this is ReLU layer, guys, and people who have gone through the previous tutorial actually know what it is. So let me just give you a quick introduction of ReLU layer. So ReLU is nothing but an activation function. All right. So what I mean by that is it will only activate a node if the input is above a certain quantity. While the input is below zero, the output is also zero. All right. And when the input rises above the certain threshold, it has a linear relationship with the dependent variable. Now I'll explain you with an example. We have a graph of ReLU function here. So my function says that when f of x is equal to 0 if x is less than 0, and it is equal to x when x is greater than 0. All right. So whatever values that I have which are below 0 will actually in turn become 0, and whatever values that are above 0, our function value will also be equal to that particular value. So f of x will be equal to x if it is greater than or equal to 0, and it will be 0 if it is less than 0. So if I have x value as -3, so definitely it is less than 0, so f of x becomes 0. Similarly, if I have -5x value, then again it is less than 0, so my f of x value becomes 0. But when I consider 3 as my x value, then my f of x becomes equal to x, which is nothing but 3. So over here I'll have 3. Again, if I take my x value as 5, then obviously it is greater than or equal to 0. Then my f of x becomes equal to x, so my f of x value becomes 5. So this is how a ReLU function works. So why are we using ReLU function here is we want to remove all the negative values from our output that we got through the convolution layer. So we'll only take the first output that we got by moving one feature throughout the image. So this is the output that we have got for only one filter. All right. So over here, I'm going to remove all negative values. So over here, you can see that it was minus 0.11 before, and I've converted that to 0. Similarly, I'm going to repeat the whole process for the entire matrix. And once I'm done with that, I get this particular value. Now remember, this is only for the output that we got through one feature. All right. So when we were doing convolution at that time, we were using 3 features, right? So this is the output only for one filter. After doing it for the output of the other 2 filters as well, we have got these 2 values more. So totally we have these 3 values after passing through ReLU activation function. Next up, we'll see what exactly is pooling layer. So in pooling layer, what we do, we take a window size of 2 and we move it across the entire matrix that we have got after passing through ReLU layer. And we take only the maximum value from there so that we can shrink the image. So what we are actually doing is we are reducing the size of our image. So let me explain you with an example. So this is basically one output that we have got after passing through ReLU layer. And over here we have taken a window size of 2 cross 2. So when we keep this window at this particular position, we see that 1 is the highest value. So we are going to keep 1 here. And we are going to repeat the same process for this particular window as well. So over here the maximum value is 0.33, so 0.33 will come. So if you notice here, earlier we had 7 cross 7 matrix, and now we have reduced that to 4 cross 4 matrix. So after doing that for the entire image, we have got this as our output. This output we have got after moving our window throughout the image that we have got after passing through ReLU layer, right? And when we repeat this process for all the 3 outputs that we have got after the ReLU layer, then we get this particular output after pooling layer, right? So basically we have shrinked our image to a 4 cross 4 matrix. Now comes the tricky part. So where we are going to do now is stack up all these layers. So we have discussed convolution layer, ReLU layer, and pooling layer. So I'll just give you a brief recap of what all things we have discussed. In convolution layer, what we did, we took 3 features, and then after that, one by one, we moved each filter throughout the image. And when we were moving it, we are continuously multiplying the image pixel value with that of the corresponding filter pixel value. And then we were dividing it by the total number of pixels. All right. With that, we got 3 output after passing through the convolution layer. Then those 3 output, we passed through a ReLU layer where we have removed the negative value. All right. And after removing negative value, again, we have got the 3 outputs. Then those 3 outputs, we passed through pooling layer. So basically, we're trying to shrink our image. And what we did, we took a window size of 2 cross 2, moved it through all the 3 outputs that we have got through ReLU layer. And after doing that, we were only taking the maximum value, pixel value in that particular window. And then we were putting it in a different matrix so that we get a shrinked image. And after passing it through pooling layer, we have got a 4 cross 4 matrix. And since we took 3 features in the beginning, so therefore we have got 3 outputs after passing through pooling layer. All right. Next up, we are going to stack up all the layers. All right. So let's do that. So after passing through convolution, ReLU, and pooling, we have got this 4 cross 4 matrix. This was our input image. Now when we add one more layer of convolution, ReLU, and pooling, we have shrinked our image from 4 cross 4 to 2 cross 2, as you can notice here. Now we are going to use fully connected layer. Now what happens in fully connected layer? The actual classification happens here, guys, okay? So what we are doing here is we are going to take the shrinked images and put it into a single list. So basically this is what we have got after passing through 2 layers of convolution, ReLU and pooling. And this is what we have got. So basically we are converting into a single list or a vector. How we do that? We take the first value 1, then we take 0.55, then we take 0.55, then we take 1 again. Then we take 1, then we take 0.55, 0.55, 0.55. Then we again take 0.55, 1, 1 and 0.55. So this is nothing but a vector, or you can say a list. If you notice here that there are certain values in my list which is high for X, and similarly if I repeat the entire process that we have discussed for O, there will be certain different values which will be high. So for X we have first, fourth, fifth, 10th and 11th element vector values are high. For O we have second, third, 9th and 12th element vector which are high. So basically we know now if we have an input image which has first, fourth, fifth, 10th and 11th element vector values high, we know that we can classify it as X. Similarly, if our input image has a list which has the second, third, 9th and 12th element vector values high, then we can classify it as 0. Now let me explain you with an example. So after the training is done, after doing the entire process for both X and O, you know that our model is trained now. Okay, so we have given a new input image, and that input image passes through all the layers. And once it has passed through all the layers, we have got this 12 element vector. Now it has 0.9, 0.65, all these values, right? Now, how do we classify it, whether it is an X or O? So what we do, we'll compare this with a list of X and O, right? So we have got the list in the previous slide. If you notice, we have got 2 different lists for X and O. We are going to compare this new input image list that we have got with that of X and O, right? So first let us compare that with X. Now, as I've told you earlier as well, for X, there are certain values which will be high, which is nothing but first, fourth, fifth, 10th and 11th value, right? So I'm going to sum first, fourth, fifth, 10th and 11th value, and I've got 5. 1 plus 1 plus 1 plus 1 and plus 1. So 5 times 1, I've got 5. And now I'm going to sum the corresponding values of my input image vector as well. So the first value is 0.9. Then the fourth value is 0.87, fifth value is 0.96, 10th value is 0.89, and the 11th value is 0.94. So after this, doing the sum of these values, I've got 4.56. When I divide this by 5, I got 0.91, right? Now this is for X. Now when I do the same process for O, so in O, if you notice, I have second, third, 9th and 12th element vector values as high. So when I sum these values, I get 4. And when I do the sum of the corresponding values in my input image, I've got 2.07. When I divide that by 4, I got 0.51. And so now we notice that 0.91 is a higher value compared to 0.51. So when we have compared our input image with the values of X, we got a higher value than the value that we have got after comparing the input image with the values of O. So the input image is classified as X. All right, so now let us move towards our use case. So this is our use case, guys. So over here, what we are going to do is we are going to train our model on different types of dogs and cat images. And once the training is done, we are going to provide it an input, and it will classify whether the input is of a dog or a cat. Now, let me tell you the steps involved in it. So what we are going to do in the beginning is obviously first we need to download the data set. After that, we are going to write a function to encode the labels. Labels are nothing but the dependent variable that we are trying to predict. So in our training data and testing data, obviously we know the labels, right? So on that basis only we can train our model. So we are going to encode those labels. After that, we'll resize the image to 50 cross 50 pixel, and we are going to read it as a grayscale image. Then we are going to split the data, 24,000 images for training and 50 for testing. Once this is done, we are going to reshape the data appropriately for TensorFlow. Now TensorFlow, I think everyone knows about TensorFlow. TensorFlow is nothing but a Python library for implementing deep learning models. Then we are going to build the model, calculate the loss. It is nothing but categorical cross entropy. Then we are going to reduce the loss by using Adam optimizer with a learning rate set to 0.001. Then we are going to train the deep neural network for 10 epochs, and finally we are going to make predictions. All right, so I'll just quickly open my PyCharm and I'll show you the code, how it looks like. So this is the code that I've written in order to implement the use case. In the beginning, I need to import the libraries that I require. And once it is done, what I'm doing, I'm defining my training data and the testing data. So train and test one contains both my training data as well as testing data respectively. Then I've taken my image size as 50 and learning rate I've defined here. And I've given a name to my model. You can give whatever name you want. All right, so first thing that we saw, we need to encode the dependent variable. That's what we are doing here. We are encoding our dependent variable. So whenever the label is cat, then it will be converted to an array of 1, 0, and when it is dog, it will be converted to an array of 0, 1. So why we're actually encoding the label? Because our code cannot understand the categorical variable. So we need to encode it, right? Next, what I'm doing is I'm resizing my image to 50 cross 50, and I am converting it to a grayscale image, right? And once this is done, I'm going to split my data set into training and testing parts. So yeah, we are basically splitting the data set into two parts for training and testing. And here we are defining a model. So you can I can just go ahead and throw in a comment here. Building the model. Yeah. So this is where we are building the model. So basically what we have done here is we have resized our image to 50 cross 50 cross 1 matrix, and that is the size of the input that we are using, right? This input that I'm talking about. Then what we have done, a convolution layer we have defined with 32 filters and a stride of 5 with an activation function, a ReLU. And after that, we have added a pooling layer, max pool layer. Okay. Again, what we have done, we have repeated the same process, but over here we are taking 64 filters and 5 stride, passing it through a ReLU activation function, and after that we have a pooling layer, max pool layer. Then we have repeated the same process for 128 filters. After that we have repeated for 64 filters, then for 32 filters. And after that we are using a fully connected layer with 1024 neurons. And finally we are using the dropout layer with key probability of 0.8 to finish our model. So this is where our model is actually finished. And then what we are doing is we are using the Adam optimizer to optimize our model. So basically whatever the loss that we have, we are trying to reduce it. And this is basically for your TensorBoard. So we are creating some log files, and then with that log file, TensorBoard will create a pretty fancy graphs for us that helps us to visualize the entire model. And then what we are doing is we are trying to fit the model. And we have defined epochs as 10. That is the number of iterations that will happen will be 10. And yeah, so this is pretty much it. Model name we have given. Then input is x_test to check the accuracy. Similarly, the target will be y_test. The labels associated with that test data will be a y_test, and which we have encoded basically. So this is how we are going to actually calculate the accuracy, and we'll try to reduce the loss as much as possible in 10 epochs. So till now our model is complete. We are done with it. Next, what I'm doing is I'm feeding in some random input from the test data, and I'm validating whether my model is predicting it correct or not. All right. So I've already trained the model because it takes a lot of time, and yeah, I cannot do it here. So I've already trained the model, and you can see that the loss that came after the 10th epoch is 0.2973, and the accuracy is somewhere around 88%, which is pretty good, guys. And yeah, and I've done the prediction on the test data as well. So let me just show it to you that. So this is the prediction that it has done on few of the images in the test data. So yeah, it is a cat predicted as cat, cat predicted as cat, 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 and dogs as well. There are certain dogs as well. So this is the problem statement, guys. We need to figure out if the banknotes are real or fake. And for that, we'll be using artificial neural networks. And obviously, we need some sort of data in order to train our network. So let us see how the data set looks like. So over here, I've taken a screenshot of the data set with few of the rows. In it, data were extracted from images that were taken from genuine and forged banknote-like specimens. After that, wavelet transform tools were used to extract features from those images. And these are few features that I'm highlighting with my cursor. And the final column, or the last column, actually represents the label. So basically, label tells us to which class that pattern represents, whether that pattern represents a fake note or it represents a real note. Let us discuss these features and labels one by one. So the first feature, or the first column, is nothing but variance of a wavelet transformed image. The second column is about skewness. The third is curtices of wavelet transformed image. And finally, fourth one is entropy of the image. After that, when I talk about label, which is nothing but my last column, over here, if the value is 1, that means the pattern represents a real note. Whereas when value is 0, that means it represents a fake note. So guys, let's move forward and we'll see what are the various steps involved in order to implement this use case. So over here, we'll first begin by reading the data set that we have. We'll define features and labels. After that, we are going to encode the dependent variable. And what is a dependent variable? It is nothing but your label. Then we are going to divide the data set into two parts, one for training, another for testing. After that, we'll use TensorFlow data structures for holding features, labels, etc. And TensorFlow is nothing but a Python library that is used in order to implement deep learning models, or you can say neural networks. Then we'll write the code in order to implement the model. And once this is done, we will train our model on the training data. We'll calculate the error. Error is nothing but your difference between the model output and the actual output. And we'll try to reduce this error. And once this error becomes minimum, we'll make prediction on the test data and we'll calculate the final accuracy. So guys, let me quickly open my PyCharm and I'll show you how the output looks like. So this is my PyCharm guys. Over here I've already written the code in order to execute the use case. I'll go ahead and run this and I'll show you the output. So over here, as you can see, with every iteration the accuracy is increasing. So let me just stop it right here. So we'll move forward and we'll understand why we need neural networks. So in order to understand why we need neural networks, we are going to compare the approach before and after neural networks. And we'll see what were the various problems that were there before neural networks. So earlier, conventional computers use an algorithmic approach. That is, the computer follows a set of instructions in order to solve a problem. And unless the specific steps that the computer needs to follow are known, the computer cannot solve the problem. So obviously we need a person who actually knows how to solve that problem, and he or she can provide the instructions to the computer as to how to solve that particular problem, right? So we first should know the answer to that problem, or we should know how to overcome that challenge or problem which is there in front of us. Then only we can provide instructions to the computer. So this restricts the problem solving capability of conventional computers to problems that we already understand and know how to solve. But what about those problems whose answer we have no clue of? So that's where our traditional approach was a failure. So that's why neural networks were introduced. Now let us see what was the scenario after neural networks. So neural networks basically process information in a similar way the human brain does. And these networks, they actually learn from examples. You cannot program them to perform a specific task. They will learn from their examples, from their experience. So you don't need to provide all the instructions to perform a specific task, and your network will learn on its own with its own experience. All right, so this is what basically neural network does. So even if you don't know how to solve a problem, you can train your network in such a way that with experience, it can actually learn how to solve the problem. So that was a major reason why neural networks came into existence. So we'll move forward and we'll understand what is the motivation behind neural networks. So these neural networks are basically inspired by neurons, which are nothing but your brain cells. And the exact working of the human brain is still a mystery though. So as I've told you earlier as well, that neural networks work like human brain, and so the name. And similar to a newborn human baby, as he or she learns from his or her experience, we want a network to do that as well. But we want it to do very quickly. So here's a diagram of a neuron. Basically, a biological neuron receives input from other sources, combines them in some way, perform a generally non-linear operation on the result, and then outputs the final result. So here if you notice these dendrites will receive signals from the other neurons. Then what will happen, it will transfer it to the cell body. The cell body will perform some function. It can be summation, it can be multiplication. So after performing that summation on the set of inputs, via axon it is transferred to the next neuron. Now let's understand what exactly are artificial neural networks. It is basically a computing system that is designed to simulate the way the human brain analyzes and processes the information. Artificial neural networks has self-learning capabilities that enable it to produce better results as more data becomes available. So if you train your network on more data, it will be more accurate. So these neural networks, they actually learn by example. And you can configure your neural network for specific applications. It can be pattern recognition, or it can be data classification, anything like that, all right? So because of neural networks, we see a lot of new technology has evolved. From translating web pages to other languages, to having a virtual assistant to order groceries online, to conversing with chatbots. All of these things are possible because of neural networks. So in a nutshell, if I need to tell you, artificial neural network is nothing but a network of various artificial neurons. All right. So let me show you the importance of neural network with two scenarios, before and after neural network. So over here we have a machine, and we have trained this machine on 4 types of dogs, as you can see where I'm highlighting with my cursor. And once the training is done, we provide a random image to this particular machine which has a dog. But this dog is not like the other dogs on which we have trained our system on. So without neural networks, our machine cannot identify that dog in the picture, as you can see it over here. Basically, our machine will be confused. It cannot figure out where the dog is. Now, when I talk about neural networks, even if we have not trained our machine on this specific dog, but still it can identify certain features of the dogs that we have trained on, and it can match those features with the dog that is there in this particular image, and it can identify that dog. So this happens all because of neural networks. So this is just an example to show you how important are neural networks. Now I know you all must be thinking how neural networks work. So for that, we'll move forward and understand how it actually works. So over here, I'll begin by first explaining a single artificial neuron that is called as perceptron. So this is an example of a perceptron. Over here, we have multiple inputs, x1, x2, dash, 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 till xn. And we have corresponding weights as well, w1 for x1, w2 for x2, similarly wn for xn. Then what happens, we calculated the weighted sum of these inputs. And after doing that, we pass it through an activation function. This activation function is nothing but it provides a threshold value. So above that value, my neuron will fire, else it won't fire. So this is basically an artificial neuron. So when I talk about a neural network, it involves a lot of these artificial neurons with their own activation function and their processing element. Now we'll move forward and we'll actually understand various modes of this perceptron or single artificial neuron. So there are two modes in a perceptron. One is training, another is using mode. In training mode, the neuron can be trained to fire for particular input patterns, which means that we'll actually train our neuron to fire on certain set of inputs and to not fire on the other set of inputs. That's what basically training mode is. When I talk about using mode, it means that when a taught input pattern is detected at the input, its associated output becomes the current output, which means that once the training is done and we provide an input on which the neuron has been trained on, so it will detect the input and will provide the associated output. So that's what basically using mode is. So first you need to train it, then only you can use your perceptron or your network. So these were the two modes, guys. Next up, we'll understand what are the various activation functions available. So these are the three activation functions, although there are many more, but I've listed down three. Step function. So over here, the moment your input is greater than this particular value, your neuron will fire, else it won't. Similarly for sigmoid and sine function as well. So these are three activation functions. There are many more that I've told you earlier as well. So yeah, these are the three majorly used activation functions. Next up, what we are going to do, we are going to understand how a neuron learns from its experience. So I'll give you a very good analogy in order to understand that. And later on, when we talk about neural networks, or you can say multiple neurons in a network, I'll explain you the math behind it. I'll explain you the math behind learning, how it actually happens. So right now I'll explain you with an analogy. And guys, trust me, that analogy is pretty interesting. So I know all of you must have guessed it. So these are two beer mugs, and all of you who love beer can actually relate to this analogy a lot. And I know most of you actually love beer, so that's why I've chosen this particular analogy, so that all of you can relate to it. All right, jokes apart. So fine, guys. So there's a beer festival happening near your house and you want to badly go there. But your decision actually depends on three factors. First is how is the weather, whether it is good or bad. Second is your wife or husband is going with you or not. And the third one is any public transport is available. So on these three factors, your decision will depend whether you will go or not. So we'll consider these three factors as inputs to our perceptron, and we'll consider our decision of going or not going to the beer festival as our output. So let us move forward with that. So the first input is how is the weather. We'll consider it as x1. So when weather is good, it will be 1, and when it is bad, it will be 0. Similarly, your wife is going with you or not, so that will be your x2. If she is going, then it's 1. If she is not going, then it's 0. Similarly, for public transport, if it is available, then it is 1, else it is 0. So these are the three inputs that I'm talking about. Let's see the output. So output will be 1 when you're going to the beer festival, and output will be 0 when you want to relax at home. You want to have beer at home only. You don't want to go outside. So these are the two outputs, whether you're going or you're not going. Now what a human brain does. Over here, okay, fine. I need to go to the beer festival. But there are three things that I need to consider. But will I give importance to all these factors equally? Definitely not. There'll be certain factors which will be of higher priority for me. I'll focus on those factors more. Whereas few factors won't affect that much to me. Alright, so let's prioritize our inputs or factors. So here our most important factor is weather. So if weather is good, I love beer so much that I don't care even if my wife is going with me or not, or if there is a public transport available. So I love beer that much that if weather is good, then definitely I'm going there. That means when x1 is high, output will be definitely high. So how we do that, how we actually prioritize our factors, or how we actually give importance more to a particular input and less to another input in a perceptron or in a neuron. So we do that by using weights. So we assign high weights to the more important factors or more important inputs, and we assign low weights to those particular inputs which are not that important for us. So let's assign weights, guys. So weight W1 is associated with input X1, W2 with X2, and similarly W3 with X3. Now, as I've told you earlier as well, that weather is a very important factor, so I'll assign a pretty high weight to weather and I'll keep it as 6. Similarly, W2 and W3 are not that important, so I'll keep it as 2, 2. After that, I've defined a threshold value as 5, which means that when the weighted sum of my input is greater than 5, then only my neuron will fire, or you can say then only I'll be going to the beer festival. Alright, so I'll use my pen and we'll see what happens when weather is good. So when weather is good, our X1 is 1, our weight is 6, we'll multiply it with 6. Then, if my wife decides that she is going to stay at home and she will probably be busy with cooking and she doesn't want to drink beer with me, so she's not coming. So that input becomes 0. 0 into 2 will actually make no difference because it will be 0 only. Then again, there is no public transport available also. Then also this will be 0 into 2. So what output I get here? I get here as 6. And notice the threshold value, it is 5. So definitely 6 is greater than 5. That means my output will be 1, or you can say my neuron will fire, or I'll actually go to the beer festival. So even if these two inputs are 0 for me, that means my wife is not willing to go with me and there is no public transport available, but weather is good, which has very high weight value and it actually matters a lot to me. So if that is high, it doesn't really matter whether the two inputs are high or not. I will definitely go to the beer festival. Alright, now I'll explain you a different scenario. So over here our threshold was 5, but what if I change this threshold to 3? So in that scenario, even if my weather is not good, I'll give it a 0. So 0 into 6. But my wife and public transport both are available. Alright, so 1 into 2 plus 1 into 2, which is equal to 4. And it is definitely greater than 3. Then also my output will be 1. That means I will definitely go to the beer festival even if weather is bad. And my neuron will fire. So these are the two scenarios that I have discussed with you. Alright, so there can be many other ways in which you can actually assign weight to your problem or to your learning algorithm. So these are the two ways in which you can assign weights and prioritize your inputs or factors on which your output will depend. So obviously in real life, all the inputs or all the factors are not as important for you. So you actually prioritize them. And how you do that in perceptron, you provide high weight to it. This is just an analogy so that you can relate to a perceptron to a real life. We'll actually discuss the math behind it later in the session as to how a network or a neuron learns. Alright, so how the weights are actually updated and how the output is changing, that all those things we'll be discussing later in the session. But my aim is to make you understand that you can actually relate to a real life problem with that of a perceptron. Alright, and in real life problems are not that easy. They are very, very complex problems that we actually face. So in order to solve those problems, a single neuron is definitely not enough. So we need networks of neurons. And that's where artificial neural network, or you can say multi-layer perceptron, comes into the picture. Now let us discuss that. Multi-layer perceptron or artificial neural network. So this is how an artificial neural network actually looks like. So over here we have multiple neurons present in different layers. The first layer is always your input layer. This is where you actually feed in all of your inputs. Then we have the first hidden layer. Then we have second hidden layer, and then we have the output layer. Although the number of hidden layers depend on your application, on what are you working, what is your problem. So that actually determines how many hidden layers you'll have. So let me explain you what is actually happening here. So you provide in some input to the first layer, which is nothing but your input layer. You provide inputs to these neurons. All right. And after some function, the output of these neurons will become the input to the next layer, which is nothing but your hidden layer 1. Then these hidden layers also have various neurons. These neurons will have different activation functions. So they'll perform their own function on the inputs that it receives from the previous layer. And then the output of this layer will be the input to the next hidden layer, which is hidden layer 2. Similarly, the output of this hidden layer will be the input to the output layer. And finally, we get the output. So this is how basically an artificial neural network looks like. Now let me explain you this with an example. So over here, I'll take an example of image recognition using neural networks. So over here, what happens, we feed in a lot of images to our input layer. Now this input layer will actually detect the patterns of local contrast and then will feed that to the next layer, which is hidden layer 1. So in this hidden layer 1, the face features will be recognized. We'll recognize eyes, nose, ears, things like that. And then that will be again fed as input to the next hidden layer. And in this hidden layer, we'll assemble those features and we'll try to make a face. And then we'll get the output, that is the face will be recognized properly. So if you notice here, with every layer, we are trying to get a more abstract version or the generalized version of the input. So this is how basically an artificial neural network, how it works. All right. And there's a lot of training and learning which is involved that I'll show you now. Training a neural network. So how we actually train our neural network? So basically the most common algorithm for training a network is called backpropagation. So what happens in backpropagation? After the weighted sum of inputs and passing through an activation function and getting the output, we compare that output to the actual output that we already know. We figure out how much is the difference. We calculate the error. And based on that error, what we do, we propagate backwards. And we'll see what happens when we change the weight. Will the error decrease or will it increase? And if it increases, when it increases by increasing the value of the variables or by decreasing the value of variables. So we kind of calculate all those things and we update our variables in such a way that our error becomes minimum. And it takes a lot of iterations. Trust me guys, it takes a lot of iterations. We get output a lot of times and then we compare it with the model, with the actual output. Then again we propagate backwards, we change the variables, then again we calculate the output, we compare it again with the desired output of the actual output. Then again we propagate backwards. So this process keeps on repeating until we get the minimum value. All right. So there's an example that is there in front of your screen. Don't be scared of the terms that I used. I'll actually explain you with an example. So this is the example over here. We have 0, 1 and 2 as inputs and our desired output or the output that we already know is 0, 1 and 4. All right. So over here we can actually figure out that desired output is nothing but twice of your input. But I'm training a computer to do that, right? The computer is not a human. So what happens? I actually initialize my weight. I keep the value as 3. So the model output will be 3 into 0 is 0, 3 into 1 is 3, 3 into 2 is 6. Now obviously it is not equal to your desired output. So we check the error. Now the error that we have got here is 0, 1 and 2, which is nothing but your difference. So 0 minus 0 is 0, 3 minus 2 is 1, 6 minus 4 is 2. Now this is called an absolute error. After squaring this error, we get square error, which is nothing but 0, 1 and 4. All right. So now what we need to do, we need to update the variables. We have seen that the output that we got is actually different from the desired output. So we need to update the value of the weight. So instead of 3, our computer makes it as 4. After making the value as 4, we get the model output as 0, 4 and 8. And then we saw that the error has actually increased. Instead of decreasing, the error has increased. So after updating the variable, the error has increased. So you can see that square error is now 0, 4 and 16. And earlier it was 0, 1 and 4. That means we cannot increase the weight value right now. But if we decrease that, make it as 2, we get the output which is actually equal to desired output. But is it always the case that we need to only decrease the weight? Definitely not. So in this particular scenario, whenever I'm increasing the weight, error is increasing. And when I'm decreasing the weight, error is decreasing. But as I've told you earlier as well, this is not the case every time. Sometimes you need to increase the weight as well. So how we determine that? All right, fine guys, this is how basically a computer decides whether it has to increase the weight or decrease the weight. So what happens here, this is a graph of square error versus weight. So over here, what happens, suppose your square error is somewhere here and your computer, it starts increasing the weight in order to reduce the square error. And it notices that whenever it increases the weight, square error is actually decreasing. So it'll keep on increasing until the square error reaches a minimum value. And after that, when it tries to still increase the weight, the square error will increase. So at that time, our network will recognize that whenever it is increasing the weight after this point, error is increasing. So therefore, it will stop right there and that will be our weight value. Similarly, there can be one more scenario. Suppose if we increase the weight, but then also the square error is increasing. So at that time, we cannot increase the weight. At that time, computer will realize, okay, fine, whenever I'm increasing the weight, the square error is increasing. So it'll go in the opposite direction. So it'll start decreasing the weight and it'll keep on doing that until the square error becomes minimum. And the moment it decreases more, the square error again increases. So our network will know that whenever it decreases the weight value, the square error is increasing. So that point will be our final weight value. So guys, this is what basically backpropagation in a nutshell is. Fine, so we'll move forward and now is the correct time to understand how to implement the use case that I was talking about in the beginning. That is how to determine whether a node is fake or real. So for that, I'll open my PyCharm. This is my PyCharm again, guys. Let me just close this. All right. So this is the code that I've written in order to implement the use case. So over here, what we do, we import the first important libraries which are required. Matplotlib is used for visualization. TensorFlow we know in order to implement the neural networks. NumPy for arrays, Pandas for reading the data set. Similarly, sklearn for label encoding as well as for shuffling, and also to split the data set into training and testing paths. All right, fine, guys. So we'll begin by first reading the data set, as I've told you earlier as well when I was explaining the steps. So what I'll do, I'll use Pandas in order to read the CSV file which has the data set. After that, I'll define features and labels. So X will be my feature and Y will contain my label. So basically X includes all the columns apart from the last column, which is the fifth one. And because the indexing starts from 0, that's why we have written 0 till 4th. So it won't include the 4th column. All right. And so our last column will actually be our label. Then what we need to do, we need to encode the dependent variable. So the dependent variable, as I've told you earlier as well, is nothing but your label. So I've discussed encoding in TensorFlow tutorial. You can go through it and you can actually get to know why and how we do that. Then what we have done, we have read the data set. Then what we need to do is to split our data set into training and testing. And these are all optional steps. You can print the shape of your training and test data. If you don't want to do it, it's still fine. Then we have defined learning rate. So learning rate is actually the steps in which the weights will be updated. All right. So that is what basically learning rate is. Then when we talk about epochs, means iterations. Then we have defined course history. That will be an empty NumPy array, and its shape will be 1, and it will include the float type objects. Then we have defined ndim, which is nothing but your x shape of axis 1, which means your column. Then we'll print that. After that, we have defined the number of classes. So there can be only 2 classes, whether the node can be fake or it can be real. And this model path I've given in order to save my model. So I've just given a path where I need to save it. So I'll just save it here only in the current working directory. Now is the time to actually define our neural network. So we'll first make sure that we have defined the important parameters like hidden layers, number of neurons in hidden layers. So I'll take 10 neurons in every hidden layer, and I'm taking 4 layers like that. Then X will be my placeholder, and the shape of this particular placeholder is none, comma n underscore dim. N underscore dim value, I'll get it from here, and none can be any value. I'll define one variable W, and I'll initialize it with zeros, and this will be the shape of my weight. Similarly for bias as well, this will be the particular shape, and there will be one more placeholder y dash, which will actually be used in order to provide us with the actual output of the model. There'll be one model output and there'll be one actual output, which we use in order to calculate the difference, right? So we'll feed in the actual values of the labels in this particular placeholder y dash. And now we'll define the model. So over here we have named the function as multi-layer perceptron, and in it we'll first define the first layer. So the first hidden layer, and we are going to name it as layer underscore 1, which will be nothing but the matrix multiplication of x and weights of h1, that is the hidden layer 1, and that will be added to your biases b1. After that, we'll pass it through a sigmoid activation function. Similarly, in layer 2 as well, matrix multiplication of layer 1 and weights of h2. So if you can notice, layer 1 was the network layer just before the layer 2, right? So the output of this layer 1 will become input to the layer 2. And that's why we have written layer underscore 1. It'll be multiplied by weights h2, and then we'll add it with the bias. Similarly for this particular hidden layer as well, and this particular layer as well. But over here we are going to use the ReLU activation function instead of sigmoid. Then we are going to define the weights and biases. So this is how we basically define weights. So weights h1 will be a variable which will be a truncated normal with the shape of n underscore dim and n underscore hidden underscore 1. So these are nothing but your shapes. All right. And after that, what we have done, we have defined biases as well. Then we need to initialize all the variables. So all these things actually I've discussed in brief when I was talking about TensorFlow. So you can go through TensorFlow tutorial at any point of time if you have any question. We have discussed everything there. Since in TensorFlow we need to initialize the variables before we use it. So that's how we do it. We first initialize it and then we need to run it. That's when your variables will be initialized. After that, we are going to create a saver object. And then finally, I'm going to call my model. And then comes the part where the training happens. Cost function. Cost function is nothing but you can say an error that will be calculated between the actual output and the model output. All right, so y is nothing but our model output and y dash is nothing but the actual output or the output that we already know. All right, and then we are going to use a gradient descent optimizer to reduce the error. Then we are going to create a session object as well. And finally, what we are going to do, we are going to run the session. So this is how we basically do that. For every epoch, we will be calculating the change in the error as well as the accuracy that comes after every epoch on the training data. After we have calculated the accuracy on the training data, we are going to plot it for every epoch how the accuracy is. And after plotting that, we are going to print the final accuracy, which will be on our test data. So using the same model, we'll make prediction on the test data. And after that, we are going to print the final accuracy and the mean squared error. So let's go ahead and execute this, guys. All right, so training is done. And this is the graph we have got for accuracy versus epoch. This is accuracy, y-axis represents accuracy, whereas this is epochs. We have taken 100 epochs and our accuracy has reached somewhere around 99%. So with every epoch, it is actually increasing. Apart from a couple of instances, it is actually keep on increasing. So the more data you train your model on, it will be more accurate. Let me just close it. So now the model has also been saved where I wanted it to be. This is my final test accuracy and this is the mean squared error. All right, so these are the files that will appear once you save your model. These are the 4 files that I've highlighted. Now what we need to do is restore this particular model. And I've explained this in detail how to restore a model that you have already saved. So over here what I'll do, I'll take some random range. I've taken it actually from 754 to 768. So all the values in the row of 754 and 768 will be fed to our model and our model will make prediction on that. So let us go ahead and run this. So when I'm restoring my model, it seems that my model is 100% accurate for the values that I've fed in. So whatever values that I have actually given as input to my model, it has correctly identified its class, whether it's a fake node or a real node. Because 0 stands for fake node and 1 stands for real node, okay? So original class is nothing but which is there in my data set, so it is 0 already. And what prediction my model has made is 0. That means it is fake. So accuracy becomes 100%. Similarly for other values as well. Fine guys, so this is how we basically implement the use case that we saw in the beginning. So in the slide you can notice that I've listed down only 2 applications, although there are many more. So neural networks in medicine. Artificial neural networks are currently a very hot research area in medicine, and it is believed that they will receive extensive application to biomedical systems in the next few years. And currently the research is mostly on modeling parts of human body and recognizing diseases from various scans. For example, it can be cardiograms, CAT scans, ultrasonic scans, etc. And currently the research is going mostly on 2 major areas. First is modeling and diagnosing the cardiovascular system. So neural networks are used experimentally to model the human cardiovascular system. Diagnosis can be achieved by building a model of the cardiovascular system of an individual and comparing it with the real-time physiological measurements taken from the patient. And trust me guys, if this routine is carried out regularly, potential harmful medical conditions can be detected at an early stage and thus make the process of combating disease much easier. Apart from that, it is currently being used in electronic noses as well. Electronic noses have several potential applications in telemedicine. Now let me just give you an introduction to telemedicine. Telemedicine is a practice of medicine over long distance via a communication link. So what the electronic noses will do, they would identify odors in the remote surgical environment. These identified odors would then be electronically transmitted to another site where an door generation system would recreate them. Because the sense of the smell can be an important sense to the surgeon, telesmell would enhance telepresent surgery. So these are the 2 ways in which you can use it in medicine. You can use it in business as well, guys. So business is basically a diverted field with several general areas of specialization such as accounting or financial analysis. Almost any neural network application would fit into one business area or financial analysis. Now there is some potential for using neural networks for business purposes, including resource allocation and scheduling. I've listed down 2 major areas where it can be used. One is marketing. So there is a marketing application which has been integrated with a neural network system. The airline marketing tactician is a computer system made of various intelligent technologies, including expert systems. A feed-forward neural network is integrated with the AMT, which is nothing but airline marketing tactician, and was trained using backpropagation to assist the marketing control of airline seat allocation. So it has wide applications in marketing as well. Now the second area is credit evaluation. Now I'll give you an example here. The HNC company has developed several neural network applications, and one of them is a credit scoring system which increases the profitability of existing model up to 27%. So these are few applications that I'm telling you guys. Neural network is actually the future. People are talking about neural networks everywhere. And especially after the introduction of GPUs and the amount of data that we have now, neural network is actually spreading like plague right now. Why can't we use feed-forward networks? Now let us take an example of a feed-forward network that is used for image classification. So we have trained this particular network for classifying various images of animals. Now if you feed in an image of a dog, it will identify that image and will provide a relevant label to that particular image. Similarly, if we feed in an image of an elephant, it will provide a relevant label to that particular image as well. Now if you notice, the new output that we have got, that is classifying an elephant, has no relation with the previous output, that is of a dog. Or you can say that the output at time t is independent of output at time t minus 1. As we can see that there is no relation between the new output and the previous output. So we can say that in feed-forward networks, outputs are independent to each other. Now there are few scenarios where we actually need the previous output to get the new output. Let us discuss one such scenario. Now what happens when you read a book? You'll understand that book only on the understanding of your previous words. Alright, so if I use a feed-forward network and try to predict the next word in a sentence, I can't do that. Why can't I do that? Because my output will actually depend on the previous outputs. But in the feed-forward network, my new output is independent of the previous outputs. That is, output at t plus 1 has no relation with output at t minus 2, t minus 1 and at t. So basically, we cannot use feed-forward networks for predicting the next word in a sentence. Similarly, you can think of many other examples where we need the previous output, some information from the previous output, so as to infer the new output. This is just one small example. There are many other examples that you can think of. So we'll move forward and understand how we can solve this particular problem. So over here, what we have done, we have input at t minus 1. We'll feed it to our network. Then we'll get the output at t minus 1. Then at the next timestamp, that is at time t, we have input at time t that will be given to our network along with the information from the previous timestamp, that is t minus 1, and that will help us to get the output at t. Similarly, at output for t plus 1, we have two inputs. One is a new input that we give. Another is the information coming from the previous timestamp, that is t, in order to get the output at time t plus 1. Similarly, it can go on. So over here, I have just written a generalized way to represent it. There's a loop where the information from the previous timestamp is flowing. And this is how we can solve this particular challenge. Now let us understand what exactly are recurrent neural networks. So for understanding recurrent neural network, I'll take an analogy. Suppose your gym trainer has made a schedule for you. The exercises are repeated after every third day. Now this is the order of your exercises. First day you'll be doing shoulder, second day you'll be doing biceps, third day you'll be doing cardio. And all these exercises are repeated in a proper order. Now what happens when we use a feed-forward network for predicting the exercise today? So we'll provide in the inputs such as day of the week, month of the year and health status. Alright, and we need to train our model or our network on the exercises that we have done in the past. After that, there'll be a complex voting procedure involved that will predict the exercise for us. And that procedure won't be that accurate. So whatever output we'll get won't be as accurate as we want it to be. Now what if I change my inputs and I make my inputs as what exercise I've done yesterday? So if I've done shoulder, then definitely today I'll be doing biceps. Similarly, if I've done biceps yesterday, today I'll be doing cardio. Similarly, if I've done cardio yesterday, today I'll be doing shoulder. Now there can be one scenario where you are unable to go to gym for one day. Due to some personal reasons, you could not go to the gym. Now what will happen at that time? We'll go one timestamp back and we'll feed in what exercise that happened day before yesterday. So if the exercise that happened day before yesterday was shoulder, then yesterday there were biceps exercises. Alright, similarly biceps happened day before yesterday, then yesterday would have been cardio exercises. Similarly, if cardio would have happened day before yesterday, yesterday would have been shoulder exercises. Alright, and this prediction, the prediction for the exercise that happened yesterday will be fed back to our network, and these predictions will be used as inputs in order to predict what exercise will happen today. Similarly, if you have missed your gym say for 2 days, 3 days or 1 week, so you need to roll back. You need to go to the last day when you went to the gym. You need to figure out what exercise you did on that day, feed that as an input, and then only you'll be getting the relevant output as to what exercise will happen today. Now what I'll do, I'll convert these things into a vector. Now what is a vector? Vector is nothing but a list of numbers. Alright, so this is the new information guys along with the information from the prediction at the previous timestamp. So we need both of these in order to get the prediction at time t. Imagine if I have done shoulder exercises yesterday. So this will be 1, this will be 0, this will be 0. Now the prediction that will happen will be biceps exercise, because if I've done shoulder yesterday, today it will be biceps. So my output will be 0, 1 and 0. And this is how vectors work, guys. So I hope you have understood this, guys. Now this is how a neural network looks like, guys. We have new information along with the information from the previous timestamp. The output that we have got in the previous timestamp will use certain information from that, will feed into our network as inputs, and then that will help us to get the new output. Similarly, this new output that we have got will take some information from that, feed in as an input to our network along with the new information to get the new prediction, and this process keeps on repeating. Now, let me show you the math behind the recurrent neural networks. So this is the structure of a recurrent neural network, guys. Let me explain you what happens here. Now consider a time t equals to 0, we have input x naught, and we need to figure out what is h naught. So according to this equation, h of 0 is equal to wi weight matrix multiplied by our input x of 0 plus wr into h of 0 minus 1, which is h of minus 1, and time can never be negative, so this particular equation cannot be applied here, plus a bias. So wi into x of 0 plus bh passes through a function g of h to get h of 0 over here. After that, I want to calculate y naught. So for y naught, I'll multiply h of 0 with the weight matrix wi, and I'll add a bias to it and pass it through a function g of y to get y naught. Now in the next timestamp, that is at time t equals to 1, things become a bit tricky. Now let me explain you what happens here. So at time t equals to 1, I have input x1. I need to figure out what is h1. So for that, I'll use this equation. So I'll multiply wi, that is a weight matrix, by the input x1 plus wr into h of 1 minus 1, which is 0. H of 0, we know what we got from here. So wr into h of 0 plus the bias, pass it through a function g of h to get the output as h1. Now this h1 will use to get y1. We'll multiply h1 with wi plus a bias and we'll pass it through a function g of y to get y1. Similarly, the next timestamp, that is at time t equals to 2, we have input x2. We need to figure out what will be h2. So we'll multiply the weight matrix wi with x of 2 plus wr into h of 1 that we have got here plus b of h and pass it through a function g of h to get h of 2. From h of 2, we'll calculate y of 2, wi into h of 2 plus by, that is the bias, pass it through a function g of y to get y2. And this is how recurrent neural network works, guys. Now you must be thinking how to train a recurrent neural network. So a recurrent neural network uses backpropagation algorithm for training. But backpropagation happens for every timestamp. That is why it is commonly called as backpropagation through time. And I've discussed backpropagation in detail in artificial neural network tutorial, so you can go through that. Over here, I won't be discussing backpropagation in detail. I'll just give you a brief introduction of what it is. Now with backpropagation, there are certain issues, namely vanishing and exploding gradients. Let us see those one by one. So in vanishing gradient, what happens? When you use backpropagation, you tend to calculate the error, which is nothing but the actual output that you already know minus the model output, the output that you got through your model, and the square of that. So you figure out the error. With that error, what do? You tend to find out the change in error with respect to change in weight or any variable. So we'll call it weight here. So change of error with respect to weight multiplied by learning rate will give you the change in weight. Then you need to add that change in weight to the old weight to get the new weight. All right. So obviously what we are trying to do, we are trying to reduce the error. So for that, we need to figure out what will be the change in error if my variables are changed, right? So that way we can get the change in the variable and add it to our old variable to get the new variable. Now over here, what can happen if the value dE by dW, that is a gradient, or you can say the rate of change of error with respect to our variable weight, becomes very small than 1, like it is 0.00 something. So if you multiply that with the learning rate, which is definitely smaller than 1, then you get the change of weight, which is negligible. All right. So there might be certain examples where you are trying to predict, say, a next word in a sentence, and that sentence is pretty long. For example, if I say I went to France dash dash dash, I went to France, then there are certain words, then I say few of them speak dash. Now I need to predict speak, what will come after speak. So for that, I need to go back in time and check what was the context, which will be very complex. And due to that, there will be a lot of iterations. And because of that, this error, this change in weight will become very small, very small. So the new weight that we'll get will be actually almost equal to your old weight. So there won't be any updation of weight that will be happening. and that is nothing but your vanishing gradient. Alright, I'll repeat it once more. So what happens in backpropagation, you first calculate the error. This error is nothing but the difference between the actual output and the model output and the square of that. With that error, we figure out what will be the change in error when we change a particular variable, say weight. So dE by dW, multiply it with learning rate to get the change in the variable or change in the weight. Now we'll add that change in the weight to our old weight to get the new weight. This is what backpropagation is, guys. Alright, I'm just giving you a small introduction to backpropagation. Now consider a scenario where you need to predict the next word in a sentence. And your sentence is something like this. I have been to France. Then there are a lot of words. After that, few people speak. And then you need to predict what comes after speak. Now if I need to do that, I need to go back and understand the context. What is it talking about? And that is nothing but your long-term dependencies. So what happens during long-term dependencies, if this dE by dW becomes very small, then when you multiply it with n, which is again smaller than 1, you get delta W, which will be very, very small. That will be negligible. So the new weight that you'll get here will be almost equal to your old weight. So I hope you're getting my point. So this new weight, so there will be no updation of weights, guys. This new weight will always be almost equal to our old weight. So there won't be any learning here. So that is nothing but your vanishing gradient problem. Similarly, when I talk about exploding gradient, it is just the opposite of vanishing gradient. So what happens when your gradient or dE by dW becomes very large, becomes greater than 1, all right? And you have some long-term dependencies. So at that time, your dE by dW will keep on increasing, delta W will become large, and because of that, your weights, the new weight that will come will be very different from your old weight. So these two are the problems with backpropagation. Now let us see how to solve these problems. Now exploding gradients can be solved with the help of truncated BTD, backpropagation through time. So instead of starting backpropagation at the last timestamp, we can choose a smaller timestamp like 10. Or we can clip the gradients at a threshold. So there can be a threshold value where we can, clip the gradients. And we can adjust the learning rate as well. Now for vanishing gradient, we can use a ReLU activation function. Similarly, we can also use LSTM and GRUs. Now let us understand what exactly are LSTMs. So guys, we saw what are the two limitations with the recurrent neural networks. Now we'll understand how we can solve that with the help of LSTMs. Now what are LSTMs? Long short-term memory networks, usually called as LSTMs, are nothing but a special kind of recurrent neural network. And these recurrent neural networks are capable of learning long-term dependencies. Now what are long-term dependencies? I've discussed that in the previous slide, but I'll just explain it to you here as well. Now, what happens sometimes we only need to look at the recent information to perform the present task. Now, let me give you an example. Consider a language model trying to predict the next word based on the previous ones. If we are trying to predict the last word in the sentence, say, the clouds are in the sky. So we don't need any further context. It's pretty obvious that the next word is going to be sky. Now, in such cases where the gap between the relevant information and the place that it's needed is small, RNNs can learn to use the past information. And at that time, there won't be such problems like vanishing and exploding gradient. But there are few cases where we need more context. Consider trying to predict the last word in the text, I grew up in France. Then there are some words. After that comes, I speak fluent French. Now, recent information suggests that the next word is probably the name of a language. But if we want to narrow down which language, we need the context of France from further back. And it's entirely possible for the gap between the relevant information and the point where it is needed to become very large. And this is nothing but long-term dependencies. And the LSTMs are capable of handling such long-term dependencies. Now, LSTMs also have a chain-like structure like recurrent neural networks. Now, all the recurrent neural networks have the form of a chain of repeating modules of neural networks. Now, in standard RNNs, the repeating module will have a very simple structure such as a single TANH layer that you can see. Now this TANH layer is nothing but a squashing function. Now what I mean by squashing function is to convert my values between -1 and 1. Alright, that's why we use TANH. And this is an example of an RNN. Now we'll understand what exactly are LSTMs. Now this is a structure of an LSTM. Or if you notice, LSTM also have a chain-like structure, but the repeating module has different structures. Instead of having a single neural network layer, there are 4 interacting in a very special way. Now the key to LSTM is the cell state. Now this particular line that I'm highlighting, this is what is called the cell state. The horizontal line running through the top of the diagram. So this is nothing but your cell state. Now you can consider the cell state as a kind of a conveyor belt. It runs straight down the entire chain with only some minor linear interactions. Now what I'll do, I'll give you a walkthrough of LSTM step by step, alright? So we'll start with the first step. Alright guys, so the first step in our LSTM is to decide what information we are going to throw away from the cell state. And you know what is the cell state, right? I've discussed in the previous slide. Now this decision is made by the sigmoid layer. So the layer that I'm highlighting with my cursor, it is the sigmoid layer called the forget gate layer. It looks at ht minus 1, that is the information from the previous timestamp, and xt, which is the new input, and outputs a number between 0 and 1 for each number in the cell state ct minus 1, which is coming from the previous timestamp. A 1 represents completely keep this, while a 0 represents completely get rid of this. Now if we go back to our example of a language model trying to predict the next word based on all the previous ones, in such a problem, the cell state might include the gender of the present subject so that the correct pronouns can be used. When we see a new subject, we want to forget the gender of the old subject, right? We want to use the gender of the new subject. So we'll forget the gender of the previous subject here. This is just an example to explain you what is happening here. Now let me explain you the equations which I've written here. So ft will be combining with the cell state later on, that I'll tell you. So currently ft will be nothing but the weight matrix multiplied by ht minus 1 and xt and plus the bias, and this equation is passed through a sigmoid layer. Alright, and we get an output that is 0 and 1. 0 means completely get rid of this, and 1 means completely keep this. Alright, so this is what basically is happening in the first step. Now let us see what happens in the next step. So the next step is to decide what information we are going to store. In the previous step, we decided what information we are going to keep, but here we are going to decide what information we are going to store here. Alright, what new information we are going to store in the cell state. Now this has two parts. First, a sigmoid layer, this is called a sigmoid layer, and which is also known as an input gate layer, decide which values we'll update. Alright, so what values we need to update. Then there's also a tan layer that creates a vector of the candidate values c bar of t minus 1 that will be added to the state later on. Alright, so let me explain it to you in a simpler terms. So whatever input that we are getting from the previous timestamp and the new input, it will be passed through a sigmoid function which will give us I of t. Alright, and this I of t will be multiplied by ct, which is nothing but the input coming from the previous timestamp and the new input with that is passed through a tan h, that will result in ct. And this will be later added on to our cell state. And then the next step will combine these two to update the states. Now let me explain the equations. So I of t will be what? Weight matrix, and then we have ht minus 1 comma xt multiplied by the weight matrix plus the bias, pass it through a sigmoid function, we get I of t. C bar of t will get by passing a weight matrix ht minus 1 xt plus bias through a tan h squashing function, and we'll get C bar of t. Alright, so as I've told you earlier as well, in the next step we'll combine these two to update the state. Let us see how we do that. So now is the time to update the old cell state ct minus 1 with the new cell state ct. Alright, and the previous steps we have already decided what to do. We just need to actually do it. So what we'll do, we'll multiply the old cell state ct minus 1 with ft that we got in the first step, forgetting the things that we decided to forget earlier in the first step, if you can recall. Then what we do, we add it to it and ct, then we add it by the term that will come after multiplication of it and c bar t, and this new candidate value scaled by how much we decided to update each state value. Alright, so in the case of the language model that we were discussing, this is where we would actually drop the information about the old subject gender and add the new information as we decided in the previous steps. So I hope you are able to follow me, guys. Alright, so let us move forward and we'll see what is the next step. Now our last step is to decide what we are going to output, and this output will depend on a cell state, but it will be a filtered version. Now finally what we need to do is we need to decide what we are going to output, and this output will be based on our cell state. First we need to pass ht minus 1 and xt through a sigmoid activation function so that we get an output that is OT. Alright, and this OT will be in turn multiplied by the cell state after passing it through a tan h squashing function or an activation function. And why we do that? Just to push the values between minus 1 and 1. So after multiplying OT, that is this value, and a tan h ct, we'll get the output h2, which will be our new output, and that will only output the part that we decided to. Whatever we have decided in the previous steps, it will only output that value. Alright, now I'll take the example of that language model again. Since it just saw a subject, it might want to output information relevant to a verb, and in case that's what is coming next. For example, it might output whether the subject is singular or plural. so that we know what form of a verb should be conjugated into. All right, and you can see from the equations as well. Again, we have a sigmoid function. Then that whatever output we get from there, we multiply it with tan h ct to get the new output. All right, guys. So this is basically LSTMs in a nutshell. So in the first step, we decided what we need to forget. In the next step, we decided what are we going to add to our cell state, what new information we are going to add to our cell state, and we were taking an example of the gender throughout this whole process. All right, and in the third step, what we do, we actually combined it to get the new cell state. Now in the fourth step, what we did, we finally got the output that we want. And how we did that? Just by passing ht minus 1 and xt through a sigmoid function, multiplying it with the tan h ct, the tan h new cell state, and we get the new output. Fine, guys. So this is what basically LSTM is, guys. Now we'll look at a use case where we'll be using LSTM to predict the next word in a sentence. All right, let me show you how we are going to do that. So this is what we are trying to do in our use case, guys. We'll feed our LSTM with correct sequences from the text of 3 symbols. For example, had a general and a label, that is council in this particular example. Eventually, our network will learn to predict the next symbol correctly. So obviously, we need to train it on something. Let us see what we are going to train it on. So we'll be training our LSTM to predict the next word using a sample short story that you can see over here. All right, so it has basically 112 unique symbols. So even comma and full stop are considered as symbols. All right, so this is what we are going to train it on. So technically, we know that LSTMs can only understand real numbers. All right. So what we need to do is we need to convert these unique symbols into a unique integer value based on the frequency of occurrence. And like that, we'll create a dictionary. For example, we have had here that will have value 20. A will have value 6. General will have value 33. All right, and then what happens, our LSTM will create a 112 element vector that will contain the probability of each of these words or each of these unique integer values. All right, so since 0.6 has the highest probability in this particular vector, it will pick the index value of 0.6, then it will see what symbol is attached to that particular integer value. So 37 is attached to council. So this will be our prediction, which is absolutely correct, as a label is also council according to our training data. All right, so this is what we are going to do in our use case. So guys, this is what we'll be doing in our today's use case. Now I'll quickly open my PyCharm and I'll show you how you can implement it using Python. We'll be using TensorFlow, which is a popular Python library for implementing deep neural networks or neural networks in general. All right, so I'll quickly open my PyCharm now. So guys, this is my PyCharm, and over here I've already written the code in order to execute the use case that we have. So first we need to do is import the libraries. NumPy for arrays, TensorFlow, we know TensorFlow.contrib. From that we need to import RNN, then random collections and time. All right, so this particular block of code is used to evaluate the time taken for the training. After that we have log underscore path, and this log underscore path is basically telling us the path where the graph will be stored. All right, so there will be a graph that will be created, and then that graph will be launched. Then only our RNN model will be executed. Then that's how TensorFlow works, guys. So that graph will be created in this particular path. All right, and we are using summary writer. So that will actually create the log file that will be used in order to display the graph using TensorBoard. All right, so then we have defined a training underscore file, which will have a story on which we'll train our model on. Then what we need to do is read this file. So how are we going to do that? First is read line by line whatever content that we have in our file. Then we are going to strip it. That means we are going to remove the first and the last white space. Then again we are splitting it just to remove all the white spaces that are there. After that we're creating an array, and then we are reshaping it. Now during the reshape, if you notice, this -1 value tells us the compatibility. All right, so when you're reshaping it, you need to make sure that we are providing in the correct parameters to reshape it. So you can convert a 3x2 matrix to a 2x3 matrix, right? So just to make sure that it is compatible enough, we add this -1 and it will be done automatically. All right, then return content. After that, what we are doing, we are feeding in the training data that we have, training underscore file. We are feeding in our story and calling the function read underscore data. Then what we are doing, we are creating a dictionary. What is a dictionary? We all know key value pairs based on the frequency of occurrences of each symbol. All right, so from here collections.counter words.most common. So most common words with their frequency of occurrence, there will be a dictionary created. And after that, we'll call this dict function, and this dict function will feed in word, and which is equal to length of dictionary. That means whatever the length of that particular dictionary is, how many times it is repeated. So we'll have the frequency as well as a symbol. That will be our key value pair, and we are reversing it as well. Then what we are doing, we are calling it build underscore data set, and we're feeding in our training data there. This is our vocabulary size, which is nothing but the length of your dictionary. And then we have defined various parameters such as learning rate, iterations or epochs. Then we have display step and underscore input. Now learning rate, we all know what it is. The steps in which our variables are updated. Training underscore iterations is nothing but your epochs, the total number of iterations. So we have given 50,000 iterations here. Then we have display underscore step, that is 1000, which is basically your batch size. So batch size is what? After every 1000 epochs, you'll see the output. All right. So it'll be processing it in batches of 1000 iterations. Then we have n underscore input as 3. Now the number of units in the RNN cell will keep it as 512. Then we need to define X and Y. So X will be our placeholder that will have the input values, and Y will have all the labels, all right, vocab size. So X is a placeholder where we'll be feeding in our input dictionary. Similarly, Y is also one more placeholder, and it'll have a shape of none, comma, vocab size. Vocab size we have defined earlier, as you can see, which is nothing but the length of your dictionary. Then we are defining weights as well as biases. After that, we have defined our model. All right, so this is how we are going to define it. We'll create a function RNN when we'll have X weights and biases. And after that, we are calling in RNN.multi-RNN cell function. And this is basically to create a two-layer LSTM, and each layer has n underscore hidden units. After that, what we are doing, we are generating the predictions. But once we have generated the prediction, there are n underscore input outputs, but we only want the last output. All right, so for that, we have written this particular line. And then finally, we are making a prediction. We are calling this RNN function, feeding in X weights and biases. After that, we are calculating the loss and then we are optimizing it. For calculating the loss, we are using reduce underscore mean, softmax cross entropy, and this will give us basically the probability of each symbol, and then we are optimizing it using RMS prop optimizer. All right, and this gives actually a better accuracy than Adam optimizer, and that's the reason why we are using it. Then we are going to calculate the accuracy, and after that we are going to initialize the variables that we have used. As we have seen in TensorFlow that we need to initialize all the variables, unlike constants and placeholders in TensorFlow. All right, and once we are done with that, we are feeding in our values, then calculating the accuracy, how accurate it is, and then when optimization is done, we are calculating the elapsed time as well. So that will give us how much time it took in order to train our model. Then this is just to run the tensor board on local host 6006. And this particular block of code is used in order to handle the exceptions. So exceptions can be like whatever word that we are putting in might not be there in our dictionary or might not be there in our training data. So those exceptions will be handled here, and if it is not there in our dictionary, then it will print word not in our dictionary. All right, so fine guys, let's input some values and we'll have some fun with this model. All right, so the first thing that I'm gonna feed in is had a general. So whenever I feed in these three values, had a general, there will be a story that will be generated by feeding back the predicted output as the next symbol in the inputs. All right, so when I feed in had a general, so it will predict the correct output as council, and this council will be fed back as a part of the new input, and our new input will be a general council. So it will be a general council. All right, so these three words will become our new input to predict the new output, which is 2. All right, and so on. So surprisingly, LSTM actually creates a story that somehow makes sense. So let's just read it. Had a general council to consider what measures they could take to outwit their common enemy, the cat. By this means, we should always know when she was about and could easily. All right, so somehow it actually makes sense when you feed in that. So what will happen when you feed in these three inputs? It will predict the next word, that is council. After that, it will take council and it will feed back as an input along with a general. So a general council will be your next input to predict 2. Similarly, in the next iteration, it will take general council 2 and predict consider for us. And this will keep on repeating.
Keras is a Python-based deep learning framework which is actually the high-level API of TensorFlow. And now I have 4 major highlights for you guys, so let's check it out from the start. Well, Keras basically runs on top of Theano, TensorFlow or CNTK. Since it runs on top of any of these frameworks, Keras is amazingly simple to work with. You might be wondering why. Well, building models are as simple as stacking layers and later connecting these graphs. Guys, Keras attracts a lot of attention, but why? Since it is open source, it is actively developed by all the contributors across the world and the documentation is nearly endless. Well, we're good with the documentation, but how does Keras perform? Guys, since it is an API which is actually used to specify and train differentiable programs, high performance naturally follows through here. So now that we know what Keras actually is, who makes Keras what it is? Well, we need to check out some of the contributors and the backers to the deep learning framework. Well guys, Keras had over 4,800 contributors during its launch and the initial stages. And now that number has gone up to 250,000 active developers. Well, what amuses me is that there is a 2x growth ever since every year since its launch. Also, it holds a really good amount of traction among multiple startups. Big players like Microsoft, Google, Nvidia, and Amazon actively contribute to the development of Keras. Good enough? So at this point, I'm sure all of you are curious about who uses Keras. Well, Keras has an amazing industry traction and it is used in the development of popular firms like Netflix, Uber, Expedia, Yelp, and more. Well, now that you know, the next time you watch a movie on Netflix or book an Uber, you know Keras is being used. So guys, if Keras is getting all this attention, what makes it so special? What makes Keras stand out among all the top framework? Here I have for you top 10 snippets that makes Keras so special. Well guys, the focus on user experience has always been the major part of Keras. And next, large adoption in the industry, definitely. We just checked out all of the industry traction it gets and this holds well. And next, it is multi-backend and supports multi-platform as well. This helps all the coders come together and code easily. Next up, the research community present for Keras is amazing along with the production community. So this is a win-win for me guys. So what do you think? And moving on, all the concepts are really easy to grasp with Keras guys. And next up, it supports fast processing, which is really good. And guys, it runs seamlessly on both the CPU and the GPU, and it has support for both Nvidia and AMD as well. And the best part for me is the freedom to design on any architecture and then later implement it as an API for your projects, guys. This definitely is a major advantage for me. So next up, for all the beginners, Keras is really simple to get started with, and I'm here to help you guys with this tutorial for that. So stay tuned. And lastly, the easy production of models makes Keras that much special, guys. Now that we know Keras is special, guys, let's dig in a little bit about one of the major concepts which make Keras what it is, the user experience. Well, in my opinion, this is very important for anyone who wants to know more about Keras, or better, they want to start creating their own neural nets using Keras. So clearly, Keras is an API designed for humans. Well, why so? Because it follows the best practices for reducing cognitive load, which ensures that the models are consistent and the corresponding APIs are simple. And moving on, Keras provides clear feedback upon occurrence of any error, and this minimizes the number of user actions required for the majority of the common use cases, guys. And lastly, Keras provides high flexibility to all of its developers. Well, we all love high flexibility, right? So how is Keras doing this? Guys, it's very simple. It integrates with lower level deep learning framework languages like TensorFlow or Theano. So guys, this ensures that you can implement anything in Keras which you actually built in your base language, which is amazing. So next up, we need to talk about how Keras supports the claim of being able to support multi-platform and lets us work with multiple backends. You can develop Keras in Python as well as R. The code can be run with TensorFlow, CNTK, Theano, or MXNet totally based on your requirement. This almost feels like a tailor-made API for the framework, guys. The code can be run on the CPU or the GPU as well. Support for both the big players being Nvidia and AMD here. So this ensures that producing models with Keras is really simple. Total support to run with TensorFlow serving, GPU acceleration such as CUDA when using modules such as WebKeras and Keras.js, native support to develop Android and iOS apps using TensorFlow and Core ML, and yes, full-blown support to work with Raspberry Pi as well. So guys, moving on, we need to check one quick concept which forms the backbone as a working principle of Keras. So let's check out a computation graph. Here is an example for you guys. Just before decoding and working our way through the graph, let's look at the features. So guys, do note that computational graphs are used for expressing complex expression as a combination of simple operations for Keras to work with. It is mainly useful for calculating the derivatives during the phase of backpropagation, and hence it makes it easier to implement distributed computing on the whole. So all it takes is to specify the inputs, outputs, and to make sure that the graph is connected throughout. I hope you guys know what a connected graph is. So let's check out our graph. We'll be working our way from the leaf nodes to the top. So guys, here as you can see, E equal to C multiplied with D, where C is equal to A plus B and D is equal to B plus 1. So all we're doing is we're making sure we land at E equal to C cross T, which is the head of our tree, and we get to this by performing two operations on the leaf nodes. So as you can see, working down further, E equal to A plus B into B plus 1 actually makes sense now. And in our case, A and B are inputs. So guys, it is as simple as that. So next, let's dive a little bit deeper and check out the two major models, guys. So the first model is a sequential model. The working is basically like a linear stack of layers. So the first thing that comes into my mind when I think about the layered approach is the sequential model. It is majorly useful for building simple classification network and encoder-decoder model, guys. And definitely yes, this is the model which we all know and love. So here we basically treat every layer as an object that feeds into the next layer and so on. And now in the simple code, we'll import Keras into Python. We define the model as sequential, and with the hidden layers, we have 20 neurons and we'll be using ReLU here. ReLU is rectified linear unit, guys. It is one of the activation functions we'll be using. Well, model.fit is used to train the network. Here, by epoch, I'm sure all of you guys are familiar with it already. So it is basically the forward and the backward pass of all of our training examples. And batch size is really straightforward as well. It is the number of training examples in one forward and backward pass, guys. So higher the batch size, the more the memory you'll need. So next, we need to check out the functional model. It is widely used and it holds good for about 95% of the use cases. Well, imagine the concept of playing with Legos, guys. I'm pretty sure most of us have played with Legos in our childhood. It's pretty much the same here as well. Well, the highlights of the functional model is that it supports multi-input, multi-output, and an arbitrary static graph topology. We have branches, so whenever we have a complex model, the model is forked into two or more branches based on the requirement, guys. The code which we have here is pretty much similar to the previous one, but with subtle changes. We first import the models, we work on its architecture, and lastly, we train the network. Well, with functional models, we have this concept called as domain adaptation. So guys, what we did until this stage is that we train a model on one domain but test it on the other. This definitely results in poor performance on the overall test dataset because the data is different for each of the domains, right? So what's the solution for this? Well, we adapt the model to work on both the domains at the same time. And guys, we'll be looking at a very interesting use case using the functional models in the upcoming slides. So stay tuned for that. So moving on, we need to understand about the two basic types of execution in Keras, deferred and eager execution. It is also called as symbolic and imperative execution as well. Well, with deferred, we use Python to build a computation graph first like we previously discussed, and then this compiled graph gets executed. Well, with eager execution, there is a slight change, guys. It is here that the Python runtime itself becomes the execution runtime for all of the models. It is very similar to execution with NumPy. So if you're familiar with NumPy, then it's a cakewalk, guys. So on the whole, here is a quick note. Symbolic tensors don't have a value in the Python code as of yet, but eager tensors will have a value in the Python code. And with eager execution, we make use of a type of recurring neural networks called as trees. So guys, it is basically a value dependent dynamic topology structure. So what are you guys thinking about Keras at this point? Well, it is actually really easy to grasp, guys. Well, next, let's look at the steps needed to implement our own neural network using Keras. There are 5 major steps here, guys. So starting out, we need to prepare the inputs for the model. We do this by analyzing our requirements and specifying the input dimensions. Well, as you know it, the common inputs are images, videos, text, or audio based on your model requirement. The next step is to actually define the artificial neural network model. Here, we do everything from defining the model architecture to building the computation graph and also defining the style we'll be using for the model. It is as straightforward as that. Well, step 3 is to specify the optimizer. Think of it this way, a neural network is just a complex function. We need to simplify the process of making the machine learn. Well, the optimizer is just for that. There are many types of optimizers such as SGD, which is stochastic gradient descent. We have RMSProp, which is based on root mean square, and Adam, and so on. And the next step is to define the loss function. So for every step in our training, we'll be checking the accuracy of prediction by comparing the obtained value with the actual one. We check for the difference between them and we print out the loss, guys. Well, the goal is to actually define a function which we will use to reduce the losses in each pass of the training phase. There are many types of loss functions such as MSE, which is mean squared error, and we have cross entropy loss, which is also called as the log loss in most cases, and so on. And the last step is to actually train the network based on the input data, which is also called as a training data. And after training, we will need to test the model based on the trained data to check if the model actually learned anything. So it is as simple as this, guys. What do you think? I would love to know your views on this, so head to the comment section, let's have an interaction there. And now, guys, let's spice things up a bit. I'm sure you guys were curious about the use case, so let me walk you through the entire thing. Well, we'll be checking out a wine classifier in this use case, so let's begin by checking out our problem statement. So we're trying to predict the price of a bottle of wine just by knowing the description and the variety of wine. Well, we can work this out with the Keras functional API and TensorFlow. We'll be building a wide and a deep network using Keras to make predictions for us. Well, can we achieve this goal? Yes, we can. This is a problem statement suited for wide and deep learning networks, as I mentioned. Well, it involves textual input and there isn't any correlation between the wine's description and its price. Well, this is what makes it fun in my opinion, guys. So next we need to check out the model. A lot of Keras models are built using the sequential model API as I told you earlier. But let's make use of the functional API for our use case. Well, true, the sequential API is still the best way to get started with Keras. Why? Because it lets you define models easily as a stack of layers like I explained earlier. However, the functional model allows for more flexibility and is best suited for models with multiple inputs. So we need to know a little bit about wide and deep model, guys. Well, wide models are models with sparse feature vectors. Well, what I mean by sparse feature vectors is that it consists of mostly zeros and a little bit of ones. And deep networks are networks which do really well on tasks like speech and image recognition. So now that that's sorted, we need to take a look at the dataset. Well, for this case, we'll be using a wine dataset from Kaggle. So what's the data? Well, it's basically 12 columns of data and it's as follows. Here we'll be talking about the country that the wine is from. Next up is description, a few sentences from the sommelier describing the wine's taste, smell, look and feel. A sommelier is a person who is a professional wine taster, guys. Next up is designation, the vineyard within the winery where the grapes that the wine has been made from. Next up is points, the number of points that the wine enthusiasts rated the wine on a scale of 1 to 10. However, they only say that they post reviews for the wines which scores greater than equal to 80. Next up is price, the cost of the bottle of the wine obviously, followed by province, the province or the state where the wine is from. Next up I have something called as region 1. Well, with region 1, it's the wine growing area in a province or a state. Let's say for example India. Next I have region 2. Well, sometimes there are more specific regions within a specified wine growing area. For example, we can say Bangalore, India. But this value can sometimes be blank as well. Next up is taster's name. Well, as it suggests, it's the name of the person who tasted and reviewed the wine. Taster Twitter handle for the person who tasted and reviewed the wine. Well, the title of the wine review, which often contains the vintage if you're interested in extracting that feature. Variety, the type of the grapes that is used to make the wine. Let's say for example Pinot Noir, that's a type of the grape. And finally, the winery that made the wine. Guys, the overall goal here is to actually create a model that can identify the variety, winery and the location of a wine based on the description alone. And this dataset offers some really great opportunities for sentiment analysis and other text-related predictive models as well. So now that that's clear, we need to take a look at the sample data case. So here we have a description for the wine such as scent, if it's tart, firm or needs more decanting, etc. So this forms our input for the model, guys. And the output our model provides just from all of this textual information is the pricing that it predicts. How cool is that, guys? So basically we need to check out some of the prerequisites before jumping into the code. Since you're working with Python, we'll require pandas, we'll require NumPy, scikit-learn and Jupyter Notebook. So yes, Keras works on top of TensorFlow, so we'll require both Keras and TensorFlow to be installed on the machine. So now that that's done, moving on, let's look at a small piece of code. Here are all the inputs that we'll require to build the model. And lastly, we test the presence of TensorFlow by printing the installed version. Well, without TensorFlow, it wouldn't make any sense. So we go to Kaggle and download the data and end up converting the data to a pandas data frame, guys. Well, that's good enough to start. Let's look at the code for this model. I'll quickly open up Google Collaboratory, which is basically a Jupyter Notebook hosted on their Google Cloud. You can actually do this on your local machine as well by installing all of the frameworks that I've previously mentioned. So let me go ahead and open Collaboratory and let's begin, guys. So guys, we'll be executing each of these blocks and we'll be going on from there. So let us check out the first block. So here we import all of the modules that we require. So guys, let me run it. And that's done. So next we'll need to install the latest version of TensorFlow. Well, with Google Colab, it doesn't require any extra setup, so it's pretty much straightforward. So guys, that took about 2 minutes and TensorFlow is installed. And as I explained before, we need to import the models that we'll use to build the model. And after that, we'll actually run the code to check the version output of the TensorFlow that we just installed. And the output we're supposed to be expecting is version 1.7 because 1.7 is the TensorFlow version that we installed. As you can check out the output, you have TensorFlow version 1.7. So beautiful. So moving on, we need to download the data, which is from a CSV file hosted on the cloud. So let's go ahead and do that. Now that it is downloaded and ready, let us convert all the data from the CSV file into a pandas data frame as I mentioned. So now that that is done, let's go ahead and mix up the data by shuffling it. And yes, so let's start printing samples from our data set. So we'll be printing the first 5 rows, and as you can see, all the columns that we discussed earlier from country, price, province, all the way till a detailed description of the wine is present here. So now that that's done, next we need to do some pre-processing to limit the number of varieties of wine in the dataset. So let us go ahead and set a threshold of 500 in our case. So anything less than 500 will be removed from analysis in our model. We'll be replacing it with NaN, which is not a number, instead of letting it to be blank. So let me go ahead and run this. So now that that's done, the next step we need to do is actually split the data into a training dataset and a testing dataset. So let's go ahead and do that and print the size of both the training dataset and the testing dataset. So let me go ahead and run this code for you guys, and there it is. We have the training dataset size and the testing dataset size. Now that we have the size, we need to actually extract the testing and the training features and all of the labels. So let me go ahead and run this code and we can actually get the labels. And so that does it. The training and the testing features and the labels are known to our machine by now. So now it's very obvious that we're using a test description. Well, instead of looking at every word that we found in our description in our dataset, let us limit our bag of words to, let's say, top 12,000 words in our dataset. So guys, don't worry, there is actually a built-in Keras utility for creating just this vocabulary. This is considered as wide because the input to our model for each description will be a 12k element wide vector with zeros and ones, indicating the presence of word from our vocabulary in a particular description. Well, Keras has some handy utilities for text pre-processing that we'll use to convert the text descriptions into a bag of words. With the bag of words model, we'll typically want to use only a subset of all the total words that we found in our dataset. And in this example, I used 12,000 words, but this is a hyperparameter that you can tune. Well, you can try out a few values to see what works best on your dataset. Well, we can use the Keras tokenizer class to create our bag of words vocabulary for us. So let me go ahead and run this to create the tokenizer. Guys, so now that that's done, we'll be actually using text to matrix function to convert each description to a bag of words vector. So let me go ahead and run it. Well, now that that's done, guys, in the original Kaggle dataset, there are about 632 total varieties of wine. To make it easier for our model to extract the patterns, we did a bit of pre-processing to keep only the top 40 varieties. Well, around 65% of the original dataset or 96k total examples. Well, we use a Keras utility to convert each of these varieties to integer representation. And then we'll create 40 element wide one hot vectors for each input to indicate the variety. So let me go ahead and run it, guys. So now that that's run, guys, at this stage, we are ready to build our wide model. Well, guys, Keras has two APIs for building the models, the sequential API and the functional API. The functional API gives us a bit more flexibility in how we define our layers and lets us combine multiple feature inputs into one layer. It also makes it easy for our wide and deep models into one when we're ready. Guys, with the functional API, we can define our wide model in just a few lines of code as you see. Well, first we need to define our input layer as a 12k element vector, well, for each word in our vocabulary, and then we'll connect this to our dense output layer to generate the price prediction. So let me go ahead and run this. Well, now that that's done, we'll compile the model so that it is ready to use. If we were using the wide model all on its own, this is when we'd actually start training it with the fit function and evaluate later with the evaluate function. Since we're going to combine it with our deep model later on, we can hold off on training until the two models are combined, which is done later, guys. So let me go ahead and execute this so we define our wide model. And yep, our wide model is done. Let's go ahead and print out a summary from the wide model. Well, now that we have a summary, we can realize the total number of trainable parameters and non-trainable parameters. Well, in our case, the non-trainable parameters are 0, guys. So guys, that's the end to the construction of the wide model, and it's time to build our deep model. So let's go ahead and check that. Well, to create a deep representation of the wine's description, we'll represent it as an embedding. Well, there are a lot of resources on word embeddings, but the short version is that they can provide a map word to vectors so that the similar words are closer together in the vector space. Well, to convert our text descriptions to an embedding layer, we'll need to first convert each description to a vector of integers corresponding to each word in our vocabulary. We can do that with the handy Keras text to sequence method. And now we've got the integerized description vectors, we need to make sure that they're all the same to feed into our models. Well, Keras is fancy and it has a handy method for that too. We'll use part_sequences to add zeros to each description vector so that they're all the same length. Well, in this case, I used 170 as the max length, so no descriptions were cut short. So let me go ahead and run this. Well, with our descriptions converted to vectors that are all the same length, we're ready to create our embedding layer and then feed it into our deep model, guys. So let's start building our deep model. Well, there are two ways to create an embedding layer. We can use weights from the pre-trained embeddings as I previously explained, or we can actually learn the embeddings from our vocabulary. Well, it's best to experiment with both and to see which performs better on your particular dataset. Here, we'll consider using learned embeddings. Well, firstly, we'll define the shape of our input to the deep model. Then, we'll feed it into the embedding layer, and here I'm using an embedding layer with 8 dimensions. Well, you can experiment this with tweaking the dimensionality of your embedding layer as per your choice. And the output of the embedding layer will be a 3-dimensional vectors with the following shape. Well, it'll have a batch size, a sequence length. Well, in our case, the sequence length is 170. It'll have an embedding dimension. It is 8 in our example. And in order to connect our embedding layer to the dense, fully connected output layer, we actually need to flatten it first. So let's go ahead and define our model and then we can flatten our layer. Well, once the embedding layer is flattened, it's ready to be fed into the model and to compile it. So let's go ahead and compile it. And now that the compilation is done, as you can see, the loss function we've used in this case is MSE, which is mean squared error. The optimizer we'll be using is Adams and the metrics is accuracy. And at this point of time, we have established the wide model and the deep model. So once we have defined both our models, combining them is really easy, guys. We simply need to create a layer that concatenates the output from each of the model and then merge them into a fully connected dense layer, and finally define a combined model that combines the input and the output from each one. Well, obviously, since each model is predicting the same thing, which is the price, the outputs or the labels from each one will be the same. Also, guys, do note that since the output of our model is a numeric value, we will not need to do any pre-processing and it's already in the right format as well. How cool is that? Well, that's done, guys. It's time for the training and the evaluation. Well, you can experiment with the number of training epochs and the batch size that works best for your data set. Well, this is going to take some time, so I'll save you the pain by fast forwarding this a bit. So guys, as you can see, the training is actually done. So each of the epoch took about 100 seconds and we had 10 epochs for the same. So guys, here's the important thing that you have to notice. With every epoch, we were actually reducing the loss all the way from 1100 to 130, guys. And the accuracy of prediction went from 0.02 all the way till 0.0994, which is almost 0.1. Well, wow, that's definitely a breakthrough for just 10 passes, guys. And now that the training is done, it's time to evaluate it. So let me go ahead and run this piece of code for you guys. So that was quick. That took only about 5 seconds and we have evaluated the model. And now it's time for the most important part, guys, seeing how our model actually performs on the data that it has never seen before. To do this, we'll actually call the predict function on our trained model and we'll be passing it our data set. So let's go ahead and do just that. Well, now that that's done, we'll have to compare the predictions to the actual values for the first 15 wines from our test data set. So guys, as you can see, we have a set of predictions from the description and the predicted value is about $24 while the actual value is $22. Next up, we have $34 as a predicted one while the average is 70. Well, this is not a really good case, but okay, that's tolerable. And next up, we have predicted 11.9 when the actual value is 12. Wow, that is actually really close. So next up we have 15.7 versus 9. Well, this goes on and on for the first 15 and it's actually really good. Well guys, pretty well it turns out that there is some relationship between a wine's description and its price. Well, we might not be able to see it instinctively, but our machine learning models certainly can. So lastly, let's compare the average difference between the actual price and the model's predicted price. Well, the average prediction difference is about $10 for every wine bottle. Wow, that is really nice, guys.
What are search algorithms? Well, as the name suggests, they help us search for something, but what exactly? It is a route or a path that we can follow to reach our destination in the most optimal way possible. You would have heard about the traveling salesperson problem in some way or the other. The problem is basically that a salesperson needs to travel between various points in a city so that he can sell everything that he has. But he has to keep the cost of his traveling as less as possible. Before computers, all of this was manual and had a lot of time and monetary wastage. But now that is not the case. We have many algorithms that do the work for us. All we need to do is to feed them with maps or graphs. They process the data obtained through them and output the best possible path for traveling. So that is basically what a search algorithm is. We have many algorithms developed that could match every case, such as the Dijkstra, the breadth first search, and the depth first search, A star, AO star, and so many more. This video focuses mainly on the A star algorithm because of its features. Let's now talk about it, which is also a next topic. So what exactly is the A star algorithm? It is an advanced breadth first search algorithm that searches for shorter paths first rather than the longer paths. A star is optimal as well as a complete algorithm. What do I mean by optimal and complete? Optimal meaning that the A-star algorithm is sure to find the least cost path from the source to the destination, and complete meaning that it is going to find all the paths that are available to us from the source to the destination. So that makes A-star the best algorithm, right? Well, in most cases, yes. But A-star is slow, and also the space it requires is a lot, as it saves all the possible paths that are available to us. This makes other faster algorithms have an upper hand over A-star. But it is nevertheless one of the best algorithms out there. So why choose A star over other faster algorithms? Let the graphs below answer that for you. I have taken the Dijkstra and the A star algorithm for comparison. You can see here that the Dijkstra's algorithm finds all the paths that can be taken without finding or knowing which is the most optimal one for the problem that we are facing. This leads to the unoptimized working of the algorithm and unnecessary computations. A-star algorithm, on the other hand, finds the most optimal path that it can take from the source in reaching the destination. It knows which is the best path that it can take from its current state and how it needs to reach the destination. So now that you know why we choose A-star, let's understand a bit of theory about it, as it is essential to help you understand how this algorithm works. A-star, as we all know by now, is used to find the most optimal path from a source to a destination. It optimizes the path by calculating the least distance from one node to the other. There is one formula that all of you need to remember, as it is the heart and soul of this algorithm. F is equal to G plus H. Remember this by heart if you want to understand the algorithm properly. Let's understand what each of these parameters means and what makes them so important. F is the parameter of A star, which is the sum of all the other parameters G and H and is the least cost from one node to the next node. This parameter is also responsible for helping us find the most optimal path from our source to the destination. G is the cost of moving from one node to the other node. This parameter changes for every node as we move up to find the most optimal path. H is the heuristic or an estimated part between the current node to the destination node. This cost is not the actual one, but is in reality a guess cost that we can use to find which is the most optimal path between our source and the destination. So once you have understood this formula, let me show you a simple example to help you understand how this algorithm works. Suppose we have a small graph with the vertices S, A, B, and E, where S is the source and E is the destination. You have to also remember that the cost to enter the source and the destination is always going to be zero. That means the cost to enter S and the cost to enter E is always going to be zero, right? So the heuristic values are S is equal to 5, A is equal to 4, B is equal to 5, and E is equal to 0. Okay? So let's use the formula and calculate the shortest path from the source to the destination now. F is equal to G plus H, where G is the cost to travel and H is the heuristic value. So to reach the source, f of s is equal to 0 plus 5 is equal to 5. That's simple enough to understand for now, right? So we have entered the source. Moving on, the paths from S are the other two vertices. So the cost of S to A is 1 plus 4 is equal to 5, and the cost for S to B is 2 plus 5 is equal to 7. So now S to A is the shortest path. So we choose S to A. Moving on from here, the paths from A and B to the destination will be calculated now. So the total for the path SAE comes up to 14 and the path for SBE comes up to 7. So what happens right now? We choose the path SBE as it is the shorter one. So after the calculation, we have found that B has given us the least path. So we change our least path to SBE and have reached our destination. That is how we use the formula to find the optimal path. So with having the example understood, I am pretty sure that you will be okay with the algorithm too. Let me just explain it now. Do not worry, it's simple words and it is easy to understand what is happening. You have two lists here, which are the open and the closed lists. The open list is the node we are currently visiting and are on. The closed list over here is what we have not visited but will calculate, as you know that A star is a complete algorithm. So let me just explain the algorithm for now. So we add the start node to the list, simple enough. So for all the neighboring nodes to that start node, we will find out which is the least cost of F. Okay. So once we have done that, we switch over to the closed list. Now, for all the nodes that are adjacent to the current node that we are on, you have to find if there is a node which is reachable. If it is not reachable, you have to just ignore it. If a node is reachable, then check if it is on the open list. If it is not, move it to the open list and calculate f of g and h. Now, if a node is on the open list, make sure to check if that path is lesser than the path that we are currently on. If so, change over to that path. Now, you stop working when you find the destination, or you cannot find the destination going through all the possible points that are given to you in the graph or the map. Okay? So that is basically what the algorithm is, and I hope it is really easy to understand for you guys. So with that context explained, it'll be easier to understand everything that we are going to do from now onwards. Okay? With the algorithm being done, let's move over to how A star is done practically. I'll be showing you two algorithms, Dijkstra and A star, which will help you understand where exactly some algorithms fail and how A star can be helpful in finding the path. Let's code. So as you can see here, this is the first algorithm, which is the Dijkstra's algorithm, and I have basically given it a maze over here. So let me just explain what's happening in this algorithm. So the algorithm basically takes all the points and maps it to infinity, okay? And then finds all the other lists that are really needed. And it makes sure that the distance to reach the source is 0, obviously, because if I am in Bangalore and I want to reach Bangalore, it'll always going to be 0, right? So let's do that. So next we have q is equal to the list of range of n. So for all the number of nodes that are available, so you make that. So while q is equal to true, you have to just find out about the various paths between one node to the other node. So if a path is basically infinity, you just break, you just come out of the loop. Else you go through all the various possible nodes, okay? And you check if there is a node. So as you can see here, so you are trying to find out a distance where there is an alternate path which is giving you a lesser distance, right? So for example, if I am at node 1 and I want to reach node 3, there are two possible paths. I can go from node 2 or I can go directly from node 1 to node 3. But I am currently at node 2 to node 3. I'm taking that route right now, and that is giving me a value of 6. And if I go from 1 to 3 directly, it's just giving me a value of 3. So basically, I'm trying to find out all the possible paths that are available. And then what I'm going to do is, if there is any path which is, alternate or which is much more lesser than what I'm currently on, I'm going to move over to that path. Okay. So that's what this function is basically going to do. And I just return the distance and the previous ones. So then I have another function which is basically just to display the solution accordingly. And here, yes, I have two mazes over here. So wherever you have a 0 over here, right? So that means it is a travelable path, means you can go through that path. But if there is a 1 over here, it basically means that it is an obstruction, meaning that I can go from here, 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 but I cannot move ahead of here. Okay. So same thing over here. And as you can see in the last row, it is completely free. So that means I can move over from here. Okay. And this is also the same thing. Wherever I have zeros, I can travel through that. And if it is a 1, I cannot travel through that. So what's happening over here is I am just going to, give out the solution over here. So I have given one maze over here and I have given the other maze over here. So you will be able to find out the shortest path from here. So I have given one graph over here and I have given the other graph over here. So it will basically give me the shortest part between, the nodes to reach one part to the other. So let me just run the program. So as you can see over here, this is the value that I had obtained for one particular graph, and this is the path to travel from 0 to 5. And then there is another path which is all infinities. So INF is basically all the infinite paths, and it is telling me that it is not able to find it. It's because the list indexes is not in the way of an integer or a float. It is basically in INF formats, and it is basically meaning that there is no path from this this node to the other node. So that is the reason I am getting this error actually. Okay, what's happening over here? Let me see what's it for. So whenever there was a graph, right? So this is the graph, this is the input that I've given here. It had some or the other path because of which it was able to calculate to go from one part to the other. Whereas Digextras failed for this one because it was not able to understand which part should I go through, because all ones were over here and it had no idea how to go through it, right? So that was the reason it failed for that particular graph. And let me now show you how this is overcome when I use the A-star algorithm. Okay, so basically I have the main function and I've given the same graph over here, but I'm using lists over here. I can even use tuple that will still give me the same answer. And I have the starting path and I have the ending path, and the same thing over here which I have done. So I hope you have understood the main function right here. So what I'm doing over here is I am basically creating a class node for which basically it's like I have G, H and F, and accordingly all the other parameters that are required for the A star. I have all of that in that. And then these are all my open list, close list, all the initializations that I need to do first. And then while I am in the open list, I am just going to find out for what are the basic elements that I can travel from one list to the other, and make sure that it is on the open list or the closed list, according to the algorithm I've gone through over here. And then if it is on the end node, it basically means that I have reached my destination over here. So I am just going to append it and I'm going to return the path basically. So then I'm just checking if there is any other path. So this function over here, right? So I'm just checking for a child node. So basically what this is meaning is that if from one node I'm able to find another position or another route which is much more smaller than what I'm currently on, I will change over to that route. Okay, so that's what this function is basically for. And then I'm just going to find out everything over here. So let me just run the program. Yes. So as you can see, this was for the first graph, that is path, and then it's path 1. So to reach from 0 to 0, 0 to 5, 5, it is using this path for one graph, that is the path, and this is the second path, right? So it is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So you can understand that even though Digextras failed, A-star was able to accomplish that. Even though it has taken a bit more time and computations, it is able to find out the path from going to one place to the other, right? So that is the reason A-star is such a good algorithm, but as you know, it is basically very, very slow. This is just a very small example. Think about it when it comes to, huge data sets and huge graphs and huge maps. It's really slow, but nevertheless, it is one of the best algorithms out there because it is able to give you the output properly. So you can see where Digextras fails simply because it tries to find a path and it gets stuck in a loop and cannot identify how to come out of the problem. A-star was able to do that, and that's a very practical example of where A-star wins where other fails, right?
Let us understand how AI has actually shaped the space science so far. The extraordinary feat the humankind has achieved with their journey into the space is just a start to an infinite reality, and artificial intelligence is the key to finding out the answers to the unknown. So first of all, let me just talk about space exploration. So I'm going to talk about a few feats that humankind has actually achieved with AI. And space exploration has been the ultimate guiding force that drives the innovation into technological advances to explore the unknown in the outer space. And the newly discovered Kepler 90I that orbits a star is one of the feats achieved by artificial intelligence. The planet was actually discovered through the NASA's Kepler Space Telescope by using machine learning. And according to a news article from NASA, Kepler's Fourier dataset consists 35,000 possible planetary signals, and automated tests and sometimes human eyes are used to verify the most promising signals in the data. However, the weakest signal often are missed using these methods. So Shalvey and Vandenberg thought there could be more interesting exoplanet discoveries faintly lurking in the data. So first what they did was they trained the neural network to identify transiting exoplanets using a set of 15,000 previously vetted signals from the Kepler exoplanet catalog. And in the test set, the neural network correctly identified true planets and false positives 96% of the time. Then with the neural network having learned to detect the pattern of transiting exoplanet, the researchers directed their model to search for weaker signals. And in 670 star system that already had multiple known planets, their assumption was that multiple planet systems would be the best places to look for more exoplanets. So basically there was a lot of data and they were able to put machine learning algorithms and neural network to get the results that they may not have been possible a few decades ago. The space agencies all across the globe have realized the importance and relevance of artificial intelligence in space exploration. And we are seeing the results with each passing day. Talking about the global navigation or the GNSS, so basically a satellite navigation or sat-nav system is a system that uses satellites to provide autonomous geospatial positioning. It allows small electronic receivers to determine their location to a high precision using time signals transmitted along a line of sight by radio from satellites. Now to understand how AI can help in global navigation, the data collected by the Global Navigation Satellite System can be used to detect in real time events like tsunami and other disastrous situations by processing the data collected by the GNSS using the artificial intelligence and machine learning algorithms. And it can study the parameters like temperature, gases, and other signals that can define an immediate danger. Although these factors may not look significant enough from the ground, but years and years of data from the space can actually detect even the smallest of changes, and using the data and other parameters and a few machine learning and artificial intelligence algorithms, the experts can figure out events that may have been finding like a needle in a haystack. And with the GNSS, it is possible to study a lot of data, and using the artificial intelligence, it is possible to help us in a lot of ways. To study the atmosphere, or in case of large fires, let's say, or forest fire, it can also figure out the best possible plan of action as well. Now, talking about the communication part, the NASA spacecraft typically rely on human-controlled radio systems to communicate with the Earth. And as collection of space data increases, NASA looks to cognitive radio, the infusion of artificial intelligence into space communications network to meet the demand and increase efficiency. So software-defined radios like cognitive radio use artificial intelligence to imply underutilized portions of the electromagnetic spectrum without the human intervention. And these white spaces are currently unused, but already licensed segments of the spectrum. So the FCC permits a cognitive radio to use the frequency while unused by its primary user until the user becomes active again. So in the future, a NASA cognitive radio could even learn to shut itself down temporarily to mitigate the radiation damage during severe space weather events. An adaptive radio software could circumvent the harmful effect of space weather, increasing science and exploration data returns. And a cognitive radio network could also suggest alternate data paths to the ground. And these processes could prioritize the route data through multiple paths simultaneously to avoid interference. And the cognitive radio's artificial intelligence could also allocate ground station downlinks just hours in advance, as opposed to weeks, and leading to more efficient scheduling. So these are a few feats in the space science led by artificial intelligence among many. So let's take a look at the future, how it actually looks with artificial intelligence for space science. So the scientists are actually trying to figure out if the artificial intelligence can be used to identify or find asteroids or even discover life on nearby planets. And the team, which included students from France, South Africa, and United States, plus mentors from academia and from technology company NVIDIA, developed an algorithm that could render an asteroid in as little as 4 days. So today the technique is used by astronomers at the Arecibo Observatory in Puerto Rico to do nearly real-time shape modeling of asteroids. Along with exoplanetary atmosphere analysis are a couple of FTL examples that show the promise in applying sophisticated algorithms to the volumes of data collected by NASA's more than 100 missions. As NASA heliophysicist notes, the space agency gathers about 2 gigabytes of data every 15 seconds from its fleet of spacecraft. But we analyze only a fraction of that data, and we have a limited people, time, and resources. So that is why they actually are looking to utilize these tools more. So on this mission, there was a spacecraft that studies the sun's influence on Earth and near Earth space. So back in 2014, just 4 years after the mission launched, there was a sensor which actually stopped returning data related to extreme ultraviolet radiation levels, and information that is actually correlating with the ballooning of the Earth's outer atmosphere, and this affects the longevity of satellites, including the International Space Station. So computer science doctoral students from Stanford and University of Amsterdam, among others, with mentors from organizations which included IBM, Lockheed Martin, and SETI, developed a technique that could essentially fill in the missing data from the broken sensor. So their computer program could do this by analyzing the data from other SDO instruments along with old data collected by the broken sensor during the 4 years that it was actually working. So to infer that the EUV radiation levels that sensors would have detected based on what the other SDO instruments were observing at any given time. So they generated basically a virtual sensor using AI. And there was a recent development where a 29-year-old computer scientist has earned worldwide fame for helping develop the algorithm that created the first ever image of a black hole. So these are a few feats, and this is how we actually are shaping our future into the space science using AI. So what was not actually possible a few years ago, now it is actually very much within our reach because we have gathered the tools that could actually process the years and years of data that we have collected through all these missions that have been sent out in space. Like we have sent a spacecraft to Mars and we have a lot of data, and we could actually make or build some tools and some resources that could actually process all that data, and we could actually bring in a lot of information that was not possible decades ago. And one more thing that we are going to see in the future is that there will be a lot of role of robots, basically, the AI robots in space science. When we are talking about space exploration, it is quite obvious that the humans are not basically meant to spend a lot of time in space because of obvious reasons. Like for the very least, there is gravitation, and there are a lot of factors that makes it very difficult for any human being to remain in space for a long time. If you be in space for a long time, it'll take toll on your health. You will lose a lot of muscle mass, and there are a lot of things that you have to consider. But if we replace a few tasks that a human is present for in the space missions, if we replace them with robots that can actually do all the tasks that they are actually doing, and we can monitor the whole program, the space program from down Earth, using a simple software program, not actually a simple program, it will be a very sophisticated program, an AI program that can remotely access all the tasks that are happening inside the space, and we still get the data that we actually need. So that is one thing that we are looking at. We actually achieved a lot of feats regarding this also. Like there was a Mars mission where we sent rovers, and a relentless work and dedication with a hint of technology is going to take the space sciences a very long way. And it is quite safe to say that a spacewalk wouldn't be a spectacle after 50 years of time. Even though it is well within out of our reach right now, we might be able to do it for an evening stroll if everything goes as planned, maybe a 50, 60 years later. And now comes the important part, guys. As much as we want to travel to some other planets in the times of crisis, but we actually have to stay here and save our planet first. So there is one more thing we can do in these testing times, that is to learn our way into the future.
Now, what is this cognitive computing? So, cognitive computing refers to individual technologies that perform specific tasks to facilitate human intelligence. Basically, these are smart decision support systems that we have been working with since the beginning of the internet boom. So with recent breakthroughs in technology, these support systems simply use better data, better algorithms in order to get a better analysis of a huge amount of information. Not just that, you can also refer to cognitive computing as understanding and simulating reasoning, understanding and simulating human behavior. Now, using cognitive computing systems helps in making better human decisions at work. Some of the applications of cognitive computing include speech recognition, sentiment analysis, face detection, risk assessment, etc. We'll talk about these in details later. So now that you know what is cognitive computing, let's move on and see how cognitive AI works. So cognitive computing systems synthesize data from various information sources while weighing context and conflicting evidence to suggest suitable answers. To achieve this, cognitive systems include self-learning technologies using data mining, pattern recognition, and natural language processing to understand the way the human brain works. Now, using computer systems to solve problems that are supposed to be done by humans require huge structured and unstructured data. With time, cognitive systems learn to refine the way they identify patterns and the way they process data to become capable of anticipating new problems and model possible solutions. Now, to achieve these capabilities, cognitive computing systems must have some key attributes. First of all, it should be adaptive. Now, cognitive systems must be flexible enough to understand the changes in the information. Also, these systems must be able to digest dynamic data in real time and make adjustments as the data and environment change. Then another attribute is being interactive. So human-computer interaction is a critical component in cognitive systems. Users must be able to interact with cognitive machines and define their needs as those needs change. The technologies must also be able to interact with other processors, devices, and cloud platforms. The next one is iterative and stateful. Now, also these systems must be able to identify problems by asking questions or pulling in additional data if the problem is incomplete. The systems do this by maintaining information about similar situations that have previously occurred. The next attribute is being contextual. Now, cognitive systems must understand, identify, and mine contextual data such as syntax, time, location, domain requirements, a specific user's profile, tasks, or goals. They may draw on multiple sources of information, including structured and unstructured data and visual, auditory, or sensor data. Now, cognitive computing is also called as the subset of artificial intelligence. There are various similarities and differences between the two. So now let's move on and understand the difference between cognitive computing and artificial intelligence. Now, the technologies behind cognitive computing are very similar to the technologies behind AI. These include the machine learning, deep learning, NLP, neural networks, etc. But they do have various differences as well. Now, cognitive computing focuses on mimicking human behavior and reasoning to solve complex problems, whereas AI augments human thinking to solve complex problems. It focuses on providing accurate results. While cognitive computing simulates human thought processes to find solutions to complex problems, AI finds patterns to learn or reveal hidden information and find solutions. Cognitive computing also simply supplements information for humans to make decisions, whereas AI is responsible for making decisions on their own, minimizing the role of humans. And finally, cognitive computing is used in sectors like customer service, healthcare, industries, whereas AI is mostly used in finance, security, healthcare, retail, manufacturing, etc. So now that you have an idea about cognitive computing and artificial intelligence combined together, known as the cognitive AI, let's understand this in a better way with an example. So let's take this use case. Now, cognitive computing and AI are technologies that rely on data to make decisions, but there are nuances between the two terms which can be found within their purposes and applications. So let us imagine a scenario where a person is deciding on a career change. An AI assistant will automatically assess the job seeker's skills, find a relevant job where his skills match the position, negotiate pay and benefits, and at the closing stage, it will inform the person that a decision has been made on his behalf. Whereas a cognitive assessment suggests potential career paths to the job seeker, besides furnishing the person with important details like additional education requirements, salary comparison data, and open job positions. However, in this case, the final decision must be still taken by the job seeker. Now, based on this scenario, we can say that cognitive computing helps us make smarter decisions on our own leveraging machines, whereas AI is rooted in the idea that machines can make better decisions on our behalf. So these were some of the differences between cognitive computing and artificial intelligence. Now, let's move ahead and talk about some of the applications of cognitive AI in details and see how together it makes some smart technology and makes it simpler for us. So talking about applications, we have the smart IoT. Now this includes connecting and optimizing devices, data, and the IoT. But assuming we get more sensors and devices, the real key is what's going to connect them. Then we have the AI-enabled cybersecurity. So we can fight the cyber attacks with the use of data security, encryption, and enhanced situational awareness powered by AI. This will provide the document data and network locking using smart distributed data secured by an AI key. Then we also have the content AI. So a solution powered by cognitive intelligence continuously learns and reasons and can simultaneously integrate location, time of day, user habits, semantic intensity, intent, sentiment, social media, contextual awareness, and other personal attributes. Next up is the cognitive analytics in healthcare. Now, the technology implements human-like reasoning software functions that perform deductive, inductive, and abductive analysis for life sciences applications. And finally, we have the intent-based NLP. So cognitive intelligence can help a business become more analytical in their approach to management and decision making. Now, this will work as the next step from machine learning, and the future applications of AI will incline towards using this for performing logical reasoning and analysis. So these were some of the common applications of cognitive AI and also how it is going to change the world of technology. And with this, we have come to the end of today's session. And I hope you have understood how this cognitive computing system is a subset of artificial intelligence and how together both of these can do wonders.
Now, for a robot, an environment is a place where it has been put to use. Now, remember, this robot is itself the agent. For example, an automobile factory where a robot is used to move materials from one place to another. Now, the tasks we discussed just now have a property in common. Now, these tasks involve an environment and expect the agent to learn from the environment. Now, this is where traditional machine learning fails and hence the need for reinforcement learning. Now, it is good to have an established overview of the problem that is to be solved using the Q-learning or the reinforcement learning. So it helps to define the main components of a reinforcement learning solution, that is the agent, environment, action, rewards, and states. So let's suppose we are to build a few autonomous robots for an automobile building factory. Now these robots will help the factory personnel by conveying them the necessary parts that they would need in order to build the car. Now these different parts are located at 9 different positions within the factory warehouse. The car part includes the chassis, wheels, dashboard, the engine, and so on. And the factory workers have prioritized the location that contains the body or the chassis to be the topmost. But they have provided the priorities for other locations as well, which we will look into in a moment. Now these locations within the factory look somewhat like this. So as you can see here, we have L1, L2, L3, all of these stations. Now, one thing you might notice here that there are little obstacles present in between the locations. So L6 is the top priority location that contains the chassis for preparing the car bodies. Now the task is to enable the robots so that they can find the shortest route from any given location to another location on their own. Now the agents in this case are the robots. The environment is the automobile factory warehouse. So let's talk about the states. So the states are the location in which a particular robot is present in the particular instance of time, which will denote its states. Now machines understand numbers rather than letters, so let's map the location codes to number. So as you can see here, we have mapped location L1 to the state 0, L2 and 1, and so on. We have L8 as state 7 and L9 at state 8. Now next, what we're going to talk about are the actions. So in our example, the action will be the direct location that a robot can go from a particular location, right? Consider a robot that is at L2 location, and the direct locations to which it can move are L5, L1, and L3. Now, the figure here may come in handy to visualize this. Now, as you might have already guessed, the set of actions here is nothing but the set of all possible states of the robot. For each location, the set of actions that a robot can take will be different. For example, the set of actions will change if the robot is in L1 rather than L2. So if the robot is in L1, it can only go to L4 and L2 directly. Now that we are done with the states and the actions, let's talk about the rewards. So the states are basically 0, 1, 2, 3, 4, and the actions are also 0, 1, 2, 3, 4 up till 8. Now the rewards now will be given to a robot if a location, which is the state, is directly reachable from a particular location. So let's take an example. Suppose L9 is directly reachable from L8, right? So if a robot goes from L8 to L9 and vice versa, it will be rewarded by 1. And if a location is not directly reachable from a particular location, we do not give any reward, a reward of 0. Now the reward is just a number here and nothing else. It enables the robots to make sense of their movements, helping them in deciding what locations are directly reachable and what are not. Now with this queue, we can construct a reward table, which contains all the reward values mapping between all possible states. So as you can see here in the table, the positions which are marked green have a positive reward. And as you can see here, we have all the possible rewards that a robot can get by moving in between the different states. Now comes an interesting decision. Now remember that the factory administrator prioritized L6 to be the topmost. So how do we incorporate this fact in the above table? Now this is done by associating the topmost priority location with a very high reward than the usual ones. So let's put 999 in the cell L6, L6. Now the table of rewards with a higher reward for the topmost location looks something like this. We have now formally defined all the vital components for the solution we are aiming for the problem discussed now. We will shift gears a bit and study some of the fundamental concepts that prevail in the world of reinforcement learning and Q-learning. So first of all, we'll start with the Bellman equation. Now consider the following square of rooms, which is analogous to the actual environment from our original problem, but without the barriers. Now suppose a robot needs to go to the room marked in the green from its current position A using the specified direction. Now how can we enable the robot to do this programmatically? One idea would be introduce some kind of a footprint which the robot will be able to follow. Now here a constant value is specified in each of the rooms which will come along the robot's way if it follows the direction specified above. Now in this way, if it starts at location A, it will be able to scan through this constant value and will move accordingly. But this will only work if the direction is prefixed and the robot always starts at the location A. Now consider the robot starts at this location rather than its previous one. Now the robot now sees footprints in two different directions. It is, therefore, unable to decide which way to go in order to get the destination, which is the green room. It happens primarily because the robot does not have a way to remember the directions to proceed. So our job now is to enable the robot with a memory. Now this is where the Bellman equation comes into play. So as you can see here, the main reason of the Bellman equation is to enable the robot with a memory. That's the thing we're going to use. So the equation goes something like this. V of S gives maximum of A, R of S comma A plus gamma of V S dash, where S is a particular state, which is a room, A is the action moving between the rooms, S dash is the state to which the robot goes from S, and gamma is the discount factor. Now we'll get into it in a moment, and obviously R of S comma A is a reward function which takes a state S and action A and outputs the reward. Now V of S is the value of being in a particular state, which is the footprint. Now we consider all the possible actions and take the one that yields the maximum value. Now, there is one constraint, however, regarding the value footprint, that is, the room marked in the yellow just below the green room. It will always have the value of 1 to denote, that is, one of the nearest room adjacent to the green room. Now, this is also to ensure that a robot gets a reward when it goes from a yellow room to the green room. Let's see how to make sense of the equation which we have here. So let's assume a discount factor of 0.9. As you remember, gamma is the discount value or the discount factor, so let's take it 0.9. Now, for the room which is marked just below the 1 or the yellow room, which is the asterisk mark, for this room, what will be the V of S? That is the value of being in a particular state. So for this, V of S would be something like maximum of A will take 0, which is the initial of R S comma A, plus 0.9, which is gamma, into 1. That gives us 0.9. Now here the robot will not get any reward for going to a state marked in yellow, hence the R S comma A is 0 here. But the robot knows the value of being in the yellow room, hence V of S dash is 1. Following this, for the other states, we should get 0.9. Then again, if we put 0.9 in this equation, we get 0.81, then 0.729, and then we again reach the starting point. So this is how the table looks with some value footprints computed from the Bellman equation. Now, a couple of things to notice here is that the max function helps the robot to always choose the state that gives it the maximum value of being in that state. Now, the discount factor gamma notifies the robot about how far it is from the destination. This is typically specified by the developer of the algorithm that would be installed in the robot. Now, the other states can also be given their respective values in a similar way. So as you can see here, the boxes adjacent to the green one have 1. And if we move away from 1, we get 0.9, 0.81, 0.729, and finally we reach 0.66. Now the robot now can proceed its way through the green room, utilizing these value footprints even if it's stopped at any arbitrary room in the given location. Now if a robot lands up in the highlighted sky blue area, it will still find 2 options to choose from. But eventually, either of the paths will be good enough for the robot to take because of the way the value footprints are now laid out. Now, one thing to note here is that the Bellman equation is one of the key equations in the world of reinforcement learning and Q-learning. So if we think realistically, our surroundings do not always work in the way we expect. There is always a bit of stochasticity involved in it. Now this applies to robot as well. Sometimes it might so happen that the robot's machinery got corrupted. Sometimes the robot may come across some hindrance on its way, which may not be known to it beforehand, right? And sometimes even if the robot knows that it needs to take the right turn, it will not. So how do we introduce this stochasticity in our case? Now here comes the Markov decision process. Now consider the robot is currently in the red room and it needs to go to the green room. Now let's now consider the robot has a slight chance of dysfunctioning and might take the left or the right or the bottom turn instead of taking the upper turn in order to get to the green room from where it is now, which is the red room. Now the question is, how do we enable the robot to handle this when it is out in the given environment, right? Now, this is a situation where the decision making regarding which turn is to be taken is partly random and partly under the control of the robot. Now, partly random because we are not sure when exactly the robot might dysfunctional, and partly under the control of the robot because it is still making a decision of taking a turn right on its own and with the help of the program embedded into it. So a Markov decision process is a discrete time stochastic control process. It provides a mathematical framework for modeling decision making in situations where the outcomes are partly random and partly under the control of the decision maker. Now we need to give this concept a mathematical shape, most likely an equation, which then can be taken further. Now, you might be surprised that we can do this with the help of the Bellman equation with a few minor tweaks. So if we have a look at the original Bellman equation, V of x is equal to maximum of R s comma a plus gamma V of s dash. What needs to be changed in the above equation so that we can introduce some amount of randomness here. As long as we are not sure when the robot might not take the expected turn, we are then also not sure in which room it might end up in which is nothing but the room it moves from its current room. At this point, according to the equation, we are not sure of the S dash, which is the next state, or the room, but we do know all the probable turns the robot might take. Now, in order to incorporate each of these probabilities into the above equation, we need to associate a probability with each of the turns to quantify the robot if it has got any X percentage chance of taking this turn. Now, if we do so, we get Ps is equal to maximum of Rs comma A plus gamma into summation of S dash Ps comma A comma S dash into V of S dash. Now, the Ps, A, and S dash is the probability of moving from room S to S dash with the action A. And the summation here is the expectation of the situation that the robot incurs, which is the randomness. Now, let's take a look at this example here. So when we associate the probabilities to each of these turns, we essentially mean that there is an 80% chance that the robot will take the upper turn. Now, if we put all the required values in our equation, we get V of S is equal to maximum of R of S comma A plus gamma of 0.8 into V of room up plus 0.1 into V of room down, 0.03 into room of V of room left plus 0.03 into V of room right. Now note that the value footprints will now change due to the fact that we are incorporating stochastically here. But this time we will not calculate those value footprints. Instead, we will let the robot to figure it out. Now up until this point, we have not considered about rewarding the robot for its action of going into a particular room. We are only rewarding the robot when it gets to the destination. Now ideally there should be a reward for each action the robot takes to help it better assess the quality of the actions, but the rewards need not to be always be the same. But it is much better than having some amount of reward for the actions than having no rewards at all, right? And this idea is known as the living penalty. In reality, the reward system can be very complex, and particularly modeling sparse rewards is an active area of research in the domain of reinforcement learning. So by now we have got the equation which we have here. So what we're going to do is now transition to Q-learning. So this equation gives us the value of going to a particular state, taking the stochasticity of the environment into account. Now we have also learned very briefly about the idea of living penalty, which deals with associating each move of the robot with a reward. So Q-learning possesses an idea of assessing the quality of an action that is taken to move to a state rather than determining the possible value of the state which is being moved to. So earlier we had 0.8 into V of S1, 0.03 into V of S2, 0.1 into V of S3, and so on. Now, if we incorporate the idea of assessing the quality of the action for moving to a certain state, so the environment with the agent and the quality of the action will look something like this. So instead of 0.8 V of S1, we'll have Q of S1, comma A1, we'll have Q of S2, comma A2, Q of S3. Now the robot now has 4 different states to choose from. And along with that, there are 4 different actions also for the current state it is in. So how do we calculate Q of S comma A, that is the cumulative quality of the possible actions the robot might take? So let's break it down. Now from the equation V of S equals maximum of A R S comma A plus gamma summation S dash P S A S dash into V of S dash. If we discard the maximum function, we have Rs of A plus gamma into summation P and V. Now, essentially in the equation that produces V of S, we are considering all possible actions and all possible states from the current state that the robot is in. And then we are taking the maximum value caused by taking a certain action, and the equation produces a value footprint which is for just one possible action. In fact, we can think of it as the quality of the action. So Q of S comma A is equal to Rs comma A plus gamma of summation P and V. Now that we have got an equation to quantify the quality of a particular action, we are going to make a little adjustment in the equation. We can now say that V of S is the maximum of all the possible values of Q of S comma A, right? So let's utilize this fact and replace v of s dash as a function of q. So q s comma a becomes r of s comma a plus gamma of summation p s a s dash and maximum of the q s dash a dash. So the equation of v is now turned into an equation of q, which is the quality. But why would we do that? Now, this is done to ease our calculations because now we have only one function q, which is also the core of the dynamic programming language. We have only one function q to calculate, and r of s comma a is a quantified metric which produces reward of moving to a certain state. Now the qualities of the actions are called the q values, and from now on we will refer to the value footprints as the q values. An important piece of the puzzle is the temporal difference. Now, temporal difference is the component that will help the robot calculate the Q values with respect to the changes in the environment over time. So consider our robot is currently in the mark state and it wants to move to the upper state. One thing to note that here is that the robot already knows the Q value of making the action, that is moving to the upper state. And we know that the environment is stochastic in nature and the reward that the robot will get after moving to the upper state might be different from an earlier observation. So how do we capture this change, the real difference? We calculate the new q s comma a with the same formula and subtract the previously known q s a from it. So this will in turn give us the new qa. Now the equation that we just derived gives the temporal difference in the q values, which further helps to capture the random changes in the environment which may impose. Now the new q s comma a is updated as the following. So qt of s comma a is equal to qt minus 1 s comma a plus alpha tdt of a comma s. Now here alpha is the learning rate which controls how quickly the robot adapts to the random changes imposed by the environment. The qt s comma a is the current state q value, and the qt minus 1 s comma a is the previously recorded q value. So if we replace the td s comma a with its full form equation, we should get qt of s comma a is equal to qt minus 1 of s comma a plus alpha into r of s comma a plus gamma maximum of q s dash a dash minus qt minus 1 s comma a. Now that we have all the little pieces of Q learning together, let's move forward to its implementation part. Now this is the final equation of Q learning, right? So let's see how we can implement this and obtain the best path for any robot to take. Now to implement the algorithm, we need to understand the warehouse location and how that can be mapped to different states. So let's start by recollecting the sample environment. So as you can see here, we have L1, L2, L3 till L9. And as you can see here, we have certain borders also. So first of all, let's map each of the above locations in the warehouse to numbers or the states so that it will ease our calculations, right? So what I'm going to do is create a new Python 3 file in the Jupyter notebook, and I'll name it as QLearning NumPy. Okay. So let's define the states, but before that what we need to do is import numpy because we're going to use numpy for this purpose. And let's initialize the parameters, that is the gamma and alpha parameters. So gamma is 0.75, which is the discount factor, whereas alpha is 0.9, which is the learning rate. Now next what we're going to do is define the states and map it to numbers. So as I mentioned earlier, L1 is 0 and till L9 we have defined the states in the numerical form. Now the next step is to define the actions, which is as mentioned above represent the transition to the next state. So as you can see here, we have an array of actions from 0 to 8. Now what we're going to do is define the reward table. So as you can see here, it's the same matrix that we created just now, that I showed you just now. Now, if you understood it correctly, there isn't any real barrier limitation as depicted in the image. For example, the transition L4 to L1 is allowed, but the reward will be 0 to discourage that path. Or in tough situation, what we do is add a -1 there so that it gets a negative reward. Now in the above code snippet, as you can see here, We took each of the states and put ones in the respective state that are directly reachable from the certain state. Now, if we refer to that reward table once again, what we created, the above array construction will be easy to understand. But one thing to note here is that we did not consider the top priority location L6 yet. We would also need an inverse mapping from the states back to its original location, and it will be cleaner when we reach to the utter depths of the algorithms. So for that, what we're going to do is have the inverse map location. State to location, we will take the distinct state and location and convert it back. Now what we'll do is we'll now define a function getOptimal, which is the getOptimal route, which will have a start location and an end location. Don't worry, the code is big, but I'll explain you each and every bit of the code. Now the getOptimalRoute function will take two arguments, the starting location in the warehouse and the end location in the warehouse respectively. And it will return the optimal route for reaching the end location from the starting location in the form of an ordered list containing the letters. So we'll start by defining the function by initializing the Q values to be all zeros. So as you can see here, we have given the Q values to be 0, but before that, what we need to do is copy the reward matrix to a new one. So this is the rewards new. And next again, what we're going to do is get the ending state corresponding to the ending location. And with this information, automatically we'll set the priority of the given ending state to the highest one. Right? We are not defining it now, but we'll automatically set the priority of the given ending state as 999. So what we're going to do is initialize the Q values to be 0. And in the Q learning process, what you can see here, we are taking I in range 1000 and we're going to pick up a state randomly. So we're going to use the np.random rand int. And for traversing through the neighbor location in the same maze, we're going to iterate through the new reward matrix and get the actions which are greater than 0. And after that, what we're going to do is pick an action randomly from the list of the playable actions nearest to the next state. We're going to compute the temporal difference, which is TD, which is the rewards plus gamma into the Q of next state. And we'll take np.argmax of Q of next state minus Q of the current state. We're going to then update the Q values using the Bellman equation. As you can see here, we have the Bellman equation and we're going to update the Q values. And after that, we're going to initialize the optimal route with the starting location. Now, here we do not know what the next location yet. So initialize it with the value of the starting location, which again is the random location. Now, we do not know about the exact number of iterations needed to reach to the final location. Hence, while loop will be a good choice for the iteration. So we're going to fetch the starting state, fetch the highest Q value penetrating to the starting state. We go to the index of the next state, but we need the corresponding letter. So we're going to use that state to location function we just mentioned there. And after that, we're going to update the starting location for the next iteration. And finally, we'll return the route. So let's take the starting location of L9 and the end location of L1 and see what part do we actually get. So as you can see here, we get L9, L8, L5, L2, and L1. And if you have a look at the image here we have, if we start from L9 to L1, we got L8, L5, L2, L1, L8, L5, L2, L1. That would yield us the maximum value or the maximum reward for the robot. So now we have come to the end of this Q learning session, and I hope you got to know what exactly is Q learning with the analogy all the way starting from the number of rooms. And I hope the example which I took, the analogy which I took, was good enough for you to understand Q learning, understand the Bellman equation, how to make quick changes to the Bellman equation, and how to create the reward table, the Q table, and how to update the Q values using the Bellman equation. What does alpha do? What does gamma do?
What is Jug Problem? Now we know two things for sure here, that we've got water and also we've got jug. So what is the problem? Okay, so let me just state this problem for you. We've got two jugs here. We name it Jug A and Jug B for our convenience. And Jug A can hold 4 liters of water, Jug B can hold 3 liters of water. So this is the maximum capacity which we have set. Now, what is the problem? The problem here is that how exactly do we get 2 liters of water in jug A, right? So you could simply say that, Priyanka, why don't you just pour 2 liters in this jug A? Well, had it been so easy, this would not be a problem in artificial intelligence, right? So there are more interesting facts to it. The thing is that these jugs do not have any markings on them. That means we are working with jugs with no marking or labels. And also we do not have any measuring devices. Now imagine that if we had a jug which had labels and also a measuring device, we could easily say that yes, this jug is 2 liters filled or 3 liters filled. We can easily understand how much quantity is there in this jug. But we do not have any labels or any measuring devices to measure the quantity in this jug. This is what the problem is. And we will find various solutions to this problem. But before that, we will move on to the importance of water jug problem. So suppose I start from my house and I want to go to McDonald's to have a burger. So there are several routes that I can take, and my natural selection would be the best route that will help me to reach McDonald's faster. So now let us relate this to the water jug problem. Now in water jug, what happens is that we have a start and an end state too. Like here we have got house, we are starting from the house, that is our start state. And in water jug, we start with empty jugs. So, and the destination here is the McDonald's, but for our water jug, the destination is having 2 liters of water, exactly 2 liters of water in jug A. This is our goal state. So in both the things, we can relate that we are having a start state and a goal state. Thus, there are several ways to reach McDonald's. Similarly, in water jug, we have several possible solutions to get exactly 2 liters of water or arrive at the goal state. Now, if we know how to solve this problem in artificial intelligence, where we know the start state and the goal state, this can really help us in getting search states, various possible solutions, and also the optimal search. And water jug problem is the very basic to any problem solving process, as it helps us to find various possible ways and also the best optimal way. So now let's proceed on to understanding various possible solutions to water jug problem. But before that, there are certain assumptions that we have to keep in mind. And that is, we can fill a jug from a pump. There is unlimited supply of water, so you don't have to worry about water. Also, we can pour water out of a jug to the ground. So you can also empty the jugs by pouring water out to the ground. And another assumption is that we can pour water from one jug to another, right? You can interchange the water from one jug to another. And another last assumption is that there's no measuring devices available with us so that we can measure the how much quantity of water is there in the jugs. So these are the assumptions which you have to keep in mind before framing any possible solutions in artificial intelligence. So now let's move on to devising various solutions and looking on how artificial intelligence really solves this problem. Now consider we have 2 jugs here that we have seen. This is a 4-liter jug, and this one I will create it as a 3-liter jug's capacity. And we named these jars as A, and this was named as B, right? So just for the convenience sake, we will refer to this jug as A and this jug as B. Now, what we have to do is we have a goal state in mind, and that is we want 2 liters capacity in jug A and 0 liter capacity in jug B. This is our goal state to be reached. And our start state is nothing but we start with 0, 0. That means assuming that there is no water in these jugs. Okay, so we will start with various states and see how we can fill these jugs. So now we see that we don't have any measuring mark. Also, the entire capacity of this jug is 4 liters, and this jug's entire capacity is 3 liters. All right, so now keeping this in mind, we will design our state space. So how do we do it? Let's just start filling by jug B. Okay, I filled it full. Then what I do is I will just transfer whatever I have of jug B to jug A, right? Now my jug A is 3 liters full because I have transferred 3 liters from jug B. Okay. Now what I do is I will again fill jug B. So I have this 3, 3. Okay. I have got unlimited supply of water. Remember the rules, the assumptions. So I filled this jug B with 3 liters of water. Now what I want to do is I can fill this jug A with 1 liter more because it has got 4 liter capacity. So what I do is I will transfer certain water from jug B to jug A. So this becomes 4, and since I transferred certain water, it became 2. All right. Now Let's move on for another thing. Again, my goal state is not reached because it is 2, 0 and we still have 4. So now what we have to do? I can simply empty the water of jug A to the ground and let it be 0, right? And let this be 2. Now what I can do? Simple. Transfer all the water of jug B to jug A. And this is our goal state. As simple as that, right? And this entire thing is known as state space representation. Now this is only one of the possible solutions that we have. Now let's look at another solution. How can we reach to the goal state with starting state as 0, 0? Now suppose again we have got 0, 0. Another possible solution could be I fill the jug A with entire capacity, that is 4 liters. Now what I do is I empty 3 liters from jug A and fill jug B with 3 liters. Okay, let me fill this jug B with 3 liters. Then what I do is I empty the water of jug B to the ground. So it makes it 0. Now what happens? Again, my goal state is not yet reached, right? It is 2 here. So what I do is I will make here 0 and 1. What I'm doing? I'm just pouring all the water from jug A to jug B. So this becomes 0 and this becomes 1. Now again what I do is I will fill my entire jug A with 4 liters of water and I have here 1. That is already remaining with jug B. Now what I can do again is that since this jug B has the capacity of 3 liters, it is also having the remaining capacity as 2 liters more. So I will fill this remaining capacity from jug A. So what I do is I will fill this. So this becomes 2 and this becomes 3. Okay, so this is again my goal state which has been reached. All I was concerned with that I get exactly 2 liters of water in my jug A, right? Exactly. I'm not bothered about how much water I have in jug B, right? So these are the two state space representations of filling this or achieving this goal state, right? So this was how we do it in manually. Now let us understand how we do it in artificial intelligence. So now let's understand the state space representation or the production rules that our artificial intelligence program would understand. And based on these rules, we will also code. So understanding this becomes a little important, and I'll make things really simple for you. So let's just stick around and have patience while understanding this. So now one thing we know that our jug A has 4 liters of capacity and jug B has 3 liters of capacity, right? So keeping these two things in mind, we will start afresh. Now, what I do is I will take it as A and B, okay? And this I will write here as, let's suppose we will fill it in with 4 comma B. That means I fill the entire jug. That means the jar here, let me have 2 jars also. So I fill the jar A completely with 4 liters of water and let B be B. Now here what I do is there are certain rules which we follow, but here we are certain, I'll just write here rules, okay, just for our convenience. So now what we do again we'll write here AB and then let's fill jar B. Now these rules are nothing but the possibilities that we can apply and code, right? These are the conditions that we can use in our code, just like if else conditions, okay? Now another rule is that I would simply write again AB, and now coming to another rule, that is I withdraw certain amount from jug A. So this is simple, I just withdraw the amount and jug B has the same amount. Now here the condition is that A is greater than 0. That means there has to be some water in A so that I can withdraw certain water, okay? Now another rule is for B. Here A would remain the same and I will withdraw certain water from B. So here the rule applies that B need to have certain water. So B has to be greater than 0. Only then I can withdraw certain water from B, right? Okay. Now coming to another rule which is very simple, and that is, what is it? 0 comma B. That means I'm withdrawing, or I'm emptying the jar A to the ground completely, right? So nothing remains in jar A. That means that in jug A, so it becomes 0. This is the empty rule, and again here B should be greater than 0. Again, the another rule I have is I would empty the jug B, right? So here again the condition would be B is greater than 0. That has to be something to empty, right? So that's what I do it. And here it is A, not B, sorry, because I'm emptying something from A, so there has to be something here. Now another rule comes like, let's create another state, and what we did was we also poured certain water from A to B and from B to A right? So there was some exchange of waters between these two jugs. So how do I code it, and how do I write that in artificial intelligence or code it? So what I do is I would simply just understand this thing. My jug A has a capacity of 4 liters, right? I keep it as it is. Now what I'm doing is I'm withdrawing certain water from jug B and I'm filling it in jug A, right? So whatever modification has to be done or whatever things I have to do it with jug B. So I'm taking out certain water from B, so I'll use the minus sign. And what I'm doing, I'm filling it in A. So whatever I fill it in A would be something like the total capacity minus A. That means the filled water. Understand this like, suppose this is are both the jugs A and B, and what I'm doing is this is 4 liter capacity, this is having 3 liters capacity. I have to pour or add certain water from B to A. Now suppose this is already filled with 1 liter. Suppose it is already having it. Now the remaining capacity becomes how much? 3 liters. So how much will I write this? 4 minus 1, that is 3. So how can I write it here? That means this is, I'm withdrawing it from jug B. So I will write it as that from B, I am withdrawing or I'm adding 3 liters of water. So this has been written as 4 minus the capacity, that is A, right? Okay, so similarly, I will do this for when the water I have to pour or interchange from jug A to jug B. How would I do it? Again, I will write here A, right? And okay, I've not talked about the conditions here. So before we proceed, let me talk about a little conditions here. And these conditions are, let me rub this out also so that I can write the conditions. So the condition for here, or the rule here would be nothing but A plus B. It should be greater than equal to 4. And also one more condition is there. That is B should be greater than 0. Because I have to give something from B, jug B, so it has to have certain capacity. Okay. So now coming to another rule. And that is, now suppose I want to withdraw certain water from jug A and I have to fill it in jug B. So the condition would be jug A minus entire thing. I'm just reversing this thing. The capacity minus the quantity to be added. And then I will just write here the capacity of jug B, right? And here the condition is nothing but it has to be like A plus B should be greater than equal to 3. And also A should be greater than 0, right? Now remember, we have another condition wherein we just poured all the water from jug A to jug B, right? And jug B to jug A. So for that, what we can code is like A plus B, and from B, that means from jug B becomes 0, the water in jug B. So here, what we do is we are pouring all the water from jug B to jug A. And the condition for this would be A plus B, it is less than equals to 4, and B should be greater than 0 because you have to transfer certain water from B to jug A. Now another condition is we made it for like jug A. Now let's make it for jug B. So now we empty the jug A and fill all the water of jug A to jug B. And here the condition would be what? A plus B should be less than equals to 3. And also A should be greater than 0 because we have to fill certain water from A to B. So these rules, as we have seen, these are nothing but these are called the production rules. And these rules are being followed by the AI programming or the search space to find the best or optimal state spaces for a problem, right? And how to reach to the goal state, which was 2 or 0, right? And which we have figured out previously that we are reaching it by 2 possible solutions, right? So now let us just apply these rules to our previous problems and see how we apply these rules, and then we will do on our hands-on. So now we've got these rules listed, and let's just name these rules as, 1. So now let's name these rules as 1, 2, okay, just for our convenience, 3, 4, 5, 6, and we know what we are doing in each rule. We are withdrawing water, or we are just emptying the jars, or we are just refilling it, right? So we've got, again, for convenience sake, let's just have 2 jars, our previous jar, jug B, jug A, and jug A has 4 liter capacity, jug B has 3 liters of capacity. So now in this table, let's have A here and let's have B here. And let's just use this, and this thing is the basic principle they will be applying in solving the artificial intelligence code also. So the same things goes there also. So this is A, Jug B, and the rule. So now what we did previously was we started with 0, 0 state, and that obviously had no rule, right? And our goal state, as we can just write it here, the goal state is to fill 2 liters of exact capacity in our jug A, right? And in jug B, we can have either 0 or any quantity like 2n. This is a problem known as 2n, right? Okay. So now let us just move on to refilling it. So what I do is I would fill the jug B with 3 liters of water. Let's just fill it. So we are completely filling it. So which rule fills it? This rule, rule 2, right? So let's just fill rule 2 here, right? Understand now what we are doing is we are simply transferring jug B water to jug A. So we just write here 3 and we write here 0 because this is emptied. Now since we are transferring, as you can see here, we are transferring this from here, from jug B to jug A. So this is the 9th rule, right here 9. Now another thing is that notice that this condition is fulfilled, that A plus B should be less than or equal to 4 and B should be greater than 0. So we can see here, you add them, 0 plus 3 is 3, which is less than 4, and B is also greater than 0. So this condition is met and hence this has been executed. So our next, or the current state is 3, 0. Okay. So now let's move on to our next state. What we want now, what I do is I just refill my jug B. So when I'm refilling it simply with additional water, I'm using simple rule, that is 2 here, right? Okay, now this becomes my current state. Now let's move on to another state. We'll repeat until our goal state is reached, that is 2, 0. So now let us move on to, now what I do to the next state is that I fill certain water in jug A till its maximum capacity and I transfer some water from jug B. So I transferred how much? 1 liter is remaining here to make it 4 and remaining is 2 here. So what rule am I using here? Simply we applied this rule here, 7th rule, right? I'm pouring certain water, B minus 4 minus A. So this rule applies here. So I write here 7, right? Now this becomes my current state. Again, my goal is not reached. So what I do is I can simply empty jug A and I write here jug B same. This rule is simply rule 6 because I'm simply emptying this thing. I'm using these rules. It's not important that I will use all these rules, but only the rules which are required here to reach the goal state. So this is one of the possibility. Now what I do is I will simply empty this jug B water to jug A. So here we get 2, 0 and this rule is nothing but 9th rule here. I'm emptying this water to here, right? So this is how I will apply these rules to solve one problem. Now this is one possible solution. Another possible solution could be something different, wherein we started with 4 and 0. So what can that be? If I can just write here oblique, and if you don't get confused, we can simply play it around here. We start with 0, 0, we start with state 4 and here B is 0. The rule applies is 1. Similarly here what I do is I write here 1 because I'm transferring some of the water to jug B. Just focus on the oblique sign, and this is what, just the second combination I'm doing, replicating the same one. You can always tally this and the rules will change, right? When I'm just changing the state, I am just changing the rule, that's all. 0 and 1, and again I will change the rule, and that is 10th rule here. So depending on the state, your rules will change, and also the goal state. So goal state here is different. Here we get 2, 3 and here we are getting 2, 0. Now depending on the goal state, we will be devising the solutions. So these are the two possible solutions that we have obtained by using these rules, right? So this is how we imply this in artificial intelligence. And now let's see the code in Python by applying these in conditions. So these rules are very important once we execute these small problems. Okay, so now let's move on and execute this code in Python. Alright, so now we are here with the water jug problem, and the simplest way to implement this is define a function. So we have defined a function called pour water here, and we have taken two, our jug A and jug B, and then we have defined the maximum capacities of both these jugs, and here we are taken as 5 and 7. Let's increase it and see different solutions for this. And fill is 4. So you can change the minimum and the maximum capacities also depending on the goal state you want to attain. So now what I do is when I run this code, I've used if and elif and else control loops here. So this would be the flow of the code and how it will look. We can see when I run it. I've given the condition with jug B if it is fill, and it will return the maximum capacity. Again, I am withdrawing certain water, I am filling certain water, I am pouring the water from one jug to another jug, and this is how the code goes, and that's what we have seen. So when you implement this, you would get something like this, and our goal state was to fill the jug B with 4 liters of exact capacity and get 0 in jug A. And that's what we have gone through. And we have started with the start state at 0, 0, and the goal state was 0 and 4 to get exactly 4 liters of capacity or 4 liters of water in jug B. Okay. So this is how the code runs. You have to apply the logic here. Like when this iterates, it just fills the jug B, jug A, and then it fills the jug B. So this is how you simply implement it in Python. Also, we can apply various algorithms like breadth first search or depth first search to find the best optimal search space or the state space for this problem. That could have been a little complex for this tutorial. So we are sticking to a simplest solution here, wherein we have to find the goal state as 0, 4 and starting from 0, 0. So this was the implementation.
ChatGPT, ChatGPT, ChatGPT. This has been the buzzword since the day of its release, and people are going crazy about everything it can do. Microsoft will be integrating ChatGPT into Teams to automatically take notes and recommend tasks. ChatGPT has also passed the US medical and law exams, and it has got a lot of doctors, lawyers, and engineers concerned about whether it could replace them. People want to know if ChatGPT is the next step towards our evolution by replacing Google and voice assistants like Siri and Alexa. But what exactly is ChatGPT? Why is it changing everything? Now, I want you to think of ChatGPT like Siri or Alexa minus the voice capabilities. ChatGPT can give you detailed and contextual answers in a very human-like manner. It can remember conversations, do math, write essays, and much more. And it does it so well that people are genuinely scared of losing their jobs. Now, ChatGPT is not really a new concept. Microsoft and other companies have also tried this before, but were nowhere near successful. OpenAI developed a model called GPT-3 using huge data sets that had a variety of information. They released it to the public, calling it Playground, where a lot of developers used it for their daily tasks. ChatGPT has been another implementation of this. OpenAI took a year to make this model faster and more accessible to the general public, and when they released it in November 2022, the crowd went nuts. The site gained more than 1 million users in just 5 days. And to give you some perspective, this number is bigger than Netflix, Twitter, Facebook, and even Instagram. All that said, I want to let you know how everyone is using ChatGPT to simplify business operations. For developers, ChatGPT has been a blessing. Since ChatGPT can write code, provide code templates, and fix errors, most of the problems that developers usually run into has been fixed. As a result of this, productivity has greatly increased and companies are getting more results. It's the same thing with content development. Videos like this one traditionally take a lot of time and effort to be made. We have to think about how best to explain things so that you, the viewer, can easily understand it while making sure that the content is SEO friendly and extremely engaging. ChatGPT has also helped us give you better, more optimized content while reducing our workload. By the way, did you know that ChatGPT can explain stuff better than most university professors? I guess it's time we contemplated our learning methods. Marketing and sales has also been much easier than before. Think about it like this. If you want to make a customized sales pitch, all you need to do is enter the details. ChatGPT can provide a customized sales pitch for each individual lead. How convenient is that? And it doesn't just end there. ChatGPT can also be integrated with accounting and data analytics platforms So you don't need to know the formulas directly. All you need to have is data, and you just need to type what you want to do. If all this doesn't blow your mind just yet, then know that psychologists and psychiatrists are using ChatGPT to help and counsel their patients. Now, if you are questioning whether it would really be helpful, then let me tell you, it can. I just had a 30-minute conversation with ChatGPT about my dog, and it seemed way more interested in him than most of the people I usually talk to about this. All that said, if you want to start using ChatGPT, then all you need to do is open chat.openai.com. This is the URL of ChatGPT, and the moment you open this, it will ask you to create an account. Once you do that, you will land in a web page similar to this. Let's start with a simple question about programming. This is just a random question on Stack Overflow, which I will be using for this demonstration. How to check if an array includes a value in JavaScript. The user has also provided some code, and he has said that he only knows how to do it like this. Is there a better way? And once we ask ChatGPT the same thing, boom, ChatGPT is on it. It finds a solution and provides the best answer it could think of. If you look at the question, while the solution might be simple, the complexity of conditions and following my instructions properly is quite hard. ChatGPT eased through it and also provided a sample snippet which I can directly copy and paste into my editor. But this is not the only thing. It can also give you complete guides on how to do something. Like for example, let me type, using Python, help me fetch data for Nifty Bank for the past 3 years. ChatGPT is already providing explanation and code of how this can be done, and is pretty damn cool. Now, remember that ChatGPT remembers conversations and can have future answers based on it. So now, if I type, great, how can I create an AI model that can predict values using this data? It immediately understands what I want and provides an accurate answer. The answer might not be everything that you hope for, but at least now you know where to start from. Another use case for ChatGPT that we talked about was content creation. To do this, let's create a new chat thread. This makes sure that the previous conversations don't affect the current conversation. If we start without a new chat thread, ChatGPT might think that we are trying to write content about stocks and machine learning. We don't want to do that now, do we? So let me ask ChatGPT to give me blog ideas for ChatGPT itself. And we already have multiple blog ideas for ChatGPT. We can then ask it to write a story based on some option. We can then say, I like the third option. Could you create a storyline for it? And we can see that ChatGPT immediately starts generating a storyline based on my option. It includes an introduction and sections of what my blog will contain. Similarly, we can also create a sales pitch. Let's just say, create a motorbike sales pitch for a person with the following details. And then I have listed down a few details like name, product, age, country, and source. And once we submit this prompt, we can see that ChatGPT immediately starts writing a beautiful sales pitch. You can even use the sales pitch directly if you want. Now, if we dive too deep into this subject, then this video will take forever to finish. So if you are interested in knowing more about how to use ChatGPT, then check our course on ChatGPT, which will not only cover the basics of ChatGPT, but also the advanced and complex usage for different scenarios. But before we end this video, I definitely need to make you aware of a few limitations. The first thing is that it may occasionally provide incorrect information. You should know that ChatGPT is a relatively new application and it needs some time to improve. The current version of this is a free research preview, meaning that they have released it to test the application. This statement could also mean that we might see an improved paid version of this in the future. There's a lot of rumor going about that already. The second limitation is that it may occasionally produce harmful or biased content. This is something that we have seen in all chatbots in the past, and ChatGPT has reduced the occurrence, but it's still not perfect. But the biggest drawback is that the model was trained on data collected before 2021. This means that it has very limited knowledge about the current affairs. So make sure to check the facts before drawing conclusions. And with all this, I want to know what you think of ChatGPT. How do you think it will look in the future? And what do you think about the future of automation and AI? I personally think that we can expect radical changes in all segments. Imagine voice assistants being as intelligent as ChatGPT. And if it is updated with real-time information, things would be much more convenient than now. You could shop online with ChatGPT's recommendations, find good restaurants, meet new people, plan trips, and much more.
Before we dive into AI and culture, let's play a little game. I like games and I hope you do as well. So the name of the game is Guess the Title of the Movie. So I'm going to show you 4 different movie posters and your job is to guess the name of the movie. I hope that was clear, the instructions were clear. Guess the name of the movie as you see the posters. You can pause the screen and then go down to the comment section below and leave your answers there. So are you ready? 3, 2, 1. So I hope that you left your answers in the comments and I'm going to give you the titles, of course. So there they are on the screen. The point of this game is to see how many of you recognize the movies. And I think most of my viewers will at least recognize 2 out of the lot. Yeah, and all of these movies are based on artificial intelligence. And if you haven't watched any of these movies, I recommend that you find some time for them. They're mind blowing. The Matrix is my personal favorite from the ones you see on the screen. But why did we play this game? Well, this is the easiest way to show you guys that people get excited when they hear the term AI thrown about because it is cool and it's everywhere and there's so much to talk about. People have so many different opinions and perspectives on the matter. So I think it is safe to agree that it's deeply embedded in not just the Western culture but cultures all over the world. Wouldn't it be cool to look at some of the factors or elements that led to such a widespread adoption of artificial intelligence in cultures? Well, first up, we're going to take a look at advancement in science. Movies like the one you see on the screen came out before World War I, and they inspired a whole generation of scientists who did some amazing work in the field of computer science and AI. So, what were the advancements that led to AI? The first computer was made in 1946 and was called ENIAC. It was enormous. It occupied a space of 50 by 30 foot, but could only do simple calculations. But the benefit was that it was reprogrammable. Following which in 1950, who is regarded as Alan Turing, who is regarded as the father of modern computer science, wrote in his paper how to build intelligent machines and how to test their intelligence. But as you know, computers weren't advanced to hold any instructions or data. But Turing's test for intelligence is still used today, over a half a century later. Isn't that amazing? Next, in 1956, at the Dartmouth Summer Research Project on Artificial Intelligence is where it all began. I mean for artificial intelligence. As a matter of fact, this is where the term artificial intelligence was first used. From 1957 to 1974, AI flourished. It became the buzzword. And also the computers could store more information, became faster, cheaper, and more accessible. Yet, they were too slow to exhibit any kind of intelligence. Remember the first movie and the game we played earlier? That came out in 1968. Since the computers were too slow and needed to catch up, the AI buzz started to quiet down. And that was until 1997 when IBM's supercomputer called Deep Blue beat Garry Kasparov at chess. And mind you, Gary was regarded as the grand master of chess. Here's a picture of Deep Blue on the right, so you get an idea of how compact the computers got by the year 1997. So I hope you had as much fun as I had by giving you a little bit of a history on AI. So this was the first element, advancement in science and technology, that influenced the culture around AI today. What's the second one? It is books and literature on AI. Literature can range from the ones that deal in facts, such as academic, scientific, or research papers, to the ones that are very imaginative and completely fictional, like comics. Inspired by the advancement in science and technology, written literature is where writers take the most complex and evolving ideas and present them in a way of stories so common folks can understand and relate to them. But the next element that we are about to see does this better than books, in my opinion: movies and television shows. Movies and TV shows have a wider audience than books. And like I said earlier, the right ones inspire the future scientists. And the advancements that they make inspire the next generation of movies. So it's like a cycle, you see. Let's move on to the next one. Different events such as conferences, seminars, webinars, trade shows and expos, awards and competitions, workshops, and others provided a platform to exchange ideas on artificial intelligence and connected like minded people. They range from highly academic events like the one we saw earlier, Dartmouth Summer Project on Artificial Intelligence, to things like Comic Con, where people attend as their favorite characters and meet movie stars. Next one is mainstream media like newspaper, news channels, and radio. Across the world, they have provided coverage on artificial intelligence and brought on experts to talk about it. The next one is normal everyday conversations. Yeah, if AI is going to be everywhere, then it will be part of everyday conversations. All of these different elements, and not to forget social media, have made AI incredibly famous in cultures across the world. But in the past few years, the buzz around AI is back, especially with companies like Amazon, Google, Facebook, Apple, Tesla, and two or three dozen research organizations making incredible progress in this field. So naturally, that will make you wonder, what is AI like right now? In this section, I have another surprise for you. But before we get to it, let's check out what are the different types of artificial intelligence. So there are three main categories of artificial intelligence: ANI, AGI, and ASI. So obviously the first thing that popped in your mind if you don't know about these categories is, what are they? Well, let's briefly take a look. Artificial Narrow Intelligence is what ANI is. It is also known as weak intelligence. Artificial Narrow Intelligence refers to AI systems that can only perform a specific task on their own using human-like capabilities. They can learn from past experiences in regards to that specific task. Even the most complex AI that uses machine learning and deep learning to teach itself falls under ANI. This type of artificial intelligence represents all existing AI, including even the most complicated and capable AI that has ever been created to this date. Let me give you some examples. Google, Alexa, and Siri voice assistants use AI to detect speech and carry out commands. Today's security and surveillance systems uses facial recognition, which is a type of narrow AI. Social media platforms use it to learn about preferences and show you ads and content that you will enjoy. E-commerce websites like Amazon use it to learn about your shopping activities, where you are located, and so much more to recommend similar products. It also helps them figure out inventory for warehouses for different locations and their unbelievable 2-day delivery. Banking and financial sector use it for fraud activity detection, loan approval, and so on. Last, but certainly not the least, autonomous vehicle use it to navigate the roads on their own. So I hope that you got a little bit of an idea of what ANI is. Let's move on to the second category, which is AGI, and it stands for Artificial General Intelligence, and it's also known as Strong AI. So you're probably wondering what it is. First, we talked about artificial narrow intelligence. Now we're talking about artificial general intelligence. Does it give you any idea? If you're thinking that this type of artificial intelligence is good at general tasks, meaning all tasks, instead of a specific task like we saw in the previous category, A and I, you would be right. So AGI will be able to better understand the humans it is interacting with by discerning their needs, emotions, beliefs, and thought processes. It will be able to learn things and apply a broad range of areas, just like human beings can, and unlike narrow artificial intelligence. Right now, AGI is the goal of the field of AI. a place where AI will become part of the physical world and will navigate it like we do. Quite a bit of leading AI researchers think we'll get there in a few decades. There's been a lot of research and development happening on AGI by organizations like OpenAI, DeepMind, Apprente, and many more. So I hope you got an idea about this one. Let's move on to the last type, which is ASI, and it stands for Artificial Super Intelligence. Judging by the name, super, you probably already got an idea that this will be the pinnacle of AI. ASI is where machines will become self-aware like us humans, and they will be overwhelmingly superior than humans at everything. That is, they will have greater memory, faster data processing and analysis, and decision-making capabilities. The potential of having such powerful machines at our disposal seems appealing, but these machines may also threaten our existence or, at the very least, our way of life. We don't have any examples of AI, thank God for that, because we aren't even ready for artificial general intelligence, the one before this one. Okay, let's switch gears and play a little game because the section after this is going to be a little tense. So let's disperse some tension before we get into dangers of AI. The name of the game is Guess the Type of AI. ANI, which is Artificial Narrow Intelligence, good at specific tasks. AGI is more like human capabilities, but it is not self-aware. And ASI, which is artificial superintelligence, which is where the machines become self-aware and get way better than human beings. So I will put up a few pictures or videos and you will have to guess the type of AI. And if you want, you can comment your answers below. Let's see how many of you get them right. Sounds good? Okay, let's begin. First one here is an autonomous vehicle that can drive from point A to point B and even park itself without a human in it. If you guessed ANI, you'd be right. Second one is a Tesla bot. The robot will be able to perform basic repetitive tasks with the aim of eliminating the need for people to handle dangerous or boring work, like getting groceries from Walmart. If you guessed AGI, you wouldn't be completely wrong, but its capabilities will be limited, so it's A and I. These last ones are from Boston Dynamics. They've been making incredible strides in robots navigating the world. And personally, their robots give me the goosebumps. I mean, look at them move. But remember, even though they can navigate the world and obstacles around them, they are not able to understand the humans. So take that as a hint, if you will. So, any guesses? If you guessed AGI, again, you'd be wrong. The point of this game was to show you that everything that we have today is artificial narrow intelligence. All three examples that we saw were artificial narrow intelligence. But there are a lot of companies that are working on artificial general intelligence, and it is around the corner. So I wanted you guys to watch these two clips before we move on to the next section. Freaking goosebumps, right? I mean, imagine one day you go out for a stroll or a jog and you just see this thing just running loose. This is something from your worst nightmare. Robots taking over the world? That must make you wonder, what are the dangers of AI, doesn't it? Well, then let's talk about its dangers in this next section. So, what are the near to midterm dangers of AI? And when I say near to midterm, I mean from present day to 20 years in the future. Well, the first one we're going to take a look at is privacy. Imbalances of access to information has been exploited in the recent past and is probably being exploited as you watch this video. Let's see some of the examples to understand how everyone's privacy is always at stake. In 2018, news broke out that a data analytics firm, Cambridge Analytica, had analyzed the psychological and social behavior of users through Facebook's likes and targeted them with ad campaigns for the 2016 US presidential election. Now imagine being able to influence US presidential election. That is crazy. Second example is Clearview Face Recognition. Clearview is a company that created a face recognition system to help police officers identify criminals. They claimed that it only used publicly available images on social media platforms like Facebook, Instagram to identify criminals. But in January 2020, the New York Times reported that in a demo from Clearview, it scraped personal images from Instagram account of the show's producer. Next example is deepfake, and this is really concerning. Images and videos that are created using deep learning and contain a real person acting or saying things that they didn't do or say are called deep fakes. If you use it for entertainment purposes, deep fakes are fun. But people are creating deep fakes for fake news and information, and worse, deep fake porn. And the last example is mass surveillance in China. China uses over 200 million surveillance cameras and facial recognition to keep constant watch on their people and also mine their behavioral data captured on the cameras. China also implemented a social credit system to rate the trustworthiness of its citizens and give them ratings accordingly based on their surveillance. So on this system, if they rate higher, they get more benefits, and if they rate lower, well, you're out of luck. All of this was done without their knowledge or consent, and that is what is most concerning. As you can see, people's privacy is a big concern right now, and more so in the future years to come. Next one we are taking a look at is AI producing biases. Well, naturally, you're going to say, Kevin, how does AI produce biases? Well, AI and machine learning models use parameters and the data it was trained with to make yes or no decisions. There have been many examples in which the parameters don't tell the full story, and the labeling of training data could be done with some sort of bias. So when AI is used for serious tasks like filtering job candidates, giving out loans, accepting or rejecting insurance requests, or even for medical diagnosis, it can have a tremendous impact on somebody's life. Here's just one for example. This image shows how one of these thermometer guns gets classified as a gun when it is held by a person of dark skin, and as a monocular when it is held by a person of salmon or white skin. This happened in 2015, where Google's image recognition software made this bias. Now imagine something like this being used by law enforcement in real life scenarios. Ooh, I don't even want to think about that. The next one is centralization of AI. This danger deals with the fact that what if all the AI technological advancements always end up in the hands of a few people or groups? So we are already seeing this now to a certain degree. The amount of time that people spend on platforms like Facebook, Instagram, Twitter, YouTube is so ridiculous. And we're constantly giving data to these companies with each interaction. They all have gigantic oceans of data on their users, which along with their AI enables them to keep making advancement in technology, staying ahead of the curve and always on the top. But it is a very likely scenario that some of these companies will advance to extremely high-tech machines and the rest of the world wouldn't be able to keep up. Will they then become all-powerful like United States with atomic bombs in World War II? Or even worse, because AI can unlock a whole bunch of threats to humanity? Of course, there's this problem of rich getting richer. And also there's this issue of transparency where we don't know how much these organizations know about us and what they can do. Here's another scenario. What if one of these companies, just like in the movie Iron Man, where Tony Stark has his fancy high-tech AI-powered suits, and there's people that are always trying to steal it so that they can reverse engineer. And then there's bad people who want to use this technology to bring mayhem and destruction to the world. So it may not end up being that extreme, but it is entirely possible that these companies may have good motive and good intentions towards the world, but an entity with a bad intention can steal it and use it to cause harm to humanity. So centralization of AI in the hands of few people or group is a real threat. And we need to make sure that we always keep these threats in check. So the next danger is loss in jobs. It's also called AI dislocation. Use of AI in the workplace is expected to result in the elimination of large number of jobs. Though AI is expected to create and make better jobs, education and training will have a crucial role in preventing long-term unemployment. But initially, it will lead to a lot of lost jobs. It is a common misbelief that AI dislocation will only hold true for labor to semi-skilled jobs. But the truth of the matter is that it has already started displacing even high-skilled jobs that require master's and PhD degree. Let me give an example. One such job is consultants for companies to help them make decisions. They are being replaced by AI and machine learning softwares. Let's now talk a little bit about the long-term dangers. And by long-term, I mean 20 to 50 years into the future. So what's the first danger? Well, the first danger that we will talk about is safety and security. AI applications that are in physical contact with humans or integrated into human body could pose safety risks as they may be poorly designed and misused or hacked. Poorly regulated use of AI in weapons could lead to loss of human control over dangerous weapons. So the first example is Neuralink brain implants, and the second one is autonomous weapon system. The second danger, which is very real and it could happen, and I think it is going to happen at a certain degree at least, is the transformation of society. Remember the times when 3, 4 generations would live under the same roof? And since the silicon revolution of 20th and 21st century has broken down families into nuclear units of 2 to 4 people on an average. Today you look around and you'll see everyone with their heads down and eyes glued to their phones. Most of the people prefer to spend their time on their phone than the world around them. And if you want proof of this, you only need to look around. Go to a public space and just observe people. With the AI revolution that we are in, we will see entire realities unfold in real time in augmented reality, and we will be able to interact with an intelligent projection in them that behave like humans. Also, we will be surrounded by robots that human beings will have relations and feelings towards. It is quite possible that on this course, we might forget what it is to be a human. And that brings us to the last danger, that is AI rise to power. I know a lot of people think that singularity or AI rise to power or taking over the world is not a likely scenario, but super intelligent AIs with real world traction, such as an access to pervasive data centers and autonomous robots, could radically alter their environment. Example, harnessing all available solar, chemical, and nuclear energy. If such AIs found uses for free energy that better furthered their goals than supporting human life, human survival would become unlikely. So these were some of the scenarios and dangers that we need to avoid while we go forward with the AI revolution. So let's now find out in this last and final section, what does the future hold for us? An important challenge is to determine who is responsible for damages caused by an AI operated device or service. In an accident involving a self-driving car, for example, should the damage be covered by the owner, the car manufacturer, the programmer, the person who trains the machines on data? It's really unclear right now. But with that being said, the future of AI is very promising, it's very bright, and it feels like a start of a revolution. World is also taking baby steps towards artificial general intelligence, and it is going to be really, really helpful for humankind. But that also means that we should tread really carefully. And we should take all the dangers as very real, because this isn't something that human beings could control once it gets out of hand, as opposed to every other technology that we had previously. Okay, so how should we prepare ourselves for the future? Educating ourselves about AI or other tech is going to be absolutely paramount if we are going to make this AI revolution a net positive effect for the whole world. So for that, we need to have tough conversation and debates, especially when it comes to developments in artificial general intelligence. Artificial narrow intelligence is not as concerning as what we are trying to achieve right now. And then lastly, we need to ask difficult questions, keep the progress in check by establishing ethics and laws on AI. And if required, there should be licensing and registration of every single tech that we make. So here's my closing remark. With great power comes great responsibility. Just as the world thought that the development of nuclear weapons will wipe out the entire planet. But we now know that if handled with great care, responsibility, and universal cooperation, then it could not only lead to world peace, but resolve energy crisis of the world with nuclear power.
So, what is knowledge representation actually? Now, knowledge representation in AI describes the representation of any knowledge. Basically, it is a study of how the beliefs, intentions, and judgments of an intelligent agent can be expressed suitably for automated reasoning. Now, one of the primary purposes of knowledge representation includes modeling intelligent behavior for an agent. Knowledge representation and reasoning, also known as KR or the KRR, represents information from the real world for a computer to understand and then utilize this knowledge to solve complex real life problems, like communicating with human beings in natural language. Now, knowledge representation as AI is not just about storing data in a database. It allows a machine to learn from that knowledge and behave intelligently like a human being. Now, there are different kinds of knowledge that need to be represented in AI, such as the objects, events, performance, facts, then we have meta knowledge and the knowledge base. So these were the different kinds of knowledge that you need to represent. And now that you know about knowledge representation in AI, let's move on and know about the different types of knowledge here. Now, talking about the different types of knowledge, there are 5 types. Talking about the first one, we have declarative knowledge. Now, this includes concepts, facts, and objects expressed in a declarative sentence. Then we have the structural knowledge. Now, it is a basic problem solving knowledge that describes the relationship between concepts and objects. Next up, we have the procedural knowledge. Now, this is responsible for knowing how to do something and includes rules, strategies, procedures, etc. The fourth one is the meta knowledge. Now, this defines knowledge about other types of knowledge. And finally, we have the heuristic knowledge. Now, this one represents some expert knowledge in the field or subject. So, these were the 5 important types of knowledge in AI. Now, let's have a look at the cycle of knowledge representation and how it actually works. So, talking about the cycle of knowledge representation, artificial intelligence systems usually consist of various components to display their intelligent behavior. Now, these components include perception, learning, knowledge representation, and reasoning. Then we have planning and finally execution. Now, here is an example to show the different components of the system and how it works. Now, this diagram shows the interaction of an artificial intelligence system with the real world and the components involved in showing the intelligence. So, first of all, the perception component retrieves data or information from the environment. Now, with the help of this component, you can retrieve data from the environment, find out the source of noises, and check if the AI was damaged by anything. Also, it defines how to respond when any sense has been detected. The next component is the learning component. Now, this learns from the captured data by the perception component. Here, the goal is to build computers that can be taught instead of programming them. Now, learning focuses on the process of self-improvement. In order to learn new things, the system requires knowledge acquisition, inference, acquisition of heuristics, faster searches, etc. Now, moving on to the next components, these are the main components in the cycle, that is, the knowledge representation and reasoning. Now, this shows the human-like intelligence in the machines. Knowledge representation is all about understanding intelligence. Instead of trying to understand or build brains from the bottom up, its goal is to understand and build intelligent behavior from the top down and focus on what an agent needs to know in order to behave intelligently. Also, it defines how automated reasoning procedures can make this knowledge available as needed. And finally, we have the planning and execution. Now, these components depend on the analysis of knowledge representation and reasoning. Here, planning includes giving an initial state, finding their preconditions and effects, and a sequence of actions to achieve a state in which a particular goal holds. Now, once the planning is completed, the final stage is the execution of the entire process. So, this was all about the cycle of knowledge representation in artificial intelligence. Now, let's move on and understand the relationship between knowledge and intelligence. So, what is this relation between knowledge and intelligence? In the real world, knowledge plays a vital role in intelligence as well as creating artificial intelligence. It demonstrates the intelligent behavior in AI agents or systems. Now, it is possible for an agent or system to act accurately on some input only when it has the knowledge or experience about the input. So, here is an example to understand this relationship better. So here there is one decision maker whose actions are justified by sensing the environment and using knowledge. But if we remove this knowledge part from here, it will not be able to display any intelligent behavior. So this is the relationship between a knowledge and intelligence. you need the knowledge in order to display any intelligent behavior. That is, for any intelligent system, you need knowledge first. So now that you know the relationship between knowledge and intelligence, let's move on to the techniques of knowledge representation in AI. Now, talking about the techniques, there are 4 techniques of representing knowledge. These 4 techniques include logical representation, semantic network representation, frame representation, and production rules. So, talking about the first one, logical representation is a language with some definite rules which deal with propositions and has no ambiguity in representation. It represents a conclusion based on various conditions and lays down some important communication rules. Also, it consists of precisely defined syntax and semantics which supports the sound inference. Each sentence can be translated into logics using syntax and semantics. So, what is the difference between a syntax and a semantic? Now, for syntax, it decides how we can construct legal sentences in logic, and it determines which symbol we can use in knowledge representation. Also, how to write those particular symbols. But when it comes to semantics, semantics are basically the rules by which we can interpret the sentence in the logic. Also, it assigns a meaning to each of these sentences. So let's talk about some of the advantages and disadvantages of this representation. Now, logical representation helps to perform logical reasoning. This representation is also the basis for the programming languages. These are some of the advantages of logical representation. Talking about the disadvantages, logical representations have some restrictions and are challenging to work with. Now, this technique may not be very natural and inference may not be very efficient. Now, talking about the next technique, we have the semantic network representation. Now, semantic networks work as an alternative of predicate logic for knowledge representation. Now, in semantic networks, you can represent your knowledge in the form of graphical networks. This network consists of nodes representing objects and arcs which describe the relationship between these objects. Also, it categorizes the object in different forms and links those objects. Now, the representation consists of 2 types of relation. First one is an is-a relationship, which is also known as the inheritance, and then we have another kind of relation. Now, talking about some of the advantages, semantic networks are a natural representation of knowledge. It also conveys meaning in a transparent manner, and these networks are simple and very easy to understand. But talking about the disadvantages, semantic networks take more computational time at runtime, and these are inadequate as they do not have any equivalent quantifiers. Also, these networks are not intelligent and depend on the creator of the system. So this was about the semantic network representation. Now let's move on to the next one, which is the frame representation. Now, a frame is a record-like structure that consists of a collection of attributes and values to describe an entity in the world. Now, these are the AI data structure that divides knowledge into substructures by representing stereotype situations. Basically, it consists of a collection of slots and slot values of any type and size. Slots also have names and values which are called the facets. Moving on to the advantages, it makes the programming easier by grouping the related data. Frame representation is easy to understand and visualize. Also, it is very easy to add slots for new attributes and relations. Also, it is easy to include default data and search for the missing values. Talking about the disadvantages, in frame system inference, the mechanism cannot be easily processed. The inference mechanism cannot be smoothly processed by the frame representation either. Also, it has a very generalized approach. Now, moving on to the final technique, we have the production rules. Now, in production rules, agent checks for the condition, and if the condition exists, then production rule fires and corresponding action is carried out. The condition part of the rule determines which rule may be applied to a problem, whereas the action part carries out the associated problem-solving steps. Now, this complete process is called a recognize act cycle. The production rule system consists of three main parts. The first one is definitely the set of production rules. Then we have a working memory, and finally the recognize act cycle. Now, talking about the advantages and disadvantages. First up is the advantages, where the production rules are expressed in natural language, and the production rules are highly modular and can be easily removed or modified. But talking about the disadvantages, it does not exhibit any learning capabilities and does not store the result of the problem for future users. Now, during the execution of the program, many rules may be active. Thus, the rule-based production systems are inefficient. So these were the four important techniques for knowledge representation in AI. So now let's have a look at the requirements for these representations. Now, a good knowledge representation system must have properties like the representational accuracy. It should represent all kinds of required knowledge. Also, it must have inferential adequacy. It should be able to manipulate the representational structures to produce new knowledge corresponding to the existing structure. It also must have the inferential efficiency. So, the ability to direct the inferential knowledge mechanism into the most productive directions by storing appropriate guides. Then finally, it must have the acquisitional efficiency as well. That is, the ability to acquire new knowledge easily using automatic methods. So these are some of the important requirements for the knowledge representation in AI. Now, let's understand some of the approaches of this knowledge representation with examples. So the first approach is a simple relational knowledge. Now, this is the simplest way of storing facts, which uses the relational method. Here, all the facts about a set of the object are set out systematically in columns. Also, this approach of knowledge representation is famous in database systems where the relationship between different entities is represented. Now, taking an example, you can see that we have three different columns like name, age, and employee ID, and we have three different names along with their age and employee IDs. So this is how you represent a simple relational knowledge. It is the simplest way of defining. You just have to take the name, age, and employee ID and define the relation. Moving on to the next approach, we have the inheritable knowledge. Now, in the inheritable knowledge approach, all data must be stored into a hierarchy of classes and should be arranged in a generalized form or a hierarchical manner. Also, this approach contains inheritable knowledge, which shows a relation between instance and class, and it is called the instance relation. Now, in this approach, objects and values are represented in boxed nodes. So here you can see the example where we have two different players, Danny and Peter, who plays two different games such as cricket and football. But they both are known as players and they both play for the under 19 teams. So you can see the relationship here. For Danny, cricket, and Peter, football, it's an instance. But when you compare the relationship of cricket, football with the player and the under 19, it's a is a relationship, which is also the inheritance. Now, the final approach is the inferential knowledge. Now, the inferential knowledge approach represents knowledge in the form of formal logic. Thus, it can be used to derive more facts. Also, it guarantees correctness. So here, if we take an example, you can see that we have first statement, which is John is a cricketer. Then we have another statement which says all cricketers are athletes. So you can also represent this as cricketer, who is John, and give the relationship as cricketers are athletes. So here you are checking out the relationship between John, cricketer, and athletes. And also this helps you and guarantees correctness in your relationship. So this is the final approach, which is the inferential knowledge. And these were some of the important approaches along with their examples that you need to know for knowledge representation in AI.
So what is hill climbing? Now, hill climbing is a heuristic search used for mathematical optimization problems. It is used in the field of artificial science. And basically, this means that if you're given a large set of inputs and a good heuristic function, heuristic as in self-learning function, it tries to find a sufficiently good solution to the problem. Now, this solution may not be the global optimal maximum or the best solution for the problem, but it's basically the best possible solution in a very reasonable period of time. This implies that hill climbing solves the problems where we need to maximize or minimize a given real function by choosing values from the given inputs. A very good example of this is the traveling salesman problem, where you need to minimize the distance traveled by the salesman. Now, the flowchart for hill climbing looks something like this. First of all, you select a current solution, you evaluate that solution, then you pick up a neighboring point or solution, you evaluate the point that you just picked up, then you make a decision, is your new solution better than the original solution? If yes, you select the new solution as the current solution and then carry on the same method. And if no, if your original solution is better, then again you go back to your step 2. You select a new solution from the neighborhood and then you evaluate X, and this goes on and on. Now, what you see on your screen right now is the algorithm, which is corresponding to the flowchart that I just showed. Basically, as you can see, it is somewhat like a generate and test algorithm, but it somewhat uses a greedy approach to reach a solution. Okay. Now, you need to understand what the generate and test algorithm is. So, as I mentioned, hill climbing is a variant of the generate and test algorithm. So first what it does is it generates possible solutions, then it tests that solution or evaluates it to see if it is the expected solution. If the solution has been found, then it quits the loop, else it goes back to step 1 and selects a new current solution. It's pretty simple, isn't it? Hence, we can call hill climbing as a variant of generate and test algorithm, as it takes feedback from the test procedure and then the feedback is utilized by the generator in deciding the next move in the search space. Another feature is that it uses the greedy approach. So basically, at any point in the state space, the search moves in a direction only which optimizes the cost of the function with the hope of finding an optimal solution at the end. So basically, it's going to take the best possible way to reach a solution. Now, this is a state space diagram of hill climbing. There are different regions in this state space diagram. Now, for those of you who do not know what state space diagram is, it is a graphical representation of a set of states that our search algorithm can reach versus the value of the objective function. The objective function meaning the function which we wish to maximize or minimize. Now here the x-axis denotes the state space, that is the state or configuration of our algorithm, and y-axis denotes the values of objective function which is corresponding to a particular state. The best solution will be the state space where the objective function has maximum value or the global maximum. Now there are different regions in this diagram. First of all, this is our current state. It is the region in the state space diagram where we are currently present during the search. Pretty self-explanatory, isn't it? Next, you have the global maxima. Now, this is the best possible state in the state space diagram. It is because that at this state, the objective function has reached its maximum value. Next is the local maxima. Now, this is a state which is better than its neighboring states. However, there exists a state which is better than this particular maxima, which is the global maxima. Obviously, we've just discussed it. This state is better because here the value of the objective function is higher than its neighbors. But obviously, we know it is not the best possible solution. Given reasonable time, this is a good enough solution. Okay, another kind of maxima is a flat maxima. Yes, it is also known as a plateau. Now, it is a flat region of a state space where the neighboring states have the same value. As you can see, it is a straight line. Neighboring points are also on the same level. Then there is something you can see in the beginning. It's called a ridge. It is a region which is higher than the neighbor, but it itself is a slope. It's a special kind of local maximum. And apart from that, that area in the front is a shoulder. Now, if the plateau would not have descended from its sharp point and gone up, it would have been called something known as a shoulder. It's basically an uphill edge from the plateau. Yes, with that, we've come to the end of the introduction section. Let's move on to types of hill climbing. So first of all, we have simple hill climbing. Now, simple hill climbing is the simplest way to implement a hill climbing algorithm. It only evaluates the neighbor node state at a time and selects the first one which optimizes the current cost and sets it as a current state. It only checks its one successor state, and if it finds that it is better than the current state, then it moves to the next state, else it will be in the same state. It is less time consuming than the other types of hill climbing, but it also gives a less optimal solution, and the solution is not guaranteed. Now here is the algorithm for simple hill climbing. First, you evaluate the initial state. If it is the goal state, then you get success and stop. Step 2. You have to loop until a solution is found or there is no new operator left to apply. Step 3. You select and apply an operator to the current state. And finally, you check the new state. Now, if the new state is a goal state, then you return success and quit. Else, if it is better than the current state, then assign new state as the current state. Or else, if it is not better than the current state, then you return to step 2. And finally, you exit that loop. As I said, this might be less time consuming, but it also gives the less optimal solution, and the solution is not guaranteed. Next, you have the steepest ascent hill climbing. Now, this algorithm is a variation of the simple hill climbing algorithm, where it examines all the neighboring nodes of the current state and selects one neighbor node which is closest to the goal state. Now, this algorithm consumes more time as it searches for multiple neighbors. So first, you evaluate the initial state. If it is the goal state, then you return success and stop. Else, you make the state, which is currently where you are, as the initial state. Pretty simple. It is much like the previous type of hill climbing. Next, you loop until a solution is found or the current state does not change. Now, the conditions to this are many. So let's start with the first one. Let success be a state such that any successor of the current state will be better than it. Next, for each operator that applies to the current state, first apply the new operator and generate a new state. Evaluate the new state. If it is the goal state, then return it and quit, else compare to success state. Now, if this is better than the success state, then set this as the new state of success. If success is better than the current state, then set current state to success. And then you can exit. Now, what this does is it takes more time, but since it is more complex, you are most likely to get a better solution. Now, apart from these two, there's a third kind of hill climbing. It is the stochastic hill climbing. Now, this algorithm does not examine for all its neighbors before moving. Rather, the search algorithm selects one neighbor node at random and decides whether to choose it as a current state or examine another state. That is it. It does not go around searching the entire graph for a better node. It just picks up points at random and decides to choose whether it is a better solution or not. Now, a great way to optimize this particular type of hill climbing is to take as many possibilities in the bracket as possible. It might take time, but this guarantees you a better solution. So as we discussed, hill climbing is the most simple implementation of a genetic algorithm. It completely gets rid of concepts such as population and crossover. Instead, it focuses on the ease of implementation. It has faster iterations compared to most traditional genetic algorithms, but in return, it is less thorough, obviously. So even though it is not a challenging problem, Hello World is still a pretty good introduction. So that is what we are going to do, and we are going to execute it using Python code. So how does it work? Hill climbing works in a very simple way. We can actually show it in a step-by-step list. So you start out with an empty or a random solution. This is your best solution. Make a copy of the solution and mutate it slightly. Now what you do is you evaluate this new solution. If it is better than the best solution, we replace the best solution with this one. If not, you go to step 2 and repeat. So basically, to evolve a solution to a problem, you need to write 3 functions. You write a random solution, you evaluate the solution and return a score, and you mutate the solution in a random manner. Pretty easy, isn't it? So for Hello World, let's start with a basic outline of the hill climbing algorithm. Here you are trying to generate a random solution and you're naming it the best solution. Next, in your while loop, you're trying to print the best scores so far while comparing your new solution to the previously best solution that there is. Next, we are generating a random solution. This function needs to return a random solution, and in the hill climbing algorithm, you make this a separate function. Now, making this a separate function might be too much abstraction, but if you want to change the structure of your code to be a population-based genetic algorithm, it will be very helpful. So here again, we are giving a parameter of the length equal to 11 to generate the random solution. And then we are returning the string that we are getting. Next, you evaluate the solution. The target of our algorithm is producing the string hello world, so our evaluation function is going to return a distance metric between two strings. Now this is a simple way to do it. The function here will return the absolute difference of our solution to the target. And finally, you mutate the solution. Now in genetic algorithms, mutating a solution basically means randomly changing it in a small way. In the context of this particular code, this means that you change one of the letters randomly. So that is what is happening in this piece of code. Now one last thing we need before our code is ready is the copy function, but our solution is just a list of characters which is easily copied in Python. So let's get all of this code together, tie it all together in a state that is ready to run. Now this is what the code looks like when you tie it all together. I'm using a trusty Jupyter notebook. For a complete Jupyter notebook tutorial, you can refer to the link given in the description bar. So now let's move on to our code. As you can see, all the parts are there. We're starting out with generating a random solution, then evaluating that particular solution, mutating that solution to generate the best random solution. And here is our base code. Now let's bring it here and let's try to run it. Here we are running all the cells one by one. And once you run it, you should be greeted with this particular output. See how it is randomly changing the best scores so far till you finally reach the solution that you were waiting for, and that is hello world. It's right here. It starts out with these random solution. It has taken 433 attempts to reach to our ideal solution. And that, my friends, is how the hill climbing algorithm works. Moving on, let's look at a few complexities and problems in different regions in hill climbing. Now, hill climbing cannot reach the optimal best state, global maximum, if it enters any of these following regions. First up, we have local maximum. At a local maximum, all neighboring states have values which is worse than the current state. So since hill climbing uses a greedy approach, it will not move to the worst state, and it will definitely terminate itself at the local maximum. The process will end even though a better solution may exist. Now, to overcome such a problem, you can utilize a backtracking technique. Maintain a list of visited states, and if the search reaches an undesirable state, it can backtrack to the previous configuration and explore a new path. Next, it's a plateau. Now, on a plateau, all the neighbors have the same value. Hence, it is not possible to select the best direction. Now, to overcome this problem, what you do is you make a big jump. Randomly select a state far away from the current state, and chances are that you will land at a non-plateau region. Next is a ridge. Now, any point on a ridge can look like a peak because movement in all possible direction is downwards. Hence, the algorithm stops where it reaches this state. Now, to overcome this problem, use 2 or more rules before testing. It implies moving in several directions at once to test which one is the best direction. Now, let's move on to a few applications of the hill climbing algorithm. Now, the hill climbing technique can be used to solve many problems, where the current state allows for an accurate evaluation function, such as the network flow, traveling salesman problem, 8 queens problem, and integrated circuit design. Hill climbing is used also in inductive learning methods. It can be used in robotics for coordination amongst multiple robots in a team. And these are only to name a few.
The first artificial intelligence project is Chatbot. Now, Chatbot is an AI software that can start a conversation or a chat with a user through messaging application, websites, mobile apps, or even through calls. Chatbots are increasingly becoming popular. Many companies' websites use chatbots to communicate with their customers. It's been used in almost all the fields, be it education, medical, IT, and even in banking websites, now they're using chatbots. For example, EVA by HDFC Bank. Now, if you're a beginner, then you can program a simple version of a chatbot. There are many chatbots available online. Just learn from them, identify the basic structure, and then build your own chatbot using that structure. You can then enhance it using your creativity and make it better. So this was the first AI project. The next AI project idea is music recommendation app. Now, due to AI, music recommendation app, which can also be known as music recommended engine, makes it quicker and easier to show the music recommendation that are tailored to each user's interests and preferences. Now, how does this work? So first, it basically collects all the data, which is what the songs the user listens to the most, what is the genre of the song, which language that the user listens to, and so on. Next, it stores all this data and then analyzes it. It then recommends songs from the similar genres and the same language and the songs which have high ratings. You would have seen this in apps like Spotify or Wing, where they have the entire section of songs recommendation for you. So using artificial intelligence, online searching is improving as well, since it makes recommendation related to the user's visual preferences rather than a project description. You can program this music recommendation app by learning from some online blogs or watching some YouTube videos. The next project idea is stock prediction. Now, many people invest in stocks, and they need a stock predictor in order for them to know when to buy the stock. Now, although it is impossible to predict the future, we can make an estimation or guesses and an informed forecast based on the data we have in the present and the past regarding the stocks. This is known as technical analysis, which is used to predict the stock's price direction. Will it increase or decrease after a particular time? So for your project, you can create an application that analyzes the trend of the stock market and offers data-driven insights. You can start off by keeping your stock prediction cycle small and then go on and try for higher values and insights. Also, if you design a good stock prediction application, there'll be a great value and demand for such system and it will make your career. Now moving on to a fourth AI project idea, which is social media suggestions. Now, artificial intelligence has been used in all popular social media networks that we use on a day-to-day basis. Like for example, Facebook uses AI and advanced machine learning to serve you all the content based on your preferences and to recognize people's faces in photos, so you can tag them basically, and also target users for the right advertisement. Also, Instagram, which is owned by Facebook, uses artificial intelligence to identify visuals. Next, LinkedIn uses artificial intelligence to offer job recommendation based on your qualification and interest. It also suggests people to connect with. This also happens in Facebook. So these were just some of the examples of how social media uses artificial intelligence. Now, AI-powered research platform analyze a variety of social media analytics to understand which accounts can provide the most engagement, reach, and influence for a specific industry. So for your project, you can do any of the following tasks, like suggest your users to connect with people they might know, or suggest them some content they might like to watch, or suggest some product they might be interested in, and so on. So this was the social media suggestion project. So now let us move on to the next project idea, which is to identify inappropriate language and hate speech. Now this project sounds easy, but it is quite hard to identify all the hate speeches and inappropriate language. There are many companies like Facebook, Twitter, and YouTube who are trying to create a system like this. So for your project, you can use detection techniques which identify the characters in a context and then compares it to the content that has already been removed as hate speech. Now usually this would be used for identifying any hate speech in any post, like Facebook or Twitter post. So design an artificial intelligence system that looks into things like the text in a post, the reaction and comment to the post, and how closely it matches the common phrases of a hate speech. Also, if it contains at least one appropriate word, then identify those words and report them. So this could be one of your AI project. Now let us move on to the next AI project, which is lane line detection. Now many of you know that self-driving cars are gaining a lot of popularity. Now as a beginner, it would be very hard to design this, but you can design a part of it which is lane line detection while driving. This lane line detection technique is used by many self-driving autonomous vehicles as well as line following robots. So you can use computer visual techniques and AI to teach the vehicle to go in a particular lane. You can use computer vision techniques such as color thresholding to detect the lane. So usually the lanes are colored in white color, and usually there are double lanes in the middle of the road which separates the direction the vehicle runs in. Then there is usually one white line at the end of the road, after which is the edge of the road. Using all this data, you can design an AI-powered system that detects the lane lines. Now let us move on to our next project idea, which is monitoring crop health. Artificial intelligence has been increasingly adopted as a part of agriculture industry evolution. Using AI, you can perform predictive analysis to determine what is the right date for sowing the seed to obtain maximum yield after the previous harvest. You can also get insights on the crop health, soil health, the fertilizer recommendation, and also the next 7 days weather forecast. So you can create a project which uses artificial intelligence to monitor the health of the crop and check for disease by using various images of the plant that has the same disease. So when a user collects the image of a plant, it will be matched with the images that has already been stored and then diagnose the particular disease, and then even maybe provide an intelligent spraying technique and treatment automatically. Our next project idea is using AI for medical diagnosis. AI has been used in medical industry for analyzing risk, identifying hotspot and chronic diseases, and accounting for social determinants of health. So for your project, you can use artificial intelligence to develop a software that can be programmed to accurately spot signs of a certain diseases in medical images such as MRI scans or X-rays and CT scans. For example, you can design a system that uses artificial intelligence for cancer diagnosis by processing photos of skin lesions. This project can be very helpful to diagnose patients more accurately and also prescribe the most suitable treatment. The next project idea is AI-powered search engine. You can design a search engine which is powered by artificial intelligence, which will scan billions of content available on the web and match the exact search sentence or keyword and will show the relevant information, images, videos, text, and other documents. You can also use ranking algorithms that will rank the content for a particular keyword based on various factors like engagement rate, that is for how long that the user spends on that website, is the content from a reliable website, and so many factors. To do this project, you can refer some online blogs or watch some videos to get started. Also for this project, you need to know a little bit about networks and how the data passes on the internet from one place to another. So this was about the AI-powered search engine. Now let us move on to our next project idea, which is AI-powered cleaning robots. Today's artificial intelligence-powered robots possess no natural general intelligence, but are capable of solving problems and thinking in a limited capacity. You can design a robot that uses artificial intelligence to clean a room by scanning the room size, identifying obstacles, and remembering the most effective routes for cleaning. For starters, you can design a robot that does only one of these things. Then you can enhance it until it effectively cleans the entire room properly. The next AI project idea is house security. Now, this is a very interesting project. For this project, you can design a system that uses artificial intelligence to scan and identify the face of the visitor. First, the facial structure of the family members or someone who frequently visits the house can be scanned and stored. So every time a visitor comes near the gate, the system can scan the face, and if it matches the existing facial structure that is stored in the database, it can open the door and allow the person to pass. Else, the gate can remain shut and the people living in the house can be notified that the person is waiting outside. The next project idea is handwritten notes recognition. Handwriting note recognition refers to the computer's ability to detect and interpret alphabets and numbers. These inputs could be from various sources like paper document, notes on the phone, photos, and other sources. Note that handwriting characters remain complex since different individuals have different handwriting styles. So you can develop a system that uses artificial intelligence to scan the handwriting notes and convert them into digital format. You can use the artificial neural network, which is a field of study in artificial intelligence, to design the system. The next AI project idea is loan eligibility prediction. Nowadays, one of the major problems banking employees face in this ever-changing economy is the increasing rate of loan defaults. So the employees are finding it difficult to correctly access loan requests and decide whom to give loan and whom not to. So in order to determine whether an individual should be given a loan or no, you can create an AI program that will check a person's loan eligibility criteria by accessing certain attributes of an individual such as the salary, the previous loan details, and so on, and then make a decision to approve a loan or not. This program will make the process a lot more easier by selecting suitable people from a given list of candidates who have applied for loan. So this was about loan eligibility prediction project idea. So now let us move on to our next project idea, which is AI powered voice assistant. So this is one of the interesting artificial intelligence project idea. You can create a voice-based personal assistant using artificial intelligence. So for this, you have to train the system to understand human language, so it can understand and save the command in the database. So next time you give the same command, it will identify the words and perform the necessary action. This can be very helpful and you can enhance it to do various activities like searching for some information or item on the web, setting alarms, taking down notes, calling someone, playing songs, and many more. The next AI project idea is e-commerce recommendation engine. So in this project, you can build an e-commerce recommendation engine using the similarities among the background information of the items or users to propose the recommendation to the user. So in this project, you can build an e-commerce recommendation engine using the similarities among the background information of the items or users to propose recommendation to the user. So for example, if the user has searched for Apple phones, then you can design a recommendation engine that recommends only Apple phones to the user. Now, the other way to do this is you can identify the trends and patterns in the previous and other user item interaction and advise similar recommendation to the present user based on his existing interactions. So an example for this would be if a person has bought a formal shirt, then you can design your recommendation engine to recommend more formal clothing and accessories. You can use artificial intelligence to recommend the user what exactly they need. The next AI project idea is AI-enabled maps. With artificial intelligence, you can create a project that scans the road information and uses algorithm to determine the optimal route to take in order to reach the destination faster. Also to determine which mode of transportation is the best to go to a destination. It could be on foot or in a car, bike, bus or train. We can also use advanced artificial intelligence in the program by implementing voice assistant that will guide the users about the turns, the potential roadblocks, traffics, and create augmented reality map in real time. The next AI project idea is emotion detection. Now, everything that's happening in a science fiction movie could be a future. There are varieties of fields where artificial intelligence is used. One such area of interest is detecting human emotions. There are many top companies investing a lot of money in doing this. So you can design a facial emotion detection and recognition system that can be used to identify human facial expressions. So for this, first the system would have to analyze the facial expression for some time and then perform facial feature extraction and classify the facial expression. For starters, you can design the system to identify only one expression, maybe just happy or normal. Then you can enhance it and try for different emotions. The next AI project idea is AI Health Engine. You can create a project that will use artificial intelligence to give personalized health guidance to a user. The user must provide all the medical reports, and based on that, the artificial intelligence system will check for any pre-existing condition, ongoing health concerns, and gaps in general health knowledge. Then the health engine could be programmed to combine both the personal data of the users and the external health data to provide informed advice to the user. It can also help the users with prescription support, vaccination advice, recommended doctor visits, and specific condition guidance. So this was about AI Health Engine project. Now let us move on to our next project idea, which is trying on online clothes and accessories. Now you would have already seen this feature if you ever visited the Lenskart app. For your project, you can design an artificial intelligence system that takes the input image and computes the person's body model, which would represent their posture and their shape. The segments can then be selected on which the dresses are going to be displayed on, like for example, shirt on the body, gloves for hands, and so on. And then when the user chooses a particular dress, the system can combine them with the body model and update the image's shape representation. Our 20th AI project idea is spam email detection. Spam email detection means detecting emails that are irrelevant to the user by understanding the text content of the email. You can create a project that uses artificial neural network to detect and block spam emails. Also, the newsletter or updates or any ad, we can also enhance it. Let's say the newsletters or updates or any ads which are received from emails can be liked by one person but disliked by another. So you can include this feature using artificial intelligence that will filter the email based on the individual user preferences.
A lot of us are paranoid about how artificial intelligence might negatively impact our lives. However, the present picture is thankfully more positive. I'll be discussing how AI has impacted various fields like marketing, finance, gaming, agriculture, and so on. So let's explore how artificial intelligence is helping our planet and at last benefiting humankind. So at number 10, we have artificial intelligence in artificial creativity. Now, have you ever wondered what would happen if an artificially intelligent machine tried to create music and art? Here's a short audio clip of a classical piece. So this short audio was composed by an AI-based system called MuseNet. Now, MuseNet is a deep neural network that can generate 4-minute musical compositions with 10 different instruments and can combine styles from country to Mozart and to the Beatles. MuseNet was not explicitly programmed with an understanding of music, but instead it discovered patterns of harmony, rhythm, and style by learning on its own. Another creative product of artificial intelligence is a content automation tool called Wordsmith. Wordsmith is a natural language generation platform that can transform your data into insightful narratives. Tech giants such as Yahoo, Microsoft, and Tableau are using Wordsmith to generate around 1.5 billion pieces of content every day. Let's move on to our next field, which is AI in social media. Now, ever since social media has become our identity, we've been generating an immeasurable amount of data through chats, tweets, posts, and so on. And whenever there's an abundance of data, AI and machine learning are always involved. In social media platforms like Facebook, artificial intelligence is used for face verification, wherein machine learning and deep learning concepts are used to detect facial features and tag your friends. Deep learning is used to extract every minute detail from an image by using a bunch of deep neural networks. Machine learning algorithms are used to design your feed based on your interests. Another such example is Twitter's AI, which is being used to identify hate speech and terroristic language in tweets. It makes use of machine learning, deep learning, and natural language processing to filter out offensive content. According to a recent survey, the company discovered and banned 300,000 terroristic linked accounts, 95% of which were found by non human, artificially intelligent machines. Moving on to our next field, we have AI in chatbots. Now, these days, virtual assistants have become a very common technology. Almost every household has a virtual assistant that controls the home. A few examples include Siri, Cortana, which are gaining popularity because of the user experience they provide. Amazon's Echo is an example of how AI can be used to translate human language into desirable actions. This device uses speech recognition and natural language processing to perform a wide range of tasks on your command. It can do more than just play your favorite songs. It can be used to control the devices at your house, book cabs for you, make phone calls, order your favorite food, check the weather conditions, and so on. Another example is a newly released Google's virtual assistant called Google Duplex that has astonished millions of people. Not only can it respond to calls and book appointments for you, it adds a human touch. It uses natural language processing and machine learning algorithms to process human language and perform tasks such as manage your schedule, control your smart home, make reservations, and so on. Next, we have artificial intelligence in autonomous vehicles. For the longest time, self-driving cars have been a buzzword in the AI industry. The development of autonomous vehicles will definitely revolutionize the transportation system. Companies like Waymo conducted several test drives in Phoenix before deploying their first AI-based public ride-hailing service. The artificial intelligence system collects data from the vehicle's radar, cameras, GPS, and cloud services to produce control signals that operate the vehicle. Advanced deep learning algorithms can accurately predict what objects in the vehicle's vicinity are likely to do. This makes Waymo cars much more effective and safer. Another famous example of autonomous vehicles are Tesla's self-driving cars. AI implements computer vision, image detection, and deep learning to build cars that can automatically detect objects and drive around without human intervention. Elon Musk, the founder of Tesla, talks a ton about how AI is implemented in Tesla's self-driving cars and autopilot features. He quoted that Tesla will have fully self-driving cars ready by the end of the year and a robo-taxi version, one that can ferry passengers without anyone behind the wheel. Tesla's autopilot software goes beyond driving the car where you tell it to go. If you're not in the mood for talking, autopilot will check your calendar and drive you to your scheduled appointment. That sounds pretty amazing. Moving on to our next application, we have applications of artificial intelligence in space exploration. So this is one of the most interesting fields in which artificial intelligence is being implemented. Space expeditions and discoveries always require analyzing vast amounts of data. Artificial intelligence and machine learning is the best way to handle and process data of this scale. So, after rigorous research, astronomers use artificial intelligence to go through years of data obtained by the Kepler telescope in order to identify a distant 8-planet solar system. This was accomplished by using AI technology. Artificial intelligence is also being used for NASA's next rover mission to Mars, which is the Mars 2020 rover. The Aegis, which is an AI-based Mars rover, is already on the red planet. The rover is responsible for autonomous targeting of cameras in order to perform investigations on Mars. This proves how far AI has reached. Moving on to our next field, artificial intelligence in the gaming field. Over the past few years, artificial intelligence has become an integral part of the gaming industry. In fact, one of the biggest accomplishments of AI is in the gaming industry. I'm sure all of you have heard of DeepMind's AI-based AlphaGo software. DeepMind's AI-based AlphaGo software, which is known for defeating Lee Sedol, the world champion in the game of Go, is considered to be one of the most significant accomplishments in the field of artificial intelligence. Shortly after the victory, DeepMind created an advanced version of AlphaGo called the AlphaGo Zero, which in turn defeated AlphaGo in an AI to AI face-off. Unlike the original AlphaGo, which DeepMind trained over time by using large quantities of human knowledge and supervision, the advanced system AlphaGo Zero taught itself to master the game. Other examples of AI in gaming include the First Encounter Assault Raccoon, which is popularly known as Fear, is basically a first-person shooter video game. So what makes this game special? The actions taken by the opponent AI are unpredictable because the game is designed in such a way that the opponents are trained throughout the game and never repeat the same mistakes. So basically, they get better as the game gets harder. This makes the game very challenging and prompts the players to constantly switch strategies and never sit in the same position. Moving on to our next application, we have artificial intelligence in banking and finance. We all know that trading mainly depends on the ability to predict the future accurately. Machines are great at this because they can crunch a huge amount of data in a short span. Machines can also learn to observe patterns in past data and predict how these patterns might repeat in the future. An example of this is Japan's leading brokerage house, Nomura Securities, which has reluctantly been pursuing one goal, that is to analyze the insights of experienced stock traders with the help of computers. So after years of research, Nomura is set to introduce a new stock trading system. The new system stores a vast amount of price and trading data in its computer. By tapping into this database of information, it will make assessments. For example, it may determine that current market conditions are similar to the conditions 2 weeks ago and predict how share prices will be changing a few minutes down the line. This will help to make better trading decisions based on the predicted market prices. AI in banking is growing faster than you thought. A lot of banks have already adopted artificial intelligence-based systems to provide customer support, detect anomalies, and credit card frauds. An example of this is HDFC Bank. HDFC Bank has deployed an AI-based chatbot called EVA, which stands for Electronic Virtual Assistant. Since its launch, EVA has addressed over 3 million customer queries, interacted with over 500,000 unique users, and held over 1 million conversations. EVA can collect knowledge from thousands of sources and provide simple answers in less than zero point 0.4 seconds, which is quite impressive. Moving on to our next field, we have artificial intelligence in agriculture. Now, here's an alarming fact. The world will need to produce 50% more food by 2050 because we're literally eating up everything. The only way this can be possible is if we use resources more carefully. With that being said, artificial intelligence can help farmers get more from the land while using resources more sustainably. Blue River Technology has developed a robot called See and Spray, which uses computer vision technologies like object detection to monitor and precisely spray weedicide on cotton plants. Precision spraying can help prevent herbicide resistance. Apart from this, the Berlin-based agriculture tech startup called Peat has developed an application called Plantix that identifies potential defects and nutrient deficiencies in soil by using images. The image recognition app identifies possible defects through images captured by the user's smartphone camera. Users are then provided with soil restoration techniques, tips, and other possible solutions. The company claims that its software can achieve pattern detection with an estimated accuracy of up to 95%. So, the next field we're going to talk about is artificial intelligence in healthcare. When it comes to saving our lives, a lot of organizations and medical care centers are relying on AI. There are many examples of how AI in healthcare has helped patients all over the world. IBM's Watson for Health is helping healthcare organizations apply cognitive technology to unlock vast amounts of health data and power diagnosis. IBM has also developed AI software specifically for medicine. More than 230 healthcare organizations worldwide use IBM Watson technology. Google's DeepMind Health is another such example that is working in partnership with clinics, researchers, and patients to solve real world healthcare problems. DeepMind has successfully developed a system that can analyze retinal scans and spot symptoms of sight threatening eye diseases. The technology combines machine learning and systems neuroscience to build powerful general purpose learning algorithms into neural networks that mimic the human behavior. Finally, we have artificial intelligence in marketing. We all know that marketing is a way to sugarcoat your product in order to attract more customers. We humans are actually quite good at sugarcoating, but what if an algorithm or a bot is built solely for the purpose of marketing a brand or a company? It would do a pretty awesome job. For example, let's consider the recommendations provided by Amazon. It's a known fact that 35% of Amazon's revenue is generated by its recommendation engine. Amazon makes use of AI and machine learning to recommend products to their customers. It uses recommendations as a targeted marketing tool to increase their revenue. There are different ways through which Amazon recommends products to you. For example, if you open up Amazon right now, you'll see a few sections like these, right? You'll see something known as your recently viewed items and featured recommendations. Here, Amazon looks at the products that you've been browsing and recommends very similar products to you. You'll also see a section like customers who bought this item also bought this. Here, Amazon studies the shopping behavior of customers who have a similar shopping trend and displays items that have been purchased together in the past. All of this is carried out by using artificial intelligence and machine learning algorithms. Another famous example of recommendation systems is Netflix. Netflix uses machine learning to recommend movies to you based on the data it collects about you, such as your browsing history, your age, your location, and so on. It is also a known fact that over 75% of what you watch is recommended by Netflix. And what is the logic behind Netflix? It is machine learning, artificial intelligence, and deep learning.
Artificial intelligence was coined in 1955 to introduce a new discipline of computer science. It is rapidly and radically changing the various areas of our daily lives as the market for AI technologies is demanding and flourishing. Now, there is a significant race between many startups and internet giants to acquire them. Now, as we all know, artificial intelligence is expanding and growing every day. It's literally taking over every sector, or it's spreading over every possible industry right now. So let's have a look at the top most trending technologies of AI. So on number 10, we have the robotic process automation, or the RPA. Now, robotic process automation refers to the functioning of corporate processes due to the mimicking human tasks and automate them. Now, in this particular sphere, it is important to bear in mind that AI is not meant to replace humans, but to support and complement their skills and talent. Now, companies like Pegasystems, Automation Anywhere, Blue Prism, UiPath, WorkFusion Focus, etc. work on these. Now, RPA along with AI takes care of customer service, accounting, financial services, healthcare, human resources, supply chain management, and a lot more. But these are definitely some of the important aspects of the robotic process automation. Now let's move on to the next one. So on number 9, we have text analytics and NLP. Now, natural language processing, or the NLP, focuses on the interactions between human languages and computers. It uses text analytics to analyze the structure of sentences as well as their interpretation and intention through machine learning. Now, this technology is widely adopted in fraud detection and for security systems. Many automated assistants and applications derive unstructured data by NLP. Now, some of the service providers in this aspect include the Basis Technology, Expert System, Covio, Indico, Nime, Mindbreeze, etc. Now, no wonder these terms make it to the top 10 trending artificial intelligence technologies list. So now let's check out what's on number 8. Here we have biometrics. Now, biometrics is definitely a very common term to all of us right now because we use our fingerprints or the biometrics and also face detection in order to unlock our phones, laptops, etc. Now, biometrics deals with the recognition, measurement, and analysis of the physical features of the body's structure, form, and human behavior. It fosters organic interactions between machines and humans as it works with touch, image, speech, and body language. Also, it is predominantly used for the purpose of market research. Now, VR, Effectiva, Ignicio, Phase First, Sensory, Tazo, all of these provide these technology service. So this was about biometrics. Now moving on number 7 we have cyber defense. Now this is definitely one of the trending technologies AI because it is one of the most important ones with the increasing number of cyber attacks. So cyber defense has become very important in order to save our systems and also our confidential data. Now, cyber defense is a computer defense mechanism that aims to detect, prevent, and mitigate attacks and threats to data and infrastructure of systems. Neural networks that are capable of processing sequences of inputs can be put to use along with machine learning techniques to create learning technologies in order to reveal suspicious user activity and detect cyber threats. So this was about cyber defense. Now on number 6 we have decision management. Now, artificially intelligent machines have the capability of introducing logic to AI systems in order to gear them up to be used for training, maintenance, and tuning. Now, in order to add value to the business and profitable, decision management is already being used by organizations by incorporating it into their applications to propel and execute automated decisions. Some companies that provide this service are the Informatica, Advanced Systems Concepts, Pegasystems, UiPath, etc. Now next up on number 5 we have the marketing automation. Marketing has definitely become one of the most popular strategies for anything that you produce, create or build right now because the right kind of marketing can make your product successful. Now marketing automation just makes this work simpler and better. Now, the marketing and sales teams and divisions have adopted AI and benefited a lot from it in return. Methods incorporating AI through automated customer segmentation, customer data integration, and campaign management are widely used. The edX AI has grown to become a pioneer in adopting these marketing automation technologies. And in the coming days, definitely most of the companies will only rely on the marketing automation. And that's exactly what makes it one of the most trending technologies in AI. Now, next up on number 4, we have digital twin. This is one of the newest and very interesting concept of artificial intelligence. Now, digital twins are just virtual replicas of physical devices that data scientists and IT pros can use to run simulations before actual devices are built and deployed. They are also changing how technologies such as IoT, AI, and analytics are optimized. Now, digital twin technology has moved beyond manufacturing and into the emerging worlds of the IoT, artificial intelligence, and data analytics. As more complex things become connected with the ability to produce data, having a digital equivalent gives data scientists and other IT professionals the ability to optimize deployments for peak efficiency and create other what-if scenarios. Now moving on to the next one, On number 3, we have the Industrial IoT or the IIoT. Now, IIoT, which is the Industrial Internet of Things, refers to the extension and use of the Internet of Things in industrial sectors and applications. The IIoT encompasses industrial applications including robotics, medical devices, and software-defined production processes. Now, both IoT and IIoT have the same main characteristic of availability, intelligence, and connected devices. The only difference between those two is their general usages. While IoT is most commonly used for consumer usage, IIoT is used for industrial purpose such as manufacturing, supply chain monitor, and management system. This technology is definitely for the advanced industries and thus one of the most trending technologies in AI right now. Now, on number 2, we have virtual agents. This is definitely very common to all of us because in our everyday life, while booking a flight ticket or ordering a food, anytime we need any help, we are actually talking to virtual agents online. Now, a virtual agent is basically a computer-generated, animated, artificial intelligence virtual character that serves as an online customer service representative. It leads an intelligent conversation with users, responds to their questions, and also performs adequate non-verbal behavior. The introduction of virtual agents have been very helpful as it has reduced the work of human beings and also they provide assistance anytime and anywhere. So this was about the virtual agents. Now moving on number 1 we have augmented reality. This is definitely one of the most fascinating technologies in AI right now. So augmented reality is actually an interactive experience of a real world environment where the objects that reside in the real world are enhanced by computer generated perceptual information, sometimes across multiple sensory modalities including visual, auditory, haptic, and olfactory as well. Now, basically, augmented reality is a technology that superimposes a computer-generated image on a user's view of the real world, thus providing a composite view of what is happening. Now, when we compare a VR and AR, VR implies a complete immersion experience that shuts out the physical world. That's why it's also called as the virtual reality. But in case of AR, that is augmented reality, it adds digital elements to a live view, often by using the camera on a smartphone.
At number 1, we have increased automation. Artificial intelligence can be used to automate anything ranging from tasks that involve extreme labor to the process of recruitment. That's right, there are n number of AI-based applications that can be used to automate the hiring or the recruitment process. Such tools help to free the employees from tedious manual tasks and allow them to focus on complex tasks like strategizing and decision making. An example of this is the conversational artificial intelligence recruiter called MYA. This application focuses on automating tedious parts of the recruitment process such as scheduling, screening, and sourcing. MYA is trained by using advanced machine learning algorithms, and it also uses natural language processing to pick up on details that come up in a conversation. It is also responsible for creating candidate profiles, performing analytics, and finally shortlisting applications. It is a known fact that automating the recruitment process reduces time to hire by 50% and helps in finding key hires that impact profitability and growth. Our next benefit is increased productivity. Artificial intelligence has become a necessity in the business world. It is being used to manage highly computational tasks that require maximum effort and time. Did you know that 64% of businesses depend on AI-based applications for their increased productivity and growth? An example of such an application is a legal robot. I call it the Harvey Specter of the virtual world. This bot uses machine learning techniques like deep learning and natural language processing to understand and analyze legal documents, find and fix costly legal errors, collaborate with experienced legal professionals, clarify legal terms by implementing a AI-based scoring system on multiple scales. It also allows you to compare your contract with those in the same industry in order to make sure that yours is a standard document. Moving on to our next benefit, AI helps us in making smarter business decisions. One of the most important goals of artificial intelligence is to help in making smarter business decisions. Salesforce Einstein has managed to do that quite effectively. Following Albert Einstein's dictum that the definition of genius is taking the complex and making it simple, Salesforce Einstein is removing the complexity of artificial intelligence, enabling any company to deliver smarter, personalized, and more predictive customer experience. Salesforce Einstein is a comprehensive artificial intelligence for customer relationship management. Driven by advanced machine learning, deep learning, natural language processing, and predictive modeling, Einstein is implemented in large scale businesses for discovering useful insights, focusing market behaviors, recommending the best possible solutions, and also automating tasks. Moving on to our next benefit, AI has been mainly used to solve complex problems that cannot be solved through other means. Throughout the years, artificial intelligence has progressed from simple machine learning algorithms to advanced machine learning concepts such as deep learning. This growth in AI has helped companies solve complex issues such as fraud detection, medical diagnosis, weather forecasting, and so on. Consider the use case of how PayPal uses artificial intelligence for fraud detection. Thanks to deep learning, PayPal is now able to identify possible fraudulent activities very precisely. The company processed over 235 billion in payments from 4 billion transactions by more than 170 million customers. Along with so much data, machine learning and deep learning algorithms were used to mine data from the customer's purchasing history in addition to reviewing patterns of likely fraud stored in databases. The derived insights and patterns were then used to predict whether a particular transaction is fraudulent or not. Coming to the next benefit of artificial intelligence, AI is used in strengthening the economy. Regardless of whether you think AI is a threat to the world, it is estimated to contribute over $15 trillion to the world's economy by the year 2030. According to a recent report by PwC, the progressive advances in artificial intelligence will increase the global GDP by up to 14% between now and 2030. It is also said that the most significant economic gains from AI will be in China and North America. These two countries will account for almost 70% of the global economic impact. The same report also reveals that the greatest impact of artificial intelligence will be in the field of healthcare and robotics. The report also precisely states that approximately 6.6 trillion of the expected GDP growth will come from productivity gains, especially in the coming years. Major contributors to this growth include automation of routine tasks and development of intelligent bots and tools that can perform all human-level tasks. Presently, most of the tech giants are already in the process of using AI as a solution to laborious tasks. However, companies that are slow to adopt these AI-based solutions will find themselves at a serious competitive disadvantage. Moving on to our next benefit, which is AI in performing repetitive tasks. So we all know that performing repetitive tasks can become very monotonous and time consuming. Not to forget, it's quite boring. So using artificial intelligence for tiresome and routine tasks can help us focus on the most important tasks in our to-do list. An example of such an AI is the virtual financial assistant used by the Bank of America called Edureka. Edureka implements artificial intelligence and machine learning techniques to cater the bank's customer service requirements. It does this by creating credit report updates, facilitating bill payments, and helping customers with simple transactions. Edureka's capabilities have recently been expanded to help clients make smarter financial decisions by providing them with personalized insights. As of 2019, Edureka has surpassed 6 million users and has serviced over 35 million customer service requests. Our next benefit of artificial intelligence lies in personalization. Research from McKinsey found that brands that excel at personalization deliver 5 to 8 times the marketing ROI and boost their sales by more than 10% over companies that don't personalize. Personalization can be an overwhelming and time consuming task, but it can be simplified with the help of artificial intelligence. In fact, it's never been easier to target customers with the right product. An example of this is a UK-based fashion company called Thread that uses artificial intelligence to provide personalized clothing recommendations for each customer. Most customers would love a personal stylist, especially one that comes at no charge. But staffing enough stylists for 650,000 customers would be expensive. Now, instead, the UK-based fashion company Thread uses artificial intelligence to provide personalized clothing recommendations for each of its customers. Customers frequently take style quizzes to provide data about their personal style. Each week, customers receive personalized recommendations that they can upvote or downvote. Thread uses a machine learning algorithm called Thimble that uses customer data to find patterns and understand the likes of the buyer. It then suggests clothes based on the customer's taste. This is how personalization is performed in Thread. Moving on to our next benefit, which is artificial intelligence in global defense. The most advanced robots in the world are being built with global defense applications in mind. This is no surprise since any cutting edge technology first gets implemented in military applications. Though most of these applications don't see the light of day, one example that we know of is the Ant bot. The AI-based robot developed by the Chinese is an armed police robot designed by the country's National Defense University. Capable of reaching maximum speed of 11 miles per hour, the machine is intended to patrol areas and, in the case of danger, deploy an electrically charged riot control tool. The intelligent machine stands at a height of 1.6 meter and can spot individuals with criminal records. The Antbot has contributed in enhancing security by keeping a track of any suspicious activity happening around its vicinity. Moving on to the next benefit, we have artificial intelligence in disaster management. For most of us, precise weather forecasting makes vacation planning easier. But even the smallest advancement in predicting the weather majorly impacts the market. Accurate weather forecasting allows farmers to make critical decisions about planting and harvesting. It also allows airlines to maximize the use of their planes. It makes shipping easier and safer. And most importantly, it can be used to predict natural disasters that impact the lives of millions. Among companies using artificial intelligence to predict the weather, only a few have invested as heavily as IBM. After years of research, IBM partnered with the weather company and acquired tons and tons of data. The acquisition gave IBM access to the weather company's impressive network of sensors and models, providing a massive pipeline of weather data it could feed into IBM's AI platform Watson in order to attempt to improve any predictions. In 2016, the weather company claimed that their models use more than 100 terabytes of third-party data every single day. The product of this merger is the AI-based IBM Deep Thunder. This system provides highly customized information for business clients by using hyper-local forecasts at a 0.2 to 1.2 mile resolution. This information is useful for transportation companies, utility companies, and even retailers. Moving on to the last benefit of artificial intelligence is that it enhances our lifestyle. And we're all aware of how AI is actually enhancing our life and changing our life. In the last decade, artificial intelligence has gone from a science fiction dream to a critical part of our everyday lives. We use AI systems to interact with our phones and speakers through voice assistants like Siri, Alexa, and Google. Cars made by Tesla interpret and analyze their surroundings to intelligently drive themselves. Amazon monitors our browsing habits and then serves up products it thinks we'd like to buy. And even Google decides what results to give us based on our search activity. Artificially intelligent algorithms are here, and they've already changed our lives for better or for worse. But this is only the beginning. And one day we'll look back at AI in 2019 and laugh about how primitive it was. Because in the future, artificial intelligence is going to change everything.
Let's look at some of the AI use cases. The first one is face detection and recognition. Using virtual filters on our face when taking pictures, and using Face ID for unlocking our phones are two applications of AI that are now a part of our daily lives. The former incorporates face detection, meaning any human face is identified. The latter uses face recognition through which a specific face is recognized. The next use case is text editor and autocorrect. When you're typing out documents, there are inbuilt or downloadable autocorrecting tools for editors that check for spelling mistakes, grammars, readability, and plagiarism depending on their complexity. It must have taken you a while to learn your language before you became fluent in it. Similarly, artificial intelligence algorithms also use machine learning, deep learning, and natural language processing to identify incorrect usage of language and suggest corrections. The next use case are chatbots. As a customer, getting queries answered can be time consuming. An artificially intelligent solution to do this is the use of algorithms to train machines to cater to customers via chatbots. This enables machines to answer frequently asked questions and track orders. Chatbots are taught to impersonate the conversational styles of customer representatives through natural language processing. Advanced chatbots no longer require specific format of input. They answer complex questions requiring detailed responses. The next use case is search and recommendation algorithms. When you want to watch your favorite movies or listen to songs or perhaps shop online, have you noticed that items suggested to you are perfectly aligned with your interests? This is the beauty of artificial intelligence. These smart recommendation systems learn your behavior and interest from your online activities and offer you a similar content. The personalized experience is made possible by continuous training. It is then able to predict your preferences by recommendations that keep you entertained without having to search any further. Moving ahead, let's discuss the AI roadmap for 2021. First, let's discuss based on career. A career in artificial intelligence is not one size that fits all. So, if you're interested to start a career in artificial intelligence, here's what you can do. To start off, get a bachelor's degree in subjects like computer science, information technology, mathematics and statistics, or even finance or economics. It's the first step towards achieving your goal of having a career in artificial intelligence. It is important to remember that to have a career in AI, you need to have relevant skills along with your degree. Since artificial intelligence is the buzzword of today's tech world, it is advisable to take up online and training programs to improve your skills. Ideally, a bachelor's degree could only help you land an entry level job like junior machine learning engineer or junior data scientist. So, once you get a job and get into the industry and understand how things work, you can plan your future career. Talking about positions entailing supervision, leadership, or administrative roles, you need to have a master's degree or a PhD. It's best to have a master's degree that offers advanced computer science education with a specialization in artificial intelligence or a master's degree in artificial intelligence. The master's program generally focuses on developing professionals. The robust coursework entails real world problems and application domain. A relevant master's or PhD degree can help you land a job at senior level, like senior machine learning engineer or AI engineer. A relevant master's degree or PhD degree can help you land a job at a senior level, like senior machine learning engineer or AI engineer, or even robotics engineer with a good salary hike. But even after landing a job, it is important to fine tune your technical skills. To be an AI engineer, one needs to be up to date with the latest skills and technologies. AI engineers are not just skilled professionals but have in depth practical and theoretical knowledge. Having a practical approach towards these technologies will help you gain an edge over other competitors. Additional add on AI certification programs will win you a brownie point while seeking jobs in AI. Moving ahead, let's see the roadmap based on skills. So let's look at the skills you need to master. The first skill required to become an AI engineer is programming. To become well versed in AI, it's crucial to learn programming languages such as Python, R, Java, and C++ to build and implement models. In-depth knowledge of computer software fundamentals, starting from data structures, trees, graphs, linear programming, and computer architecture is required, as the role of an AI engineer would be to simulate a machine to behave like a human. Hence, without understanding the working principle of systems, it would be difficult to cope. The next skill is linear algebra, calculus, and statistics. It is recommended to have a good understanding of the concepts of matrix, vectors, and matrix multiplication. Moreover, knowledge in derivatives and integers and their application is essential to even understand simple concepts like gradient descent. While statistical concepts like mean, standard deviation, and Gaussian distributions, along with probability theory for algorithms like naive Bayes and Gaussian mixture, are necessary to thrive in the industry. The next skill is neural network architectures. Machine learning is used for complex tasks that are beyond human capabilities to code. Neural networks have been understood and proven to be by far the most precise way of countering many problems like translation, speech recognition, and image classification, playing a pivot role in AI department. The next skill is signal processing techniques. Competence in understanding signal processing and ability to solve several problems using signal processing techniques is crucial for feature extraction, which is an important aspect of machine learning. Then we have time frequency analysis and advanced signal processing algorithms like wavelets, curvelets, and bandlets. A profound theoretical and practical knowledge of these will help you solve complex situations. The next skill is communication and problem solving skills. AI engineers need to communicate correctly to pitch their products and ideas to stakeholders. They should also have excellent problem solving skills to resolve obstacles for decision making and drawing helpful business insights. Next, let's discuss the roadmap based on job roles. So, there are various job roles that you can get with your knowledge in artificial intelligence. So, the first one is AI engineer. Artificial intelligence engineers are responsible for developing, programming, and training the complex networks of algorithms that make up AI so that they can function like a human brain. This role requires combined expertise in software development, programming, data science, and data engineering. Though this career is related to data engineering, AI engineers are rarely required to write the code that develops scalable data sharing. Instead, artificial intelligence developers locate and pull data from a variety of sources, create, develop, and test machine learning models, and then utilize application program interface calls or embedded code to build and implement AI applications. The average salary of AI engineer per annum is 8,70,000 rupees in India and $1,14,000 in the United States. The next job role is machine learning engineer. Machine learning engineers must possess strong software skills, be able to apply predictive models, and utilize natural language processing while working with massive data sets. Also, machine learning engineers are expected to know software development methodology, agile practices, and the complete range of modern software development tools, right from IDEs like Eclipse to components of continuous development pipeline. The average salary of a machine learning engineer per annum is 11 lakhs rupees in India and $1,14,000 in the United States. The next job role is as a data scientist. Data scientists are big data wranglers, gathering and analyzing large set of unstructured and structured data. A data scientist's role combines computer science, statistics, and mathematics. They analyze, process, and model data and then interpret the results to create actionable plans for companies and other organizations. Data scientists are analytical experts who utilize their skills in both technology and social science to find trends and manage data. They use industry knowledge, contextual understanding, and skepticism of existing assumptions to uncover solutions to business challenges. Average salary of a data scientist per annum is 10 lakh rupees in India and $1,13,000 in the United States. The next job role that we are going to discuss is robotic engineer. Robotics can automate jobs, but they require programmers working behind the scenes to ensure they function well. As a robotics engineer, their primary function is to build mechanical devices or robots that can perform tasks with commands from humans. Other necessary skills required for this role include writing and manipulating computer programs, collaborating with other specialists, and developing prototypes. The average salary of robotics engineer per annum is 6 lakhs rupees in India and $84,000 in the United States.
Let's get started with our basic level questions. So first we have, what is the difference between AI, machine learning and deep learning? I'm sure all of you have this question at the top of your mind because there's a huge confusion between AI, machine learning and deep learning. So let's try to understand how they are different. Now, first of all, AI came into existence at around 1950s. All right, this was followed by machine learning and then deep learning was introduced. Now, AI basically represents simulated intelligence in machines, which means that it represents any robot or any machine that can mimic the behavior of a human being. Machine learning, on the other hand, is a practice of getting machines to make decisions without being explicitly programmed to do so. Now, if you don't program a machine, how are you going to let it make decisions? Now, the way machines learn is through data. So the most important thing in machine learning is the data. All right, you're going to train machines using data so that they can make their own decisions. Next, we have deep learning. Now, deep learning is basically the process of using artificial neural networks to solve complex problems. So basically, you can think of deep learning as a field that tries to mimic our brain. Okay, so how we have neural networks in our brain, that's exactly how deep learning uses the concepts of artificial neural networks in order to solve problems. Now, AI is a subset of data science. So guys, first of all, data science is the process of deriving useful insights from data. All right, it's the process of extracting information from data that will help you solve problems. So AI is a subset of data science. Now, on the other hand, machine learning is a subset of AI and data science because machine learning comes after AI. So basically in AI, you're going to make use of techniques and concepts of machine learning in order to solve problems. Then we have deep learning. So it's sort of a hierarchy. First, we have data science, then we have AI, then we have machine learning, and then we have deep learning. Deep learning is a subset of machine learning, AI, and data science. Okay, I hope this is clear. Now, the main aim of artificial intelligence is to build machines in such a way that they are capable of thinking like human beings. All right, so basically, they must be able to mimic the behavior of a human being. Now, the aim of machine learning, on the other hand, is to make machines learn by providing them a lot of data. Okay, once you make a machine learn through data, it's going to be able to solve complex problems and find solutions. Now, the aim of deep learning is to build neural networks that are able to solve more advanced and complex problems. Okay, now, like I mentioned, deep learning is like an artificial brain. All right, you're basically building an artificial brain that is able to think exactly like how we do. Okay, that's what deep learning is. It's a little more advanced than machine learning. Now, guys, in short, AI, machine learning, and deep learning are used to solve problems through data. So basically, AI makes use of techniques and methods of machine learning and deep learning to solve problems or to draw useful insights from data. So this is the difference between AI, machine learning, and deep learning. I hope all of you are clear with this. Now let's look at our question number 2. The question is, what is artificial intelligence? Give an example of where AI is used on a daily basis. So there are a lot of definitions of AI on the internet. A few of them are: artificial intelligence is an area of computer science that emphasizes on the creation of intelligent machines that work and react like humans. So like I said, basically, a machine that is able to mimic the behavior of a human being is known as artificial intelligence. Another such definition is the capability of a machine to imitate the intelligent human behavior. All right. So artificial intelligence, in short, is basically a machine that we created who can act and think like a human being. Now, where do you think AI is used on a daily basis? There are tons of applications that make use of AI, but one of the most popular applications of AI is the Google search engine. Now, if you just open up Google search and you start typing anything, immediately you get recommendations. These recommendations you derive by using machine learning algorithms, by using deep neural networks, and so on. So on the top of my head, the most general example of AI is the Google search engine. All of us use Google search engine and we know how quick it is with its results and how relevant searches it gives us. All this is because of AI. All right. Now let's look at our next question, which states, what are the different types of AI? Now, a lot of people might not be aware of this because there are a couple of types of AI or a couple of types of machines which are hypothetical. Okay, we haven't actually implemented these machines in the real world. We just have a theoretical definition of these. Okay, let's look at what I'm talking about. So first of all, we have reactive machines AI. Now, these machines are all based on the present actions. Okay, they have no memory or they have no concept of storing memory so that they can learn from their experience. They just react at the moment. Okay, so they're based on present actions and they cannot use previous experiences to form current decisions and update their memory. Then we have limited memory AI. Now, this type of AI has some temporary storage of memory in it. Now, if we have some memory stored in a machine, we know that it can look back into the memory and it can try to make decisions based on previous or past experiences. So limited memory AI makes use of that concept. We have temporary memory here. We do not have permanent memory. But one of the top applications of limited memory AI is the self-driving cars. I'm sure all of you have heard of self-driving cars. They make use of limited memory AI in order to run. Then we have theory of mind AI. Now, like I mentioned earlier, there are a couple of types of artificial intelligent machines which are not actually implemented in the real world. An example of that is theory of mind AI. Okay, this is basically an advanced machine which will have the ability to understand emotions, people, and other things in the real world. We might have come close to this type of AI, but we haven't actually developed something that can understand emotions. Next, we have self-aware AI. Now, this is another such example of a machine that is not built in the real world. This basically includes any machine that has consciousness or that can react just like a human being. Okay, so basically a machine that can take own decisions, that can form own conclusions, and these are machines that have the capability of making their own decisions without any human intervention. Now, this kind of AI is not developed, like I mentioned, because it's going to take up a lot of resources and we still haven't reached that peak of evolution yet. Then we have artificial narrow intelligence. Now, these are the general purpose AI that we see on a daily basis. I'm sure all of you have used Google Assistants, you've used Siri. All of that comes under artificial narrow intelligence. After that, we have artificial general intelligence. Now, these are a little more advanced than the artificial narrow intelligence. Then we have artificial superhuman intelligence. Now, these are one of the most advanced type of AIs that are there. Now, like I mentioned earlier, there are a couple of types of artificial intelligent machines which are not actually implemented in the real world. An example of that is artificial superhuman intelligence. So guys, these were the different types of AI. Now let's look at the next question, which says, explain the different domains of artificial intelligence. Now, AI covers a lot of different domains, starting with machine learning. Okay, so machine learning, like I mentioned earlier, is the science of getting computers to act by feeding them data and by letting them learn a few tricks on their own without being programmed to do so. Okay, so you're not explicitly programming the machine. Instead, you're feeding it a lot of data so that it understands the data and it makes its own decisions. Then we have neural networks. Now, neural networks are basically a set of algorithms, or you can say a set of techniques which are modeled in accordance with the human brain. Okay, like I mentioned earlier, deep learning or neural networks is almost the same thing. Deep learning makes use of neural networks in order to solve complex problems. Now we have robotics. Now, robotics is a subset of AI which includes different branches and applications of robots. These robots are basically artificial agents which act in a real world environment. Okay, so an AI robot works by manipulating the objects in its surrounding, by perceiving, moving, and taking relevant actions. Then we have expert systems. Now, an expert system is basically a computer system that mimics the decision-making ability of a human being. Now, I know all of these domains sound very similar, but they have a very different approach with which they solve a problem. All right, that's the main difference between these domains. Next, we have fuzzy logic systems. Now, traditional systems usually give out output in the form of binary. So usually if you feed something to a machine, it's always in the binary form. The output is also usually in the form of yes, no, true, false, and so on. But when it comes to fuzzy logic, it tries to give an output in the form of degrees of truth. Okay, so it's very different when compared to the traditional computer systems or the traditional programs. Next, we have natural language processing. Now, this is a field of AI that analyzes natural human language to derive useful insights so that it can solve problems. Now, NLP is used majorly in social media platforms. So, Twitter sentimental analysis is done via NLP. Even Facebook uses NLP in a lot of things. Alright, so NLP, fuzzy logic, expert systems, machine learning, neural networks, and robotics are the different domains of AI. I hope all of you are clear with the domains. Now let's look at our next question. Okay, so how is machine learning related to artificial intelligence? There is a huge confusion between machine learning and AI. A lot of people tend to believe that AI and machine learning is one and the same thing. All right, I would say that you cannot compare AI and machine learning because machine learning is a subset of AI. So basically, AI makes use of machine learning algorithms and machine learning concepts to solve problems. That's the basic difference, or that is where the confusion ends. Machine learning is a technique which is implemented in artificial intelligence in order to solve problems. I hope this is clear. Now let's look at what are the different types of machine learning. So there are three types of machine learning. We have supervised, unsupervised, and reinforcement learning. Now, supervised learning is the type of learning in which the machine learns by using labeled data. Now, to make you understand, let's look at an example. Okay, let's say that you've input images of apples and oranges to your machine and you've labeled them. You've told the machine, like, listen, this is the apple, this is an orange, and the output should also look like this. Okay, so you're labeling the input as apple and an orange, and then you're asking the machine to output an apple and an orange. But when it comes to unsupervised learning, you're not going to label them. You're just going to give them images of apple and oranges, and it has to figure out on its own. It has to try and understand the difference between apple and oranges, try and understand how they look different or how they have a different color. So basically in unsupervised learning, you don't have a labeled data set. Okay, you're going to give it an unlabeled data set and you're going to ask it to find out and classify which is an apple and which is an orange. Okay, that's the difference between supervised and unsupervised. Now, reinforcement learning is comparatively different. Let's imagine that you were put off in an island. Okay, let's say that you were left in an isolated island. What would you do? Now, initially, we'll all panic and we won't know what to do. But after a point, you'll start exploring the island. You start adapting to the change in the climate conditions. You start looking for food, and then you'll try and understand which food is right for you and which food is wrong for you. You know, you learn from your experience. So in reinforcement learning, basically an agent interacts with its environment by producing actions and discovers errors or rewards. Now, the type of problems that supervised learning is used to solve is regression and classification. When it comes to unsupervised, it is association and clustering. And in reinforcement learning, it solves reward-based problems. The type of data for supervised learning is labeled data. For unsupervised, it is unlabeled. And for reinforcement, it is no predefined data. Now, when I say no predefined data, I mean that the reinforcement learning agent has to start collecting the data. So basically, in reinforcement learning, from data collection to model evaluation, it does everything. In terms of training, supervised learning provides external supervision in the form of labeled data set. In unsupervised learning, there's no supervision. That's why it's called unsupervised learning. Again, in reinforcement learning, there's no supervision at all. The agent has to figure everything out. Now, how supervised learning works is you map the labeled input to the known output. So basically, you teach the machine, like you tell it that this is the input and this has to be the output. When it comes to unsupervised learning, you just provide data to the machine and it has to understand patterns and it has to discover the output. Now, in reinforcement learning, it has to follow the trial and error method. Okay, there's no particular way in which the agent learns. It just has to explore the environment, try out a few things and learn from that experience. Popular supervised learning algorithms include linear regression, logistic regression. For unsupervised, we have k-means, and for reinforcement learning, we have q-learning. So guys, these were the different types of machine learning, and I also discussed the difference between the three. Now let's move on and look at our next question, which is what is q-learning? In the previous slide itself, I told you that a type of reinforcement learning algorithm is q-learning. So basically here what happens is an agent tries to learn the optimal policy from its past experience with the environment. The past experience of an agent are a sequence of action, state, and rewards. So what happens is, first of all, you take an agent and you put it in state 0. Okay, let's say there's some state known as state 0. Now this agent is going to perform some action A0. On performing this action, it is going to get a reward R1. And if it gets a reward R1, then it's going to move to state S1. But in case the action is wrong, then it's going to get a negative reward, as in some points are going to be reduced. So guys, think of q-learning as a game. You're in state 0 and then you do some action, and either you get a reward and go to the next state, or else you lose and you go back to the same state. So until you learn, you're going to be in the same state. But if you keep learning and if you keep receiving positive rewards, then you're going to move on to state 1, and similarly you'll move on to state 2, 3, and so on. This is what q-learning is about. Now the next question is, what is deep learning? Now deep learning, like I mentioned earlier, basically mimics the way our brain works. Okay, it learns from experience. Now the main concept behind deep learning is neural networks. In our brain also we have neural networks. So what deep learning tries to do is it tries to use the concept of neural networks in order to solve complex problems. So basically we're trying to mimic our brain. Any deep neural network will have three types of layers. The first is the input layer. Now this layer will basically receive all the input and it will forward them to the hidden layer. Now in the hidden layer, all the analysis and the computation takes place. Alright, once the computation is done, the result is transferred to the output layer. Now there can be n number of hidden layers depending on the type of problem you're trying to solve. Then we have the output layer. So basically this layer is responsible for transferring the information from the neural network to the outside world. So it's as simple as that. It's pretty obvious. Input layer will take in the input, hidden layer will perform the computations, and the output layer will give out the output. This is a small explanation of what deep learning is. Now, of course, this is much more complex than this, but in short, this is exactly what deep learning is. Now let's look at our next question, which is explain how deep learning works. So basically, deep learning is a concept based on something known as neuron. Okay, neuron is a basic unit of the brain. Inspired from this neuron, they came up with something known as perceptrons or artificial neurons. Now in this image on the left hand side, you can see that there is something known as dendrite. These are modules which receive the input. It basically receives all the signals that we send to our brain. Okay, similar to the dendrites are the input layer in our artificial neural networks. Now in the previous slide, we discussed that the input layer takes in all the input from the outside. That's exactly what a dendrite does. So basically a perceptron receives multiple inputs, it applies various transformations and functions, and then it provides an output. So basically guys, just like how our brain contains multiple connected neurons called neural networks, we also have a network of artificial neurons called perceptrons to form a deep neural network. So basically an artificial neuron or a perceptron, it models a neuron which has a set of inputs, each of which is assigned some specific weight. Okay, all of these inputs will have a specific weight, and the neuron will compute some function on these weighted inputs and give you the output. So the neuron will basically perform analysis and all of that on these weighted inputs to give you some output. This is the basic concept of deep learning. So there are inputs which have some weight on it, and these inputs are then formulated and analyzed in order to give you an output. Now let's look at our next question, which is explain the commonly used artificial neural networks. Now this is a very theoretical question because in order to make you understand how each of them work will take a lot of time. Okay, so I'm just going to briefly tell you what each of these networks are and what they do. Now feed-forward neural network is the most basic kind of artificial neural network. So basically the feed-forward neural network is unidirectional. The data passes through the input nodes and leaves through the output nodes. In feed-forward neural network, usually the number of hidden layers depends on the complexity of the problem. Coming to convolutional neural networks, here basically the input features are taken in small sets, okay, or they're taken in batches. This will help the network remember better because you're feeding batches of images or you're feeding batches of input to the neural network. Now, this type of neural network is mainly used for signal and image processing. Next, we have recurrent neural networks. These are also known as long short-term memory networks. So this basically works on the principle of feeding the output of a layer back into the input layer in order to predict the outcomes. Okay, this way it's more precise and it is a little more complex when compared to convolutional networks. Now, one main important point of recurrent neural networks is that they have something known as memory. So basically each neuron will have some information or some memory stored in them so that they can use this memory in order to take actions in the future. So they have some experiences stored in the form of memory so that they can make their decisions based on previous actions. Now finally, we have autoencoders. Now autoencoders are mainly used in dimensionality reduction for learning generative models. Okay, and one more important thing about autoencoders is that the number of units in the output layer and the input layer is the same. This is because the output layer has to reconstruct its own inputs. So these were the different types of artificial neural networks. Now let's look at our next question, which is what are Bayesian networks? Okay, so a Bayesian network is a statistical model that represents a set of variables and their conditional dependencies in the form of a directed acyclic graph. Now, basically, on the occurrence of any event, a Bayesian network can be used to predict the likelihood that any one of several possible known causes was a contributing factor. An example of this is a Bayesian network could be used to study the relationship between diseases and symptoms. So given a set of symptoms, the Bayesian network can be used to find out the probability of the presence of any diseases. Alright, so the next question is explain the assessment that is used to test the intelligence of a machine. Now guys, this is a very common question and it is sort of a general knowledge based question. Alright, I'm hoping that most of you know the answer to this. So let's look at what the answer is. I'm not sure how many of you have heard of Alan Turing. So Alan Turing was the one who came up with the Turing test. Now, this test is basically to determine whether or not a computer is capable of thinking like a human being. So if a machine or if a computer passes this exam, it means that that machine is capable of thinking like a human being. It means that it is successfully an artificial intelligent machine, meaning that it can make its own decisions and interpret data and form their own formulations or form their own conclusions about the data. Now, sadly, I don't think there are a lot of machines that have passed the Turing test. In fact, I'm not sure if there is any machine that's passed the Turing test as of now. But in the near future, I'm sure that we'll see machines who are more smarter than human beings and who have passed this test. Now, for a machine, it might be very easy to do computations, but it might be very hard for a machine to just get up and walk around. All right, the simple things that us humans can do is very complicated for a machine. They can do computations which we can do in probably a year. They can do those computations in maybe a week or less than a week. But doing simple things such as walking up to the fridge or walking up to the kitchen is very hard for the machines. So to achieve that level of intelligence, we're going to take a while. But in the near future, I'm sure we'll see machines which are way more capable than human beings. Now let's move on to our next level. Now here I'll basically be discussing intermediate level artificial intelligence questions. So let's look at the first question. All right, the first question is how does reinforcement learning work? Explain with an example. Okay, so first of all, reinforcement learning is a type of machine learning. We discussed about reinforcement learning earlier. Reinforcement learning is a type of machine learning wherein there's an agent and you put this agent in an unknown environment. All right, now the agent has to figure out actions, what sort of actions it must take, and how it's going to get rewards so that it can move from state 0 to state 1. It's sort of like a video game. If you're in a video game, let's say if you're playing Counter-Strike, you're in level 0 or state 0. Now, if you perform some action and if you get some rewards, you're going to move to state 1. That's exactly how reinforcement learning works. If you perform the relevant actions and the correct actions, you're going to get a reward and you'll move on to the next state. But in case you perform a wrong action, you'll get negative rewards and you'll stay in the same state unless and until you don't learn. All right, so if you learn and achieve, then you'll move to the next state. So basically, a reinforcement learning system will have two main components. It'll have an agent and an environment. Now, the agent, I've been repetitively saying an agent is basically the reinforcement learning algorithm. It is the model. The model has to learn everything on its own. It has to collect data on its own. It has to draw useful insights on its own. Okay, you're not going to feed any predefined data to this reinforcement learning agent. All right, he has to figure out everything on its own. So let's look at an example of Counter-Strike. Okay, I'm not sure how many of you play the game, but yeah. What happens here is the reinforcement learning agent or the player one collects a state S naught from the environment. Okay, so let's suppose that you're playing Counter-Strike and you're in state 0. Now you'll perform some action A naught. Right, initially it's going to be a random action. So obviously if you're put in an unknown environment, your first action is going to be random, correct? Because you don't know what's right, you don't know what's wrong. So in your state 0, you'll take an action A naught. This will result in a new state S1. And on achieving state S1, the agent will get a reward R1, okay, from the environment. Now, in the case of Counter-Strike games, if you've observed, whenever you win a state or you pass a level, you're going to get some rewards. Maybe you'll get more weapons or you'll get more points. Okay, just like that, in reinforcement learning problem, you'll get some reward R1. Okay, it's basically a plus point. You might get a negative reward or a positive reward based on the action that you take. Now, this loop will go on until the agent is dead or it reaches the destination. So in Counter-Strike, until you have failed the level, you will keep playing the game, right? You'll keep moving from state 1, state 2, state 3, and so on. Or if you've reached the destination, then it's the end game. That's exactly how it works in reinforcement learning. If the agent has explored the entire environment and reached the end state, that's when the loop will end. All right, that's exactly how reinforcement learning works. It is very similar to the games that we play. All right, it's very understandable. Now let's move on and discuss the next question. So the next question is explain Markov's decision process with an example. Now the solution for a reinforcement learning problem is achieved through the Markov's decision process. This is basically a mathematical approach that maps the solution in reinforcement learning. Okay, so now to understand this, there are a couple of parameters in a Markov's decision process. They're going to be a set of actions called A. Okay, you can name them A set of states, there's going to be reward, there's going to be policy, and there's going to be value. To sum it up, what exactly happens in a Markov's decision process is that the agent takes an action A to transition from the start state to the end state. Now, while doing so, the agent receives some reward R for each action that he takes. The series of actions taken by the agent will define a policy or an approach, and the rewards collected will define the value. So the main goal in a Markov's decision process is to maximize the rewards by choosing the most optimum policy, meaning that you're going to choose the best path or the best solution in order to get the most number of rewards. Now, in order to make you all understand this better, let's solve the shortest path problem by using Markov's decision process. I'm sure all of you have heard of shortest path problem. This was, I think, taught to us when we were in 11th or 12th, I'm not sure. Look at the diagram that is over here. This is basically a representation of our problem. Given this representation, our goal here is to find the shortest path between the node A and node D. All right, you can see nodes A, B, C, and D. We have to find the shortest path between node A and node D. Now, the link between these two nodes has a number on it. Okay, for example, between A and C, you can see there's a number 15. Okay, this basically denotes the cost to traverse that edge. So if you want to go from A to C, you'll spend around 15 points. So our end goal here is to travel between node A and node D with minimal possible cost. We should travel between A to D in such a way that our cost is minimal. Now in this problem, if you notice that we have a set of states. Okay, these are denoted by the nodes A, B, C, D. Now, like I mentioned earlier, a Markov's decision process has a set of states. Similarly, in this problem, the set of states are A, B, C, D. The action is to traverse from one node to the other. So going from A to B is basically an action. Going from A to C is another action. Going from A to D is another action, and so on. Now, reward is represented by the cost on each of these links. And the policy is the path which is taken to reach the destination. So our aim here is to choose a policy that gets us to node D in the minimum cost possible. So how do you think you can solve this problem? All right, you can start off at node A and you can take baby steps to your destination. Now, initially, only the next possible node is visible to you. Like I mentioned earlier, the initial action taken in a reinforcement learning problem is always random. So at random, you'll choose any node. Let's say you take A to B. Now, if you go from A to B, you can go B to D and you'll reach the destination. So policy is the path which is taken to reach the destination. All right, so it can go from A to B to D, or you can go from A to C to D, or you can go A, C, B, D. All right, now it's up to you to figure out which is the shortest path. All right, you have to choose a path in such a way that the cost between A to D is minimized. So guys, this was a simple problem of how Markov's decision process is used to solve the shortest path problem. Now let's move on and look at our next question. All right, now the next question is explain reward maximization in reinforcement learning. So basically a reinforcement learning agent works based on the theory of reward maximization. Okay, in the previous question itself, I told you that the main aim of reinforcement learning is to maximize the reward. So that's why a reinforcement learning agent must be trained in such a way that he takes the best action so that the reward is maximum. Okay, this is exactly what reward maximization means. He has to choose the best policy in such a way that the reward is maximum. Now let me explain this with a small game. So in the figure, you can see a fox, you can see some meat, and you can see a tiger. Now our reinforcement learning agent is the fox. His end goal is to eat the maximum amount of meat before being eaten by the tiger. Okay, so he has to explore around, eat the maximum number of meat that he can eat before the tiger kills him. Since the fox is a clever fellow, he eats the meat that is closer to him. Okay, so rather than eating the meat which is close to the tiger, he eats the meat which is only close to him. This is because the closer he gets to the tiger, the higher are his chances of getting killed. So as a result of this, the rewards near the tiger, even if they are bigger meat chunks, will be discounted. So because the fox is not going closer to the tiger and eating the meat chunks closer to the tiger, this reward will get discounted. Now I know you all are wondering what discounted is. Now this is done because of the uncertainty factor that the tiger might kill the fox. So what is discounting of reward? Okay, how does it work? To understand this, we define a discount rate called gamma. Okay, this is a parameter and the value of gamma always ranges between 0 and 1. So the smaller the gamma, the larger the discount and so on. So guys, this was reward maximization. So here basically the fox will try to get as much as meat chunks as he can, and he'll also try to avoid getting killed because that will end the reinforcement learning loop. We also discussed the discounted factor. All right, now that is not needed to understand reward maximization, but I just thought I'll add on some extra info. Now let's look at the next question, which is what is exploitation and exploration trade-off? So basically exploration is, like the name suggests, it is about exploring and capturing more information about an environment. Now on the other hand, exploitation is about using the already known exploited information to heighten the rewards. So consider the same example that we discussed in the previous question. Here the fox only eats the meat chunks which are close to him. Okay, he does not eat the bigger chunks because even though the bigger chunks would give him more rewards, it would get him killed. Okay, he does not go towards the tiger itself. Now, if the fox only focuses on the closest reward, he will never reach the big chunks of meat. Okay, this is what exploitation is. He's sticking only to the information that he knows and he's trying to get the most number of rewards from it. But if the fox decides to explore a bit, it can find the bigger rewards. Okay, the bigger rewards are basically the big chunks of meat which are near the tiger. And this is exactly what exploration is. Okay, exploitation is about using the already known information to heighten your rewards. Exploration, on the other hand, is about exploring and capturing more information about an environment. All right, so that was about exploitation and exploration. Now let's move on to our next question. So this is a difference question which asks the difference between parametric and non-parametric models. So a parametric models basically uses a fixed number of parameters to build the model. Now, first of all, guys, what are parameters? Now, parameters are basically predictor variables that are used to build a machine learning model or build any predictive analytics model. Now that we know what parameters are, let's try to understand the difference between a parametric and a non-parametric model. Now, parametric model basically uses a fixed number of parameters to build the model. A non-parametric model uses flexible number of parameters to build the model. When it comes to a parametric model, the assumptions about the data are very strong. In a non-parametric model, there are fewer assumptions about the data. A parametric model has the fixed number of parameters. Everything is defined over here. So the computation is very fast. Okay, you know what sort of variables you'll need to predict the outcome. Okay, you have a defined set of variables or a defined set of predictor variables that will compute your outcome. So that's why the computation is a bit faster. When you compare to non-parametric models, there are a lot of parameters taken into account. Now, when it comes to a non-parametric model, you do not have a fixed number of parameters. Alright, you do not have a fixed number of predictor variables that will help you get to the outcome. So the computation is a bit slower. Now, parametric models require lesser data and non-parametric require more data. Example of parametric models include logistic regression and naive Bayes. And for non-parametric models, we have KNN and decision tree models. Now, logistic and naive Bayes models are very stern models because they have a fixed number of parameters or a fixed number of predictor variables, and they will give you an immediate output. Okay, when it comes to non-parametric models like decision tree models and KNN, you might even observe a little bit of overfitting. Okay, this happens because you have a fewer number of assumptions about the data and also because your parameters are not fixed. Now, that's not the reason for overfitting, but it's seen that in some of the non-parametric models, overfitting occurs more often. Now, let's discuss the next question, which is what is the difference between hyperparameters and model parameters? Now, model parameters are the predictor variables that I was speaking about earlier. Hyperparameters, let's discuss what they are. Okay, model parameters are the features of training data that will learn on its own during training, whereas model hyperparameters are the parameters that determine the training process. Now, let's say that you want to determine the height of an individual depending on his weight. The height and weight will become your model parameters. But your hyperparameter is basically the learning rate. It's the rate at which your model is going to learn this correlation between the height and the weight. So this is the difference between model parameters and hyperparameters. Model parameters are the ones that you find in your data. These are all the variables that you use to predict your outcomes. Hyperparameters will define your training process. There is a huge difference between model and hyperparameters. Another difference is that they are internal to the model and their value can be estimated from the data. Hyperparameters are external to the model and their value cannot be estimated from data. Now, like I said, model parameters are derived from your data itself. Okay, these are the parameters that are there in your data. Hyperparameters are the ones that you define in order to train your entire data. So that is the difference between hyperparameters and model parameters. So the next question is, what are hyperparameters in deep neural networks? So guys, like I mentioned in the previous example, hyperparameters are variables such as the learning rate. This will define how your entire data training process goes. For those of you who don't know, in order to build a model, you first need to train the model and then you need to test it. Okay, now while training the model, you're going to make the model learn a lot of things. You're going to give it a lot of data. It has to figure out relations between various variables and how these variables are affecting the output. All of this training will depend on a few variables such as the learning rate. Okay, these are basically called hyperparameters in deep neural networks. So these parameters will define the number of hidden layers that are present in the network. Okay, and more the number of hidden layers, the more accurate your network is going to be. Whereas if you have lesser number of units, you may cause underfitting in your data. Underfitting will also result in inaccurate predictions. So that's why you need to make sure that the number of hidden units in your hidden layers are perfect, are ideal. Okay, and this is determined by your learning rate or by your hyperparameters. Not by your learning rate specifically, but by the number of hyperparameters you have. These number of hidden layers are determined by the hyperparameters. Okay, that's why hyperparameters are very important in deep neural networks. I hope you all are clear with this. Now let's look at our next question, which is explain the different algorithms used for hyperparameter optimization. We'll discuss the three methods, which are grid search, random search, and Bayesian optimization. Okay, now grid search basically will train the network only on the two sets of hyperparameters, which are learning rate and the number of layers. Okay, so it's going to use every combination of these two sets in order to train the network. Okay, after that, it will evaluate the efficiency of the model by using the cross-validation techniques. Cross-validation is the best improvement method. Okay, it's the best way to check if your model is optimal or not. Then we have random search. Now, this will randomly select samples and it will evaluate sets for a particular probability distribution. Now, in random search, there is no fixed number of hyperparameters that it's going to evaluate. So, it'll randomly select a set of hyperparameters. Okay, for example, now instead of checking your entire sample or your entire, let's say that you have 10,000 samples, instead of checking all of these samples, it'll randomly select 100 parameters that can be checked. Okay, and then it'll use this to build the model. After that, we have Bayesian optimization. Okay, now Bayesian optimization basically uses something known as the Gaussian process. Basically, the Gaussian process will help in model tuning. Okay, model tuning, or you can also say parameter tuning. So parameter tuning will help you tweak the parameters a little bit in order to improve the efficiency of the model. Okay, so Bayesian optimization basically makes use of the Gaussian process, which will provide model tuning to your algorithm and thus improve the efficiency. Now guys, one of the most important ways to improve the efficiency of a model is by hyperparameter optimization. Okay, if you're tuning your hyperparameters and if you're trying to check in which way these hyperparameters will give you the most accurate outcome, that's when your result will be very good. Okay, so that's the best way to improve the efficiency of the model. All right, now let's look at our next question. The next question is, how does data overfitting occur and how can it be fixed? Now guys, this is a very common question in a machine learning or in an artificial intelligence interview. Okay, people expect you to understand what data overfitting is and how you can fix these problems. Okay, because data overfitting occurs pretty often, especially if you're using decision trees or if you're using random forest. Okay, random forest actually reduces overfitting, but sometimes with these complex models, you can get data overfitting. Now, to answer this question, first of all, let's understand what overfitting really is. So, overfitting occurs when a machine learning algorithm captures the noise of the data. Okay, this causes an algorithm to show low bias but high variance in the outcome. Now, what overfitting really means is you have trained your model way too many times on the training data. Okay, so basically the model has memorized the training data. It has memorized the noise in the training data. Okay, so if you feed new data to the model during the testing stage, it will not be able to recognize the noise or it will not be able to recognize any sort of correlation in that data. Okay, that's why it won't be able to get a proper outcome. Okay, that's when overfitting happens. You have trained the model way too much with the training data, and this has resulted in inaccurate outcome during the testing phase. Okay, that's what overfitting is about. Now, how do you avoid overfitting? First of all is cross-validation. Now, before this also I mentioned that cross-validation is the best way to obtain a more optimal solution. Now, the general idea behind cross-validation is to split the training data in order to generate multiple mini train test splits. Okay, these splits can be used to tune your model. Okay, so you're basically splitting the training data in such a way that, the model does not just use the entire training data and memorize it. Instead, it's going to check the different sets in the training data and the different sets in the testing data and learn from it. Okay, so cross-validation is one of the best ways to prevent overfitting. Another method to prevent overfitting is by training the model with more data. So feeding more data to the machine learning model will help in better analysis and classification. However, this method is not always going to work, but yeah, this is also one of the ways to prevent overfitting. Okay, next we have removing features. Now, many times the dataset contains irrelevant features or predictor variables which are not needed for analysis. Such features will only increase the complexity of the model. Therefore, it will lead to possibilities of data overfitting. Okay, so if you have irrelevant data, like for example, if you're trying to understand the weight of a person depending on its height, and you have another variable, let's say you have a variable like the name of the person. Okay, now the name of the person is not relevant in understanding the height of an individual. So if you have irrelevant predictor variables, then it will just increase the complexity of the model because you have an extra irrelevant variable. All right, this will only increase the complexity of the model. It will not help the model in any way. So make sure you remove irrelevant features or you remove redundant features. Okay, the next method is early stopping. Now, a machine learning model is trained iteratively. This will allow us to check how well each iteration of the model performs. But after a certain number of iterations, the model's performance starts to saturate. Further training will only result in overfitting. Okay, so like I mentioned, if you train the model with the same data and you make the model memorize the data, then it'll just saturate. It won't be able to predict any outcomes after a point. What you have to do is you have to understand where you need to stop training the model. So this can be achieved by using a mechanism known as early stopping. So at this point, you know that you have to stop training the model because this might result in overfitting. Now, regularization is one of the most common ways to prevent overfitting. Regularization can be done in n number of ways. Okay, the method will always depend on the type of learner you're implementing. For example, pruning is performed on decision trees. Now, pruning is a type of regularization. Similarly, the dropout technique can be used on neural networks. And also there are other methods like parameter tuning, which can help to solve overfitting. The next way to prevent overfitting is by using ensemble models. Now, ensemble learning is a technique that is used to create multiple machine learning models, which are then combined to produce more accurate results. So basically, if you have one problem statement in machine learning, you're going to use like 5 to 10 different models, and then you're going to calculate the accuracy depending on the average of the result from each of these models. By this way, you will reduce overfitting. Now, ensemble models is one of the best ways to prevent overfitting. An example is the random forest. Random forest uses ensemble of decision trees to make more accurate predictions and to avoid overfitting. So basically, random forest is a set of decision trees. So here you're going to train the model by using a set of decision trees, and this way you'll have different data sets, and on each of these data sets you'll have a different decision tree model. Okay, this will reduce overfitting to a very large extent. That's why in most of the cases when you see a decision tree having overfitting issues, you'll be asked to use random forest. So guys, those were the different ways to prevent overfitting. Now the next question is, mention a technique that helps to avoid overfitting in a neural network. Now the most famous method to prevent overfitting in neural networks is dropout technique. Okay, now dropout is a type of regularization technique which is used to avoid overfitting in a neural network. So here what you do is you randomly select neurons and you drop them during the training phase. Right, so the dropout value also has to be chosen very carefully because a higher dropout value will result in underlearning by the network. So if you're dropping out too many predictor variables or if you're dropping out too many neurons in a neural network, then the model will not learn enough. Okay, because there's not enough predictor variables and not enough neurons. But if you have too much of a low rate for a dropout value, then this might have a very minimal effect. So make sure your dropout value is very optimal depending on the problem you're trying to solve. Okay, so dropout is the technique which is used to avoid overfitting in a neural network. Next question is, what is the purpose of deep learning framework such as Keras, TensorFlow, and PyTorch? So Keras is basically an open source neural network library which is written in Python. So basically it is designed to enable fast experimentation with deep neural networks. Now, TensorFlow is another open source software library for data flow programming. TensorFlow is mainly used in machine learning applications. Similarly, PyTorch is again an open source machine learning library for Python. Its applications are mainly in the field of natural language processing. Now, I'd say that these three deep learning frameworks are the most important when it comes to machine learning and deep learning because they have a varied set of functions in them which help in building a better machine learning model or a better deep learning network. Now let's look at question number 24, which is differentiate between NLP and text mining. So guys, NLP stands for natural language processing for those of you who don't know. Now, first of all, let me clear out a confusion between text mining and natural language processing. A lot of people tend to think that text mining and NLP are the same thing, but text mining is the broader field and NLP is basically an application of text mining, or it's basically a technique used in text mining. So the aim of text mining is to extract useful insights from structured and unstructured text, whereas the aim of NLP is to understand what is conveyed in these texts. Now, text mining can be done using text processing languages like Perl, And NLP can be achieved using advanced machine learning models such as deep neural networks. Now, the outcome for text mining is you'll calculate the frequency of words, you'll understand the patterns between different words, you'll understand the correlations between two different words, and you'll see how these two words occur together more frequently and why they occur together more frequently. So text mining basically will give you a more understanding about the words that are used in a document. Whereas in NLP, you will understand the grammar behind the text. You will understand in more depth about the language that is used in the document or in whatever you're trying to analyze. So that is the difference between NLP and text mining. NLP is a little more advanced field because you use deep neural networks to perform this. Text mining, on the other hand, makes use of NLP. Next question is, what are the different components of NLP? Now, there are two components of natural language processing, which is natural language understanding and natural language generation. In natural language understanding, you'll basically map your input to some useful representation. This means that you'll try to understand the correlations in your language, and it'll also include analyzing different aspects of the language. All right, so this is majorly about understanding your text. When it comes to natural language generation, here you'll understand how to generate text by having a brief plan about the text. You'll have sentence planning and you'll have text realization. Now, natural language generation will basically break down sentences or will break down text in order to understand it better. Okay, that's what natural language generation is. Natural language understanding is more about analyzing your language or analyzing the text that you have at hand and predicting some useful outcome out of it. Generation is more focused on the planning aspect of your text. So these are the different components of natural language processing. Now let's look at what is stemming and lemmatization in natural language processing. Now, what is stemming? It is an algorithm which works by cutting off the end or the beginning of the word and only taking into account a list of common prefixes and suffixes that can be found in inflected words. Now, for example, on the screen you can see that there is detections, detected, detection, and detecting. Now, if you apply stemming on these four words, it will lead to detect. Okay, because at the end of the day, detections, detected, detection, and detecting is the same thing as detect. So stemming will help you remove all of these unwanted prefixes and suffixes. This way you can analyze the importance of the word. Alright, you don't have to have extra suffix or prefix before the word. Now, sometimes during stemming, cutting off the ends of the words will form an inaccurate result. Okay, that's why we have lemmatization. In lemmatization, the most important thing is the morphological analysis of the word. Okay, so here, in order to perform lemmatization, you have to have a detailed dictionaries which the algorithm can look through and it can form back to its lemma. So the main difference between stemming and lemmatization is that stemming will just crop the prefix and the suffix, whereas lemmatization will try to understand the word in a grammatical way and give you an actual word as the output. Next is to explain the fuzzy logic architecture. Alright, so the fuzzy logic architecture looks like what is shown on the screen. Okay, so basically the input is fed into something known as the fuzzifier. Okay, the fuzzifier or the fuzzification module will transform the system's input into a number of fuzzy cells. Okay, after that it's fed to the controller. Now the controller will have knowledge base and the inference engine. Knowledge base is basically a set of rules, or you can say it's an algorithm which is provided by experts. Inference engine, like the name suggests, will basically infer meaning out of these rules. Okay, so once you've applied the rules to your input, you'll have to draw some useful insights or you'll have to infer these inputs. Okay, for that you use the inference engine. After that, whatever inferences and analysis you've formed from your inference engine is passed on to the defuzzification model. Now the defuzzification will just give you a crisp output. Alright, it will give you a clear and cut output. That is the whole fuzzy logic architecture. Now let's understand the components of an expert system. Now there are three important components in an expert system, which is knowledge base, inference engine, and user interface. Now, like I mentioned in fuzzy logic, the knowledge base and inference engine will play the same part. The user interface is basically to provide interaction between the users of the expert system and the expert system. Okay, the expert system is basically a program that helps in decision making process. Okay, so here the knowledge base will contain some high quality knowledge or will contain rules and algorithms. The inference engine will acquire all the knowledge that is needed to solve the problem, and the user interface is just for the users to interact with the expert system. Okay, this is the whole expert system component. Now, obviously, this is a little more complex than this, but let's stick to how this works. All right, I'm just going to tell you the working of expert systems and fuzzy logic. If I start to explain each and everything, it's going to take a lot of time. All right, so let's move on to our next question, which is how is computer vision and AI related? Now, computer vision is a field of artificial intelligence that is used to obtain information from images or multidimensional data. Now, computer vision is basically the concept behind the self-driving cars that you see these days, right? Computer vision involves a lot of image processing. So machine learning algorithms like k-means can be used in image segmentation. Support vector machines can be used for image classification. Okay, that's how computer vision and AI are related. Because most of the things that happen in computer vision like image processing and segmentation make use of machine learning algorithms like k-means and support vector machines. So to sum it up, computer vision makes use of artificial intelligence technologies to solve complex problems such as object detection, image processing, and so on. That is the relationship between computer vision and AI. Now, question number 30 is which is better for image classification? Is it supervised or unsupervised classification? So guys, earlier in the session, we discussed what supervised learning is and what unsupervised learning is. In supervised learning, the images are interpreted manually by the machine learning expert to create feature classes. Now, what this means is you're manually going to feed a labeled set of data to the supervised learning model. All right, that's how supervised learning works. You're manually going to feed a set of images which are labeled to the classifier. In unsupervised learning, the machine learning software creates feature classes based on image pixel values. So basically in unsupervised classification, the model itself has to figure out what to do and what not to do. Okay, so it'll create a own feature class based on some values such as image pixels, or it can also use the image color, or it can use intensity factors in order to classify. So if you ask me, it is better to opt for supervised classification because you're manually inputting images with a lot more information. Okay, whereas in unsupervised learning, you're totally letting the model perform everything. Okay, so in image classification, I think it's better to go for supervised learning. Now let's look at question number 31. The next question is finite difference filters in image processing are very susceptible to noise. To cope up with this, which method can you use so that there would be minimal distortions by noise? Now, the noise in an image can be due to high intensity or high contrast. Okay, so if you increase the contrast and increase the intensity of an image, you won't be able to understand each pixel. Okay, so each pixel will have a value associated to it. And if the intensity and the contrast of that pixel is a little too much, it'll be hard for us to understand the image properly. It'll be hard to perform image analysis because we don't have a clear image. Contrast and intensity will just cause noise in an image. So the best method to remove this is image smoothing. Okay, it is used for reducing noise by forcing pixels to be more like their neighbors. Okay, this way you'll have a faded image or you'll have a more equalized image. Now the next question is how is game theory and AI related? So guys, AI is actually applied in a vast number of fields. Okay, so a lot of fields from computer vision to game theory to machine learning. AI is always a concept behind these fields. Most of the game examples that we see make use of reinforcement learning or deep neural networks. Now, deep neural networks and reinforcement learning are very closely related to AI because they are branches of machine learning. So machine learning is majorly involved in game theory. An example of this is in Dota 2 also they make use of machine learning. So game theory is just a very logical approach to solving a problem. And machine learning is the best way to implement game theory. Now question number 3 is what is the min-max algorithm? Explain the terminologies involved in the problem. Now guys, min-max is one of the main algorithms which is used in game theory. Alright, it is used to choose an optimal move for a player, assuming that the other player is also playing optimally, meaning that both of these players are playing in order to win, and you're going to use the min-max algorithm on one of these players so that they choose the optimal move. In order to understand the min-max algorithm, you need to know what are the components in a game. Okay, there's something known as game tree. It is basically a tree structure which contains all the possible moves in a game. If it's up, down, right, left, any strategy, everything is mentioned in the game tree. Now, initial state is obviously the initial position of the player on the board. Alright, the successor function, it defines all the possible moves that a player can make. We'll understand this in the next question itself, so don't worry if you haven't understood this properly. Terminal state is obviously the end of the game. It's basically the state which will lead to the end game, or it will lead to your destination. Utility function is a numerical value for the output of the game. So guys, these were the terminologies, and this is what the min-max algorithm is. It is basically a game theory algorithm which helps a player choose the best optimal policy in order to win a game. Now I'll explain this in more depth in the upcoming slides. So let's move on. Now the next couple of questions are going to be scenario based questions. Now such questions are very important in an interview because this is where the interviewer will understand how well you know the concepts. So the first question is, show the working of the min-max algorithm using the tic-tac-toe game. Now, one of the major applications of the min-max algorithm is the tic-tac-toe game. Okay, you can understand and analyze all the possible outcomes of the tic-tac-toe game by using the min-max algorithm. Let's see how this happens. Now, first of all, in a min-max algorithm or in a game, there are two players involved. Okay, the max is the player that tries to get the highest possible score, and min is the player that tries to get the lowest possible score. So this algorithm is designed in such a way that, assuming that there are going to be two players, and obviously one player is going to win the game, and that is the max player, and min is the player which loses the game and has the lowest possible score. Now the first step in the min-max algorithm is to generate the entire game tree. Okay, the game tree is all the possible outcomes that can happen in tic-tac-toe. Okay, in the figure you can see that first X is aligned in the first box, then in the second box, third box, and so on. All the possible actions that you can take in a tic-tac-toe game are put in this game tree. And then step number 2 is to apply the utility function to get the utility values from all the terminal states. Getting utility value is important because this is how you'll understand your outcome. Okay, you'll understand if you're going to win or lose. Now in the terminal states, whatever numbers you see over here, these are the utility values. Now step 3 is determine the utilities of the higher nodes with the help of utilities of the terminal nodes. Now in this diagram, you can see that in the terminal nodes, we have the utility values. The step 3 is to get utility values in the higher stages, which is the min stage. All right, these two circles, you need to fill in the utility values by using the utility values which are in the terminal state. Now, how do you calculate the utility value? Let's start by calculating the utility value of the left node. Okay, this red color node, we'll start by calculating this. Now you calculate that by finding the minimum of the 3 nodes that it's leading to. Now this red node is leading to 3, 5, and 10. And the minimum out of 3, 5, 10 is 3. So the utility value for this red node is going to be 3. Okay, similarly for this green node, it's going to be 2 because the minimum value between 2 and 2 is still 2. Now step 4 is to fill in these utility values that you've calculated. So now we have a min-max algorithm which has all the utility values filled in. Now the only utility value which isn't filled is the one with max. Okay, the one on the root node. Here we haven't filled the utility value. Again, to fill this value, you're going to check the nodes which are directly connected to it, which is 3 and 2. You'll find the maximum between these two because this is the max function. All right, so here you'll get a value of 3. So that's why the best opening move for max is the left node. Okay, you can make use of the left node in order to win the game. This is the first step that the max player has to take in order to get to the path of winning the game. So guys, by doing this for each and every step, you can win the game. Okay, so you'll have to calculate the utility value at the terminal nodes. You'll have to move up to the other hierarchical nodes above it, calculate the utility values there until you reach the root node. Okay, once you reach the root node, you'll get a utility value, and that utility value will be connected to some move or some node. You'll have to take that node or you'll have to take that move in the game in order to win the game. So this way you'll have to calculate the utility value for each and every move that the player makes so that the player will win the game. So guys, min-max algorithm is quite easy and it's very understandable. All you need to know is a little bit of math in order to solve this problem. Question number 35 is, which method is used for optimizing a min-max based game? Now this is not a scenario based question, but this question is usually asked if an interviewer asks you about a min-max game. Now the best way to optimize a min-max game is by using something known as alpha-beta pruning. Now, the main thing about alpha beta pruning is that it will remove all the nodes that are not affecting the final decision. It's just a faster way to reach your outcome. That's what alpha beta pruning is all about. So let's look at an example to understand this. Okay, let's say there was another node over here. Okay, here you can see that this is going down to a terminal state with utility value 2. Okay, now you don't know the value of the other two nodes, but if you use min-max to calculate the utility of the other two nodes, you'll get a value of 3. So in this example, again, we'll start at the terminal nodes. So 3, 5, 10 are the utility values here. So this will give us a value of 3 because we're calculating the minimum over here. Now here you have 2 and you have two unknown values. You have A or B. Okay, I've named them as A and B. Okay, let's leave this for now. Let's go to the next node. Okay, here the possibilities are 2, 7 and 3. So the minimum between 2, 7, 3 is 2. Okay, so here there's going to be 3. There's going to be a value, let's say C, and here there's going to be a value, let's say 2. Now we know that the maximum between 3, C and something else will be 3. Okay, that's because 2 is the minimum value over here and the maximum will obviously be 3. So the hint here is in the 2AB node, we know that the value or the utility value will obviously be equal to 2 or it will be less than 2 because you're calculating the minimum in this step. Now, if you calculate the max out of these three values, we'll obviously get the answer as 3. So this way, this entire node itself is removed because you don't need it to get to the final answer. Okay, that's what alpha beta pruning is all about. It'll identify the nodes which are not going to affect the final decisions and it'll just remove those nodes. So guys, this is how the optimization for a min-max game is done. It's done using the alpha beta pruning. So that's it for today, guys. I hope all of you enjoy the video. Have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!